Hello, everybody. Thank you for joining for this session today. Today, I'm going to talk about VxRail in the real world. I will share some experience that I have with this kind of appliance. And I will share with you some tips and tricks, okay? Well, I'll talk a little about me. My name is Arno Santana. I am a Brazilian. And so I have more than 20 years in experience with IT infrastructure, especially with VxRail. I started with 400 of VxRail. It's a vBrownBag, okay? And if you want to learn more about me, access my LinkedIn. I have an entire description there, and can you contact me through LinkedIn, okay? And then I will start our agenda for today. The first part of our presentation, we are talking a little about key points of VxRail, and after we are describe some important steps or key points or some tips about the installation, and after install we have some key points to pay attention, and some tips and some problems I faced during the updating the device, and I will share some tips with you, and and some reference and docs to solve possible problems during the updating or during using the device and day by day, during the day by day. Okay, so the key points of VxRail. In my opinion, VxRail is a game changer. For me, it's the best HCI solution. I have some experience with other players, other solutions, but for me, if you use VMware, if you have this free infrastructure, VxRail is the best solution, because the true single panel of glass, you can do everything on the same screen, the vCenter screen, and this is great, because other solutions, maybe you need to go out of vCenter, perform some tasks, return to vCenter. In this case, it's not. This is truly real single panel of glass. You do everything inside vCenter. The interface you are very well customized using on your day-by-day IT administration, IT infrastructure administration. And the other interesting fact is the compatibility, fully compatible with vSAN. Some years ago, during VMworld, I do not remember the exact year, I watched a presentation about problems with vSAN, and one of the most common problems with vSAN is about compatibility. The other thing is very interesting about VxRail is the real on-click update. You press on button and everything goes automatically. You know, do you have firmware updates? Do you have vSphere updates? Do you have vCenter updates? Don't worry about these, and the process is very automated, and you don't need to take care. You don't need to worry about this. You don't worry about, okay? And the other interesting fact is the unique point of contact. If you have a problem, you just call for one person, one number, and they will solve your problem without need to contact many vendors. This is a great advantage of the HCI, and especially when you're working with a VxRail. Well, now I will share some tips about the installation. The first one is don't ignore the requirements, especially about network and DNS. You need to spend some time planning your installation, and it's very, very important using the solve procedures for install. I have experience with more 200 devices deployed, and every installation is a new installation, and every installation do you face different kinds of problems, and many times the problems are occurring because sometimes you are not check and trying the requirements, especially about the network. Okay, and it's not a problem if you spend some time planning your installation, reviewing requirements, okay, and reading some solve procedure, special notes about the installation before you start the installation, okay? If you are using Dell network suites compatible with smart fabrics, evaluate the benefits of use this feature, okay? Because when you use smart fabric suites, do you not need to configure the suites? The X-Ray will configure automatically the suites for you. This is maybe save time during the deployment, okay? Many people said, no, this is not so good, but if you deploying a cluster with a lot of nodes, maybe this is a good idea. Well, it's preferred to use the suites in the mode, not in the stacking mode. Prefer to use VLT if you are using Dell networking, or VPC if you are using Cisco switches, or other manufacturers have different names for the same feature. I don't recommend the use of stacking, because when you use Tor suites in the stacking mode, when you need to perform some kind of maintenance, like primary updates, you can incurring on network disrupt and network down, and this is not good. And when you're planning your network for HCI solution, especially about the X-Rail, we recommend to use two switches. And in this mode, VLT or VPC, they are working independently. But outside, if the other switch looking for this, the other switch see like one switch, okay? But do you have benefits about this configuration? Because you can perform updates without any network outage, okay? X-Ray requires some specific VLANs, and you need to configure that before you start your implementation. When you, after you put the device on the rack, you need to cable them. When you are cable them, pay attention in the ports. Don't worry about network interface cards outside the onboard interface cards, because the setup using only onboard cards, okay? And my recommendation for this is using odd ports in one switch and even ports in another, because the X-Ray that have a predefined network organization, network layout, and if you're looking in the network planning guide, this document you can find during the LMC websites. At the end of the presentation, I will share the address of the LMC websites when you where you want to find this kind of documentation. After installing the devices, after cable the device, I recommend to configure all iDirect of all nodes first, because sometimes I faced problems. I had problems with some implementations. I remember a specific case. I spent a lot of hours believing that the problem is network configuration. And in fact, the problem was a problem. You need to look at direct console user interface of each node and look if the information about PSMT is present. Some nodes produced last year have a bug with this, and they don't have PSMT identification, and these they not can be found during the cluster configuration. And because of this, I very recommend to configure iDirect first. Look if each node are health. Look for hardware problems before you start your implementation, in fact. In case of using external vCenter, take a look at VxRail vCenter Server Planning Guide. This is a document because not every vCenter configuration are supported on the VxRail installation. Especially when you use external vCenter server, you need to check not only the center server planning guide, but support matrix. You need to check if you are using the correct version of the center server before you start your implementation. VxRail Manager have the full IP address, but I really recommend you to change for a definitive IP address before you start your cluster building. Okay, and for 2-node cluster, I really recommend you to configure a witness traffic separation, a special network, separate VLAN for this, and take care with you the witness about 2 facts. The documentation about 2-node cluster is very simple, and sometimes you face a lot of the problems with 2-node clusters because it's not so common implementation. It's not well covered in the training for implementation of VxRail. If you perform VxRail implementation course, it's a small portion of the course that they talking about 2-node cluster, but 2-node cluster is a little difficult to put on production because the documentation are simple and not cover all aspects. My recommendation is for this is use the same version of the rules about the vSAN witness. When you download and deploy the vSAN witness, take care with this, because if the vSAN witness has a different disk version than the hosts, you can't perform the deploy of the VxRail 2-node cluster. Okay. Well, if it's happened during your installation, you face this screen, do not panic. I face this kind of the problem in some implementations. In the most of case, just press try again, and this solves the problem. Many times this is occurring because some tasks do not perform at the correct time, and because of this, you face this kind of the problem during the implementation. But just press try again. If this doesn't work, look at the log and try to do the task manually. Example, in one of my implementations, I faced a problem with a specific step when the configuring enhanced vMotion compatibility and the installation stopped. I faced similar the screen of this, but I just read the logs and enable enhanced vCenter compatibility manually and done problem, and the installation, and I press try again, and the install continue, and the cluster was deployed with success. After install, it's very important to rename entities, because VxRail after the installation has different names. It's not different, strange names. Not to say strange is the best word for this, but many customers, many people want to rename the entities. But my recommendation is look for the solved procedures for this, because not any entity can be renamed. Okay, and the solved procedures are very complete about this. They have step-by-step instructions to perform renaming entities. Okay, enable vSAN performance services is very important too. Enable Skyline, the online health check. I recommend this because before you enter in production, the environment start production. This is very important. You make a health check of your cluster using the online option. If you want to use the duplication, compression, and encryption. This is the time before you put the device in production, because when you activate, when you enable these features, it's necessary to reformat the disks, and this task is time consuming. And the other thing, during this task executing, you have limited availability. Because of this, I recommend, and after install, before you move your workloads to the new cluster, enable this. Okay. And the other very important step is enable ESRS, the call home function of VxRail. And this is not only used for problems. Recently, we have ACA as an analytical consulting engine. The data transferred by ESRS are used for analytical consulting engine. Analytical consulting engine is a very new feature introduced last December. And it's very, very interesting because this feature provides information, analytical information about your cluster and perform updates. When you perform updates, I prefer, for my experience with a lot of implementations, to use offline bundle and the internet upgrades, especially when you are deploying more than one cluster in the same organization. Maybe this is a strange scenario, but it's not so strange for me. Because we have a limit on the standard cluster of 64 nodes, and sometimes some companies work with 2 or 3 clusters, and sometimes when you need to deploy more than one cluster, you need to do that. Download the offline bundle and perform updates faster than you use the internet upgrade. Okay. If you found errors during the upgrade, don't worry. Again, don't worry. Just press try again. It's most cases enough. Okay. And I performed installation here in Brazil and in a customer, a lot of 2-node clusters in remote regions of Brazil. And some regions don't have good power sources. And sometimes during the update, I face a power outage. Okay, don't worry if it is occurred, because you just power on the solution again, and the update continue. Okay, very, very rarely you face a problem that you need to contact support to solve this kind of problem. And if you face error during the upgrade, please look the log. Sometimes the log have more information, more detailed information that help you to solve the problem. Well, solve the problems before you can contact the support. Okay. Before contact support, take a look at event code reference. And this, I put some reference here, just 2 links, because this documentation changes every day. And just put two links. The solve online. The solve has a lot of procedures step by step. And the InfoRub. InfoRub is an entire documentation about VxRail. So for today is this. Thank you for your time. And you have doubts, feel free to contact me. Okay, thank you.
Welcome to the session today. We're going to talk about VM performance innovations around protecting your mission-critical applications. My name is Brian Reynolds, and I'm a product manager in the data protection division at Dell Technologies. We're going to talk a little bit about the challenges we have today when protecting our mission-critical applications and the innovations that we're working on in Dell and going to be previewing around the enhancements to our scale and performance when it comes to VM image backups. And finally, we'll talk a little bit about how this new enhanced data image backup is going to allow you to do more with your data than just protect it. So let's talk a little bit about the challenges. Today's VMs are faster and bigger. VMware continues to enhance the performance and capacity of the VM disks, which means that our VMs are running faster and they can handle more transactions. We're also seeing that they need to be able to accommodate that global environment, so they have fewer downtimes when we can be able to take those VM image backups. And when we talk about traditional backups, one of the challenges we have is when determining those deltas that we need to for being able to archive the data, we find that we have to halt the VM while we're looking and capturing that image. And that's going to result in the application becoming stunned. And the other problem we have is that we have a dependency on our external proxy, our agents. These agents we use to move and transfer the data to our storage. And these external proxies exist in our production environment, which means we have to be able to deploy and manage those resources, and they're taking away from our ability to support our production VMs. So let's look a little bit more into a VM image backup. There's really three stages that make up a backup. We have our snapshot creation. And this is where our point-in-time representation is collected for the VM decay. And we use this to be able to determine the deltas. We see that this operation requires for us to be able to quiet that VM decay so that we can be able to get those changes. The next part of the process is to process those snapshots. And this is where we have to work with our external agents to move the data over and determine what those changes and deltas are, and then send those over to storage. And finally, we have to clean up, which means that we need to consolidate that point-in-time representation with the current VM decay and ensure that we have all those changes captured. We tend to see a lot of IOPS degradation in both the creation and the deletion steps. We also see a lot of impact on our performance when it comes to processing and moving that data, since I'm using production resources. So that introduces the problem. How are customers getting around it? Well, today, they're using workarounds to solve or to deal with those issues. One of the things that they're doing is they're taking a limited set of data and trying to protect only that, which requires our users and customers to be able to determine what is the valuable data and continually making sure that they're protecting the right information. This still has a challenge because I still require my agents on the host now to be able to capture those file and application level data. The other option that we've seen customers try to do is limit the backups, not take as many, and be less frequent, and hoping to capture those backups during those downtimes. But in our global environment, we're finding that time is unpredictable, and I may need to have my systems up when a backup is scheduled. The other problem I have is that it increases the gap between my backups, which gives me fewer copies to be able to use for restore. And I have less ability to be flexible when it comes to restoring my system. So here at Dell, we've been working to enhance the way that we do VM image backups. And the way that we've been looking to solve this is to ensure that we eliminate the need to pause that VM during a backup. This solution that we're looking at is storage agnostic. So we're going to be able to leverage this across all our various storage platforms. And we're eliminating as well the need for us to be able to have that dependency on our external agents during that processing of the data and moving it to our storage. This would be ideal to solve those problems with your large data sets where you can't afford to have that IOP reduction. So let's talk a little bit about this new enhanced VM image protection. So first off, we've enabled our VMs to monitor the changes. And as PowerProtect Data Manager makes a request for a backup, it's able to get a transparent snapshot of those changes without any IOPS interference. And these snapshot then is able to be pushed directly from the ESX to our PowerProtect DD without having to do any additional hops. And then my final step is just cleaning up. And that cleanup operation is very simple. It's just a simple removal of that transparent snapshot with no requirement for me to sync up those changes with the current running VMDK. So this really allows us to be able to see improvements when it comes to performance. We've eliminated the need to create that point in time snapshot, which means that I no longer have that pause of my IOPS. And as we look at large VMs, I can be able to take that snapshot without any disruption to the business. And therefore, it is truly transparent. We've also been able to reduce the need for that cleanup. So therefore, the cleaning up and removal of that snapshot is a simple operation with no impact to that running VM. And in our labs, we see that those IOPS can stay consistent across the entire snapshot operation, which is ideal for those VMs which are large that need to be able to have their IOPS maintained in order to handle the high transactions that they're trying to process. From a scale perspective, we've removed the need to copy those changes to an external agent. And this has allowed us to be able to remove those hops. And so I no longer need to be concerned about where my external agents are deployed and how they're deployed and where they sit in relationship to my ESX. I've also been able to, with the embedded data mover, reduce the impact on our production environment. So we're no longer using production resources when we copy our data over from the ESX to the PowerProtect DD. And this has eliminated the need for a management of all of those external agents. Since I no longer have to deploy them, I no longer have to manage them and make sure that they're upgraded and that they're all running and keeping healthy. I no longer have that ownership, and I'm not leveraging my production resources to be able to have to allocate space for them. So therefore, I'm able to truly use my entire ESX for my production without having to account for space and resources required for data protection. I've also been able to ensure that as part of when we deploy that embedded data mover, we have the ability for it to be propagated and scaled automatically. So as you add hosts to your cluster, that data mover will get automatically moved and installed and deployed and configured. So there's no work for you as a customer to ensure that that data mover is up and running. And as we expand our environments, those data movers will expand with it. So this is really changing the way that we can protect those VMs. So the VMs that used to be unprotectable, we will now be able to protect, which allows you to be able to take more backups and no longer have to wait for downtime, which gives you a lot more flexibility when it comes to providing solid recovery. Since your copies will be more frequent, you're not going to have data being lost. And I'll have the ability to recover those in the same manner that I do with a backup. I'll be able to go directly from the PowerProtect DD to the ESX with no additional hop or involvement of those external agents. And this ultimately allows us to focus back on the VM as a valuable asset. I no longer have to be concerned about what's on my VMs. I can protect the whole VM and be assured that I'm not losing any critical data. Nor do I have to be working with trying to manage all of those agents that may be looking for the file data or application data. I can just protect the whole VM, no agents needed. So that really reduces the amount of infrastructure that I need to deploy and manage. It makes things easier for you as a customer to be able to ensure that you've got data protection up and running without requiring you to configure and manage in your production environment any of those external agents or those host agents. So in summary, this is going to be an opportunity. We're excited to present to you this new innovative way of doing enhanced VM image backups. We realized that this is going to provide you with a solution for those mission critical applications that today you cannot protect. And it'll give you complete coverage of your entire VM without having you to have to figure out what data needs to be protected or what's critical on that particular disk. And this is ideal when I need to be able to protect those VMs that have a need to be able to run in this global environment. And we're excited to offer this new enhanced VM image backup with a snapshot and the data movers that have been developed here at Dell Technologies. And this is going to open the door for you to be able to move over some of your systems that may be currently still physical to a virtualized environment and still be protected and have the same level of data protection that you would expect without the need of having to deploy all of those agents. And we're really excited to be able to provide this for you because we know this is a problem that's been around and we believe it's about time for it to be solved. So if you'd like to learn more about PowerProtect Data Manager and what we're doing to be able to enhance our data protection from a VM image perspective, please check out our website or join us on Twitter. And thank you very much for joining me in this session.
Good afternoon, good morning, good evening, wherever you are. My name is Mark Stockham. I'm a field CTO with Dell Technologies Data Protection Solutions, specifically working with VMware technologies. And today we're going to be talking about data protection for multi-cloud in VMware environments. So what do we mean initially by multi-cloud? Multi-cloud for us in this context is those on-premises, those hybrid, those multiple public clouds, any or all of the above, being able to operate in all of those clouds and give data protection solutions regardless of where the workloads run. Which hyperscalers are we going to be talking about? Primarily AWS, Azure, and GCP and Google. There are others that we'll touch on, but primarily those three. The most appropriate use cases will be covered for data protection relating to all of these clouds. We'll discuss optimal architecture. We'll be looking at some of the critical workloads, and we'll also touch on automation elements for reasons that will become apparent a bit later on. So to start off with, what are the most appropriate use cases? Today we're going to be talking about long-term retention to start off with. We'll then be moving on to cloud disaster recovery, backing up into the cloud from on-premises environments, and also backing up from within the cloud itself. In all of these scenarios, we're going to be looking at it from a data protection storage perspective, so the data domain, be that a physical appliance, a converged appliance, or a virtual appliance, and looking at things also from a data mover perspective, so the data protection software itself. In all of these scenarios, performance efficiency and the ability to operate in the multiple clouds, Amazon, Google, Azure, as well as VMC, etc., are going to be addressed in the use cases. So first scenario, long-term retention to the cloud. In this case, we're going to be using the cloud to give us the ability to hopefully reduce our reliance on tape, on those less accessible mediums, those things that take us longer to get data recovered from. So we've got the on-premises environment, we've got an active tier carrying out operational day-to-day protection and recovery. We're taking some of that data that has aged out and we're moving it to the cloud tier. We have a long-term retention tier, if you like, using S3 compatible storage. So in this case, looking on premises at something like Dell EMC ECS, Elastic Cloud Storage. But the topic for today is, of course, the cloud. So equally, we can take that deduplicated, that compressed, that encrypted data, and we can move it into the public cloud. Use a public cloud provider purely for their storage. So we have the ability to use AWS, Azure Blob Storage, AWS S3, Google Cloud, various other clouds, purely to give us that storage capability. So we're taking the high highly efficient deduplication that the data domain gives us in the first place. We're able to take that policy engine, use that policy engine to decide what we're going to move to the long-term retention, the cloud tier. We can scale highly based upon the physical appliances that we can deploy. We can also use a data protection appliance like a PowerProtect DD series 3300, 4400, giving us an entry point, much lower entry point. And we can take, even if we want to, a virtual appliance, a DDVE, and start at something like a 1 terabyte incremental increase of storage, and deploy that and use that as the on-premises storage. We can support third-party data movers, but obviously better deduplication is achieved with Dell Technologies solutions, and this helps us to move away from the likes of tape. So this is an entry point, if you like. This is using the cloud environment purely for its cheap storage. Moving on to the next level, cloud disaster recovery. So taking your virtual estate, your VMware estate that runs day to day, taking that environment, protecting the data onto a data domain on premises, be that physical, appliance, etc., and then taking some of that data and pushing it again into cloud storage. In this case, Amazon S3, Azure Blob, and making sure that we have copies that are available in the cloud. Should we want to spin that workload up in the case of a disaster recovery, we can convert that image, we can pre-convert it, or we can convert it on the fly and run it as an EC2 instance. The same thing can occur for Azure, so we can convert it to an Azure VM image and run it there. Pre-conversion also available should we need to or want to. But if we do want to run it just as another VM, if you like, we can also leverage VMware Cloud on AWS and just run that, or just take that image, bring it up, restore it into as a VMware VM, and we can then run that in the cloud, carry on running, and then should we need to move that workload back on-prem after the disaster has passed, we can vMotion that virtual machine back on premises. So we've got two options. We can take the option to run it as an EC2 or an Azure image, or we can run it in EC2. What this means is we've got this orchestrated failover capability into the various clouds. Recovery can be minutes. If we pre-convert some of these images, pre-conversion can be run on a regular basis. Once that image is uploaded into the cloud, we're able to recover in minutes. We can have recovery point objectives as short as 15 minutes, seamlessly integrated with what's going on premises, and application consistent recovery is available in Amazon itself. So this can replace a secondary or a tertiary data center. I've seen this in a lot of cases throughout EMEA, which is the region that I cover. So can obviate the need for making high physical hardware purchases, and also the cost of facilities managing entire premises. So what about if we want to actually back up from on-prem into the cloud? What does that look like? Of course, we've got the usual efficiency of DD boost. We deduplicate to the client side, we compress, we encrypt. That information is protected on premises. We could then take that data and move it into a data domain virtual edition, a PowerProtect DD virtual edition, running either in Google Cloud, in Amazon, or in Azure. And this gives us the ability to leverage the lower cost of running natively in those cloud environments. Being able to run in EC2, for example, is much, much cheaper than running in VMC. What we can get here is the ability to write directly to that storage appliance. We don't need to have storage on-prem. We could. There's another scenario coming up shortly in which we cover that use case. So we don't need to use on-site storage. Boost takes a lot of the pain of ingress, of moving data from on-prem into the cloud, and it gives us a multitude of deployment options. Use case here could be a remote site with a very small footprint, not enough footprint to deploy even a data domain virtual edition or a small appliance. If you have limited WAN capabilities, the ability to carry out this client-side dedupe allows us to minimize the amount of data that gets transitioned. And the facilities on site may not be suitable to host data protection storage. It might just not be suitable. So this is the scenario that we see in a lot of cases, customers wanting to take the data, move it out, and store it initially in the cloud. So just jumping very briefly into an architecture slide, the architecture we're taking into consideration here is the use of virtual proxies, client-side deduplication, giving us the ability to do change block tracking from a VMware perspective and take as little data as possible to move it across the network to then let it reside on the highly efficient protection storage, giving us minimal footprint. We'll cover why that's important very soon. But the highlight here is, whenever you move to the cloud, between clouds, between zones, availability zones, regions, et cetera, or when you egress, obviously one of those hidden costs is the cost of moving data. The less data you move, the better things tend to be. And also, if we're doing this from a software-defined perspective, automation is something that we can leverage, and we'll come on to automation in a few slides' time. What we can also leverage here is a lot of the in-stack and vRealize automation capabilities of the stack, and that data efficiency really does pay dividends when we're not just on-prem, but also in the cloud. So what about if we have existing platforms that we're running on-prem and we want to replicate that data elsewhere? Well, again, the efficiency that we have as part of the platform, the deduplication, the compression, the encryption, allows us to take that data and then just carry out a replica between the on-prem environment and the PowerProtect DD Virtual Edition running in either GCP, AWS, or Azure. And what this means is we're able to take that data and get it into the cloud in as quick and as efficient a manner as possible. Some customers just want to be able to move their data and get it into the cloud so that they can leverage it and replicate it elsewhere. We've got the ability to support third-party software should we require it here. Very easy to deploy through the various different marketplaces. Latest and greatest versions have been released in the past week or two on some of these platforms, and this means that reduces that ingress-egress cost, means that that bill shock is reduced or minimized. So what about where we have VMC, VMware Cloud, for example? In this scenario, we've got the on-premises environment. It's running as you would expect, all your virtual machines, vSAN, ESX, NSX, et cetera. We're also able to configure and run the environment in hybrid link mode, so we have that VMC instance that looks, smells, feels exactly like what's being run on-prem. So that's great from the perspective of being able to run workloads either on-prem or in the cloud in a hybrid and a seamless fashion. But from the data protection perspective, what we really want to be doing is making the most of the adjacency that we have between the VMC instance and the native Amazon facilities that reside next to it. In this case, we're able to run PowerProtect DD Virtual Edition as an EC2 instance using S3 storage. And because it's sat literally next door to the VMC instance, we've got high bandwidth, we've got a variety of methods of connecting to it, which gives us the ability to drive down cost for protecting those workloads that reside in VMC. We could equally run it in VMC, but it's a more cost-efficient option to deploy in native Amazon. What do we get here? Enterprise-class data protection for VMware Cloud and AWS. We get that image-based protection capability, instant recovery of those workloads either within the VMC instance, or we can vMotion them or just run them on premises. We've got the ability to store in S3, which gives us that cost benefit, and it's a consistent and seamless operation experience for the VMware operator. We'll come on to that a little bit later on from an automation perspective. What about when we're protecting workloads from an in-cloud perspective? So in the scenario here, we have a multitude of applications that reside on-prem or in the cloud. In this case, cloud applications. We have a specific set of application tools that allow us to take that data and move it from the client directly to PowerProtect DD Virtual Edition residing in Azure, Amazon, Google GCP. The ability to take that, leveraging all of the existing benefits, the deduplication, et cetera, the minimization of network traffic, and fundamentally giving higher performance, lower backup window times, being able to manage this stuff on-prem and let it reside in the cloud. And a lot of the deployment capabilities are available through those marketplaces. So it makes a lot of sense to be able to leverage the benefits of being able to run PowerProtect DD Virtual Edition in the cloud on whichever cloud provider you want, and be able to protect those various workloads that you are interested in. Not forgetting the likes of Kubernetes, that are covered in other sessions and other topics of much discussion elsewhere, but are also protected by our PowerProtect suite of products. Mentioned earlier on about the low cost footprint. Just a very brief slide here. The way in which we deploy in AWS, for example, natively on EC2 is a much more efficient from a deduplication perspective. So we're able to store much less data to protect the same workloads. We're able to use less compute instances, so the cost of EC2 compute will be lower. The cost of storage will be lower from a block perspective, and the cost of object storage will also be low based upon the lower footprint. And you can see some comparative costs in here, but just to make the point that it's not just about the minimization of the network traffic that we mentioned earlier on, but also if we're running natively in the cloud, we're able to drive down costs there too, which is obviously a key driver for most customers moving to the cloud for cost reasons. Now, all of this would be slightly irrelevant if we didn't have a way of managing the entire environment. So we're able to use Data Protection Central to get a single view of what's going on throughout the environment. A number of ways in which we can deploy and utilize this. This is not the only way in which we can do this. We also have the ability to tie into the likes of Tanzu Mission Control, but that's a topic for the cloud native side of things. Just want to make the point that all of this needs to be visualized and managed in an effective fashion. And while we're speaking about management, it'd be remiss of me not to mention vRealize automation. So taking the scenario we just mentioned where we had on-prem, we had VMC, and we've got the native EC2 data domain running in EC2 natively, we also have the ability to tie into vRealize automation. So vRealize automation being that element that gives us full lifecycle management of those VMs, regardless of whether they're running on-prem or in VMC when we're in that hybrid link mode. Now, we have a comprehensive set of vRealize integration capabilities right now, regardless of which data mover that is being used. But the product management have asked me to give you a sneaky peek into what's coming soon, what's coming next. So, as you're no doubt aware, vRealize 8.0 released earlier on in the year. vRealize 8.2 integration for our data protection extension will be published shortly. What this will allow us to do is give customers, yourselves, the ability to create policies which can then be exposed through vRealize automation and can be attached to virtual machines, giving us those day two operations for protecting, backing up, restoring to new and various other tasks that you'll be familiar with from vRealize Automation 7 that we will be the first to promote, to produce for vRealize 8.2. That's something that will be coming out later this year, but watch this space. This should be the first you've heard of it. So in summary, what we're talking about from a data protection perspective are solutions that map across all of the VMware cloud delivery options, regardless of whether you're on-prem private cloud, whether you're using some sort of subscription model, VMC on Dell EMC, AWS public cloud, GCP, Azure, etc. All of these delivery options are covered. We can protect workloads in those clouds, from those clouds, replicate to, restore from. In addition to the obvious Kubernetes, Tanzu vRealize integrations that we've mentioned also. And this technology that we use, the architecture that we use, gives us a significant benefit right now. And watch this space throughout the whole of VMworld. Look for Dell Technologies data protection solutions and see what's coming next, what we'll be announcing, and what's coming next to further enhance the way in which you can protect your workloads when they're running on any of these VMware platforms. With that, I'd like to thank you for your time and your attention. And if you do want to get in touch, my name is Mark Stockham, mark.stockham@dell.com. Please feel free to reach out, and I'll be happy to answer any questions. Thank you very much for your time and attention.
Hello and welcome to this talk. I'm David Espejo. I'm based out in Colombia, South America, and I've been part of the vBrownBag community for quite some years. So I really appreciate the chance to share these topics at VMworld 2020 Tech Talks. So let's get started. In this session, we will talk about a little bit on distributed systems theory and why it is important for us in IT, right? So first of all, theory, right? That sounds really academic, and it's really academic. So first of all, why? Why to bring this topic from textbooks, from academia to IT? Why it is important? Well, first reason, it's because distributed systems are all around us in the everyday systems, products, protocols that we use and consume every day. They are all around us. And in my experience, this academic topic is not open for the interpretation of a specific vendor. It's a concise, exact, precise topic that when it's clear for us, and that is the main goal of this session, to try to bring light on how these topics can be found or can be traced to most of the systems, protocols, and products we use on the day-to-day operations of an IT environment. So examples of distributed systems will be, for example, DNS, the distributed naming service, network file systems, some network protocols like BGP or VXLAN, and even Netflix. It's a planetary scale distributed system that happens to provide the streaming services to end users, right? So they are all among us. So now, if that is pretty much clear on the why of the importance of this topic, what is a distributed system? For most of these definitions, I will reference the textbook by Professor Tannenbaum, who is very famous. He wrote several textbooks that are used throughout computer science schools throughout the world. And he provided some definitions for this topic. So first of all, a distributed system, it's a collection of autonomous computing elements that appears to its user as a single system, right? So there's a lot there to unfold. I will try to unfold a little bit this definition. Examples of distributed systems that operate like the textbook definition are, for example, a vSphere cluster. You have several nodes. Let's say a node in this context can be a hardware device or a software process. There will be several nodes that appears to its user as a single system. You log into vCenter, you see a cluster. A cluster itself, it's a form of or an implementation of a distributed system. For example, NSX has most of these services are distributed by nature. So it's a collection. There are several components. And one of the principles is that each component could act or could operate independently from each other. But in the practice, they will need to communicate, right? You have several components, but they will need to communicate to achieve a common goal. So the next feature, the next base feature is the single coherent system. Its users are not aware of the distribution of processes, services throughout many nodes and many systems. No, they will see or they will operate this as a single system. This is not the same as having a single view, right? If you are thinking about the infamous single pane of glass, I will dive a little deep on this in the next slide. It's not the same. It's just the coherency here comes by providing the user an experience in the system that behaves exactly the way the users expect it to behave, no matter where it's deployed, no matter how it's consumed. It will respond to user requests exactly how they expect it to answer or to respond, right? And for me, this has a lot to do in the trade-off between complexity and abstractions. You know, most of the promises that technology do today is providing simplicity, right? Eliminating complexity, and complexity cannot be eliminated. So the formal definition for complexity is shown there in the presentation. There was another professor called Herbert Simon. He provided a formal definition for a complex system that happens to be one made up of a large number of parts that interact in a non-simple way. So it's very similar to a distributed system. We can say that a distributed system, it's always complex, right? But simplicity, it's not just removing parts, because the system needs all of its parts. It's just, hiding the diverse components, hiding them from the users, and make the system appear as a single coherent system, right? So that is the abstraction, the most realistic goal with a complex system. Well, so let's dive a little deep on the base features. First of all, a collection of autonomous elements. If you have several elements, they will need a way to communicate between each other, to exchange messages between them. And also, if you have different independent components, nodes, or processes, more likely each process will have its own notion of time. There is nothing like a global clock for a distributed system, so you will need a way to provide time coordination. And also, if you have several members or several nodes to form the system, you will need a way to manage membership. You can have an open group when whatever node can be part of the group and can send messages to all the members of the group, or you can have a closed group. And if you have a closed group, you will need a way to authenticate, a protocol to authenticate nodes, to accept nodes into a cluster, and once accepted, to provide authorization on or trust on which part of the groups it can communicate to. So the technical or academic definition for this problem is admission control. So it sounds very familiar to a vSphere HA cluster, which happens to have an admission control mechanism. So examples of these requirements or these features for distributed systems implemented in the day-to-day components we use in IT, it's, for example, AMQP or RabbitMQ, a protocol, a messaging protocol used by some VMware products, or NTP, the Network Time Protocol, and a way to provide time coordination for a distributed system. Active Directory, for example, an example of authentication protocol to accept or deny requests to join a group. Single socket layer, TLS, etc. Different ways to provide trust for this collection of independent elements. And the single coherent system, as I was referring previously, it's not the same as a single system view. it's not the single pane of glass. That is a fair goal, but it is harder to achieve than just to say it. So it's the trade-off between appearance versus expected behavior. And the coherency here has more to do with expected behavior than with appearance, right? So the overall goal is to hide the complexity, but the most important goal is that the system behave exactly like its users have designed it to behave. Right? When you have different components, you will need a way to provide services for these different components. That is being called middleware. And middleware provides at least 3 functions to a distributed system. First of all, communication. It will provide mechanisms to communicate components of the distributed systems. It will provide transactions, a way to manage transactions, because most of the times an application relies on different services that are distributed along many nodes or components of the system. So the scalable way to manage that is by using transactions. And finally, reliability, a way to handle partial failures. If you have a system made up of different nodes, you will have to face the reality. A part of the system will eventually fail. So how to hide the partial failures of the system from the users? You will need a way to handle rapidly or have a way to tolerate failures. So you will see this in operation in an HA or high availability event in a vSphere cluster. It's just a way to restart automatically VMs in another node. That is a way to hide or to manage partial failures of the systems for the user. So examples of middleware services are, for example, RPC, which is a highly used protocol or communication protocol used in Windows environments, for example. The microservices design pattern of today's applications relies on communication between components provided by an API, which happens to be kind of a middleware. And also serverless. Serverless work only with transactions, probably atomic transactions, but those are transactions provided by this, let's say, middleware layer that are necessary for a distributed system. So in summary, that's it. In my opinion, when you gain more knowledge or at least study a little bit this distributed systems topic, you will get a better idea on how to design an IT environment, and also it will set your expectations at the right level on how it operates. So I appreciate the chance, and I hope you like this talk. Thank you for watching.
Hello, welcome to VMworld 2020, the remote edition. This is Richard Kenyon, and I am giving a presentation called Catastrophic Failure, Tales from the Trenches. I've been a vExpert for the last 3 years. I'm also been for the last 3 years the Buffalo VMUG co-leader. You can reach me at Twitter and LinkedIn via the hashtag you see there. And I've been in the IT industry for about 20 years at this point in varying capacities. I used to be a web developer. I used to do some coding. I used to do some databases. I even used to do some help desk as well, which is what everybody should do at least once in their career. And I have moved up the tower to be a virtualization and storage engineer at Synacor in Buffalo, New York. And I would like to give this talk and let you know one of the issues we discovered when we went to do a NetApp maintenance. So if you've ever been at a bar with your friends, you're out drinking, you start telling war stories about, what's happened to you in your career and things like that. This is my story. So first of all, here's your beer, and I'm going to give you the story of what happened, and then we're going to walk through how it actually happened. and all the troubleshooting that went along with it. So to give you the point of reference, my company has a DR facility located in Dallas, Texas. The facility is completely virtualized. That runs on a storage infrastructure of NetApp. We have about 250 ESX hosts. We have a DR vCenter, and we have a development vCenter that's hosted in the data facility. One of the DIM modules in our NetApp ended up having some errors on it. So we failed over from one node to the other node, which is standard operating procedure. And in the process of doing that, the technician, which we were in communication with on site, ended up pulling out the node to replace the DIM, as one does. And as soon as he did that, the rest of our environment completely dropped and went read-only. Our first assumption was he bumped the power cord, he bumped some fiber cables, he bumped the switch cable that's in the chassis, he knocked over a circuit in the rack. He must have done something. We come to find out within about 20 minutes that he actually didn't do anything. There was a bug in the specific version of ONTAP, which is NetApp's operating system that we were running, that had a specific version of motherboard firmware, which had a specific version of network card firmware that had a bug in it that just had a loose counter. When the counter went over 1,000, it caused a kernel panic in the NetApp node that was running and dropped that one and rebooted it. And that happened all within the span of about 90 seconds. So that then caused all of our DR environment and about a quarter of our development environment to go read-only. And then when the node came back up online, it was like basically pulling the hard drives out of all of our running VMs. We had then no customer impact, which is great because it's the DR facility and development facility. And then we had to spend the next 4 hours, kind of piecing our environment back together and learning a few different things in the process. So that is the story of how that actually happened. And this is actually what happened from the point in time we realized there's a problem until the solution came to be, which was some assistance through NetApp as well as a lot of our other teams on site. I'm telling you this because everybody's been in this situation before, and sometimes having a person tell you the story of how they solved it might help you in your environment. So the first thing that we start with is, something just broke. What just went wrong? We have to figure out how it broke, what happened. So our first set of questions, once we realize there's a problem, is what can I, as a virtualization and storage administrator, hit right now? What's up and running? What's functional? What pieces are a problem? And that obviously is your vCenter, your storage controllers, as well as your general administration boxes. Okay, now that we can figure out what we can and can't hit, let's figure out what scope this is. What data center are we in? We're in our DR facility. What cluster? It's our administration cluster, our production/DR cluster, and our development cluster. Next question would be, if you are a service provider like my company is, the next immediate question is, which clients are down? Do you have any revenue generating events? Do you have any people that are going to be calling you asking questions? Do you have any customers who are using your client's application stack for their own purposes? And the answer to that in this case was no, nothing like that in our production facility because it's DR. The next thing that we ask is our network operations center, always has a bunch of dashboards up. They're looking at traffic for our clients. They're looking at our data center facilities. They're looking at all of the different things that they are responsible for. So we ask them in chat, hey, we're doing a storage change right now. What do you see? What is going on your end? And unfortunately, in this case, the next screen I'm going to show you is quite literally exactly what they saw. Everything broke. Literally, their entire monitoring solution got overwhelmed with as many problems as they've seen. Because if you think about it, when you have 1001 VMs automatically go read-only, each VM could have up to 60 checks, if not more, and it just overloads the monitoring facility. So our network operations center currently is a newer set of employees that doesn't have a lot of experience. And as Fry is showing you, basically they thought it was the end of the world because they had never seen their monitoring solution break like this. So that's a little bit of an added stressor into what they started to panic and have all these issues come up. And they're like, oh my God, what do I do? And I and my team had to kind of walk them through, relax. We're all here together. Let's fix what's wrong. And then we kind of told them, here's what happened. Here's what we know of at the moment, and kind of brought them back from the brink. But it was quite funny to see in chat that a bunch of people just went, everything just broke. So first we had to tell them where the stack broke. And this picture is where myself and my teammates have control of. Our storage administration team and virtualization team control the following stack. We control the data center square footage, the power. We help the networking team arrange their equipment to be delivered, installed, and then managed at the data center co-location itself. And the network in our instance consists of fiber as well as Ethernet. We then move down the stack to storage. And in our case, we have object storage systems, and we also have block and we have file storage systems. Then that ties into our server infrastructure, which are physical machines, as well as physical VMware hosts. And my team's responsibility is the VMware side of that equation. Once you move down the stack a little bit further, you hit the guest operating systems. And the guest operating systems in this case are mostly Linux CentOS and a little bit of corporate infrastructure for the Windows. When we break it into the storage side of things, this picture is exactly the hardware that broke in the data center that I am referring to. So it's sometimes rare when you can see physically what actually broke, and it helps in presentations like this, as well as having good pictures of your data center. So our NetApp system was the one that went down. The block and file side of the equation went down. Object store was a different setup, so that was fine. And the picture right there is an AFF 8080EX, and the back of the picture shows the relatively well done wiring that the technician was working with. So we can immediately see that he could have hit a power cable for the switches, which are up top. He could have accidentally knocked one of the fiber cables offline to the node he was not replacing and working on. He could have hit one of the SAS cables, or he could have hit one of the power cables to the secondary node as well. So any one of those things at the time when we first noticed an issue was our first, here's what's going on. So now we've moved to the storage. Which pieces have failed? Which volumes are down? Which network interfaces are okay? And which HBAs are okay? Everything from the NetApp point of view at the time when we checked seemed to be perfectly fine. All the volumes were online, all of the cards were up, all the NICs were up, all of the volumes and pieces, everything seemed to be fine until we checked the uptime of the cluster and realized the secondary node we had failed over to had rebooted, which shouldn't have happened. So the next thing we do is, okay, now we need to check DNS, make sure that's working, because that's usually one of the first things that we check. And DNS wasn't working. And then we move down to, okay, that's a virtual machine. Let's make sure our vCenters and our PSCs are functioning. We were at 6.5U1, and the vCenter and the PSCs were read-only. So we had to go and find those, make sure that they were doing their FSCKs and come back up, rebooted perfectly fine, and we had network connection, and now we can start fixing our environment. In the time of about 20 minutes where we have gotten to this point, we now have our network operations center a little more calmed down. We are letting them know what's going on bit by bit, and we're feeding them information. They then ask us, as is our chain of command, do you need an incident manager? And an incident manager is responsible for communication between all of the following teams: the network operations guys, the database guys, systems administrators, email administrators, web operations portals, an internal program called VAM that we have, the storage team, myself, and then the network team as well, because all of the pieces of this data center broke. So all of these teams are going to need to have a person in charge of fixing their individual pieces. And an incident manager while they may not necessarily be technical, always comes in with this face. They know nothing. They don't know what's going on, and their role isn't technical troubleshooting. It's being a frontline communication for all of these teams to ask a question to, so that these teams can do troubleshooting themselves. They also then report up in case this was a client impacting event. They would be responsible for communicating to the clients as well as our internal executives, who usually would start asking questions if it was a client impacting event. They are a very important piece to let the technical teams troubleshoot without getting bugged every 5 minutes. What's the status? What's going on? Why did this break? They are the front line in letting the teams that are doing the work do the work, as well as feeding the executives information they need to know, as well as the clients of the company of Synacor what they need to know. They're very good at what they do, but it's sometimes funny when they come in at 3 o'clock in the morning looking like that. So what actually broke? Here's a list of the VMs that we have. The left side is the DR facility. The right side that's expanded is the NetApp cluster that went down. So as you can see, organization is a very key part of your network and making it sure you can quickly see what broke where and how to fix it. So if we didn't have the data stores and the VMs organized like this, it would be very difficult for us to bring 1001 VMs back online after a reboot, because they went read-only, without knowing exactly where they broke and exactly which pieces went down. The right-hand side is actually especially interesting to note, is because that's actually our data stores. A lot of people don't quite realize that you can make folders for your data stores. And in this instance, if you have multiple different types of hardware, you can very quickly find out which data stores broke, because you know which hardware they're on, because you know which cluster they belong to. So this was an invaluable piece that I really hope a lot of virtual administrators utilize, and it makes for a very well laid out plan for day-to-day maintenance, as well as you can kind of see what things lie in different places. As I said, we had about 1001 VMs go read-only, which means we now need to bring them back online with a set of reboots. And because vCenter is as it is, sometimes it's hard to make a large change like that. So we ended up doing a PowerShell script at the time I didn't know existed. You can actually do open VMRC, and it ends up giving you a quite wonderful screen of things that look like this. So you can bring up on your 50-inch monitors all of the VMs that you've rebooted and watch them reboot to make sure that they are FSCKing properly, and bring them back up to functioning states. And every so often, you might have one that just gets stuck, and you can easily pinpoint it by having a screen that looks like this. You can also open a web console with PowerCLI, but I found doing the open VMRC a little bit easier, because it sets, in Windows at least, a taskbar group for things that you can cascade, you can stack side by side, or in our case, you can just tile and watch them all come up at once. We broke it apart by doing our email infrastructure for the DR side into groups. So we did like SMTP servers, we did POP servers, we did exchange, migration servers, and we did our LDAP controllers all in separate groups so we can watch the bits and pieces come up. We also obviously brought up our DNS, our corporate LDAP, our corporate Active Directory, our corporate domain controllers up in the same way. It just helps if you group them all together, which, as I said in the previous screen, you can see on the left where those pieces reside so you can script against them. So now that we have our environment back up and running after a few hours, we can figure out what actually happened. And in this instance, NetApp jumped on immediately because we opened up a P1 case with them, as well as we had a early case open to saying, hey, we're doing some maintenance. So they immediately called us and went, this is something you should never see, is an emergency root volume not working properly when the nodes came back up. So they actually, to their credit, it's one of the reasons I enjoy working with the NetApp hardware, they called us immediately and said, hey, what's going on? How can we help you? What broke? We filled them in We gave them a VDI to make sure that they had WebEx into the environment, and they started working and looking at how they can help us while we were bringing up our environment on the other side of that screen. They waited for about 4 hours. They did their research, they did their logs, and they found out that, as I had mentioned earlier, we had a strange issue of firmware versions on top of your OS versions being kind of funky. They said that this can be fixed with a workaround, which we then did. I'll show you that in a minute. And then they said that they also wanted to check our other prod facility and make sure that wasn't impacted. And it was to be fixed at a later date. So we now know that we had to fix that. So they were very, very helpful in working with us and being there when we needed them. And so we had, so we had the DIM, we had the panic, we had the root vol issue when it came back up, and NetApp did a quick give back once they did the thing. And here is the actual item that is the problem. The counter on the membership report sent, in our case, was above 1,000. And then our production facility, one node was affected and one node was not for further RCA. So that is the horror story that we have of an entire DR facility going down and being brought back up within 4 hours. If you have any questions, comments, or concerns, I hope you enjoyed your beer over my story, and I can be reached at the following information. So thank you very much, and enjoy the rest of VMworld.
Hello, everyone. My name is David Santos. I'm an NSX engineer, and today we're going to talk about some troubleshooting tips and tricks to NSXT. So to start, what we have in the box for in the NSXT box that help us to troubleshooting when we have some problem or we're facing some issues with the solution. We have syslog that we can send logs to either login site or other log solution. We can have multiple syslog servers configured to NSX, so it works really well. Also have traceflow. That's a powerful tool where you can select like the source and the destination workloads, and check the path between those two workloads. Also topology map, that's something new in 3.0, where you can see like all the segments and T1s and T0s that we have configured in our network. Container inventory, so in 3.0 we can also check the clusters that are connected, the Kubernetes cluster that are connected to NSX. Also, what are the namespaces, configure them, and the containers, the labels, and everything. Also, the ingress rules. Mirror, either logical span or ER span. They are really useful for troubleshooting. IPFix and VRNI, that's got better in the last version, and latency. So the latest part is really nice. It's really useful when you need to check if the communication between two any transport nodes are working fine or not. So for each one of those topics, I have a video here. The first one is the integration with login site. So this integration is native. So when you integrated login site with NSX, it has a content pack that brings all those nice charts to login site, and also it has all the rejects done. So here this these blue words here are called extracted fields, and they are the log parsing. So it helps login site to index all the unstructured data that we received in a syslog format, and index that to easily search for an information, an event, an error, or everything that happened in NSX or any other platform. The next one is trace flow. Here we have trace flow. So we're going to select a source workload that can be either a VM or a pod, and the destination workload that can be either a VM, a pod, or an IP address. In the case of an external IP address, you check the NSX communication up to the edge node. So you check if everything from the workload up to the edge node is working fine. In our case, we're gonna select a container as our source workload. Here it's a Deltaforce app, and we're gonna test the communication to web A. After the test is done, we can check here all the components that participate in that communication. Here I have the pod, the segment, T0, T1s, and also we have the hypervisor that are hosting that pod or that workload. Something that's nice is that we can see here the IP address of that workload, of the hypervisor, the management IP address, and also the hypervisor version where is NSX installed. The other feature that was added to NSX 3.0 was the topology mapping. So the topology map is something that's really helpful to understand the NSX topology and what's connected to what. So here you can see that we have our T0. We can download the routing table, the forwarding table, check what's the BGP neighbors, also the T1 configuration. When you have multiple segments connect to the same T1, we're gonna group them, and also we can ungroup them to see what's connected there. Here we have a segment Deltaforce that's being used for 4 pods. We can also check the labels that those pods are using, and we can export that to PDF, and also have a mini map here that is really useful to look to search something really quick. Topology map, it was something that people was asking a long time ago, and now it's happening in NSX. So I'm a really fan of that. Containers inventory, it helps a lot to figure out what we have in the Kubernetes cluster that are being used. That it helps a lot to cross-reference what you have in Kubernetes and also with what you have in NSX, and it helps to create firewall rules and check what are the rules, the ingress rules created in NSX. So here you can check the containers and the clusters. In this case, we have 1 cluster working and 2 clusters that are not connected. And we can check that there's 3 nodes in each one in that cluster. We can look for a specific namespace like Deltaforce, and we can check like the ingress rule. We can check what has been configured for load balance. In this case, we have a URI rule that's balancing /app and /web to our pods. And also we have here the SSL offload that has been configured. We can also check here the pods that are connected to that namespace, and also the service. In this case, we have two services, web and app, and also all the segments T1, T0 that communicate, that are being used for that Kubernetes cluster. Other thing that's available in NSX also is the port mirroring. We have two types of port mirroring in the simplified UI. We have the L3 span and also the logical span. The cool thing about L3 span is that we can mirror the whole segment. In this case, we're gonna mirror a segment that's being used for a container, and we're gonna send that traffic to an external IP address using GRE. In this case, I'm sending that traffic to my desktop computer that has external IP. Here I'm gonna start Wireshark and do a little filtering here to get only the pod network. I'm gonna generate here some traffic, 172.26, and after generate some traffic here, I can check all the communication in that network that's really useful for troubleshooting and to check if everything is fine or not, if why some application is not it's not communicating with another. So it's something really useful and really helps when you face a problem with connectivity. VRNI, in the last version of VRNI 5.2, we have a new dashboard, an SXT dashboard. It's providing a lot of useful info for NSXT. So here in the right side, we have the topology, the NSXT topology, with all the controllers, managers, and also the nodes, the transport nodes. And when you click in a transport node, we can check the traffic that's going, that's ingress traffic, egress traffic, the latency between that transport node and other transport nodes. Also the traffic that's being received, the traffic that's being dropped, and also the usage, the disk usage, CPU usage, and memory usage. And so it improved a lot. Something that is really cool about this dashboard also is we can check here how many VMs are hosted in that host. What's the transport zone that is being used, the IP address, the management IP address, and also if everything's fine, like what's the connectivity status to the management plane, to the control plane, and there is a lot of other nice metrics here that help us to check if everything's fine with NSX or not. Also, NSX, the new version, I think it started in 5.1, and also in 5.2 we'll have the dark mode. Dark mode sometimes is helpful for people that likes dark screen, that don't like clear screen. So it helps too much, especially when you are in the front of the computer the whole day. So in the Kubernetes integration, these dark modes got really cool because there's a diagram here of service that looks really nice. So here you can check like the namespace, the service of like that of the container integrated, the Kubernetes integrated VRNI solution, and here's the diagram of the service. So here you can check like all the pods that are configured to that service. And also we can check here the NSX that's integrated to that Kubernetes cluster. Also, if you have here like a connection to a physical device, and also like the firewall rules, and here the master nodes. So this diagram here really help us to check in a graphical way what's happening in the Kubernetes cluster. That's all I have. Thank you very much for watching, and see you next time.
Hello, everyone, and welcome to my webinar on taking the guesswork out of VDI troubleshooting for your work from home workforce. First of all, I would like to thank the vBrownBag team for putting this together so quickly, especially us having a stage set up last year to having a webinar this year so quickly and easily. In this particular webinar, I'll be talking about the VDI troubleshooting process, and over the past 6 months or so, especially since our pandemic started, we have been going through a lot of organizations have been moving more towards VDI to basically make their employees work from home. So in this particular webinar, this is the agenda. We'll be going over some of the main VDI complaints that we see on a day-to-day basis. What are some of the VDI components and their stress points? We'll be looking at a troubleshooting flowchart that we have put together in order to quickly understand where the issues could lie, and to have a systematic approach into troubleshooting a VDI performance scenario, a performance issue. And finally, I'll be going over a couple of examples to show you how you can troubleshoot an infrastructure or networking issue with regards to the VDIs itself. So let's talk about some of the major VDI complaints. So firstly, a lot of people, when it comes to VDI, they have issues with either login or if it takes too long to log in. So this could be quite a few, this problem could have quite a few fold. It could be something related to their LDAP authentication, Kerberos authentication. It could either be that there is some kind of congestion on those Kerberos or LDAP servers. Also, it could be something on the connection server regards. It could be something on latency. So there are a few different things that we can talk about in this perspective. But this is one of the complaints. The second is not being able to access the application, and the application crashes quite randomly. What that means is once the user is logged on to the VDI desktop, the mission critical application, such as the ERP system, the databases that they utilize to do and perform their job, it either becomes inaccessible or it crashes randomly. So this could be an issue either on the VDI side, or it could be something on the application side itself where there is very high responses. Thirdly, it could be sluggish user experience for the application. A sluggish user experience could be due to quite a few different scenarios. It could be the internet connection. It could be the home network. They could have multiple people using their home network, streaming Netflix or any other applications, especially in the work from home scenario. When you have multiple people in the same house working, it becomes even more harder to maintain a specific level of user experience. Next is the performance challenges during certain times of the days. During certain times of the days, there could be certain batch processes that you may not necessarily be able to find out in just one go, where one VM or one VDI desktop or multiple VDI desktops may end up having this particular issue. And lastly, you could just have random session drops. Typically, random session drops do not happen mainly because of some kind of a network-related issue where there's a complete network outage within the data center. That could be like a one-off scenario, or it could just be scenarios where a particular VDI desktop does not maintain connection. Some of the view agents inside the desktops probably crash or something of that sort. So there could be a few different scenarios with regards to these, with regards to some of the most common complaints that we have seen with regards to VDI desktops. So in this particular section, I'll be covering what are the most important VDI components and its response. But before I do that, I would like to quickly show you how people used to access C traffic before VDI and how VDI has actually made it a lot simpler. If you look at the bottom of my chart, you can quickly see that there are a lot of RDS traffic. So before VDI desktops became more popular, people used to RDP into their work computers and then access the application traffic from there. Similarly, when you're at home, you could RDP into your work desktop, going through a firewall, through a VPN, accessing the application from there. Similarly, if you wanted to access the application directly, you would use home VPN through the firewall and directly access your ERP servers, databases, and any other applications that you needed to. But with all this, there are definitely some security risks associated with that. And that's why VDI has gained a major popularity over the past few months, especially when security has been put in the forefront of many organizations, along with the ability for them to work from home. When it comes to VDI, there are a few different components that you need to be aware of. First of all, again, just like a regular VMware environment, you need to be aware that they all run on top of an ESXi host. You have multiple virtual machines or VDI desktops that are running inside. Apart from the VDI desktops, which are the most critical components, you have your connection servers, your security servers, and other components that are associated with VDI itself. You also have your on-premise applications that all these VDI desktops need to be able to access. Again, just like your databases, ERP servers, if it's a medical organization, any medical softwares and things of that sort. So you can quickly see all that. And similarly, when it comes to a remote workforce, they need to be able to access the VDI desktops from their homes, either using a public IP address that is set up on the VDI desktop pool or the connection server, or through a VPN that has to go, that will basically divert traffic through the firewall into the data center to look into the connection servers itself. So looking at such a complex setup, you can quickly see that there could be multiple areas where there could be potential stress. So let's take a look at some of these areas. Firstly, on the VDI desktops itself. On the VDI desktops itself, you can quickly see, you should be able to quickly see if there are any potential problems with regards to the compute, CPU, the memory related information. Are they spiking up? Is your GPU performing optimally? This basically helps in the user experience of that particular end user. Secondly, you want to see the ESXi hosts those VDI desktops are sitting on. Do those VDI desktops, do those ESXi hosts essentially have enough compute, enough storage, and processing capability to have the number of VDI desktops inside them? Thirdly, you want to see the connection between these VDI desktops to the application servers. Are there any network latencies between your VDI desktops to the application servers? Is there any application delays or application response times between the two? You would want to take a look at this to ensure that your application performance between the VDI desktop and the enterprise application is seamless. Next, you would want to see the traffic, you would want to see the VDI on-premise user experience when it comes to your thin clients that are inside the environment. So there could be any issues such as networking issues between the VDI thin clients to the VDI desktops itself. Another thing could be the firewall. The firewall could be blocking certain packets, could be causing packet drops that could impact the end user experience as well. And finally, you want to take a look at, for a remote worker, the most important aspect is the connection. There could be an issue with regards to the internet being slow or the home network being slow. So you would want to take a look at the network connection between the VDI remote user to the VDI desktop tool itself. So a simple troubleshooting flowchart would begin as you see over here. You would always want to keep your end user experience in mind when you start your troubleshooting process. You would want to see whether the issue is due to a network response time or an application response time. See, if it's due to an application response time, you would want to see the VDI performance. The VDI performance can be split up into a couple of different things which you would want to troubleshoot, which is either the VDI session setup or provide you with the desktop activities and resource provisioning. So desktop activities include all the different processes that are running in that particular VDI desktop. And once we understand all that, we could provision the resources accordingly. Second, when it comes to application response time, you would want to look into both their application dependency maps to basically see the flow of your enterprise applications. As you know, most of your enterprise applications are multi-tiered. So you would want to see if there's an issue in the database, the web servers, and so on to quickly troubleshoot any problems. Next, you would want to see any transaction analysis. Are there any particular errors that are taking place between the different queries when it comes to the application response times itself? When it comes to the network response time, there are a couple of things to look at. One is to look into the north-south traffic within the environment to quickly see if there are any bandwidth limitations, any band link issues between your north-south traffic, and also see if there's any network switch or router related issue with regards to traffic diverting to the internet. Secondly, with regards to the LAN east-west traffic, you would want to make sure that you have adequate east-west traffic visibility so that you can see all the connections between your VDI desktops to your application servers, or even between the different VDI desktops in between different hosts and things of that sort. And finally, you would also want to see the network edge performance to see if there are any particular issues with those remote sites within your environment as well. So this would be a very, very simplistic troubleshooting flowchart to quickly see what's going on within your environment. So in this, I'll discuss a couple of scenarios where there are infrastructure challenges. First, in order to see if there's any infrastructure challenge, monitor based on the different VDI desktops and quickly see if there are any issues in your compute, in your storage related information. And in this particular case, you can quickly see that there is some memory health related issues for a particular VDI user. Second, once you identify those memory related issues, you can drill down to see the level of spikes in each of those VDI desktops and the resource constraints and challenges that they have. Finally, once you have all the resource constraints, you can drill in and try to find out what are the different processes that are taking place within the environment. This could be done using either a specific tool, monitoring tool, or you could also use, you could also drill into the OS from the task manager as well to get this level of data. Next, a scenario to look into some of the networking challenges. First of all, when you want to view your networking challenges, you would want to visualize the end-to-end dependencies for applications, right from the thin clients all the way to the databases of the applications itself. Once you get that information, you would want to see what are some of the issues. And in this particular case, you can see network response time is higher than usual. So using this, you can isolate the issues to the virtual network. And finally, once you get this information, in order to understand what is causing the network response time, you would want to isolate the issue further to see what's causing the issue. And in some cases, issues such as virtual packet drops can be the root cause of your high network latency within the environment itself. So once again, everybody, thank you for listening to my presentation. And I would like to thank the vBrownBag team for giving me the opportunity to do so as well. And if you have any questions, feel free to reach out to me on Twitter or LinkedIn. And my website is also listed down below. Once again, thank you very much.
Welcome to this vBrownBag session deploying SQL Server 2019 big data clusters on Kubernetes with Ansible. Today, we're going to explore one of the many different ways to deploy a Kubernetes cluster with the end goal of deploying a Kubernetes application, in this case, Microsoft SQL Server 2019 big data clusters. My name is Doug Bernhardt. I'm a senior principal engineer with Dell Technologies. I've been at Dell now for a little over 8 years, and I've been working with SQL Server for over 25 years. Storage is obviously a very critical component of a big data or database environment. So now my primary focus is SQL Server and storage integration. While I've managed to hack out what I needed in VMware to get the job done and learned a fair amount about Kubernetes, Ansible, and Linux along the way, my primary background is SQL Server. My journey to Kubernetes and Linux and tools such as Ansible was one of necessity. Since my background is primarily SQL Server, my main goal was to deploy this new application, knowing that I needed a Kubernetes environment, and it was prior to the release of vSphere 7 or even the beta. Therefore, as part of my research and trying to get a Kubernetes environment up and running, I found the method that we're going to cover to be very well suited to my needs. Over the coming days, you'll surely hear a lot about forward-looking concepts and what's new in vSphere 7. This session is not about that. We're going to walk through a basic deployment of Kubernetes that's on a very simple environment of good old ESXi and vCenter. Also, keep in mind that there are literally over 100 different distributions to Kubernetes, as well as various different deployment models. This is a deployment of open source Kubernetes, or what is often referred to as vanilla Kubernetes. To perform the deployment, we're going to use basic VM templates and Ansible open source playbooks. Finally, we will deploy a big data application, Microsoft SQL Server 2019 big data clusters. There are various use cases for this deployment method. Maybe you're not ready to go to 7.0 just yet, or perhaps you want a similar deployment process and tools for bare metal, cloud, and VMs. This deployment method is similar to what you might use to deploy on bare metal with a few virtualization twists. We've got a lot of ground to cover, and this session is a whirlwind tour. If you don't get everything, no worries. I have a link to a paper at the end of the session that covers everything in detail. SQL Server Big Data Clusters is a big data and AI platform that deploys a data lake in a box, as I like to call it, on Kubernetes by running a single deployment command. As part of that deployment, application components, including SQL Server instances, Spark, HDFS, and tools such as Grafana and Kibana are all deployed as Kubernetes pods in a single namespace. Since we're working with a data application and containers are ephemeral in nature, the deployment will dynamically provision persistent volumes, somewhere in the range of 28 to 50 or 60, depending on how large you wish to scale the cluster. Because we're working with big data, some or all of these volumes could be several terabytes in size. Knowing Kubernetes is required, I want to use vanilla Kubernetes. I quickly realized I needed to figure out a way to deploy, and this was prior to the latest offerings from VMware. My research quickly led me to different solutions using Ansible. For those of you not familiar with Ansible, a little background. Ansible allows for agentless automation. So you install Ansible, and it allows scripts or collections of scripts organized as playbooks to be run against one or more targets. One of the great things about Ansible is that the scripts are designed to be rerun without harm, if needed, to achieve a desired state. If the target is already in the desired state, then the scripts will simply find nothing to do. There are various modules available for all sorts of operating systems, cloud environments, and hardware platforms, and a very rich library of existing playbooks and samples that can be leveraged. In my case, I was able to find a couple of open source playbooks to accomplish what I needed, customize the parameters for my environment, and execute these playbooks for deployment into the Kubernetes environment, So let's take a look at that now. Here are the high-level steps for this process. First, you'll need to install Ansible if you've not already done so. Next, create a template Linux VM to be used as the deployment source for our multi-node cluster. In this example, I'm using RHEL as my OS. The important thing here is to find an OS supported by kubespray, which most Linux distributions are, and then to use an OS that is supported by the application, in this case, SQL Server Big Data Clusters. Also, in the template VM, you may wish to pre-pull packages that will be downloaded, install tools, etc. Next, Kubernetes will be installed using kubespray. Kubespray is a really cool tool because it not only automates the deployment process, but supports a lot of different options such as networking types, cloud providers for storage, Linux distributions, and is therefore really customizable by just changing the config parameters. Finally, we can deploy our application, in this case, SQL Server 2019 Big Data Clusters. Now that we've covered the steps, let's quickly walk through a demo of this entire process. The first thing that needs to be done is to build a template to use when creating the cluster VMs. This will be used as a consistent starting point for all of the VMs in the Kubernetes cluster. It's a process that most VMware users are familiar with. You create a VM in the state that it will be the starting point for your VMs in the cluster. Then you shut it down and convert it to a template. Some tips for setting up the VM template. If you take away one thing from this session, it should be this. When working with Kubernetes and vSphere, make sure to set the disk enable UUID property to true. The persistent storage driver uses this to identify storage resources, and if this is not set, persistent storage provisioning will not work, and the errors may not be clear as to why. When you're finished with the template configuration, after you shut down the VM, remove the network adapter. The deployment scripts will add it back and configure it, but they may not work properly with an existing network adapter. Since setting the disk UUID property is so important, let's quickly run through how to do that. Select a VM, in this case the one to be used as a template, and go to Edit Settings, VM Options, and then click the Advanced section and choose Edit Configuration. Here, choose Add Configuration Params and enter disk.enable UUID for the name, true for the value, and click OK. Once the template is ready to go, you can deploy the VMs using the VMware Guest Ansible module. First, you'll need to install Ansible if you don't already have it somewhere. It's agentless, so you just install it on a machine that has access to everything you wish to automate. And as I mentioned earlier, Ansible has several modules that know how to communicate with various infrastructure components. Using this module, you can start with an existing playbook or write your own. I happen to find one to start with on GitHub that you can pull down as a starting point and simply customize the parameters, so that's what I'm using here. The way this playbook is written, I have two configuration files, one with the common settings and one with the settings for each VM. In this case, I'm using a file called answerfile.yaml to specify the VMware environment settings, as well as some common VM settings. As you can see, there's a section for my vSphere environment specified, as well as all of the common guest settings. In another file, I specify the settings for each VM I want to deploy. Ansible has a concept of an inventory file, which is a list of items to configure. In this example, the inventory file is called VMs to deploy. In here, I'm specifying that I'm going to build 5 nodes, 1 master and 4 workers, giving each its own name, IP, and notes. Now, running the command Ansible playbook and passing in the inventory file and the playbook name, this will deploy the VMs. Each VM was deployed as a task. The result is listed in the play recap section, where we see that each VM has a status of OK and changed equal to 1, showing that the deployment changes were applied. A properly written Ansible playbook can be rerun without harm. So here you can see where I reran the script and it just simply came back with everything OK and changes equal 0, so no changes were applied. Now that the VMs are deployed, the Kubernetes cluster can be deployed on top. In this example, I'm using kubespray, which you can read more about on the Kubernetes website, and pull the source from the GitHub link listed here as well, but it's the same idea. Pull down a set of playbooks, customize for the environment, and run. The biggest difference here is that since kubespray offers several different options, There are a lot more parameters that can be specified, but it's still fairly straightforward. First, we need to build the inventory file. This is what the inventory file looks like. We're specifying the names of the Kubernetes nodes as well as the connection information. So this file needs to be updated with the info for all the nodes of the cluster. Next, you need to configure the persistent storage, which in this case, we're using vSphere data stores. This is all done in the all.yaml file, which you can see here in the center of this file is the cloud provider and is set to vSphere, as well as the vSphere credentials and parameters. From here, kubespray will deploy and configure the vSphere cloud provider. Note that this example uses the older in-tree cloud provider. vSphere CSI support was added about 3 months ago to kubespray, so you may want to look at using that instead. But for now, this method works just fine. Depending on what other Kubernetes features you want to modify, such as the overlay network, Kubernetes version, etc., these values can be specified in the other configuration files as well. Just look at the documentation to find the location of the feature that you wish to change. Finally, we run the Ansible playbook command above, and it begins deploying the Kubernetes environment. This is a rather lengthy deployment because it does a ton of work. In my environment of 5 nodes, this takes around 15 to 20 minutes for this process to execute. Once the deployment is complete, the Ansible play recap shows all of the changes that were applied. The final step before deploying the application is to create a Kubernetes storage class. This references a storage provider installed with the cluster, and it points to the data store we wish to use as well as the file system. Here's an example of the storage class definition, and it's created using the kubectl command. Now that the cluster configuration is complete, we can deploy our application, in this case, SQL Server 2019 Big Data Clusters. At this point, the hard work is done, and it's just a matter of following the Microsoft documentation on installing VDC. Because the Kubernetes platform abstracts the infrastructure details, the deployment of BDC is pretty much the same process regardless of the Kubernetes environment. To deploy BDC, we install and run the AZ Data utility provided by Microsoft. This will deploy the entire cluster into a namespace consisting of several pods, services, and persistent volumes, which are dynamically created based on the storage class we provided earlier. As the deployment progresses, you will see various progress messages as the various components come online. After all the components are deployed, the cluster deployment will be complete. At this point, the entire deployment is complete and the big data cluster is ready for use. Now you use Azure Data Studio or your tool of choice to connect to the cluster at the cluster endpoint that is provided here during deployment. The call to action from this session: get more familiar with Ansible if you don't already know it. It's a great tool for configuration and deployment and something super handy to have. Also, deploying Kubernetes with kubespray is a great way to learn about all the various components that make up the Kubernetes environment, and it can be used with physical, virtual, and cloud. This is just one of the many different ways to deploy Kubernetes. Each one has its own personality in terms of tools, ecosystem, and integrations. There are full details of today's demo in the Dell EMC paper mentioned here. This paper is on our new Dell EMC PowerStore appliance, but the steps can be applied to almost any VMware environment. Finally, enjoy the rest of the VMworld presentations. There will be lots to come on new Kubernetes features and capabilities in VMware, specifically around vSphere 7.0 features. This concludes this vBrownBag session for today. Thank you very much for attending and have a great day.
Hello, everyone. My name is David Santos. I'm an NSX engineer, and today we're gonna take a look on NSXT 3.0 and what we can do with that. So NSX 3.0 has 3 main use cases, and we're gonna talk about each one of them. The first one is automation. As automation, we can understand that as network virtualization. So create like logical suites, logical routers, logical firewalls. We can like create those on our virtual infrastructure, or align with a broader automation strategy with VRA, VIO, or like Kubernetes. The second use case is security. So increase the security posture inside the data center, applying security rules to the east-west traffic, or like to the traffic that's coming in and out from a VM or a container. And the third use case is the business availability. So NSX can stretch the data centers and easily provide like multi-site architectures and disaster recovery strategies. So we're going to start with the first use case, that's automation. The benefit of NSX for automation is that it's a single endpoint for network virtualization. So here in the left, we have like VRA, VIO, vCloud Director, Kubernetes, Terraform, can also have Ansible and other platforms. And those orchestrators will deploy VMs and containers. However, for those workloads to communicate, we need to also provide networking. So NSX will provide layered firewall, security, network connectivity, routing, and also load balance. The other thing that's really good about NSX is that it also has governance among all those objects. So when it creates a logical suite like a layer 2 network, it will know what's connected there, and when the workload is removed, that connection is also removed, and together with all the firewall rules that belongs to that object. So this way we can control the life cycle of like a workload or like any application. To start with automation, we do our Hello World in NSX. In this case, the Hello World is a layer 2 network. We're gonna create a logical switching, and we're gonna connect 2 workloads here, Web 1 and Web 2, and we're gonna do that in the NSX UI. Here we are in the Web 01. We're gonna try to communicate to Web 02. The communication doesn't work, so we're gonna create a new network called Web, and create that on NSX in NSX UI. After that, we can go to vCenter and connect both workloads in the same network. The network will be available in NSX UI, and we just need to consume that object. After connecting both VMs in the same network, the communication works. So we have layer 2 connectivity between Web 01 and Web 02. The next step is the routing. So the communication between workloads connected in different subnets. To do that, we're going to use an object called T1 gateway or T1 router. It will be the defaultator for each one of the segments that will be created in NSX. T1 gator or T1 router are kernel-based routers. So they're going to be distributed routers that will work at the hypervisor layer. This way, we're going to have the same IP address for routing, like in all networks, in all the hypervisors that are part of the NSX domain. In this case, we're going to create a T1 gateway that will be the defaultator for segment web and also for segment app, where we have the app 01 VM. Here we are again in the web 01, and we're going to start to ping the full gateway. We don't have a T1 gateway yet. We're going to create the T1 called T1 vBrownBag. After creating that, we just need to configure that as a default gateway for our web network. Here I select my T1 and I choose the IP address that will be the default gateway. After configuring that, I successfully can ping the default gateway, and I will start to ping other network, in this case, the app network. I'm gonna configure that network to use the same T1 gateway and configure the IP address. After that, we also have connectivity between web and app in a router basis. After that, we need to figure out how this virtual network will communicate with the external world. So to do that, we're going to have a router here called T0, and we're going to connect the T1 with T0, and here we're going to share the routes using a mechanism called routing plumbing. This will automatically redistribute the routes that are connected, and also can redistribute the routes that from NAT and for load balance for VPN, and also can create route maps to select which route we're going to redistribute automatically to T0. And after that, the T0 will redistribute, will exchange routes with the physical router using BGP. In this case, I will try to ping my web 01, and I can see the ping doesn't work. So I'm gonna access my T1 gateway, connect that to T0, and select the connected segments to be redistributed. After that, I can ping my web 01 successfully. The next step is the security. So the security part we can use with overlay or not. We can deploy a security posture in the environment, like in the data center, even without using NSX overlay, which means that we can deploy that using a regular VLAN. In this case, we have like two VLANs here. We have the VLAN 100 and the VLAN 200, where we have vSphere workloads, also KVM, Kubernetes, and some bare metals here. So what NSX will do, it will deploy element called DFW. DFW is the distributed firewall of NSX, and it will take a look, actually it will enforce the security posture at the VNIC level or in containers at the CNIC level. This way, if you have like a communication that's not allowed, you will block that communication at the nearest point of the application. In the case of a pod, it will block in the pod port. In the case of VM, it will block at the VNIC. It will also can in our environment, we will deploy a security rule that will block the communication between web and app, and you will allow the communication of like HTTP. Here we are at the web 01, and we're gonna ping the web 02. The communication works successfully. We also can do an SSH, and you can also access that using curl. So here I have the our distributed firewall. I'm gonna create here a section called DFW vBrownBag, and I'm gonna include some rules here. So here we're going to create a new security group. This security group will be called Web vBrownBag, and I will select the members. So I will select the members based on VM. I also can create like dynamic rules to include the members dynamically. This way I did it manually, so those VMs will be statically belong to that group. And I'm gonna create also two other rules here, allowing HTTP traffic either in L7 and L4. And something that's really nice about this UI is that it has a drag and drop, and it's a HTML5 drag and drop, and it works really well. So here I'm allowing the HTTP for L4 and L7. And after that, I can try to ping the communication. It will be prohibited. And if I try to do also an SSH, it will be prohibited. However, the web application still works either from inside or the outside world. The next step is business continuity. So we can use NSX to extend our data centers and easily deploy a disaster recovery strategy or a multi-site strategy. In this case, we have two clusters here, cluster A and cluster B, and they are different clusters. In this case, we're using the same vCenter for those clusters, but they can be different vCenters. In the version 3.0, I think we can integrate up to 16 vCenters to NSX. And so having the work like the processing, the hypervisor layer identical, you're gonna use the NSX to provide L2 connectivity between the data centers. This way, you only need to do a vMotion to have that workload running in the other data center, and all the network parameters like IP address and DNS entries or DFW rules will be maintained in the second data center. For north-south traffic, in this way, we are using like an active standby where we have edge node for T0 active in site 1 and a standby node in site B. To do that, this way you have a maximum latency of 10 milliseconds. If you have less than 10 milliseconds, we can use that. Otherwise, we need to provide other kinds of strategy for north-south. And also, the edges are exchanging BGP with like the physical layer. And once the edge node edge node 1 got failed, the site B will start to use the edge node 2 as active, doing BFD. So BFD allows the fast converse between fails. What we're gonna do for our testing, we're gonna start a ping to Web 01, and after the ping, we're gonna do a vMotion and see how the L2 stretches across sites. So here I'm doing the ping to Web 01, and I'm gonna to migrate my Web 01 to the site B. Here I'm gonna select the host in site B that I want to host that VM now. In this case will be Web 01. The network will be the same. And after the vMotion, we can see here that the vMotion worked successfully and the communication didn't stop. that's all I have. Thank you very much, and see you next time.
Hello, welcome to the vBrownBag with Dell Technologies. Today, we are going to talk about PowerProtect Data Manager and how to protect your Kubernetes environments on VMware. Hi, my name is Nivas Iyer. I'm the product manager here at Dell, managing the data protection for Kubernetes and cloud native solutions. So the Dell EMC PowerProtect Data Manager is an enterprise-grade data protection for your Kubernetes, the virtual machines, and applications. So it's a single platform that provides a protection for your entire environment. It provides you with a management for both the enterprise IT teams and also for the cloud native administrators. So both of them will be able to simultaneously work and collaborate on a data protection. And finally, it is built using in collaboration with Velero, and it encompasses a cloud native architecture, and we support the Kubernetes community. So you have one protection experience to back up your entire VMware cloud environment and the cloud native storage with PowerProtect Data Manager. So just to give a quick pictorial overview, so regardless of whether your applications like Oracle and SAP, if they're running on bare metal servers, like on operating systems, or if they are virtualized environments like your Microsoft Exchange server and SQL server, or your containerized applications running on Kubernetes, such as MongoDB and MySQL, you can protect all of them with just one product. So this is the first and only enterprise-grade protection solution for virtual machines, applications, and Kubernetes. And we are really excited to talk about it today. So just to give a brief overview of PowerProtect and our integration with Tanzu. So currently we can support VMware Cloud Native Storage. So what that means is when you have a VMware a storage environment with Kubernetes running on top, and you're leveraging the VMware Cloud Native Storage that's exposed to the Kubernetes environment, we can protect those using special APIs that we have worked with VMware. Secondly, you can run either your Tanzu Kubernetes Grid, that's TKG, formerly known as Essentials PKS, or your TKG Integrated or TKGI solution on the VMware environment, or any other Kubernetes environment such as OpenShift or Anthos that leverages VMware Cloud Native Storage on the VMware environments. You can protect it using PowerProtect. So technically, any distribution of Kubernetes that can leverage the VMware Cloud Native Storage can be protected using PowerProtect Data Manager. And here's the exciting part, right? So we are currently actively working on with VMware to protect guest clusters. So what that means is when you have project-specific based environments, so which allows you to create these special namespaces that allows you to run Kubernetes and virtual machines and native around the Q4, and we are actively engaged with VMware to protect this. So this gives you a very integrated solution. So for your IT, as your IT team is moving to project specific and you need another feature that we currently have with our current PowerProtect Data Manager releases, you can protect your AWS workload, and that allows you to protect all your Kubernetes environments and containers running on EBS, which is the AWS block storage, and you can protect them directly to DDB. And the good part is that the PowerProtect Data Manager can run inside AWS, or it can be, technically it can run anywhere. It can run on your on-prem environment. It can be on another private cloud. Doesn't matter where the PowerProtect Data Manager runs. It can run and manage your entire AWS clusters from virtually anywhere. Now, this brings up to the challenges that we have. Now you have multiple Kubernetes environments. As we see, a lot of organizations today having multi-cloud solutions. If you have multiple Kubernetes environments running on-prem, maybe on VMware or on AWS or on Azure or other cloud vendors, and then you want to replicate data across all these clouds, that's a huge challenge. I mean, it reminds me of the scene from the 36th Chamber of Shaolin, one of my all-time favorite kung fu movies, and in which scene the hero has to carry huge buckets of water across a very thin, narrow bridge with knives attached to this, armpits. And that's very similar to the pain that we are currently seeing, the IT teams having to move S3 buckets or like huge amounts of data across different clouds. And without an efficient deduplication, a compression, and efficient replication, you are essentially transporting huge volumes of data across multiple clusters. So what this will do is going to cause delays in terms of hours, weeks, and months to replicate. When you're talking about petabytes, maybe terabytes of data, you'll be unable to meet the SLAs. And finally, the egress cost equivalent to the knives on the armpits, right? So they're going to cut you, and they cut your organization budget. So what you need is a very efficient solution that can help with replicating data across the cloud. And that's the challenge that we have undertaken as part of our solution. That with PowerProtect Data Manager, we are hoping to today manage multiple your Kubernetes environments across multiple clouds. As we talked about, we can currently support vSphere. We can support AWS today. We are adding additional capability to support other clouds pretty soon. And also we are allowing the capabilities to support a diverse array of protection storage, which includes your data domain, the object store that you currently have, or data domain virtual edition. And all of this combined to allow you to replicate across sites, tier to object, and to support secondary use cases. So regardless of where your Kubernetes environment is, whether it's in the data center or the cloud or the edge, we can protect all of them and provide synchronized enterprise-grade policies, providing dedupe and compression, application consistency for a wide range of databases in the Kubernetes cluster. In addition, providing replication, cloud tiering, SLA compliance reporting, and also centralized, and most importantly, a centralized protection for not only your Kubernetes environment, but also for the VMs and apps. So all in all, this is a complete package to protect all of your enterprise needs. And here's a quick look at the architecture for how we are going to protect your Kubernetes environments on VMware, right? So with PowerProtect Data Manager, when we discover clusters, we install a couple of namespaces. So there is the Velero namespace here. Velero, again, the open source solution, currently sponsored by VMware. And when we have a PowerProtect namespace, which is our components that we have developed here at Dell. And together, we will be protecting our applications. And we take snapshots using the VMware's exclusive partnership that we have with VMware to take cloud native storage or FCD snapshots. So what this results in is you get incremental snapshots, not like full snapshots, and all of them highly deduplicated and compressed and highly efficient to move it to your backend storage. And that's easy. So now you have, instead of having huge volumes of data, you're having very small amounts of data being protected back in your protection storage, so your footprint doesn't grow. And all this data can be easily replicated and migrated across multiple clouds or wherever your digital transformation projects lead you. So I'm really excited about talking about our PowerProtect Data Manager and our product and journey. For additional details, please visit our website. And thank you for watching.
Hello, I'm Patrick Kramer, a staff cloud solution architect on the VMware Cloud AWS team here at VMware. And I'm here to talk to you about skills modernization for the virtual infrastructure admin and modernizing your skills using a VMware open source product called VEBA, VMware Event Broker Appliance. A little bit about me. I am a pre-sales SE now. Started at VMware in 2014. I've been working with VMware products since 2006, the 3.0 days. I've been primarily a sysadmin for most of my life, very limited programming background. And again, I'm a solution architect now selling VMware Cloud on AWS. Why would you want to modernize your skills? Obsolescence, right? We've all worked with floppies, at least those of us who've been around as long as I have in the industry. And I have spent many, many hours of my life staring at this Norton Ghost screen, cloning drives for servers and desktops. But those skills aren't in demand today, right? That doesn't help. So you have to modernize your skills. You have to keep with the times to keep yourself relevant and employable. So since 2006, I was doing all system administration. It was all system administration all the time. Virtual machines, your classic 3-tier apps, and started off doing physicals, and then virtualization came in, which really virtualization was the same work as a physical, but it was just an easier way to do it, right? Virtualization came with the ability to clone VMs. You couldn't do that easily with a physical, except with Ghost, but it was a lot faster in the virtual world. Kind of the same job. And my programming skill really was all scripts. So I went and looked at one of my old directories preparing for this presentation and found that I had amassed 440 Power CLI scripts, all of maybe 10 or 20 lines each. And that's what I would do. I'd go out to the internet and I would find a script that did something close to what I wanted and hack around and get the Power CLI to do what I want, with just little chunks and snippets of Power CLI code to do what I wanted. So we'll talk about 2013, VMware launched NSX, and just like when you were doing virtualization instead of physicals, this was networking. It's the same networking that we already knew. It was just a slightly different way to do it. And now we're in 2020, and we have all of these developer words. There's Kubernetes and Docker and microservices and containers, and what makes it difficult for people who come out of a system administration background is we're not learning how to do things in a different way like we were with virtualization, like we were with NSX. It's a whole new profession, and that's why it's so tough, and that's why it's so hard to get started. If you take a look, this is from CNCF, the Cloud Native Landscape. Like, this is a lot to understand when this isn't really your profession, when you're coming into this not really knowing even the basics. It's really overwhelming. So the question is where to start. So I started, and I'm proposing to you that maybe you can start too, with the VMware Event Broker appliance. I am not good at learning things just to learn them. I need a project. And the VBA project is event-driven automation for vSphere. It's an open source project. It uses Kubernetes, which I don't really know, but I'm gaining skill in it. But I'm learning Kubernetes in the context of something that I do understand really well, which is Virtual Center. So if you look at vCenter automation today, when anything happens in Virtual Center, you have an HA event or a data store gets full. You have the same 3 alarm actions that you've had since like the beginning of time. You can send an email, you can send a trap, or you can run a command. It hasn't really changed since vSphere like 3, right? And it's limiting. You can just do those 3 things. And what VBA does is it actually reads vCenter events and can react to them. And you can write code in arbitrary programming languages. And there's a whole set of functions that are built in to do different things. A lot more than just send an email, right? Run a script, send an SNMP trap. For example, out of the box, one of the functions built into VBA is maintenance mode alarms. So how many times have you went to update a host, pop it into maintenance mode, go to reboot it, and you get a bunch of emails saying the host is down? Well, of course the host is down. You rebooted it. So this maintenance mode alarm function, when you put a host into maintenance mode, it disables alarm actions. And when you pop hosts out of maintenance mode, it enables alarm actions. So just a very simple reaction to an event that happens in Virtual Center, but it makes your life easier. This other one out of the box that was contributed by the community This is an HA event notification. So when there's an HA event, your host goes down and virtual machines are booted on a different host. You get an email that tells you, hey, this is when the virtual machines were restarted. Here's a list, and here's a date. So that's just a couple examples of functions that are there out of the box. It can do a lot more, but those are examples of what's there. So how did I get into this in the first place? Well, I needed to send notifications out of VMware Cloud and AWS, and because of security permissions and the way VMC operates, it's not possible to get into that section of vCenter. And one of the product managers told me, hey, there's this new VBA open source project that might be able to help. So I'm like, okay, I'll take a look at it. And first it was, hey, download an OVA, which, okay, I can do that. I've done that a lot of times. And then I'm reading what to do. And step one is clone the repo. Like, what does that mean? I don't know Git. I don't know any of this stuff. And then it's talking about stack.yml. I didn't even know what YML was. I now know it's called YAML. And then there's JSON. I'd heard of JSON, but I'd never used it. So it's using foreign terminology. I didn't really know what to do. So I thought, okay, I'll look at this YAML file. So it's just a config file. So this isn't too confusing, just a text config. And then I read, oh, you need Docker to be able to deploy this. And I thought, okay, I'm just going to log on to this VBA appliance and I'll look around and see what I can find. Well, all I found was a bunch of stuff called containerd and kube. And I'm thinking, where's Apache? Where's Nginx? Where's like MySQL? Where's the stuff that I know and understand? Well, it's not there because it's containerized. And so I sent back to product management. I'm like, yeah, Viva's a developer's tool. I can't use this. And the next day, William Lamb, who I'm sure you all know from all of his community work, he's like, yeah, it's actually targeted at virtual infrastructure admins. And William spent about an hour and convinced me, this really is in your skill set and you should give it a shot. So I said, okay, I'm going to give it a shot. And I'm going to blog about it because I learn better when I go into it with the intent of not only learning it, but I'm going to teach it to somebody. So I started off and I deployed the appliance and I blogged about it. And it brought me into this open source world where all of these really hardcore developers are working on this product, and then there's me. So you want to talk about feeling like an imposter out of the gate? Take a look at this. So this is a screenshot of various people on the project. This is their GitHub. And every time you see green, that's a day that they contributed code. And the darker the green, the more code they contributed on that particular day. So, 374, 258, 413 contributions in the last year. And there's me, right? Nothing. But what I wasn't prepared for is just how helpful they were. Every single person on this list has helped me. They all want the project to be successful. People who contribute to open source projects, they want them to be successful. They want to help. They've helped me in Slack. They've helped other customers in the public Slack channel that we have for this project. And it really is a lot more welcoming than I think some of the initial fears that I had are, right? And I think a lot of people are nervous. And when you start to learn just a little tiny bit, using the right tools, don't list off the process, use kubectl commands. And I started to learn, okay, containers run code, pods are a group of containers, and they're organized into namespaces. And suddenly things start to make a little bit more sense. And pods have logs, so I can actually tail a log file the way that I'm used to doing on a Linux system. That all works. So really, 2 days after I started kicking around with this stuff, I found a typo, one typo in a README file. And I was able to fix it with a little bit of help from the people in that Slack channel. So I fixed it, and I committed a change back to the open source repository, and there we go. A couple days after I started, I was able to contribute to an open source project. And, it was just one character typo, but I was able to do it. So then I did some more, and you can see, well, I've amassed, not too bad for a non-programmer. I've contributed 34 times in the last year, and I've been able to put code into an open source repository. And the blog series grew. So I blogged on how to deploy code, and I blogged on how to get a function into the VBA, and I wrote about how I got my laptop ready to deploy code, and a bunch of stuff on Git commands. And over time, over the past 8 or 9 months, I went from writing documentation, and I updated some more documentation, and then I contributed some Power CLI. And then I did a little more documentation. So I've kind of jumped around and jumped into areas of the program that made sense to me and were easier for me to understand. Maybe the biggest thing that I did right here is it's a checkbox. It's just a simple checkbox, and it auto starts SSH when the appliance comes up. But I never could have dreamed of being able to edit something on an OVA deployment screen and actually have that impact the installation of an open source product without getting started fixing a typo in December of 2019. And if you really look at what's behind the checkbox, it's not that much, and it's something that most of us who've spent any time in Linux will understand, right? Right at the top, it's just a little bit of shell scripting. And in the middle, it's just reading a property. Now, do I know off the top of my head exactly what all those commands do? Not really. I did the exact same thing that I did with all my Power CLI. I stole it because it was already done on another property. So I just pasted that in. And the bottom too, it's just a copy and paste of properties that were already there, and it's just simple markup. So it really wasn't that complex once I got under the hood, and I was able to use existing experience and apply it to a new thing. So if I've inspired you, maybe I've piqued your interest, come check out VBA, and if not, think about finding an open source project that interests you, and go ahead and get out there and start helping. If you want to check out VBA, VMware Event Broker IO, the website, the fling's there. You can check out my blog post on it and learn a little bit about how to contribute and how to use VBA. And there's a public Slack channel too if you want to talk to the development team. All right, thank you.
Hello, everyone. My name is David Santos. I'm an NSX engineer, and today we're gonna talk about the NSXT 3.0 integration with Kubernetes. So this is the last CNCF survey from the last year, where Kubernetes users talk about their experience with Kubernetes, and also what they think that are the biggest challenge to use that solution. In this case, we have here the first one is like culture change. So the way that we deploy in Kubernetes is a little bit different than using other platforms to develop. And also they have some challenge with security, complexity, and monitoring network. And from like the 6 major issues here, we can use NSX to address 4 of them. That's security, complexity, monitoring, and training. And this session, we're going to cover these 4 challenges here and also see how we can use Kubernetes in this integration. So Kubernetes use something called Container Network Interface, or simple CNI. And this allows that some vendors like VMware develop a third-party plugin to integrate with Kubernetes and deliver network. And NSX use this integration behind as the integration with NSX will be done by a component called NCP. That's the NSX container plugin. So in the left side we have Kubernetes, and in the right side we have NSX. And to do this integration, we're going to have here in the middle the NCP. NCP will talk API with Kubernetes and talk API with NSX. NCP is some containers that run, and the Kubernetes cluster will have some containers, some pods actually, that run in the master, and also others that run in the workers, and they will exchange, like they will translate the Kubernetes language to the NSX language. Basically is what NCP does. So in Kubernetes, we have namespace, and when NCP figures out that there is a new namespace in Kubernetes, it will tell NSX that a new namespace was created, and automatically NSX will create a segment to host that namespace, and also all the routing that's needed using a T1 gateway. And if it's a netted network, it will create also the net rules. We also have the pods that will be hosted in that namespace and will be connected to a network, to a segment. So NSX will create a container interface and will connect that container interface to that segment, providing also the IP address to that pod and everything that's needed to communicate. Here in Kubernetes, we can deploy security rules, like we can enforce our security posture using a network policy. In NSX, we're gonna control that using the distributed firewall. Here we have two ways of doing that. We can deploy the network policy using the Kubernetes CLI, and also we can create the distributed firewall rules in NSX that will be applied to the pods that are running in Kubernetes. So both ways are fine and work well. Also, we have the ingress for load balance, for L7 load balance. This way, when you create an ingress here, everything that's needed for that ingress work, the rewrite rules, and also the load balancing rules to the pods, to the pool, and also the inclusion of that pool and that pods in the pool. All of things will be done automatically in NSX. Also, the service, like if you do like a service, layer 4 load balancing, we also can use NSX for that, providing L4 load balancing for the pods. So to start this integration, we have Kubernetes that will deploy the pods, and NSX that will deploy the connectivity. So this way, NSX will be integrated to Kubernetes using a YAML file, and for everything that's created, it will deploy the firewall rules, the networking, the L2 networking, the L3 networking. Here we can have routed networking and also netted networking. We can also have the load balancing rules here and apply tags to everything. The way that tags work here allow us to create firewall rules based in tags based, and also load balance rules tag based. So when you tag a pod, when you tag like an application, automatically we include that pod or that application in a load balancing or in a firewall rule. So NSX will provide routing, switching, load balance, either L4 or L7, and distributed firewall, and also visibility. Visibility is something really nice that you can check, like the connectivity from like a container pod or a pod port to a database VM, and check the communication between them. If you have like a firewall rule that's blocking the communication or if the communication is working fine. So to start, we're going to create a namespace. The namespace will be created as cub control, create namespace vBrownBag. And this namespace will be created, and also the source net rule. So here we're gonna create the cubcontrol, create namespace vBrownBag, and here you can check the namespace was created, and also the, let me just zoom here a little bit, and also the logical suite that will host the containers to that namespace. So the next step is to create an application. So our application will be called vBrownBag Application Controller. We have here two sets of replication controller. One is the web and the other one is the app. So when you create that, we will create two pods of each one of the replica sets, the replication controllers. We're going to apply the configuration, and we're going to check here the container creation. After a few seconds, everything is created, and you can check here that they are also connected to my segment. We can check here all the four pods connected to that network, and everything looks fine till now. The next step is to create a service and an ingress. So the service will group like the similar pods in the same group, like in the same service. The same service will be shared for like the similar pods, and you're gonna do that using labels. And also we're gonna, in this case, we're gonna have a service called web and another one called app. And also we're gonna create an ingress rule to load balance the external traffic to either web or app based in the URI. So everything that's /web will be load balanced to the web service, and everything that's /app will be balanced to the app service. And also we have here our VIP, that's will be the external IP for that application. So we're gonna take a look in our service YAML file. So we can check here that we have two services, the web and the app. And based in the labels, we're gonna do the load balance. So here, apply the configuration for service. You can check the service. And now the ingress. So we're going to take a look in the ingress configuration, and here you can see that you have /web to the vBrownBag web and /app to vBrownBag app. I'm going to apply this configuration to our namespace vBrownBag. Kubectl get ingress. And here you can see that our URL vBrownBag.demo.corp.local is running. Here we can check the rules that match our regex for load balance. Here's the /app, and here you can take a look in the /web. Also the rewrite rule to /. And we can check if it's successful working, accessing our our URL. I'm using here a private certificate, and everything's working fine for web. Now let's take a look on app, and everything looks fine also. The next and last step for this demo is the microsegmentation. So based in the labels, we're gonna provide the security for the environment. So we're gonna take a look in our configuration file, in the replication controller YAML file, and then we can see that all the labels have also been applied to the pods. And here, based on those labels, our distributed file will enforce the security posture that will block the communication between web and app. We're going to take a look in the replication controller configuration YAML file, and you can check here that we have two labels, vBrownBag Web and vBrownBag App. Now we're going to check where those pods are running. So we're going to SSH to Kubernetes worker 1. And now take a look on the pods running there. And we're going to enter in the second pod. And to do that, we're going to start bash inside that container. And once inside that container, we're going to start to try to communicate with other pods in the same network. So I'll start the communication with like a web container, then to the same web container, and then to app. And I can see here that the communication from web to app is working. Here I'm going to create another group called vBrownBag Web. And this group will use labels, tags, as will be tag based. So it automatically discovers what was created in Kubernetes. So here have the web vBrownBag. This will be our source, and our destiny will be the vBrownBag app. We also create a dynamic rule to include everything, all pods that has the tag app in the scope vBrownBag. Once configured that, we'll set the reject and publish this rule. Now I'm going to do the same test, and you can check that the communication between web and app doesn't work, while the web to app is still working. So this concludes this presentation. Thank you very much for watching, and see you next time.
Hi, my name is Sachin Bharadwaj, and I'm going to present you a session on microsegmentation. Microsegmentation is basically a buzzy word which you might have seen or heard from various people, from the networking background guys, or maybe the compute. So it is something which has been trending from a long time, and it's also a great thing to use it in the modern infrastructure. So basically, what is microsegmentation? So microsegmentation is just a zero trust model which you are building it on your infrastructure, basically on the NSX platform. So it's something like a VM to VM communication, where you have the capability to communicate a VM to a specific VM. It is without leveraging any specific traffic or anything else. So this is a common thing. Like if you're talking about in NSX environment, microsegmentation is allow you to push those traffic or segmentations where you have zero trust models and which hereby privileging the putting down all the protection at every level, whether it's a virtual card, VM NIC, or anything else like a transport node that prepares from the NSX generation with the help of NSX preparations. That we need to say that. So how we are using this microsegmentation in today's world. So let's talk about the traditional environment which we have earlier, where we have the perimeter firewalls, which is as could be say the perimeter gateway, which is at the topmost level of every organization or every infrastructure. So perimeter gateway is just used to protect you from at the topmost level. So I'm not saying anything wrong with perimeter firewall. It is definitely a good things to be have at the topmost level to procure you or to secure you from threat which is coming into your environment. So that's pretty good. So, but what about the things which is there under the perimeter firewall? Let's say about the workload, or could be a virtual instance, or could be a container, or could be anything which is there inside the perimeter firewall. So that perimeter firewall is not protecting all those things inside it. So that's something maybe a question of concern which we have to take it out. Let's say what could be the reason why we require microsegmentation, or could be something which we required to protect down to that, because we already have the perimeter firewall at the top and layer. Why we require something the down layer, or could be at the VM level or something else. So let me give you some case studies, or could be some examples why we require. Let's say your end user is using an application or accessing any email from your Outlook, and he got an email which is a phishing email which state anything about a Trojan virus or anything else which may hit you in your environment and that may attack your environment, and possibly it could be something which may harm your environment and can take out your any data which is more secure with an environment. You don't want to take it out from the network outside your perimeter firewall. Second example could be an end user who is using a USB drive to extract any data or taking out anything from the network, or maybe installing any software that USB might be having an infected virus. Could be a Trojan horse. That's common in the network environment. So that may affect the environment, or that may attack it. Attackers are quite aggressive to do all those things, to hack your environment and do whatever they want. So to protect all of them, we required microsegmentations to be enabled with the environment, so that our instances or our infrastructure down to the perimeter firewall should be protected as well as. So in this presentation, I'll let you know about, I'll state about the challenges which we have in a traditional data center, which I have already elaborated to you. Describe NSXT microsegmentation, how it works, recognize microsegmentation use cases, and identify benefits of microsegmentations in NSXT environment. So let's get started again. See, so as I said, then traditional data center security challenges are quite high. So traditional security are more emphasis at the environment level rather than specific application level. So traditional environment is something which more emphasis at the perimeter level, at the firewall, which is at the topmost, at the gateway side. So they are not much concerned about the application level security. Doesn't prevent from lateral between workload and the tiers. So that states the same thing. Let's suppose you have protected your perimeter firewall at the topmost level. Just like a fence, you have protected your house. And what else? What if somebody jumps from your firewall, jumps from your fences, and go inside your house and take out whatever they want? So that is something which has not been prevented from the traditional data center perimeter firewalls, or you can say any firewall which has been physically allocated. So there are more challenges on low priority target at first. Low priority targets could be anything about the VM, or could be any bare metal server, or anything which is there under the parameter firewall could be being the first priority to get it attacked by the attackers. So once you have the data center hijacked, or somebody hijacked your data center and entered your perimeter firewall inside it, they can freely go inside the data center and do whatever they want. They can take out critical data or anything else. So that it's really, it's a challenges which we have in the traditional data center. So how can we overcome with that challenges? So to overcome the challenges, we have certain things which required to be there. It should be having a zero trust at most granular level. What do you mean by zero trust? Basically, zero trust is something like if you have an environment, if you have an application which is being set up, like two application which is being set up into the environment, and say that application, it's having its own boundaries or something which specify like this set of application required to connect to different application which specifically require a set of protocol. Let's say I have a set of application like web application, and I have another web application to get interacted with them. So the protocol which is reused mostly is HTTPS. So why not to do one thing? Why not to enable HTTPS traffic from one source to destination and drop all the packets which is not too required. So basically, it's something like we are giving zero trust or relationship, or could be a trust between two VMs, which definitely allows only single type of protocol and drop rather the other things. So this is one of the topmost things. It may be the application. You can define the application, whatever the application you have, and you can define the boundaries of that. Let's say you have an application or database application, and you want to flow only the database like SQL servers. You just enable the protocol. We have a set of around 400 type of protocols into the distributed firewall, which we are going to talk about in next slide, where you can enable those ports or channels into the security profiles of that VMs, and that specific protocol, that specific port will only connect with the destination. Rest all port and rest all traffic will get dropped out. What happens with that? It will minimize your traffic over the network. There will no congestion at all in your network, and that will definitely help you to granularly move your throughput of your infrastructure. So every second thing is every VM has its own firewall as well as security policies at individual level. So as I said, so zero trust relationship and most granularity. How is it? It's been managed from NSXT, and how NSXT will take it up? It's helped with the help of distributed firewall at the VM level. So when you enable distributed firewalls, it's been enabled at the hypervisor level, or could we say at the ESX level if you are connecting with the ESXi host. And that ESXi host is being that distributed firewall is managed by the kernel level, and each VM which is there at the ESXi host are being governed with that distributed firewall. So that is something is being protected. So you can set a security profile on those VMs. Let's say something like a source and destination. I have these set of VMs will only speak to this set of VMs at specific port, and whatever the packets will get dropped out. So this is how you can specify at the VM level, at the VM NIC level specifically. So this is one of the most important thing which you can do it in distributed firewall. Security policies can be based on VM, network, application attributes. So you can define the policies and distributed firewall based upon factors. Like you can specify like VMs, what type of VMs you have. You can group those VMs and make a group of them, and you can specify that this set of VMs I require to have in the policies. It could be a network in a sense, like you can put in specific IP addresses. This sort of IP address will allow this sort of IP address to communicate with them. Or you can put it by the application basis. Like I have the web servers, set of group of web servers will speak only to these set of application servers. So like this, you can set the policies about in the distributed firewall. security controls can be applied to any application at any point of time. So as I said that you can apply the security controls to any application. It doesn't restrict you to specifically allow any one of the application or two of the application. We have sort of VMs, sort of application which is here in the distributed firewalls options, which you can specifically, or you can customize your application which you would like to add it into that. So that's also an option to do within the distributed firewall. So microsegmentation in data center NSXT, how it works. Microsegmentation segregate data into security segments down to individual workload VMs. Now let's see. You have this diagram. If you can see over here, I have a set of groups which is connecting to 3 VMs. Let's say I have a finance, I have HR, and I have engineering group of set of 3 VMs. And those set of VMs are connecting to the stateless services of the environment. Let's say the AD, NTP, DHCP, DNS, and CERT. So now let's say that any of the stateless services can communicate to any one of the groups. Hey, you can go ahead and do that with the help of security firewalls. You can just say that this set of VMs, this set of group of VMs can specifically speak to DHCP. You can allow the services to DHCP on the specific VMs or on the set of VMs. Or you can also specify that group of finance VMs can speak to HR if they would like to. Or you can specify that engineering set of VMs group cannot speak to HR or finance, as they don't have their own business to do that. Why do they will go for their to see all the payloads and other things? So you can segregate them into different groups so that only the set of VMs can speak within them themselves. As you can see that each VM is having its own firewall. This is what we have the capabilities in the distributed firewall. So every VMs have its own firewall. You can define it, which is at the VM NIC level. So it says that IO control and from NIC level, it's VM NIC level, the control of the firewall you have specifically at the VM NIC level of each VM. Each VM is having its own firewall. You can just specify what all permission you required, what security levels you would like to specify for the VM, and how granular you would like to make those micro segmentation of that specific group of VMs to other group of VMs. So it monitors the states of active connections and use this information traverse the VM NIC. So let's say a VM, you have 4 NICs into that. So does it mean that all 4 NICs will be part of a distributed firewall? Yes, they would be, because whatever the traffic which is running, whatever the active NICs which is there into the VMs are all included in the distributed firewall security profile sections, or they are active into that. So next we have attached the central control and operational distributed firewall directly to each VM. So that's it. It centralizedly connect and operate the distributed firewall at the VM level, not at any other, or not at the hypervisor, or you are governing your firewall at the VM NIC level specifically. See the difference over here. You're not installing any specific agent of antivirus or anything else. So it's completely agentless. So distributed firewall which you have installed, which is being automatically configured. When you configure distributed firewall, it will configure the NIC level at the hypervisor level, and the hypervisor level, the kernel level, it will allow you to do it at the VM levels, and with the help of security profiles and rules which you have, which you create manually to as per your needs. So the use cases of microsegmentations, we specifically speak about NSX. It's protect your critical application in the environment with microsegmentations. So there are two ways you can speak it about. Critical application you're protecting, like if one thing in the way, like if you're having the parameter firewall, if somebody jumped out or got attacked within the infrastructure inside it, this microsegmentation, which is, you can say, the distributed firewall, will protect you to get affirmated from the critical application so that they will not get hampered, they will not get attacked by the attackers. So they will get secured. This is one of the most use cases. Second use cases is that, let's say if you have a set of applications, or like we have the HR application, you have engineering app set of group of applications or the group of VMs, that the HR would not be able to connect to the VM which is there at the engineering group of VMs. So there could be micro-segmentation within that, or could be, you can say, it's segmentations of the channels, or you can say the traffic which you're flowing as per the protocol or for the port level, or it could be the service levels. You can define that this set of source VM source could speak to a specific port or protocol. Other than that, when the protocols comes in, it will get dropped off. Yeah. So secure virtual desktop infrastructure, agentless antivirus with gas interceptions, and it creates a DMZ anywhere. So you have a set of groups, and that groups will get automatically connecting as treated as a DMZ anywhere. So this is how you can connect with that. So benefit of micro-segmentations, it's limit lateral movement. As I say that it will, if anything's jump out from the firewalls, from the fences within the network, it will protect you from the lateral movements. It minimizes the risk and impact of security breaches also. It simplifies network traffic. So whatever traffic which you have allowed in the security firewalls, it will only allow that specific firewalls. Use cases is infrastructure. It will use the topology which you have specified in the security firewalls. It lower the CapEx and OpEx things within infrastructure. It minimizes all software-defined storage or software-defined infrastructure as SDC. So it will definitely help you in that. It automates IT services delivery. So this is all which is helpful in that. And this all concludes the sessions of mine with the help, which is NSX micro-segmentation.
I'm Ian Breitner from the Storage Solutions team at Dell Technologies, and thanks for joining. Today we're going to talk about edge computing and how that's going to impact application modernization plans. Now, everyone's heard of the 5 Ws. Perhaps they may be more familiar this way. We'll go through each of these in turn, and the order in which we may do them will make sense to me, perhaps not to you. So let's start with the what. What exactly is edge computing? Edge computing is defined by processing data at or near the source of the data. It is essentially a distributed computing environment. Data volume is growing, and IDC estimates that in 5 years there will be about 79 zettabytes of data from roughly 42 billion devices. As the volume and velocity of data increases, so too does the inefficiency of streaming all this information to a cloud or a data center for processing. Edge solutions are designed to complement data center and cloud services. Edge computing serves as the decentralized extension of the campus network or cellular networks or data center networks or even the cloud. Santosh Rao from Gartner says, organizations that have embarked on a digital business journey have realized that a more decentralized approach is required to address digital business infrastructure requirements. So here's a simpler architectural view. Both cloud and data center have a part to play, but we now have a need to service new devices by delivering compute power close to the device itself. And those devices are proliferating at a great rate. And spoiler alert, it's not just compute power that's needed, but networking and storage as well. So why? We've defined edge as bringing compute in proximity to the source of the data. Edge computing is designed to complement existing public cloud, data center, or co-location deployments, and edge data centers offer advantages that none of these possess. It's due to the compute proximity to the data that is the core strength of edge computing. Its ability to support applications that demand a significant amount of bandwidth, require rapid response times, are latency sensitive, or any combination of them. And network traffic performance is much less of an issue at an edge location than with a data center or co-location deployment, or even the public cloud. In these latter cases, data needs to be moved from the location where it is acquired to a central location for processing. Doing so incurs latency. We still have not been able to communicate significantly faster than the speed of light. But across all industries, the digital transformation of products and processes is creating new ways to connect with customers and partner. And this is kind of interesting. The movement to edge computing parallels the cyclical nature of IT trends. What began with centralized mainframes eventually moved to a decentralized approach with client-server networks. Then the meteoric rise of the public cloud shifted computing back towards a centralized approach, only to have the recent rise in popularity of hybrid cloud deployments move the needle back towards a decentralized model. So when is this need for edge computing going to occur? The news, good or bad, is that it is occurring now. In fact, it started back in 2009 when Carnegie Mellon University used the term cloudlet to describe a micro data center, basically an edge data center. However, it was not until 2016 when edge deployments really started. Gartner estimated that only 10% of data was processed outside of the data center and cloud back in 2015. But now they estimate that within 5 years, the amount of data processed outside of a traditional data center or cloud will be 75%. This growth is basically due to IoT devices. These include mobile devices that we all use daily, like cell phones and GPS location services and so on. And they include new data sources, IoT devices that are being deployed in a variety of locations: vehicles, personal healthcare, hospitals and clinics, smart cities, retail locations, aircraft, ships, manufacturing, and so on. Growth rates for edge computing are estimated by analysts to be from 11% to 12% compound annual growth rate. And this might well be a conservative estimate. Those smart thermostats, smart utility meters, ever-growing mobile devices with specialized apps are only adding to the data that is being generated. You can see from this chart that the growth of the edge is growing exponentially, and we are here in 2020. So the Who. No, not the band. Who is looking to use edge computing? The number of use cases is still increasing, but common ones include supporting advanced Internet of Things appliances and augmented reality applications. So, for example, retailers can leverage AR to improve customer experiences by creating apps that help customers find their way around shops, implement network smart mirrors to try on clothes without a changing room, or run personalized promotions and offers that leverage the consumer's historical purchases and personal tastes. Within manufacturing environments, artificial intelligence can be used for predictive maintenance of expensive machinery, drive down long-term maintenance costs, and significantly reduce the risk of failure. Elsewhere, raw input from IoT sensors can be leveraged for quality control or to reduce wastage. Edge computing solutions can take many forms. They can be mobile in a vehicle or smartphone. They can be static, that is part of a building management solution, manufacturing plant, or an offshore oil rig. Or they can be a combination, such as in hospitals or other medical settings. A wearable health monitor is an example of a basic edge solution. It can locally analyze data like heart rate or sleep patterns and provide recommendations without a frequent need to connect back to a main data center or cloud. The capabilities of edge computing solutions range from basic event filtering to complex event processing. By 2024, edge data centers are projected to exceed $13 billion, with the IT and telecom sectors driving growth. Manufacturers in the edge data center market are providing several effective solutions that allow businesses to adopt edge computing technologies for managing their enterprise data. For instance, Dell Technologies, my employer, is with several computing solutions such as PowerEdge, XR2, R740, and R740XD servers that are optimized for mobile virtual network functions. But they also have a new offering, PowerStore, a storage array that not only can scale up and scale out, but can also run virtualized applications on the array itself. PowerStore natively runs ESXi. The management of the storage is handled in a VM, and the array can run user VMs. It appears in a vCenter as another VMware host and acts as with any vSphere host. It is highly redundant with dual controllers, servers if you like, which act cooperatively in managing the storage. The value this brings to edge computing is significant. Not only can PowerStore be used to house the data collected at the edge, it can also run applications that can process that data. And it does this in a very small 2RU form factor, about 3.5 inches high. And if this is of interest, I would encourage you to join Marco Abella's VMworld session on PowerStore or Heather Hitchcock's session on healthcare, where she talks about automating an ICU. So the where. Edge servers can form clusters or micro data centers where more computing power is needed locally. And they can be anywhere. And in fact, they are already everywhere. More complex edge computing solutions can act as gateways. In a vehicle, for example, an edge solution may aggregate local data from traffic signals, GPS devices, and other vehicles, proximity sensors, and so on, and process this information locally to improve safety or navigation. More complex still are edge servers, such as those that are currently being deployed in the next generation, that is 5G mobile communication networks. And these will host applications and cache content for local subscribers. So from connected vehicles to intelligent bots on the factory floor, the amount of data from devices being generated in our world is higher than ever before. Yet most of this IoT data is not exploited or used at all. For example, a McKinsey & Company study a few years back found that an offshore oil rig generates data from 30,000 sensors, but less than 1% of that data is currently used to make decisions. The edge is a focus area of burgeoning distributed computing framework, which is being created due to the latency and bandwidth requirements for new use cases. According to IDC's 2019 Data Center Operational Survey, 79% of United States-based organizations were planning to deploy more IT services at edge locations. Supporting new digital services at scale across many locations requires the ability to deploy and maintain infrastructure and enable connectivity in many locations. Organizations will be challenged to support connectivity needed for physical and data security in these locations. And real estate will play an increasingly role in edge deployments. For example, Walmart is exploring ways to rent out edge computing, leveraging its retail footprint. Retailers have the locations to enable edge computing. And there are several risks inherent in edge computing. So across all industries, the digital transformation of products and processes is creating new ways to connect with the customer and partners. Much of this innovation depends upon having IT service in new locations, that is, at the edge. But if organizations are unable to manage their edge endpoints in a scalable way, the costs of operating and security risks will erode or negate the value of these investments. Managing edge effectively means more than the ability to keep track of endpoints, such as within a factory or a retail location or a remote site. It means the ability to overcome the variability of endpoints, rely on remote management technologies, and scale operations at a new level. Creating an ecosystem that gathers, stores, protects, analyzes, and transports data in a frictionless way across many platforms organizations. Evaluating, deploying, and operating Yes, I can. Already. So there are risks associated with edge computing. Across all industries, the digital transformation of products and processes is creating new ways to connect with customers and partners. Much of this innovation depends upon having IT service in new locations, that is to say, at the edge. But if organizations are unable to manage their edge endpoints in a scalable way, the costs of operating and security risks will erode or negate the value of those investments. Managing edge effectively means more than the ability to keep track of endpoints, such as within a factory or a retail or remote site. It means the ability to overcome variability of endpoints, rely on remote management technologies, and scale operations at a new level. Creating an ecosystem that gathers, stores, protects, analyzes, and transports data in a frictionless way across many platforms will strain the capabilities of even the most advanced IT organizations. Small problems will become magnified as the scaling increases exponentially. The impact could result in service interruption at best or security breach at worst. As with all rapidly evolving technologies, evaluating, deploying, and operating edge computing solutions has its risks, and they come in many forms, but a key one relates to security. Extending your footprint using edge computing exponentially increases the surface area for attacks. Unsecure endpoints are already used in distributed denial of service attacks or as entry points to core networks. And another concern is that the cost of deploying and managing an edge computing environment can easily exceed the project's financial benefits. Moreover, projects can become victims of their own success. Scalability can become a serious issue as new IoT endpoints proliferate. And of course, there are additional challenges. Network resiliency. While within the edge location this is not an issue, there is still the need to move data sets back to the core, either for additional processing or for archival. Then there's scaling the number of edge locations can be challenging, as noted earlier. Bandwidth and spectrum constraints, and we expect that 5G will alleviate some of these. Another good one is data sovereignty and its application in the EU to collect the data. And this may well extend to other countries, such as Canada and the US. Also, procurement is shifting from CapEx-centric to OpEx-centric. Organizations may not want to own the infrastructure they use, but rather rent it. And then system complexity as the edge expands, it becomes more and more complex, and there are more complex interactions required. Remember this diagram? This only has 50 devices in it. What happens when you end up with tens of thousands? And not to forget the shortage of skilled labor resources. Organizations are struggling with their cloud initiatives, and edge adds the need for a different skill set, which are even harder to find. Edge computing does help you unlock the potential of the vast untapped data that's created by connected devices. You can uncover new business opportunities, increase operational efficiency, and provide faster, more reliable and consistent experiences for your customers. The best edge computing models can help you accelerate performance by analyzing data locally. A well-considered approach to edge computing can keep workloads up to date according to predefined policies and can help maintain privacy, and will also help adhere to data residency laws and regulations. Developing a successful edge strategy requires taking into consideration the complexity of management endpoints and recognizing that scale and variability is dramatically different from traditional on-premises or public cloud deployments. And with that, I end my talk, and thank you for listening.
Hi, this is Milind Halpet, Global Cloud Practice Vice President with vTechTalks. And today we are going to talk about how do we provide a consistent experience from cloud to edge with boundaryless data protection solutions. Next slide, please. So when we look at the cloud trends, the reality today is, the cloud spends are going to go from 260 billion per year to almost 927 billion per year. At the same time, we see enterprises embarking on the digital transformation journey, and the adoption of cloud across enterprises are accelerating. And this actually points to one outcome. The volume of data that is getting generated in the enterprises are skyrocketing. Whether we look at data that is structured or unstructured, And at the same time, organizations are going through certain challenges. IT needs to do more with less resources. And at the same time, data protection is at the center of the entire transformation. Anything with respect to the data protection issues that may lead to revenue loss, it may lead to brand problems. So it is actually a critical problem for any enterprise to solve. And when we look at some of the common investment priorities, in fact, data protection is the number one priority across the enterprises. Enterprise needs to manage the data lifecycle management all the way from the backup, retention, disaster recovery, archival, and long-time retentions. So with this backdrop, I would like to move to the next slide where we'll deep dive a little bit into the solutions. Just a little bit of background about our partnership. Wipro, Dell, and VMware have a solid partnership going on for decades. With a very rich system integration, transformation, and managed services experience, Wipro has been innovating in the market along with the Dell to release the cutting-edge solutions to the market, along with VMware as well. These solutions actually span across data center to cloud to edge and to the end-user devices. And some of the most important considerations while we talk about the solution sets is, do our solutions offer lower cost and high value? Does that actually integrate with the other ecosystems within the enterprise? How automation becomes an important tenet of the solution? And finally, these solutions have to work seamlessly. So are our solutions service assured? And are they trusted solutions backed by VMware as well as Dell? So with this, let's go to the next slide. So to solve these kinds of problems within the enterprise, we have a platform, what we call as the boundaryless enterprise, or the BLE. There are multiple components within the BLE. It has a hybrid IT fabric. It has got the engine to manage the modern application development using the Kubernetes ecosystem as well as the VMware Tanzu. But the most important thing which is relevant for today's conversation here is the component what we call as the boundaryless data protection, or BLDP. And in the next set of slides, we'll go a little bit deep dive into BLDP, and we'll talk about the utility and how the reference architecture yields organizations to protect their data, irrespective of whether it is an on-prem or a private cloud or a multi-cloud across various deployment models. Next slide, please. So in this slide, as you see here, there are plethoras of technologies that comes together to solve this problem. And that is why we are saying data protection has to go without confinement of boundaries. The reality today, the world is hybrid. Enterprises already have moved from on-prem to cloud. There is virtualized infrastructure, there's legacy infrastructure. There are newer patterns, for example, converged infrastructure, hyper-converged. And then when we look at deployment options, we have IaaS, infrastructure as a service, we have PaaS, we have some applications which are running across SaaS as well. And on an average, when we look at the RPO and RTO requirements, enterprises need a 4-hour RPO and RTO, and some of the business critical applications, they need instant recoveries. So how do we provide all the services all the way from replication to snapshots, backup and archival, and this has to be blended into the entire data management strategy, and protection needs to be looked upon in a holistic fashion. From an application perspective, we know that applications are now moving away from the traditional monolithic applications into digital applications. Then there are COTS applications within the enterprises. And these applications are spread across, integrated infrastructures, converged. Most of the applications are now running on software defined using infrastructure as a code. And from a consumption perspective, the models are getting transformed into as a service construct. So the data protection strategy comes in the center of all this evolution. On the application side, while there is a transformation that is already underway, on the infrastructure side, yes, the reality is multi-clouds. How do we protect data across all these clouds in a holistic fashion without compromising integrity is the important part of the solution. With this, we'll move to the next slide, please. So the key part to understand here is, how do we provide a single pane of glass management to solve this problem? How can we manage, protect, and recover enterprise-wide data whether it is AWS, Azure, or Google Clouds, or any other public cloud, or it could be on-prem private cloud as well. And at the same time, when we look at some of the multi-cloud use cases, as I said, the business requirements are very stringent today. The business critical applications need immediate backup and recovery options. At the same time, organizations are trying to cut the cost by using cloud as a backup option, long-term retention options. So these use cases will have to come together, and a single pane of glass is important to orchestrate these use cases in a seamless fashion. And when we talk about these solutions, the solution has to be scalable. It has to have a high level of cloud performance. And at the same time, it has to protect all kinds of workloads. And this is where we are talking about the Power Protect solution as an umbrella technology platform that is innovated from Dell as well as with VMware. And Wipro System Integration Services brings this to life as organizations embark on protecting data across multiple clouds. Now we are actually partnering very closely to take this Power Protect solutions to the market. With this, we'll go to the next slide, please. So the most important part of this Power Protect umbrella platform is it is enterprise-grade data protection. What it means is it provides classic features such as scheduling, service cataloging, policies, governance, automation, compliance, and most of the organizations today have very stringent SLAs. So when we talk about enterprise-grade policies, this platform, Power Protect, along with the services overlaid from Wipro, provides this enterprise-grade data protection services. At the same time, we know that organizations are embarking on a new journey where they are innovating on the digital applications using Kubernetes, VMware, Tanzu, and some of these related technologies. So the good part of this entire solution is it works for the digital native application landscape as well. We can protect data that is coming out from the Kubernetes ecosystem. And at the same time, the cloud native architecture that we are talking here, it supports the entire Kubernetes community. So the key message here is we can actually look at backing up the Kubernetes clusters and the persistent volumes. That is the part for the digital workloads data protection. At the same time, it manages the traditional data protection, the ones which are running in IaaS data protection. So basically, it brings all kinds of data lifecycle management across clouds, across deployment models, and heterogeneous applications into a single pane of glass. And that is the power of the partnership that we are talking here. With this, I'll move to the next slide. What are the customer benefits? End of the day, when customers are embarking on the digital transformation journey, innovation is the key requirement. While organizations are trying to innovate and get into next generation business model, trying to create a competitive advantage and opening a new digital channel for the business, the time to market and time to innovate is of supreme importance. The second one, enterprises do not have a lot of funds available to drive this transformation. So always there is a push to reduce the run spend and champion the change fund. The third component here is architecture really matters. How can we simplify this architecture? The complexity that I talked about, multiple clouds, multiple deployment models, different application patterns, and data protection is one common denominator that has to connect all these models together and protect the data. Make sure that replication, snapshotting, the long-term retentions, the policies, everything works according to the enterprise standards. The last but not the least, compliance, and making sure that we are creating a flexible consumption model, which is very transparent for enterprises. And the entire 4 pillars of this benefits has to be very simple. It has to be consistent operations, which can abstract the complexity while there is technology underpinnings below that. So these are the 5 things that comes together. So when we talk about providing consistent experience across clouds, across cloud to data center to edge, the boundaryless data protection is one of the key solution elements that enterprises need to embark on. Now, again, I would like to round off by mentioning the partnership between VMware, Dell, and Wipro has come together. The engineering teams have worked together to create a standard reference architecture. And there is a definite roadmap as well as the use cases that are stress tested to work in the enterprise scenarios. We are committed to drive enterprise transformation for our customers. And we look forward to seeing you in VMworld 2020 and stay tuned for the further updates. Thank you.
Welcome to the presentation on Cloud IQ, how to debug your VMware installations on the go with Dell EMC Cloud IQ. I'm Susan Sharp, Cloud IQ Product Manager. Cloud IQ provides you intelligent insights about your infrastructure, particularly by providing proactive monitoring and predictive analytics. One of the key advantages that we have with Cloud IQ is the human intelligence regarding the Cloud IQ ecosystem, leveraging the strength and power of the Dell technical community. That includes the developers and architects who are actually developing Cloud IQ, along with the product team developers who provide product-specific subject matter expertise. It also includes the support engineers who bring forward breadth and depth of vast subject matter expertise, knowing that special thing to look for or the things that you need to proactively be aware of, so that you can better understand your environment and take actions to address potential risks before they become real issues in your environment. And it also includes members of your Dell account team, whom you can invite to be trusted advisors so that they can also see the insights that Cloud IQ provides and help ensure you get the very best from your Dell infrastructure. We hired a third-party evaluator to compare Cloud IQ to some of the other products out in the marketplace. And they found that time and time again, Cloud IQ demonstrated an ability to allow users to reach faster time to insights. So hopefully you'll see that benefit too when you use Cloud IQ. When we talk about Cloud IQ, the three main pillars we talk about are reducing risk, planning ahead, and improving productivity. So I'll tell you a little more about each of those. We'll start with how Cloud IQ can help you reduce risk. One way that Cloud IQ can help you reduce risk is with the proactive health scores that you see here, where we provide a per system health score that will quickly identify systems that are at potential risk and also provide the recommended remediation to address that potential risk so that you can avoid real issues in your environment. We also have a unique performance impact analysis and anomaly detection capability that allows you troubleshooting all the way from the system level all the way down to the VM level. And this is where I will showcase this capability of Cloud IQ in the demonstration portion of this session. Along with this impact and anomaly detection, we'll also identify workloads that are in contention of the system or pool resources and need to be redistributed to remove that bottleneck. Cloud IQ also allows you to intelligently plan ahead. This was a key area where, with the ability that Cloud IQ provides for predicting capacity reaching full, we're able to provide an almost 10x advantage for our users. Cloud IQ provides both a short-term capacity full prediction as well as longer-term capacity forecasting, so that helps with both risk avoidance in terms of avoiding a data unavailability and also providing intelligence in your ongoing planning and forecasting tasks. We also recently added the ability to detect capacity anomalies. Think of this as a run on the bank scenario and enabling you to avoid that 2 a.m. phone call when all of a sudden your capacity has reached full. Additionally, Cloud IQ enables you to improve productivity. One way of doing that is by the fact that Cloud IQ has a breadth of data center support. Cloud IQ supports the majority of all Dell storage assets as well as Connectrix switches and is integrated with VMware. I'll give some details on that in the next slide. I also mentioned the trusted advisors. With all of us needing to do more with less, think of leveraging your trusted advisors for the additional expertise, additional proactive monitoring for your environment. Customers can simply invite members of their Dell account team to be trusted advisors, and that will enable them to log into Cloud IQ as well as you to be able to look for potential issues or potential areas of risk that need addressing. And finally, because Cloud IQ is hosted in the Dell private secure infrastructure, you get immediate time to value with Cloud IQ. Once you've set up your Dell storage assets and connected via remote telemetry, you can log in to cloudiq.emc.com and start viewing Cloud IQ and your assets. Cloud IQ integration with vSphere obviously starts with vSphere. And then we have a special Cloud IQ collector. Think of it as an aggregator of the key vSphere telemetry. That then gets sent to the Dell Secure Telemetry Gateway. So all of the left-hand side is on your premises. And then that Secure Telemetry Gateway then sends the telemetry into Cloud IQ for preliminary ingest and analytics. And then that information is displayed in the user interface, the browser or the mobile app. This Cloud IQ collector is available for download from the Cloud IQ application. So you can simply click to download the collector app. I'll show you when I shift over to the demo, and then you can simply set up that vApp and start collecting the data, the telemetry data from your vSphere instance. So with that, let's shift into the demonstration. So I talked about the user interface and the Cloud IQ mobile app. So let's talk about how you would use those with your vSphere and VMware infrastructure. So here's the mobile app. And on the mobile app, there's a special area here that will draw your attention to whether there's been performance impacts in your environment. So you can drill a little bit more in detail, and you can easily see right here from the mobile app that there are issues with block latency in terms of performance impacts as indicated by the pink shading, and also performance anomalies as indicated by the blue shading. So what this does is it gives you infrastructure insights right there in the palm of your hand with the mobile app. So logical next steps would be you would hop on over into the Cloud IQ web app. And so this is the Cloud IQ web app. You can see here, for instance, information about the Cloud IQ collectors, the system health, the capacity approaching full that I talked about. And as you keep scrolling down, you see an area indicating performance impacts. And one of the key points I want to make about this is both from that mobile app and here right on the overview page of Cloud IQ is going to make you aware of these performance impacts. So we want to avoid any more hunting for that needle in the haystack. We're going to bring it right up to the top and make it prominent so it's easy for you to know about, so that you can streamline your time to resolution. Let's look a little bit more at these analytics and how they work. So I've now drilled into the storage system. This happens to be a Unity XT. You can see the top talkers here at the top of this page. And as you scroll down, you see, again, just as you saw in the mobile app screenshot, you can see both performance impacts and performance anomalies. Performance anomalies are indicated where, based on the machine learning algorithm that Cloud IQ employs using a seasonality algorithm, that's indicated by the gray, we can indicate for this individual system, for this time of day and day of week, there's been an observed anomaly. We're tracking that over a 3-week period. And so this is an anomaly that has occurred outside the normal range, again, for this time of day and day of week, outside what has been established as normal over those 3 weeks. In addition to that, we have partnered this with another algorithm, a time series algorithm, time series correlation, where we can correlate that at the same time as these spikes in latency, there's been a drop in kind of the inversely related system performance metrics, IOPS, and bandwidth. So with these two algorithms, the Cloud IQ analytics engine can indicate for you, first of all, when there's been an observed performance anomaly, and second of all, when there's been an observed actual impact in the environment. So now we've told you that there is an impact, and so the next steps are what might be causing it. And so this is where the power of context is really important. Right here in the context of this system graph, you can click and drag to then identify what are the storage objects that may be contributing to this performance impact and anomaly. And so, for instance, if you look at this particular storage object, you can see that the performance metric there looks awfully suspicious and awfully similar. And so this provides a very simple way to drill right here in the context of what you're looking at the system level to then present that information at the LUN level, the storage object level. Similar metrics now at the storage object level, latency, IOPS, and bandwidth. And as we saw at the system level, again, an anomaly now for this LUN at this time of day and day of week, as well as the same algorithm applied now at the LUN level that we talked about at the system level, where we have a time series correlation where the spike in latency is correlated with a drop in IOPS and bandwidth. So you may be saying, okay, well, that's great, all about storage, but I want to know about the VM. Of course you do. So that's the next thing that we show. So like we did earlier, you can click and drag over the area of interest on the graph. And now, as you saw before, we now go all the way down to the VM level. Again, in the context of that LUN, I can click and investigate further with the VM. Again, using that special CloudIQ collector I showed you about before, where you can download it right here from the CloudIQ application. Right here, you can download that collector vApp and then deploy it. Just some real simple instructions right there. All right, so back to this VM landing page. So you can see here the key performance indicators for the VM, the CPU readiness, the active memory, and then the storage latency. Now, in this particular troubleshooting flow, I started at the system level and worked my way down to the VM. But imagine if instead you had chosen to simply search for the name of that VM and arrived at this page. You can click anywhere on the latency graph, and we'll provide for you an end-to-end map that will identify all of the components along the way for that VM. And note that when I click in the pink area where the VM had a performance impact, it will likewise indicate the various storage objects, or storage entities along the way that likewise had a performance impact. So effectively connecting the dots for you to help you again understand that performance impact and help you find that needle in the haystack. All right, so we started at the system level. We worked our way down to the VM level. Again, noting you could have reversed that direction. But now the question is, what can be done to remove that bottleneck for the VM? And so in this case, I'm just going to back up a step. That was the LUN that we looked at. If I go back to the LUN page, this was the graph we were looking at a moment ago. You can then see additional details. This is where the workload contention analysis comes in. And CloudIQ will indicate for you where there are other workloads contending for the same resources as the LUN with which that VM is associated. So this is a pretty strong recommendation that if you can distribute these workloads, perhaps to another pool for a Unity system or perhaps a whole nother storage system, then you would remove that bottleneck. You would allow that LUN to receive the resources that it needs, and therefore the VMs associated with that LUN. So hopefully you've seen that end-to-end, in-context, unique capabilities that CloudIQ provides for you to intelligently troubleshoot performance issues in your environment and gives you strong recommendation for how to remediate those performance bottlenecks so that you can remove them. Returning to our presentation, I talked about immediate time to value. All you have to do is install and configure your Dell EMC devices, connect that remote telemetry, including the CloudIQ collector that will bring information from vSphere into the secure remote gateway, and then simply log in and use CloudIQ. Log in to cloudiq.dellemc.com and start using it. You'll log in with your pro support credentials. And I haven't mentioned it yet, but maybe one of the best things about CloudIQ is all of this at no additional cost. We view CloudIQ as an enabler so that you can unlock the power of your Dell EMC devices. So again, log in to cloudiq.dellemc.com and start using it today. To summarize, CloudIQ provides intelligent infrastructure insights by reducing risk identifying and avoiding issues to expedite troubleshooting, enabling you to intelligently plan ahead by anticipating business needs and avoiding outages, and by allowing you to improve productivity with a single pane of glass across your data center, including your Dell storage assets and VMware. So get started today and start getting advantage with the faster time to insights. Thank you for listening.
Hello, everybody. Thank you for joining for this session today. Today, I'm going to talk about VxRail in the real world. I will share some experience that I have with this kind of appliance. And I will share with you some tips and tricks, okay? Well, I'll talk a little about me. My name is Arla Santana. I am a Brazilian. And so I have more than 20 years in experience with IT infrastructure, especially with VxRail. I'm started with 400 of VxRail, is an EvoRail, okay? And if you want to learn more about me, access my LinkedIn, have an entire description there, and can you contact me through LinkedIn, okay? And then I will start our agenda for today. The first part of our presentation, we are talking a little about key points of VxRail, and after we are describe some important steps or key points or some tips about the installation, and after install, we have some key points to pay attention, and some tips and some problems I faced during the updating device, and I will share some tips with you, and and some reference and docs to solve possible problems during the updating or during using the device and day by day, during the day by day. Okay, so the key points of VxRail. In my opinion, VxRail is a game changer. For me, is the best HCI solution. I have some experience with other players, other solutions, but for me, if you use VMware, if you have this free infrastructure, VxRail is the best solution, because the true single pane of glass, you can do everything on the same screen, the vCenter screen, and this is great, because other solutions, maybe you need to go out of vCenter, perform some tasks, return to vCenter. In this case, it's not. This is truly real single panel of glass. You do everything inside vCenter. The interface you are very well customized using on your day-by-day IT administration, IT infrastructure administration. And the other interesting fact is the compatibility, fully compatible with vSAN. Some years ago, during VMworld, I don't remember the exact year, I watched a presentation about problems with vSAN. And one of the most common problems with vSAN is about compatibility. The other thing is very interesting about VxRail is the real on-click update. You press on button and everything goes automatically. You know, do you have firmware updates? Do you have vSphere updates? Do you have vCenter updates? Don't worry about these, and the process is very automated, and you don't need to take care. You don't need to worry about this. You don't worry about, okay? And the other interesting fact is the unique point of contact. If you have problem, you just call for one person, one number, and they will solve your problem without need to contact many vendors. This is a great advantage of the HCI, and especially when you're working with a VxRail. Well, now I will share some tips about the installation. The first one is don't ignore the requirements, especially about network and DNS. You need to spend some time planning your installation, and it's very, very important using the solve procedures for install. I have experience with more 200 devices deployed, and every installation is a new installation, and every installation do you face different kinds of problems, and many times the problems are occurring because sometimes you're not check and trying the requirements, especially about the network. Okay, and it's not a problem if you spend some time planning your installation, reviewing requirements, okay, and reading some solve procedure, special notes about the installation before you start the installation, okay? If you are using Dell network suites compatible with smart fabrics, evaluate the benefits of use this feature, okay? Because when you use smart fabric switches, do you not need to configure the switches? VxRail configure automatically the switch for you. This is maybe save time doing the deployment, okay? Many people said, no, this is not so good, but if you deploying a cluster with a lot of nodes, maybe this is a good idea. Well, it's preferred to use the switches in the mode, not in the stacking mode. Prefer to use VLT if you are using Dell networking, or VPC if you are using Cisco switches, or other manufacturers have different names for the same feature. I don't recommend the use of stacking, because when you using Tor switches in the stacking mode, when you need to perform some kind of maintenance like firmware updates, you can incurring on network disrupt and network down, and this is not good. And when you're planning your network for HCI solution, especially about VxRail, we recommend to use two switches, and in this mode, VLT or VPC, they are working independently. But outside, if your other switch looking for this, the other switch see like one switch, okay? But do you have benefits about this configuration? Because you can perform updates without any network outage, okay? VxRail requires some specific VLANs, and you need to configure that before you start your implementation. When you after you put the device on the rack, you need to cable them. When you are cable them, pay attention in the ports. Don't worry about network interface cards outside the onboard interface cards, because the setup using only onboard cards, okay? And my recommendation for this is using odd ports in one switch and even ports in another, because VxRail that have a predefined network organization, network layout, and if you're looking in the network planning guide, this document you can find during the LMC websites. At the end of the presentation, I will share the address of the LMC websites when you where you want to find this kind of documentation. After installing the devices, after cable the device, I recommend to configure all IDRAC of all nodes first. because sometimes I faced problems. I had problems with some implementations. I remember a specific case. I spent a lot of hours believing that the problem is network configuration. And in fact, the problem was a problem. You need to look at direct console user interface of each node and look if the information about PSMT is present. Some nodes produced last year have a bug with this, and they don't have PSMT identification, and these they not can be found during the cluster configuration. And because of this, I very, very recommend to configure iDirect first. Look if each node are health. Look for hardware problems before you start your implementation, in fact. In case of using external vCenter, take a look at VxRail vCenter Server Planning Guide. This is a document because not every vCenter configuration are supported on the VxRail installation. Especially when you use external vCenter Server, you need to check not only the vCenter Server Planning Guide, but support matrix. You need to check if you are using the correct version of the vCenter Server before you start your implementation. VxRail Manager have the full IP address, but I really, really recommend you to change for a definitive IP address before you start your cluster building. Okay, for 2-node cluster, I really recommend you to configure a witness traffic separation, a special network, a separate VLAN for this, and take care with you the witness about 2 facts. The documentation about 2-node cluster is very, very simple, and sometimes you face a lot of the problems with 2-node clusters because it's not so common implementation. It's not well covered in the training for implementation of VxRail. If you perform VxRail implementation course, it's a small portion of the course that they talking about 2-node cluster, but 2-node cluster is a little difficult to put on production because the documentation are simple and not cover all aspects. My recommendation is for this is use the same version of the rules about the vSAN witness. When you download and deploy the vSAN witness, take care with this, because if the vSAN witness has a different disk version than the hosts, you can't perform the deploy of the VxRail 2-node cluster. Okay. Well, if it's happened during your installation, you face this screen, do not panic. I face this kind of the problem in some implementations. In the most of case, just press try again, and this solve the problem. Many times this occurring because some tasks do not perform it at the correct time, and because of these, you face this kind of the problem during the implementation. But just press try again. If this doesn't work, look at the log and try to do the task manually. Example, in one of my implementations, I faced a problem with a specific step when the configuring enhanced vMotion compatibility and the installation stopped. I faced similar screen of this, but I just read logs and enable enhanced vCenter compatibility manually, and done problem, and the installation and I press try again, and the install continue, and the cluster was deployed with success. After install, it's very important to rename entities, because VxRail, after the installation, has different names. It's not different, strange names. Not the same. Strange is the best word for this, but many customers, many people want to rename the entities. But my recommendation is look for the solved procedures for this, because not any entity can be renamed. Okay, and the solved procedures are very, very complete about this. They have step-by-step instructions to perform renaming entities. Okay, enable vSAN performance services is very important too. Enable Skyline, the online health check. I recommend this because before you enter in production, the environment start production. This is very important. You make a health check of your cluster using the online option. If you want to use the duplication, compression, and encryption, this is the time before you put the device in production. Because when you enable these features, it's necessary to reformat the disks, and this task is time consuming. And the other thing, during this task executing, you have limited availability. Because of this, I recommend, and after install, before you move your workloads to the new cluster, enable this. Okay. And the other very important step is enable ESRS, the call home function of VxRail. And this is not only used for problems. Recently, we have ACA as an analytical consulting engine. The data transferred by ESRS are used for analytical consulting engine. Analytical consulting engine is a very new feature introduced last December. And it's very, very interesting because this feature provides information, analytical information about your cluster and perform updates. When you perform updates, I prefer, for my experience with a lot of implementations, to use offline bundle and the internet upgrades, especially when you are deploying more than one cluster in the same organization. Maybe this is a strange scenario, but it's not so strange for me because we have a limit on the standard cluster of 64 nodes, and sometimes some companies work with 2 or 3 clusters, and sometimes when you need to deploy more than one cluster, you need to do that. Download the offline bundle and perform updates faster than you use the internet upgrade. Okay. If you found errors during the upgrade, don't worry. Don't worry. Just press try again. It's most cases enough. Okay. And I performed installation here in Brazil and in a customer, a lot of 2-node clusters in remote regions of Brazil. And some regions don't have good power sources. And sometimes during the update, I face a power outage. Okay, don't worry if it is occurred because you just power on the solution again, and the update continue. Okay, very, very rarely you face a problem that you need to contact support to solve this kind of problem. And if you face error during the upgrade, please look the log Sometimes the log have more information, more detailed information that help you to solve the problem. Well, solve the problems. Before you can contact the support, okay. Before you contact support, take a look at event code reference. And this, I put some reference here, just 2 links because this documentation changes every day. And just put two links. The Solve online. The Solve has a lot of procedures step by step. And the InfoRub. InfoRub is an entire documentation about VxRail. So for today is this. Thank you for your time. And you have doubts, feel free to contact me. Okay, thank you.
Hi everyone, my name's Dean Lewis. I'm Technical Account Manager at VMware, and today we're going to be talking about the VMware Folding at Home appliance and our efforts to support the Folding at Home project. Just a little bit of background about myself. Of course, my career focus has been in virtualization, as you can imagine, working for VMware. Outside of work, I'm a keen scuba diver, and you can get in touch with me either through my blog, theeducate.co.uk, or on Twitter at StDLE. High level, we're going to be covering what the project is, what is protein folding, what are the outputs from the project, how to get involved, and then, of course, a little bit of a technical demo as well. So the Folding at Home project is a distributed computing software project for simulating protein dynamics, which we'll talk about a little bit more in a moment. Brings together volunteers from around the world to run the simulation of protein dynamics using their own personal equipment, their home labs, or in the case of, where possible, on their business equipment as well, as long as their employer allows them to do so. The insights from this data help scientists to understand the biology better, viruses and diseases, and provide new opportunities for therapeutics. The project itself was founded in October 2000, and on March 20th of this year, VMware released the VMware appliance for Folding at Home to help support the project's efforts for those with vSphere environments. And first and foremost, I'd just like to start with a 60-second clip from our CEO, Pat Gelsinger, about our efforts to support the project.
Hi there, Pat Gelsinger here. I'm a firm believer that technology can and should play an important role in medical research, especially for fighting the COVID-19 pandemic. It's why Folding at Home is so exciting. In a grassroots example of our commitment to citizen philanthropy, over 1,000 VMware employees, partners, and customers joined Team VMware Folding through the globe. A few of our employees have gone above and beyond through our VMware Foundation's Good Gig program to strengthen the Folding at Home project by assisting in modernizing applications and creating a secure multi-cloud strategy. I'm so proud of the VMware community for coming together to take action for what they are passionate about. And thanks to everyone around the world who has been involved in this program by sharing your unused computing power. It's truly amazing to see such an outpouring of support. You can learn more at foldingathome.org. Thank you so much.
Okay, just to give a little bit of context, VMware's ethos, as Pat mentioned, throughout the company is to produce technology for good. And for me, getting involved with the Folding at Home project is a real simple way to help contribute in the fight against not only COVID-19, which of course is affecting us all today, but other diseases such as Alzheimer's. We obviously believe that our individual actions add up to our collective impact. And as you probably heard the saying, big things have small beginnings. The VMware Folding at Home appliances really kind of encapsulates that quite well. It was a concept to a public fling in 72 hours, and that's our fastest release ever. So digging down into the scientific side a little bit, what is protein folding? A protein itself is the basis of how biology gets things done in the human body. As enzymes, they help drive our bodies, build structural elements such as bones, muscles, skin, and blood vessels, antibodies, which allow the immune system to get rid of unwanted invaders. What is folding exactly? So a protein takes a shape called a fold in the body. The image in front of you, we have the image of a folded protein on the right-hand side. And the Folding at Home project is looking for gaps whereby drugs can bind to a protein to help the body in its immune response and to fight diseases. It's very similar to putting the pieces of a very complex jigsaw together. And what are the outputs from the project? Today, there's already a number of papers which have been released from the research conducted by the project and the researchers that are involved. And these images in front of you, we're looking at the same protein whereby the distributed computing scale of the project has allowed researchers to understand how this virus binds to our cells. For those of you who are fans of Stranger Things, this spike has been nicknamed the Demogorgon. And the researchers' aim now with this spike is to understand which drugs are available or can be created in the future which attack or bind to the opening of the mouth of the Demogorgon to stop it from binding to our human cells. Just finish off with some statistics. So Folding at Home does offer a little bit of gamification for those of you that are competitive out there. We've roughly at Team VMware contributing to the project just have over 1,000 active members today. And hopefully by the end of this presentation, we'll add a few more. We produce the Fling to help volunteers easily get started to contribute their resources from their vSphere platforms. And currently we have around 42,000 downloads of the Fling. We can also call on our vendors and maybe even our competitors in Dell, Nutanix, Rubrik, ECT Beam, SunGuard AS, and many others, such as VMware partners and customers using our Fling today to contribute to our team or their own teams as well. And we're going to discuss about how you can also join our team and contribute. One of the questions that I'd like to ask if you want to get in touch with me directly is, how many of you today are using our Fling? And as you can see in this big column here, a lot of users that downloaded our Fling originally downloaded the original version, but never moved or downloaded to a newer version of the Fling itself. So again, there are some benefits and features and reasons to do that. If you're unsure, then please, at the end of the session, reach out to me as well, and we can chat about that too. As Pat mentioned, getting started is really easy. Just go to the foldingathome.org website. You can either start folding locally on your machine, which we'll cover in a second, or the more technical demo is going to be looking at running it on a vSphere platform. Running it on your local machine, as you'll see in a second, we just kind of access this through a local hosted website, and it just runs in the background as we need. Or we have that more in-depth OVA, and we'll also talk through some options available for managing this at scale. So I'm going to move into my lab environment now. So as mentioned, going to the website is going to show you the version for the operating system that you've loaded from, and you can see the vSphere environment as well. And I'm just going to click on the alternative downloads, and we'll come back to that in a few moments. Running on my local machine here, so this Windows server has the Folding at Home software installed. Today, I don't really need to show you how to install Nextfusable. We're all okay with that. But what you will be able to do is add an identity, link yourself to a team. You'll get some statistics that come through to help with the gamification side of things. You'll also get some really cool information, such as which project you're contributing your CPU cycles to. And the numbers displayed here really just kind of summarize the shard or the part of the protein that you're going to compute against as well. Proteins, we mentioned before, very complex items. You need a lot of CPU resources to compute those folds. So you will find that you will not get a single project item to yourself that is looking at the full protein itself. You're always going to get a small part of that. On our flings.vmware.com website, you'll be able to find the actual appliance Folding at Home itself. We've got a number of requirements listed. You can essentially run it on pretty much any version of vSphere that's supported today, or VMware Fusion or Workstation. We've got the OVA to download, full in-depth deployment steps, an FAQ as well for commonly asked questions, and if you want to go a little bit more advanced, we also have instructions on how to use a GPU as well. So I'm going to take you through a quick demo showing you how to deploy the OVA. It is pretty simple, to be fair. I've already loaded up the OVA from the Flings website just to save some time. We're going to deploy that virtual machine. So We'll give it the name of vBrownBag -FAH. We can select an area to deploy it to. And realistically, none of these options for deploying an OVA different to what you've been used to in the past. Just take a couple of moments to validate. And the first decision you need to make is the size of the OVA itself. So we've given you some basic guidance on what we found works really well with the appliance itself. And as I mentioned, the software is very CPU heavy. So you start off with 2 CPUs, 1 gig of RAM. A large machine is going to be 16 CPUs, 4 gig of RAM, but you can change the OVA appliance manually yourself after you've deployed it. 4 gig of RAM is the maximum you need for the virtual machine, but you put as many cores as you've got available to that appliance. Then select your location to deploy to, your network, and then you've got the OVA appliance settings itself. So we're going to provide the host name, IP address, gateway, DNS, the typical settings you expect for a Linux appliance. If you leave these blank, that's perfectly fine. We'll use the HCP for networking. We've got proxy settings if you go through a web server for whatever reason. Then we've got some mandatory settings. You're going to have to set this root password. If you do not set that root password, when the appliance boots and tries to auto-configure itself, it will fail. And you'll actually see a little login screen that says vghetto-login. Setting the root password then will actually show the host name that's set for the OVA once it's deployed and the first boot has completed. So I'm just going to set VMware1 exclamation mark for this demo. I'm going to enable SSH so I can connect to this machine remotely. I can set the parameters for the folding home software itself and link to my user account. We do recommend using a passkey. It's just an additional way to authenticate itself. It's a unique key to yourself. But again, you don't need to set any of these options if you want. You can just contribute to the project anonymously. Set the mode in terms of how many cores of the virtual machine it's going to use. Because it's dedicated to OVA, I always recommend full. If you want to use GPU enablement, then you're going to have to enable it here. Set which networks can access the OVA appliance itself. And also set a remote access password as well. We also have the ability to show a top console for the OVA once it's deployed to see your environment. And then finally at the bottom, we've got some advanced settings around debugging and net unit percentage. Again, I encourage you to kind of read some of the documentation at home about what these settings do. Okay, so I've already deployed some virtual machines in my environment to save some time. And I'm just going to show you a virtual machine that's been deployed straight away. So in the web console, by default, we've got this top environment. I can see how many cores are being used. And at the bottom there, we're tailing the logs, the software. And we can see that I've computed 99% of this particular work unit that's been downloaded by the FAH client. One of the things I also want to show as well is we have the ability to download an FAH control software when you've deployed many appliances. If you download the Windows or Mac OS X client to run it locally as well, this software is included. If you're running on Linux, it is a separate download. Once installed, you just look for FAH control on your machine. It's a very, very simple interface. You will go in and add your client machine and the host, the IP addresses that it's booted on, or static IP address you've given, the port that you are interested in. So by default, this is, we use the default ports, there's no change there. Password displayed for the OVA deployment itself. And then your interface will look like this. We've got the same settings you actually see through that web interface, such as the project number and IDs we're working on. And if I open up the advanced settings, again, we can change the identity. So if you get something wrong, you can change it. The slots, this will be set for CPU by default. You're going to have to configure some of these extra settings yourself for GPUs. We've got the remote access settings, got proxy settings, some advanced, and we can even select which cores we want to dedicate to. I just choose for any disease that's available for any project. And then finally, expert settings as well. So we won't in this particular call go through them in much detail, but we do have some answers in our Folding at Home FAQ on the Fling website for you as well. So I've really taken you through a whistle-stop tour of how to deploy the OVA and how to manage multiple OVAs itself. Everything else, you leave the software to itself. One of the things that I'd really like to call out, just by going back to the slide deck in my last 60 seconds here, is once you've deployed the OVA, sometimes you'll see that you get failed to connect messages in the logs, and this is fine. The folding at home environments have hundreds of thousands of users and millions of users during the COVID at the moment. And sometimes the work servers that we download the researchers' projects from and also upload the completed work units to can come overloaded. The software itself is designed to work in the background to continue to try and upload those files and download new work units as well. So I really recommend that if you're seeing this error message, don't panic, leave your software to continue running in the background. If you realize, that it's maybe going on for a number of hours or even days where you're getting nothing, then please reach out directly to myself over Twitter or through my blog, through the Flings website as an issue, or go to the Folding at Home forums as well for additional support. I'd really like to wrap it up there today with a final call to action. It's very easy to get started. Just go to foldingathome.org. And I'd also just like to end on some short links as well so that you can go directly to our Fling website and also to the blog covering the common FAQ. Thank you very much for your time in listening to me today. It's been a pleasure. Hello, everyone. Today, I'm going to be covering the considerations and constraints for running VMware Horizon on VMware Cloud on AWS. My name's Dean Lewis, and I work as a technical account manager at VMware. You can contact me through my blog, theeducate.co.uk, and also on Twitter, SaintDLE. As there's going to be a lot of information we're going to go through in the next 15 minutes for this recording, you can grab all this by going to the short link, theexpert.me/VMC-Horizon, and I'll show these links at the end again as well. Just a quick overview of the agenda. Essentially, we're going to be looking at what Horizon is, what's special about it when it runs on VMC, talk about those considerations and constraints throughout, and then finish off on a final summary as you'd expect. Okay, so first and foremost, I'd like to start with Horizon 7 running on top of VMware Cloud and AWS is not desktop as a service. For those of you who may not be familiar with the VMC offering, it is a VMware managed service. We run the underlying vSphere platform for you, and you consume it by bringing your own virtual machines to the mix. By running Horizon 7 or 8, also known as 2006, which has just been recently announced, as an IaaS model, it means you bring the platform or the virtual machines onto the VMC and you run it yourself. So this will be self-managed, you are the tenant. This is in contrast to our Horizon Cloud offering, which is available on IBM SoftLayer and in Azure as well, which is a managed service from the Horizon platform itself. If you are using the Horizon Cloud platform, you will bring your virtual machine images and you will ask to deploy those images into a pool, which can be used by your users, but you will not have to manage the Horizon platform itself. Today, we're only going to be talking about running the IaaS model of running the IaaS components on VMC itself. Just also want to make a quick note. In VMware Horizon, we also support the cloud architecture. The reason why this is important is typically a lot of customers looking at running Horizon in VMC today already run Horizon in their on-prem data centers. You can extend your Horizon environment by using cloud architecture into the environments running in VMC and running in your on-prem vSphere environments. That creates a flexible, highly available platform. You will have to keep the platforms in sync with one another from a version and control point of view. But other than that, it's the exact same kind of architecture and references you'd be looking for to running cloud architecture if you were keeping all of your environments the same on-prem, but maybe between different data centers. Okay, so I'd like to allude to what is the big difference from a usability point of view for Horizon once it's stood up and running the VMC? And the answer is not much. It's a small little tick box. When you connect your vCenter server to tell the Horizon environment where it can deploy its resources to the platform, you tick the little box that highlights its VMware Cloud and AWS, as highlighted by the big red arrow. And this lets the Horizon environment know that there is a limited RBAC model in place as part of the VMC platform, because it is a partly managed service by VMware. I'd also like to note that there are some feature support that you need to take into consideration as well. So for example, we don't support view composer linked clones in VMC. We don't support running security servers, which are the Windows-based Horizon servers using your DMZ. It's preferred to use the Unified Access Gateway. And also there's no ability to use things like vVols, for example. This isn't applicable for VMware Cloud and AWS because we provide you a single vSAN workload data store. vRealize for Horizon monitoring. We don't actively support it. It can be granted on an individual basis. Speak to your Horizon SME that you're aligned to if you're looking into running a Horizon project. And then finally, the just-in-time services, the JMP servers, you can use them in the Horizon Cloud Console instead of running them yourself as well. But again, some of this information, as we start to release and ramp up with the GA data for Horizon 8, will once again change again. So for example, just going back to the lack of linked clones, if you were deploying the latest version of Horizon, we only support instant clones anyway, so it's not as much of a consideration going forward. On our cloud.vmware.com website, we do have a reference architecture that takes you through the minimal viable product to start building your Horizon services in VMC. So let's look at some of the typical considerations and constraints. So the first one is always about your underlying platform. Identity management's always going to be key. Proximity to your Active Directory. So if you don't run any VMC services today and you're looking at this being your first foray, you need to consider at least a read-only domain controller stretching from your private or on-prem data centers into VMC. And ensure that you configure sites and services correctly within Active Directory so that when users are authenticating to any services running in VMware Cloud and AWS, it authenticates against the local domain controller and doesn't go across your VPN or WAN links back to your on-prem data centers. File shares is always the biggest one because files access is your end user experience for most users when they log on. They want to run Word documents, PowerPoint presentations, images that they may have edited. So again, proximity of these file shares to the user's desktop running VMware Cloud AWS is key. For the user documents, consider using technology such as Microsoft Distributed File Services if you are stretching between your on-prem environment to VMC. We also support native services within Amazon that you can bring across into the VMC environment as well, in particular the Amazon FX for Windows File Server service. So this is where you would spin up a Windows server as an EC2 instance, add the Amazon FX technology on top of it, and then use it to host the file shares back into your SDVC. User profiles. I'm pretty sure for those of you that have been sysadmins for many years, user profiles have been the bane of your life as much as they have been for myself. Consider using technologies such as user profile management. So for VMware, that would be our Dynamic Environment Manager, previously named UEM, where you can dynamically build configurations for users on the fly as they log into the systems. This minimizes the need for GPOs and replication, and also as well can give the user the feeling of persistence, especially in non-persistent desktop builds where those desktops may be deleted when users log out. We also do support user profile context systems such as Microsoft FX Logic, which is a cool technology which kind of containerizes profiles as well. However, that's a little bit newer to the market and may take a little bit more changes in your environment to get up and running so that it works as you need it to. And then finally, one of the big things for me is image management. So at the moment, Horizon doesn't support the use of content libraries, which is using content libraries, you can synchronize images between environments. So unfortunately, there is going to be some manual parts to how you operate the data operations and push updates out into your tools as well. So you need to consider about running those golden images. Do you run separate images in your on-prem environment and in VMC? And if so, how do you update them in lockstep? So that's going to be more about how you control your standard operating procedures for the time being. And again, image management today, I know that it is going to be one of those things that's a little bit tricky for yourselves, but by feeding back how you'd like this to work to your VMware SMEs as well really helps, because we can work with our engineering departments to meet your needs. So for me, the biggest considerations and constraints when running in VMC to an on-prem platform is the networking and security side. When running Horizon, as you kind of already noticed, we've not really talked about in the Horizon admin console itself, for example, because everything kind of feels and looks the same, but the networking and security piece is really key. So you're going to have to create yourself some LAN and DMZ segments in the VMC console. As you can see by the screenshot that I have for my test environment, I created a DMZ, a network to run my RDS farm, which is linked to Horizon, and then also a load balance segment as well. Moving on to load balancing, VMC is a bring your own load balance environment. So although the underlying platform uses NSXT, the load balancing functionality isn't exposed to the end user. So what options are available? You could use things like AWS Route 53, which is fantastic, especially if you want to use the cloud pod architecture. You could use the AWS Elastic Load Balancer, so again, leveraging those native services of AWS, as the diagram shows here at the moment. But you also need to consider the traffic. So the user will be terminating from the public internet to those native services, and then will need to be passed from that VPC of those native services into your VMware SDDC. Or you can bring a load balancer directly to the SDDC within VMC itself, such as Avi Networks, also now renamed NSX Advanced Load Balancer. The difference being here in the second screenshot is that that traffic will terminate on the compute gateway, as all of your other traffic will within the SDDC, and then the load balancing function is going to happen in your environment. That's also very obvious, but some of the considerations you need to take there is by running them virtual machines on your platform, you're consuming the compute and storage of the SDDC, whereas you may not have those considerations if you're running the native services within AWS. And then finally, you're obviously going to be running desktops up in the environment, and typically nowadays a lot of people go down the non-persistent route, which also means using DHCP. In VMC, the options are very limited. DHCP is available as a relay now, and for an environment, especially where you're looking at running hundreds or thousands of desktops, it's recommended to set up a DHCP on a server running in VMC. Run it just on the subnets that you need, but it also gives you more granular control. Also moving on for the security side of it, we have two types of firewall. So we have the gateway firewall, which looks after north and south traffic. So that's everything entering and leaving clusters or the SEC to the outside world. And then we have the distributed firewall. So this is your east to west traffic or microsegmentation services you've probably heard from the NSX technology, protecting communications between virtual machines. You should see me highlighting that better now at the moment. You need to use the distributed firewall to create a DMZ for your UAG services and load balance services. So what does that look like in VMC? In my environment, I created a section. I've put all of my rules going back and forth between my UAGs to the various components of the Horizon platform, so such as my connection brokers, my load balancers. And at the end, it's very simple. I've created two rules. So I block any traffic which hasn't already been allowed going to my UAGs, and then finally deny any traffic going from my UAGs to anything else in my environment. This creates a DMZ. If I don't add these deny rules in, then because I'm using routed networks in VMC, my UAGs will be open to route around my network. One of the things I'd also recommend that you do is look at vRealize Log-Insight Cloud. You get a limited service offering as part of being a VMware Cloud and AWS user, and you can monitor your NSXT firewall logs up to 1 gig of logs per day, and these are easily sent to Log-Insight is built in as part of the service by just clicking the option to enable logs on your firewall rules. And here we can just kind of see in this diagram, I'm querying on the NSXT firewall, and then we can just see some traffic which has been allowed and disallowed through the environment. Okay, so let's wrap up with some final considerations. And again, I will share the links at the end of this presentation because I know I've shared a lot of information so far. Consider your use case. A lot of customers are looking at the data center evacuations being one of the use cases. You may already have an on-prem Horizon environment running on aging hardware. So do you want to use cloud pod architecture to give the user a seamless interface between consuming on-prem resources and resources in VMC? Or will you run them as separate Horizon instances? So again, what versions you run your Horizon environments will help also make that decision. What are your constraints when building this environment? So think about sizing your Horizon environment. How many users are you going to need to support? Then consider the maximums in terms of soft limits and hard limits. How many hosts per cluster can you have within your SDC? How many clusters per SDC? And what regions do you need to operate in? Desktop to host ratio is always a key thing for VMC. So do your users run intense workloads such as multi-monitor setups? If the answer is yes, you're going to get less desktops to host ratio, which then pushes up the numbers of clusters that you need. And then finally, networking. So what's your connectivity into VMC? Are you using things like IPsec VPNs, which will add an overhead into your traffic? Or are you using the AWS Direct Connect technology, which is faster links, dedicated, but also come at a high cost? And some of the resolutions for this. So you could scale out across multiple SDDCs to help with cluster limits, desktop to host ratios, and also as well splitting out maybe that traffic if you're using IPsec VPNs across different tunnels and different connection endpoints as well. If you were to do this across multiple SDCs, as we can see up here in this diagram, then you can also use cloud pod architecture just in VMC to link these Horizon environments together to give you a seamless experience. Okay, thank you very much, everyone, for this whirlwind tour of Horizon on VMC. Again, you can find all of the links at theexpert.me/VMC-Horizon, or you could also scan the QR code in the top right-hand corner. Thank you very much.
Hello, everyone. My name is David Santos. I'm an NSX engineer. And today we're going to talk about VIO, VMware Integrated OpenStack, and NSX. How a VIO is an easy button for OpenStack deployment, also with the NSX providing the network. So here we're going to talk about the architecture, the VIO architecture. In the middle, we have VIO, and it will be consumed by Horizon. That's the project that provides the user interface, the UI interface. We're going to consume our infrastructure as a service. And in the back, we have the VIO products. We have Nova for computing, and in the VMworld, the Nova will be provided by vCenter and ESXi. Here we have a benefit of using VMware as our Nova project because vCenter will be the single endpoint for all the Nova workloads, and also have like native VMware features like DRS and vSphere H8 that helps with the availability of the environment. And we have Cinder as the block storage. In the VMworld, Cinder will be provided as our data store. So every time that we use a data store, it will be used as a Cinder block storage. Neutron will be provided by NSX. Like Nova, NSX has a benefit that will be the single endpoint to deploy networking, like layer 2 switches, routers, load balance, and firewalls. We also have Glance. Glance is the image project for OpenStack, and in the case of VMware, the glance will be the VM templates that will be used and that will be consumed in VIO. So before we start, we need to deploy some objects in NSX. In this case, we need to deploy a T0 router, and also we need to exchange the routes between T0 and a physical router using BGP. This way, everything that we deploy in VIO will be automatically distributed to the physical infrastructure. So after that, we're gonna have our first step, that is to create a local network. In this case, we're gonna create a local network called local 1, and we're gonna connect 2 VMs in that network, Web 01 and Web 02. So here I have our network topology. I'm gonna create the local 1 network, create a subnet for that network that's called local 1 subnet, and also provide the IP address for that network. And it will automatically use the first IP as the default gateway when you create that. And now we're going to connect our Web 01 and Web 02 to that network. Web 01 already connected, and now we're going to connect the Web 02. And now I have already layer 2 connectivity between those VMs. And I'm gonna connect to the Web 01. It asks for changing password because the first time that I connect to that. And now I'm gonna ping to the Web 02. And you can see here that the ping is working. So the second part is to create the routing network. So to do that, we're gonna create a router in VIO in the NSX, and like under the hood, what will be done is NSX will be configured to create a new T1 gateway, a new T1 router, and also we're gonna use the T1 router to provide connectivity between the local 1 network that has just been created, and to local 2 network, where we're gonna have our other VM that's at 01. So here in the routers tab, we're gonna create a new router here called VIO router. And then we're gonna access that router and go to interface, add a new interface, select the network that will be connected, and it automatically will use the first IP as the IP for that router. And that will be our default gateway. You can check in the topology that will have our router connect to local 1 and local 2. Now I'm gonna connect the Apple 1 to that network. Apple 1 is already connected to the local 2, and it gets its IP address automatically using the HCP. And if I do a little ping here to my Web 02 or to my Apple 2, the ping works successfully. The third step is the external network. So the external network is kind of an IP pool that will be used as a floating IP or like external load balance IP. It doesn't create a real network. It creates a pool that will be consumed either as a floating IP or a load balance IP, but it doesn't create anything. In this case, that external network will be used by this T0 to provide NAT or to provide or to deliver those IPs to our objects that will be published externally. So as it's an external network, we need to do that in the VIO admin level. So this way we can share that network with among all the projects that we need. So I need to go to the admin level, go to network, and here I'm gonna create a new external network. I'm gonna call that network external, select the project, this way, in this case will be admin, and it's a local network, but I select here shared and external. I include here the subnet name that will be used as our pool name, and also the IP address that will be delivered to that pool. It doesn't have a gateway. It doesn't have a gateway now, neither DHCP. We cannot create DHCP. We cannot set DHCP rules in the external network. And here we can check that our external network has already been configured. The fourth step is the floating IP. So the floating IP will be done by connecting that T1 to our T0. Actually, we're going to connect that T1 to the external network. That what is showing. That's what is shown on the VIO console, and it actually is will distribute the floating IPs that we assign to the VMs here. So when you create that, it will create a source NAT rule to all those VMs communicate with an external, with an external network using a source NAT IP, and also to the ingress traffic, the traffic that comes from the external, like the physical network. We need to provide a floating IP to those workloads. This way, we don't need to redistribute or to share the internal networks with like a physical network. It helps a lot when you have like bubble environments or when you have a multi-tenant environment and you have IP overlapping. This way you can have multiple identical networks with identical subnets sharing only the floating IP as a common network. So this way we're gonna go to routes. It has to be done. It has to be done in the project level, and here in the VIO router, I select my external network as my source, my way to the to external world. And here I can see that all the networks can communicate externally, and I'm gonna create a floating IP. So I have 50 floating IPs available. I'm gonna allocate one to my project and associate that floating IP to my Web01. After associate that, I can successfully do an SSH to that VM. And here I will log in and try to do a little ping to my app VM, and the ping will work as it worked before. The fifth step is the load balancing. So we're going to create a load balance that will be placed in the T1, and our pool members will be Web01 and Web02. So I also need a floating IP pool to do that. That IP pool will be associated to our load balance later. I go to neutral load balancer, create a new load balancer. I can select here a name for that load balance, select which subnet will be connected, the load balancing protocol, that in this case will be HTTP, also the port that will be used, and the method, in this case will be round robin. Here select the pool members, that will be Web01 and Web02. Also can select the port if it's another port, the monitor. I can select like get to a specific URL or an object. And it's really simple to create a load balancer. After that, we need to associate that load balancer to my floating IP. And once that's associated, we can connect it to our network, to our application that's running in that network using the floating IP. You can see that's load balancing across Web01 and Web02. The last step is the sixth and last step is the security group. So security group will be delivered by the NSX DFW. So in this case, we're going to create a new security group called allow HTTP and block everything else. It will allow external, like ingress traffic to HTTP, like to a web application, like Apache or any Nginx. And I will associate that security group to my Web02. That my Web02 is in the full security group now. If I try to ping my Web02, it works. And if once I change my security group to allow HTTP and block all and remove the default, I can check here that the ping is no longer working. So I can see the packet drops here. And that's all I have today. Thank you very much for watching. See you next time.
Hey, this is Shashi from PowerFlex product management team. And I mainly focus on developing applications and workload solutions for PowerFlex. And in today's session, we'll talk about some specific use cases and applications for high-performing machine learning solutions like Elastic Stack on PowerFlex with VMware. So just a brief update or a brief summary of what is Elastic Stack and its use cases. So Elastic Stack, previously known as ELK Stack, is kind of a combination of 3 different modules, open source modules. One is the Kibana, Elasticsearch, and then also the key other module is the Logstash. Again, the Kibana is the component which again mainly handle storage analytic operations. And then the Logstash is the component which kind of takes care of all the ingestion and then again feeds that ingested values into the Elasticsearch, and Kibana helps in the visualization. So all these 3 components together is called as Elastic Stack, which has become very popular now for customers who are challenged with really exponentially growing, very mission critical and high throughput, and it is definitely becoming very popular. Again, a lot of customers are looking for alternatives. There are some leaders in this field, but again, customers are looking for alternative because machine data analysis is becoming more expensive, and then also very challenging data. And then also they're looking for platforms or infrastructure which can be scaled easily, and then also provide some kind of a really predictive, and then also one of the very popular open source tool, which is again gaining really good traction. And then again, customers are looking for deploying this kind of deployments on containers with virtualization, because that's the way they can actually address a lot of challenges with respect to these customers, because they have that kind of flexibility now wherein they can actually manage different kind of or different challenges with respect to performance with different applications and containers, and also the VMs. So let's talk about PowerFlex. Dell EMC PowerFlex, again, is a software-defined storage. Again, the three key tenets are harness software, embrace change, and deliver predictability. Again, when I say harness software, Dell EMC PowerFlex is the software-defined storage, which is really known for its performance, scalability, and fluidity benefits. Again, when I say embrace change, the other pillar is the deployment options PowerFlex provides. And then also the different options with respect to the platform support, whether it is 2-socket or 4-socket. And then also the consumption models, whether you need a completely engineered system or an appliance model, wherein you can bring in your own networking. So you have all that flexibility and deployment options with PowerFlex. Again, the other key tenet for PowerFlex is the predictability. You get 6 nines of availability, and then also the automation which you get with PowerFlex Manager, which is the orchestration software, is very unique because it can actually provide end-to-end automation and orchestration capabilities for your entire stack, including networking, storage, and compute resources. And whatever is your challenges with respect to workloads, whether it is performance or reliability, PowerFlex can provide you that kind of predictability. So they get a little bit more details on the PowerFlex software-defined storage. Again, PowerFlex is known for performance, scale, and resiliency. How does it provide that kind of massive performance? The PowerFlex can provide that kind of unique massive performance because of the architecture, the unique architecture which PowerFlex has. On a PowerFlex system, every node on the cluster, including every drives sitting on those nodes, actually contribute with the IO operations. This is one of the main reasons why, because of this aggregated resources, you get millions of IOPS with sub-millisecond latency. And then also you get the same kind of throughput. And then also when you scale your environment, because all your nodes and drives are contributing with IO, you get the same kind of benefit without any latency impact. When I say scalability, I talked about the key benefits with respect to latency and also the performance benefits. Again, as you can see, you can start probably with the 4 nodes, a very small footprint of 4 nodes, and then you can grow up to like hundreds or even up to 4,000 nodes. We actually have customers who have more than 11,000 nodes in their infrastructure data center, and then also with almost up to 300 to 400 nodes on a single cluster. So PowerFlex provides this kind of unrestricted scalability. And then again, whether you use 4 or 400 nodes, you get the same kind of benefits with respect to performance and without any latency impact. And the other key tenet or the key unique value add or the differentiation with PowerFlex is the resiliency. Whether you use 4 nodes or 400 nodes, as I mentioned, you get the same kind of performance. Again, the other key thing, which is very critical for a database administrator or a analytic administrator, is the reliability of the storage. So on a PowerFlex cluster, if for some reason, if there is a planned or unplanned outage of a node, then the administrator or the application administrator does not need to worry about that. The PowerFlex storage will automatically take care of rebalancing the remaining IO operations, all the IO operations on the remaining nodes. And then also it will make sure that the IO is completely rebalanced on the other existing nodes of the cluster. Again, similarly, once that node becomes online, it will automatically make sure that the IO is completely optimized by rebalancing across all the nodes available on the cluster. And the other key thing I think which I mentioned as one of the tenet of PowerFlex is the flexible deployment architecture. So PowerFlex offers a unique architecture called a disaggregated or two-layered architecture, wherein you can have your compute and storage resources independently managed, and then also independently you can scale them based on the need. This is very unique architecture by PowerFlex, because especially in analytics application, typically you don't need to scale your compute resources all the time. There is always a lot of data being ingested to the system, and then most probably your scalability requirements are only with respect to capacity. So in this kind of scenarios, you can actually independently scale your storage nodes and then keep your compute nodes as it is. Or in case if there is a requirement, you can also increase your compute resource as per the need, which is going to give you a very predictable and then also very cost-effective architecture for analytic applications. And also if there is a need for you to have all your compute and storage resources as a single system, as like a hyperconverged model, PowerFlex even offers that, and then also it supports that. And then also a lot of customers start with a hyperconverged configuration for some specific use cases, and then based on the need, you can actually add only compute resources in a two-layered architecture as per the need. So as you can see, PowerFlex can provide you all these different kind of deployment models based on your need with the same infrastructure. And the other key thing I just want to highlight here is whatever is your application, whether it is like a very high throughput intensive application, like analytic application like Elastic Stack, or a SaaS grid, or any databases, or any other cloud native or container based applications. And you can deploy that on PowerFlex on the same infrastructure, and then that is the kind of flexibility you get here. So as you can see, PowerFlex can support bare metal configuration, wherein you can deploy some applications like Oracle RAC or any other traditional databases, or you can even have native applications running on containers, or you can even deploy virtual machines. And then also, if required, there are a lot of use cases where customers would like to prefer deploying containers on top of VMs for specifically addressing some isolation and security aspects, and even that is supported on PowerFlex. So you can see the kind of broad platform support PowerFlex provides for analytical applications and then also other mission critical applications here. And then also PowerFlex provides some of the very features which is very, very relevant, and then also which is required by large mission critical applications like native replication and compression, which are very effective for managing your huge ingestion and then also the growth in analytic applications like AI/ML and other cloud native and then database applications. So let's go into detail of little bit of specific validation and then also some of the reference architectures we have developed with Elastic Stack on PowerFlex with VMware and then containers. So we have a reference architecture. This is a partner validated solution. We worked very closely with Elastic team here, and then we have come up with we have validated a solution wherein PowerFlex was used as the storage infrastructure, and then with VMware Hypervisor, we use Kubernetes containers on top of VMware Hypervisor to deploy the entire Elastic Stack components, which is Logstash, Elasticsearch, Elasticsearch, and Kibana, and all those components which I explained previously were deployed on top of VMs here, like on the virtualized VMs, and then again, ESXi 6.7 was used here as the hypervisor. And then again, this solution actually is completely validated, and then also it's not just, when I say validation, it's not just a validation of the architecture. We also did a quite detailed performance benchmarking on this solution to see what is the kind of value, because there is always a question by a lot of Elasticsearch or any analytic applications, analytic customers saying that, hey, if I virtualize this kind of environment, especially this kind of throughput intensive applications, what kind of performance can I expect? because they're always worried about this kind of throughput intensive applications. Again, there was always a concern. So we have done like detailed performance benchmarking with the tools, which is completely the industry standard tool, which is developed by Elastic to make sure that what workload we are simulating is very realistic here. So as you can see on this ESXi 6.7 based PowerFlex cluster, with this cluster, we were able to achieve more than 1 billion events within 3 hours. Again, this is again a very basic 4 storage node cluster. As you can see, it's a very starting point of a PowerFlex node cluster with a 4 node storage only cluster. We were able to hit more than 1 billion events within 3 hours. And then again, this is the kind of performance you can get. So these numbers are like phenomenal. And then as you can see, again, when we grow your PowerFlex nodes from 4 to 8 or again more than that, you can get the same kind of linear scaling and linear performance benefits. So again, the other advantage, as I mentioned, is you can even scale only storage if required, or you can scale compute only if required based on your needs. So these numbers are again available in the link what I'm sharing in this. So you can go into the details of that white paper and the detailed reference architecture which I showed here, and then you can get all the details about other key performance numbers which we were able to get from this testing. Again, as I mentioned, like why PowerFlex for Elastic? So PowerFlex, as I mentioned, is known for its high performance and scalable block-based storage, which is really ideal for applications like Elastic Stack, because Elastic Stack customers are looking for this kind of high performance, scalable solution wherein they don't have to worry about the challenges with respect to scalability and the daily ingestion. And then also if they need to scale, how easily they can scale without any, worrying about what needs to be done at the storage side. So, and they can focus entirely on their application and tweaking the application for day-to-day operations. And then the other key things, again, as I mentioned, is PowerFlex supports any hypervisor, including VMware, or you can even do bare metal or even on containers. And then the scalability of compute and storage resources independently is one of the key, key factor. And the other thing I wanted to highlight, especially with Elastic Stack solution, again, Elastic is a GCP partner. Already the Elastic Stack is available. The entire Elastic Stack is available through GCP partner today on GCP Marketplace. Again, a lot of customers are looking to deploy this on top of containers. And then there is a lot of traction happening in this area. And then PowerFlex is already validated for Google Anthos. And then already there are work going on, and then there are some POCs and investigations, and then more work happening wherein we are investigating and trying to validate solutions where you can deploy Elastic Stack on top of containers with PowerFlex. And then also Google Anthos is one of the solutions we are validating. So just to conclude here, again, as I mentioned, for Elastic Stack especially, we were able to achieve 1 billion plus events with just a 4-node storage-only configuration with 3 compute nodes, and again with 3 hours. So this is with Elastic Rally benchmarking tool. And then again, as you can see here, it's not only analytic applications, like again, Elastic Stack and SAS Grid, as you can see, are some of the examples for analytic applications here. But even other applications, whether it is like a traditional database like Oracle or SQL, or even a NoSQL database like Cassandra, you can get the same predictability, or you can get the same performance benefits and the scalability benefits for these kind of applications on PowerFlex. Actually, I just wanted to highlight here that I'm covering some of the specifics or more details on some of these traditional databases and NoSQL databases, how you can deploy and what are the benefits with PowerFlex in another vBrown session. I'll be really happy if you can please also join that session, and then if you have any questions, please let us know. And then again, I just wanted to highlight the resource link here. Again, this is the detailed reference architecture, partner validated solution, which we have done with Elastic. Again, this has all the details with respect to what are the guidelines, and then also the sizing, and then also it has all the details with respect to the performance results which I shared, like how we were able to get this kind of performance, and then also some more details about the test configuration and then other test tunable parameters and all the details here. Again, I just wanted to end with a customer testimonial here. Again, PowerFlex, as I mentioned, is already, again, we are seeing a lot of traction of deploying this kind of AI/ML or analytic applications with PowerFlex. Again, we have a large North American bank. Again, they were really impressed when they were able to ingest more than 25 terabyte in 18 hours with just 5 VMs. That's what I wanted to highlight here. It's just 5 VMs, and then they were able to get 25 terabytes. So this is the kind of performance you can get. And then also the other scalability and linear scalability and the reliability benefits complements this. So this is a really great solution for analytics and any machine language or any kind of AI/ML kind of workloads. That concludes my session. Thank you.
Hello, my name is Rich Colbert, Field CTO for Dell Data Protection. The topic of this presentation is how does Dell Technologies offer a low-cost data protection solution? Today, organizations are experiencing rapid data growth and diversification. Therefore, effectively managing the cost of data protection has become a priority. Data now spans the edge, the core, and the cloud across a multitude of applications and platforms. And in response, organizations are deploying and extending data protection solutions to protect that data and those applications where they reside. The saying that you get what you pay for still holds true, but in the multi-cloud world, it is probably more accurate to say you pay for what you get. In other words, consumption is rapidly becoming a leading factor in determining the costs associated with data protection. That leads us to the key point for our conversation today. Architecture matters. It's not a new concept. Technology innovation and progress has always placed a premium on developing superior architecture. But this is no longer an engineering conversation about building a better mousetrap. Architecture has a direct impact on consumption, and consumption is a leading factor in cost, along with a whole list of additional business values. What this means is that architecture is now a business conversation. And as such, there is additional focus applied to making the business case. It's no longer acceptable to simply compete with academic arguments in the marketplace of ideas. Architecture conversations need to be tied to measurable outcomes with validated metrics that impact the bottom line. These are the 4 pillars of the Dell data protection strategy that are the keys to our architectural advantage. The first is highly differentiated deduplication. Not all dedupe is created equal. And in this category, being second best simply isn't good enough. The second is distributed deduplication, also known as DD Boost. This innovative and unique approach to protection storage provides numerous benefits that we will cover in some detail. The third is our storage appliance architecture known as Sizzle, or Stream-Informed Segment Layout. This is our secret sauce to provide industry-leading performance and scale. Fourth, and finally, is our data and vulnerability architecture. At Dell, we haven't lost sight of the fact that it isn't just about managing data. It's about protecting data. When we say deduplication, we're really talking about compounded data reduction. Data deduplication and compression work together to reduce the amount of usable capacity required to store protection data. With daily backups retained for typically 30 days or more, data protection requires many logical copies of very similar data. In fact, protection copies can account for up to 95% of an organization's entire data storage footprint. So efficiency is the key to driving down the associated costs. Based on proven data domain technology, Dell's deduplication is inline with variable segments. Inline is important because it eliminates the need for a landing zone, which reduces the storage required in half right off the top. Variable length segments are even more important, and the smaller the segment size, the better. Our segment size is an average length of 8 kilobytes. Variable segments encapsulate changes in the data patterns to allow the system to find duplicate data, regardless of whether that data has been copied, appended, or even updated somewhere in the middle. And this algorithmic approach works well for both structured and unstructured data. But what matters to the business are the results. And how does that compare to the industry? Dell's technology is typically anywhere from 30% to 3 times more efficient than alternative solutions. And I'm making a direct and practical comparison. I'm talking about the basic question of how much usable storage is consumed and how much network traffic is generated to back up and replicate the data. What does that mean for the business? It means that Dell can protect your data using a right-size solution that requires significantly less storage and less bandwidth than the alternatives. And now take that one step further. What about the cloud, where you pay for your cloud provider for that storage consumption and that network bandwidth every single month? Protection storage on premises generally accounts for anywhere from 8 to 20% of an organization's total storage spend. But organizations who use ineffective data protection in the cloud can see those costs skyrocket to over 50% of their cloud infrastructure consumption costs. Dell Data Protection can reduce that exorbitant level of cloud spending dramatically. That is why effective data reduction matters. And that is why Dell Data Protection customers are protecting over 4 exabytes of data in the public cloud today. But no matter how effective your deduplication is, you give up almost all of the real benefits if you still have to send 100% of your data over NFS every time you back up. Backup execution can be broken down into 3 logical steps: process data, send data, and store data. When deduplication happens at the storage device, the upstream processing of sending and storing data is unchanged. And that is a whole lot of data to sift through and send across the wire every single day. A number of alternative solutions still use plain old NFS as a data transport. But distributed deduplication is a powerful innovation that takes the task of identifying unique data and moves it closer to the data source so that far less data is processed or sent in the first place. We call this technology DD Boost. DD Boost is an embedded technology, and it can be found in all sorts of places. DD Boost can be found embedded in backup agents, both provided by Dell and by a number of third-party DD Boost partners. DD Boost can be embedded in VMware infrastructure, leveraging VADP and bringing source deduplication directly into the virtual infrastructure. DD Boost is also deployed inside database backup utilities like Oracle RMAN or Microsoft SQL Management Studio and many others to bring the power of source deduplication to DBAs and application owners. DD Boost can also be embedded in Linux and Windows file systems so that modern application backup tools can take advantage of distributed deduplication simply by utilizing their basic file export utilities for backup and recovery. So, what are the benefits of deploying DD Boost? The first is faster backups. Backups using DD Boost can complete in about half the time compared to backups that send all the data to the target. The second is network utilization. DD Boost reduces backup traffic on the network by as much as 98%. Third is the performance of the backup storage itself. Many hands make light work, and therefore by offloading a little bit of work to hundreds or even thousands of backup clients, the overall performance of the data protection storage can nearly double when using DD Boost. And the performance implication of running DD Boost at the client is also significantly less than running a normal backup. And possibly the biggest payout is eliminating data movers. DD Boost sends data from the client directly to the storage device, eliminating the complexity and the expense of running multiple backup servers to act as middlemen between the client and the protection storage. The impact to the business is tremendous cost savings on infrastructure. And there are also benefits to people and process. By enabling application backup utilities and elevating them to equal standing with central backup agents, organizations can share the work of backing up between the central IT folks and the application owners. And once again, many hands make light work. But the impact goes beyond the division of labor. Oftentimes, application teams are already doing their own backups to expensive primary storage. And then IT comes along and sweeps up those backups in an unreliable and redundant dump and sweep process. Organizations can now reclaim all of that primary storage and eliminate dump and sweep while maintaining application owners' ability to do self-service backups and restores. Backup and recovery stresses a storage system in a totally different way than a typical storage array. Primary storage is sensitive to latency and IOPS. Protection storage requires higher stream counts and greater effective throughput. Protection storage targets can expect to see hundreds or even thousands of high-speed write streams at the same time. Dell Protection Storage, powered by data domain technology, is built with a unique set of attributes that we collectively call SISL, or the Stream-Informed Segment Layout. The first challenge this architecture addresses is performance. SISL is a log-structured file system that is append-only. This allows alignment with the underlying physical storage so that data is only read or written in full stripes. This also means no expensive data insert or update operations and no parity recalculations. The second challenge this architecture addresses is caching. In a normal array, caching applies to data that has been recently seen. However, in backup, and especially with deduplication, there's little to no benefit to caching recent data. Instead, it is far more valuable to prefetch data that the system is about to see again. This is the magic that makes high-speed inbound streams possible. With deduplication, the key to performance is the ability to decide quickly what to do with the data. Is it unique data that needs to be stored to disk, or is it duplicate data that can be referenced with a simple pointer? It turns out that the first question can be answered much more quickly than the second one. Once the system gets the slightest hint that a data segment is unique, it can stop comparing and start writing. It's the duplicate data that needs to be rigorously validated before determining that a simple pointer is actually appropriate. The SISL architecture uses some very clever memory structures to keep track of what's what, because while it is impossible to keep all of the data signatures in RAM, it is also incredibly slow to keep looking for them on storage. The innovative architectural approach employed by SISL is the main reason why the data domain platform has been able to hold its position at the top of the protection storage market, both in terms of performance and scale. But being purpose-built is not limited to a physical appliance. Data Domain Virtual Edition takes the architectural enhancements even further. Storage in the public cloud is very different from storage on premises. On-prem, block storage can be constructed with as much performance and resiliency as you want. But in the cloud, the public storage cloud providers have made object storage more affordable and more resilient than their block storage offerings. Data Domain Virtual Edition in the public cloud uses intelligent data placement to take advantage of the lower cost and higher resiliency of object storage, while also using a minimal amount of block storage when it provides a performance advantage. All the while, Data Domain Virtual Edition maintains the same effective deduplication that it provides on premises in order to maximize the efficiency and performance of your cloud solution. Last, and certainly not least, is the idea of the storage of last resort. Protection storage has an implied responsibility for data integrity and durability. If you are recovering data from protection storage, it just might be the last copy of that data that exists anywhere in the world. Dell Data Protection Storage has a group of native capabilities that we call the Data Invulnerability Architecture, or DIA. A number of these capabilities are a natural extension of the SISL architecture we just described. The data domain file system, which again is a log-structured file system, is append-only. Aside from the performance benefits, this also protects existing data from ever being changed by new data. Data is never overwritten, but instead is cleaned through an asynchronous garbage collection process. The file system is self-healing and provides continuous validation. Data is stored with strong checksums, and the file system performs read-after-write verification to ensure that data was stored correctly. Data in flight is also protected in NVRAM while awaiting write confirmation, so that any data that has been acknowledged by the system to the client is fully protected. The data domain file system is unique in that it validates 100% of the data it receives, but that's just the beginning. The file system is constantly scrubbed in search of data errors, and due to the strong checksums, if any errors are found, they can be corrected. And most importantly, when data is read from the system, either as part of a restore, or as it's being replicated to another system, or copied to another storage medium, the data is once again validated and can be corrected on the fly if needed. The data domain file system also has some advanced security features. It has 2 levels of retention lock, which provide immutability and allows for the system to prevent accidental or malicious deletion of data. Data domain systems also allow the creation of a security officer user to prevent sysadmins or root users from deleting data without authorization from an independent authority. Also, cybersecurity is top of mind for many organizations today, and that is why we offer an enhanced solution called PowerProtect Cyber Recovery. With PowerProtect Cyber Recovery, we provide an air-gapped cyber vault that includes industry-leading capabilities to isolate, detect, and recover from a malicious cyber attack or insider threat. PowerProtect Cyber Recovery includes machine learning, data entropy detection, automated immutability, and nearly 200 powerful analytics to ensure your most valuable data is recoverable. Dell's PowerProtect Cyber Recovery is the only solution certified by the Sheltered Harbor Organization, the gold standard in financial information security best practices. Collectively, Dell views data protection storage as the storage of last resort. It has a special responsibility to ensure your data is safe and secure. When it comes to data protection, architecture matters now more than ever. Dell's unique data protection solutions provide unparalleled efficiency, scale, performance, and resiliency. 2 of the leading factors driving unexpected and additional cost to a data protection solution are running out of capacity and exceeding backup windows. I talked to many organizations who chose a solution based on a very compelling sales story, only to be surprised by the need to buy more capacity and more performance a very short while later, or to be surprised by an unexpectedly high cloud bill at the end of the month. At Dell, we want to help you avoid the hamster wheel of continuous and unexpected data protection expenditure. So we offer a solution that will be sized right the first time and that will truly deliver a predictable outcome with the lowest cost to serve. So most importantly, thank you. Thank you for stopping by and hearing about how Dell offers a low-cost data protection solution. We have a number of data protection sessions at this year's VMworld, and please check out as many of them as you can and as your schedule allows. We've got a few very exciting announcements, and I can't wait for us to share them. So have a great VMworld 2020, and let's keep your data safer together.
Hello and welcome to this short tech talk. My name is David Espejo. I'm based out in Colombia, South America, and I've been part of the vBrownBag community for quite some years now. So I'm very happy to be here with you sharing these topics. In this session, I will share some history around how the data persistency models have evolved in the Kubernetes design throughout the years. So let's get started. Well, first of all, the origin of this history was Kubernetes needed a way to handle the provisioning or consumption of storage, right? So this system, no matter if it was born inside Google or how it has evolved outside of Google, it has always needed a way to handle storage consumption. So the first notion of this was the static provisioning, that is even not here in the presentation, that is step 0, static provisioning. So Kubernetes could only handle mount and unmount operation, but someone else will have to provision the storage for Kubernetes. So then it came dynamic provisioning, which is a way to connect the pod API. The pod is the basic execution unit in Kubernetes. It's like the VM, let's say, in a vSphere environment. So dynamic provisioning is a way to connect the pod object to a system that provides storage, right? So it's dynamic because it responds to a different logic than just a manual mount or unmount operation. So there are two ways to provide dynamic provisioning to Kubernetes. The first of all was internal or in-tree. So internal is the kind of volumes or storage that Kubernetes can create by itself. So Kubernetes was not born thinking on data persistency, because most of the applications designed to run on top of it are stateless or were stateless. So data persistency was not the priority, let's say. So the internal dynamic provisioning or in-tree storage services were pretty much limited in functions. And when Kubernetes was released to the world, was donated to the CNCF in 2015, the first option for storage providers was to write code and to ship and CNCF to communicate with the storage provider in order to merge that code into Kubernetes itself. So you can imagine how hard can be that to manage at scale, and that affected the agility of the release cycles of Kubernetes. So there was another way that is the external or out-of-tree dynamic provisioning, in which Kubernetes provides the pod a way to connect to an external or custom provisioner created by a specialized storage vendor. So that's great, but it's not complete because it provides just a limited set of options. And there's a question remaining out there, and it's how to translate the different storage requirements for my applications to this limited set of functions. So if you go to a virtualized data center, probably you will agree with me that all of the applications deployed there in the VMs, not all of them require the same in terms of storage. Some applications require low latency, extremely high performance. Some other types of applications are not latency sensitive, but require more capacity or more reliability or durability, etc. So there is a diverse set of requirements, and just having the storage management inside Kubernetes, it's a limited way to achieve those requirements. So a little step ahead was the creation of the volume type called Flex Volume. Why Flex? Because it's let's say it's a plugin. It's a plugin to communicate the pod API. Again, the pod is the execution unit for Kubernetes, to communicate the pod API with external storage drivers. So that's great. The thing is that Flex Volume, it has to be installed in every single node of the Kubernetes cluster. And that implies that it's part of the execution environment or part of the execution scenario, let's say, or execution namespace, let's say, for Kubernetes. It's like installing a driver or a plugin in your ESXi node. It's great, but if that driver happens to have a compatibility problem with ESXi, it will take down your node. So it's not great to have the plugins there, at least in Kubernetes. And all of that just to have attached and detached operations. So it was a little step forward, but not enough. So that prompted the CNCF and Kubernetes community to develop an specification, a complete set of or a protocol to define data models for Kubernetes, and that is the CSI, Container Storage Interface. It's a way to create, let's say, cloud native storage, right? So what is the main idea behind CSI? Decoupling the storage management from Kubernetes, right? So there are many components in a Kubernetes cluster, but there is one that runs on every node in the cluster, which is the kubelet. The kubelet is, let's say, the agent that runs on any node. So the CSI is the massive undertaking of decoupling storage management from Kubernetes, but letting a bridge or a way for the kubelet to be able to find the volumes and mount the volumes, and that's it. But Kubernetes won't be responsible for create them, destroy them, manage them, not a single bit of that. So that is important, because when you combine that with dynamic provisioning, if I take a step backwards, let's say, dynamic provisioning requires the use of a concept in Kubernetes that is called storage class. Storage class, it's, let's say, like a storage policy or storage profile in vSphere. Let's say it's a way to specify these are the requirements or the features I need in this specific type of storage for this specific type of applications. You can have several storage classes, as you can have several storage policies or profiles in vSphere. So storage classes are a declarative way of defining requirements for storage. So if you combine that with CSI, you can have a very flexible and also scalable model of handling storage, because you can define in a flexible way your requirements, and also you can manage the storage in a logic separate from Kubernetes. So you will be able, for example, to upgrade the Kubernetes cluster without having to upgrade the storage components. So that is very important. So in a, let's say, graphical way, I found this diagram clear enough from the guys at the New Stack magazine. And, in this diagram, the developers just require storage for the application, and that's it. The application run in pods, and the developers request storage using a construct called PVC, persistent volume claim. It's a way to define the storage requirements. And in both approaches, dynamic storage will fulfill the requirement. The end result probably is the same. In the right-hand side, CSI, it's kind of a bit more complex, but you can see there that is decoupled. In the left-hand side, you will see a volume controller inside Kubernetes, right? So there is external code running inside Kubernetes. So that has this limited set of features that I talked previously. So when the developer performs the request, the API server, which is kind of the gateway, or let's say like a vCenter server, the API server will receive the request, and the volume controller in the in-tree approach will find if there is a volume already created with those requirements, and if that's the case, it will publish or it will assign that volume to that pod. Right? The kubelet, in both cases, the kubelet will perform the mount operation. In the CSI world, in the right-hand side, there is an external provisioner. This is provided by your storage vendor, right? So your storage solution for Kubernetes, be it in the public cloud or on-prem, should have a CSI compatible solution. It will provide an external provisioner, which happens to be another pod running in the cluster, probably in a different namespace, but running in the cluster. It will respond to the request, and Kubernetes or the kubelet just perform the mount operation, right? So all the logic, this is a simple operation. This diagram is pretty much simple because it only mentions the mount operation. But the more mature drivers or CSI drivers these days provide not only mount or unmount, they can create the volume, mount the volume, resize the volume without affecting the applications, snapshot, restore the volume, unmount the volume, and destroy the volume. So all the life cycle of the external storage is managed by the CSI driver. So in this way, you can scale Kubernetes and keep the storage management separate from that. Right? So how can I know if my storage solution or my cloud provider has different features in the CSI driver? There's a public list in the Kubernetes documentation. You can just Google Kubernetes CSI drivers, and you will find here a list. This is just a snapshot of the list. You will find here a list of all the vendors or cloud providers, the current versions of their CSI drivers, and the features they provide. So it's important to check this when you're, researching platforms to run a Kubernetes environment. Right? So I hope that's clear. I appreciate so much your time, and thank you for watching.
Hi, everyone. Welcome to this TED Talk, The Next Frontier, Deploying Object Storage with VMware Cloud Foundation. I'm Lawrence Chu from Dell EMC, and here's my cohort, Gopala, from VMware.
Thanks, Lawrence. Hi, everyone. Welcome to our talk. This is Gopala. I'm the product manager in VMware, focusing on stateful services and cloud-native storage. All right. So before we delve into the work that we are doing together, Dell and VMware on object storage, I would like to motivate the problem a little bit by talking about why we are building this platform and why we are integrating object stores on vSphere. What we're seeing is applications in the customer enterprises are changing. The applications that were consisting of a few VMs, depended on a few databases, were mostly easier to manage in the traditional space, are now becoming more complicated applications wherein you have not just one database, but these applications depend on a variety of stateful services, right? So object stores are the centerpiece of these stateful services and have become the de facto storage platform for these modern applications that are Kubernetes based, that use containers, that use all of these newer mechanisms like functions, etc. Object stores have become almost the de facto standard for storage for such modern applications. The reason we are seeing the shift is that developers no longer depend on a ticket-based system like they used to before for their storage needs. Rather, they use self-service S3 endpoints for their storage needs, and they directly deploy their stateful volumes and persistence over these object stores. So object stores are also very flexible in the sense that they will service big data applications, analytics applications, as well as regular test dev applications that need ephemeral storage. So object stores come up as a very compelling use case for our modern applications in the enterprise. Likewise, we also see several other applications like MongoDB, Cassandra, and other modern databases, Redis, Kafka, and such other stateful services to suit these modern applications requirements in the enterprise. So not just the nature of these applications is changing. We're also seeing a huge increase in the number of such modern applications coming to the enterprise. So you're seeing some of the statistics on the screen here. We are seeing that for the first time, the line of business is spending more on IT because they are seeing a huge increase in the number of applications that are coming in. And also, by certain estimates, we will see around 500 million applications in the next few years, right? So enterprises are spending a lot of time in developing these applications, and VMware wants to make it as efficient and seamless for these enterprises to build applications. And that is the reason we have acquired a few strategic companies, as well as organically investing in building the support within VMware. So what we are introducing today is the data persistence platform on vSAN, which is essentially a platform and a framework which we offer, where the ecosystem partners like Dell EMC can bring in their modern stateful services like object stores, and together this integrated platform and the service layer offer that simplified operational model, right? We offer developers that self-service, automated service deployment, cloud consumption, etc. on vSphere and vSAN, while we are providing a lot of simplified operations and management for our vSphere administrators, right? So they get that simplified operations, integrated monitoring, and we are also introducing the vSAN direct configuration, which is allowing customers to go directly to the underlying bare metal devices that are attached directly to vSphere ESXi nodes to get that cost optimization and storage efficiency from these underlying storage. So in a nutshell, with this platform and the integrated services, our customers will be able to run these modern stateful applications like object stores with lower TCO. They get better bang for the buck from their storage. They're able to get their developers to innovate much faster, develop applications much sooner, and become more agile. And overall, their management and deployment becomes much simplified for their vSphere administrators while they're operating object stores and other stateful services on this platform. So I will hand it off to Lawrence now. I'll stop sharing and he will share his screen.
Thank you, Gopala. I'm Lawrence Chu, product manager of the Dell EMC object storage product line. So the reason for S3 compatible object storage, as you heard, really lie in the transformation of how applications are developed. Right now, we are now in a day and age where we have software-defined data center, and with Cloud Foundation, application users can quickly get access to an infrastructure, lifecycle management, and all the other automated service out there. But what about storage? What you're going to need is a reliable storage. What you're going to need is a reliable storage that simplifies how you access and then scale those storage infinitely. S3 compatible object storage, such as the Dell EMC ECS, and object scale is such a target, right? Object storage is born of the belief that HTTP is the most ubiquitous protocol, and that practically unlimited global scaling is required to support next generation of application growth. Without worries about like mounting shares, fiber channels, or other such details, object storage is the one that can give you the simple flexibility, hybrid cloud compatibility, and they also DevOps friendly. By the simple action of provisioning a bucket, you're ready to start. We're now introducing the Object Scale Early Access Platform. It is a simple S3 compatible object storage. It is Kubernetes based. It's a scale-out software-defined product, and it's also multi-cloud ready. Dell EMC Object Scale Early Access is defined as a pre-general availability beta program for organizations to test object scale code base in your environment, and you can use it on many such existing environments. So how does it work? With vSAN and now with Data Persistence Platform, you can provision persistent volume and management of multiple of these storage services. So Object Scale builds on top, of this, vSAN and persistent volume foundation. So, and then we add our own internal databases, data protections, and many other storage-specific features to give you a true scale-up architecture. And with these container services running on vSphere, The result is a scalable storage that's easily manageable, configurable, and scalable. Now, when you build application storage, it's exceedingly simple. So with objects, and in enterprise object everywhere, your applications everywhere can run object storage. This object storage is available, everywhere that vSAN persistent data platform and Cloud Foundation would operate. And with software defined, you can accelerate your development, because you don't have to pre-provision a dedicated appliance, which you typically only use none of it on day one. And you can spin up as much or as little storage as you want in your internal cloud environment. And lastly, it offers the same VMware experience. Use the same tools that you know and love. Now let's drill down a little bit into more of the benefits. After all is done with provisioning, then you can grow this storage as you need it, right? So Dell EMC, storage with either ECS or object scale enables you to have like cloud scale, built with a scale out, geo-distributed architecture, so you can keep pace with the capacity demands, wherever your data center resides. You can have global accessibility. You can stand up, remove, add capacity for object scale wherever vSAN data persistent platform runs, right? So edge or in the cloud, right? Have your storage easily co-locate where your application runs. It's your choice. And you can utilize, existing resources, deploy on existing pool of virtualized infrastructure. You can secure, you can stay assured of the security and compliance, with what we have, such as data at rest encryptions, erasure encoding, and all such data protection schemes that we have. It allows you to have peace of mind. And lastly, it's enterprise proven, right? We are the same team that brought you the industry leading object storage with ECS. And we have a long legacy of building storage and the privilege of supporting, many of the largest customers in the world. Let us help you. Now, accelerating, modern apps. What we're looking at here with cloud-native applications, storage is not really one size fits all. Sometimes you may need more metadata services. Sometimes you need higher throughput. And on the right side of the screen, what you're seeing is some example of our microservices in support of various workloads. Our microservice architecture allows us to transparently scale up, down, across the appropriate services at the optimal ratios as you need them. And we take care of managing all the possible failure domains to ensure data availability and resiliency across all the physical assets that you have. Using the tools you know. The simplicity of using the tools you know just cannot be overstated. I mean, obviously the benefits of running object storage containers on Kubernetes alongside your traditional virtualized resources in a single unified experience, and your ability to take advantage of automation that VMware Cloud Foundation gives you. And ultimately, it's really about aligning development and IT, right? Data center operators can use the tools they know to apply policies, assign quotas, and so forth, whereas developers can easily provision infrastructure services on demand while complying with IT data center policies. A couple of examples to just kind of give you like a feel of how you can take advantage of such a global archive, right? So your new application anywhere can directly store data on an object store and then have it, be replicated to all around the world. So say you have like a sensor IoT data, you can generate them worldwide, and then, at a later time, you can analyze them as a central location. So those are most of the use cases. And for traditional clients, what you see in the middle of the screen here is a GeoDrive. And it's one of the ways you can take advantage of this utility, which gives your clients, say Windows clients or Mac clients and so forth, an easy way to store data and present an efficient object storage as like a virtually unlimited file share available everywhere. Also, here's an example of how you could deploy it, right? So vSphere and vSAN are in many places now. You can run it on commodity hardware or even more easily on hyper-converged infrastructures. There are many vendors, that sell those hyper-converged infrastructures. And HCI is already available in edge and core locations. And with vSAN persistence, data platform, you can now take advantage of any excess capacity and at any of these locations and easily turn those into a dynamic, scalable global archive, right? So all without the need of separately managing a dedicated appliance, right? So it gives you tons of flexibility in how you deploy it, how you want it, when you want it. So let's quickly jump into a demo of our current early access. What you're looking at here is currently running, vSphere cluster, running the vSAN, data persistent platform, and within the vCenter, what you're able to see is what object scale running alongside other type of services, all manageable and seen at one place. So with object store, it's really easy to look at, what you have available and what state they are at, right? So for example, if you want to start a new object store, what we can do is just easily jump to the new object store. You type in the name, right? So you can select the version of software you want to run. You can decide on which encoding and protection you want. And for this particular demo, we can, for example, use vSAN, right? And then you just click next, and they give you a sizer, right? And give you some flexibility on how you want to size up this workload. Depending on how many workload you may have, you can add and then remove it. And these resources will dynamically help you size based on your expected growth and how long you plan to use it. And then there are other optional customization you could choose as well, right? So at the end, depending on how you want your workload size, by the amount of throughput, or other type of characteristics, then you can jump to, how other optional S3 services. So, for example, this screen allows you to specify, different service type, for example, load balancer, taking advantage of NSXT, for instance. And then at the end, you could review it, and then all you have to do is just apply. And then in about 10 minutes or so, typically, then, you have like a newly configured, object storage. It works just like an appliance. But, it is manageable, in the within the vCenter environment, all in one place. So I have some like object storage that's already, configured here. Right? So for example, creating new buckets, setting up the different users attributes, as well as certificates are really simple, all in one place. So you could, easily, manage events to see who has logged on and so forth, in one place. And additionally, if you want to see how your object storage is performing, you can easily go to our Grafana dashboard, for instance, and you can see, how, for example, this example, bucket that I have, how it's performing, right? So the performance metrics, obviously, this is not under heavy load, for this particular cluster. But if it were, you'll be able to see, spikes and valleys, depending on the workload and the times you run it at. So you can do a lot of drill down, as well as, debugging, about your storage performance, very simply. So it gives you a very effective way of managing storage. And once you have the buckets, you can create the new buckets here, or you can create, like a, new bucket, like typical with S3, say an S3 browser, access. So for example, this is an, S3 browser. So what I have here is, for example, I just create a new bucket. I can easily create another new bucket here. I can, see, what are the different files or objects that are in there, right? So this way you can interact with them, very easily. It's just one example. All these are really RESTful API access. So your applications, without going through any of these browsers, can directly access this deep scalable object storage. So now let's quickly jump back, to the end of our presentation here. So what we are, what we have here is, I was just want to thank you all, for joining this particular tech talk, this quick tech talk about, object scale and coming to learn more about the vSAN data persistence platform. And if you have more questions, please, do join us on this early access, beta program. Use the link to enroll, objectscale@dell.com. And let's show you what it can do.
Thank you, everyone.
Yeah, thank you. Thank you, Gopala and everybody.
Hey, y'all. I'm Gina Rosenthal. I'm the founder of Digital Sunshine Solutions. And today I want to talk about building your own online adventure for VMworld. So we know because of the global pandemic, it is not possible to go to San Francisco or Barcelona this year. VMworld 2020 has to be 100% online. The good side of that is, yay, it's free, sorta. But the worst part of it is, man, I can't see my friends. I can't interact with people. I can't hear things live and feel like something really cool is happening. Or can you? There are ways to make an online event very interactive and make it feel real, build a world around it. But the very first thing you need to do is make sure you don't freak out. Don't panic. Just take a deep breath, breathe, and make your own adventure. This is possible to do. We've done it before, and we do it when we go in person to San Francisco and when we go to Barcelona to VMworld. We already make our own adventures. We don't follow the exact template maybe that is given from VMworld.com. We decide ourselves about how we're going to interact with the world that the VMworld staff creates for us for that week. So one thing to ask yourself is, how do you usually prepare to go to VMworld? What does that world look like? That's how we start any adventure, is by preparing for it. Usually the very first thing you'll do is register. Now that one's pretty easy because you just go to vmworld.com and register. And you can get a free pass, which never has happened before, to be able to see the sessions and to see the keynotes and everything for free. And yes, it's controversial. There's a premier pass. It costs extra money. That's where the good sessions seem to be. That's how you interact with the VMware experts. I could take a whole other hour to talk about that, but really that's just extra noise right now. We are on a quest. We are going on an adventure and we've got to prepare for it. So try to set that unfortunate situation to the side for now. The other thing you do when you're normally planning to go to VMworld is you get your travel all set. You take a week and a half off. You plan your hotel, your flight. Maybe you take people with you. Maybe you do something extra on the side besides just going to the VMworld events. Because we know that's not going to happen this year. You have to block your time. We're going to, instead of VMworld staff creating a physical space for us to walk around, a physical VMworld, we have to create our own worlds online. And it starts with blocking your time. So for the last couple of days of September and the 1st of October, make it clear that this is the time I'm going to attend VMworld activities. And it's important because everyone else that's going to be part of that world for those 3 days, that's when everybody's together. So block off your time. It's really important. The next thing we need to do when we're going on this adventure, we've done our planning. Now I have to plan our campaign, or what parts of VMworld are we going to visit? That usually is separated into 3 big parts for me. Maybe you have an extra one that you would add in. But the places I would want to visit are some parts of the official VMworld planning. Some of it are the partner events and the partner sessions that they have, and all of the community things that happen, of course. So let's start with the big castle. Let's start with the official VMworld programming. Again, when we think about time, time is one of the boundaries of how we're going to build this world. There are 3 days globally that everyone is going to be checking out the new content that gets posted in the online areas, the big castle that VMworld has created. So this is really important to know what the exact time boundaries are. Do you want to go to keynotes? Do you want to go to sessions? How about hands-on lab expos? When are you going to do that? Is there a certain time you have to go when more people that speak your language will be there? I don't know. That's stuff you have to plan and check out as you start to explore the big castle of VMworld. Another pro tip this year is make sure you try and unlock some new experiences. Going back to that idea of time and world building, since VMware is recording all of these sessions, time is relative. It means you can watch the sessions and the keynotes, all of them on your time at your house over your own internet. So why not figure out how to make that happen on your TV, in your favorite comfy chair, or your very favorite couch, with all the stuff around you that you like to watch sporting events or you like to have when you're watching a TV program. And then maybe what you want to do is to talk to your regular crew and say, hey, let's watch the keynotes together, or hey, let's watch these certain sessions together. Then your interactive set, you watch that on your TV, then you have your phones out or your devices out. You use Twitter or Slack or text or however y'all normally communicate to make the more interactive piece come out. You can even meet new people doing this, either using those being open and using those communication platforms in an open Slack channel or in an open Twitter environment, or even on watch parties. Watch parties are where someone might stream one of the sessions with a group of people who are interested in the same topic, and everybody is able to communicate and talk. But it's a great way to meet people that are interested in you. So try to figure out who's streaming things, and are there watch parties you can join? And I think as we get closer to VMworld, all of that's going to play out. We'll start seeing notifications about that. This is also, I want to talk about the meeting new people. It's kind of a big point. There's a lot of people who have never come to VMworld because of cost matters or distance matters or family matters or whatever, that are now able to be a part of it. So we can take all of that energy that we normally have at that world that gets created physically for us, we can bring that online. We can create our own worlds and create our own adventures to travel through those worlds and meet people we may not have even had a chance to meet before. That's pretty cool. Let's talk about another area to visit. We can visit the partner castles. So partner events are always insanely well-produced and crazy. Sometimes they have amazing concerts. Sometimes they invite you to a great dinner. Sometimes they have extra sessions either on the expo floor or on either on the expo floor or on either on the expo floor or in a great location. So watch their Twitter accounts, watch their blog posts, find out what your favorite partners are doing. And if you don't see anything, ask them, ask your salesperson, ask somebody that you know at the partner, what are you guys doing for online? I want to include you in my quest. Now, we couldn't talk about VMworld without visiting all the community areas. Community is what has always bound VMworld together. This is how community is what has bound VMworld together always. This is how you learn new things. This is how you see new people. This is how you understand where the cool places to go hear new sessions are. It's all about community. Community people will let you know where they are because you'll see them in the same places. Twitter, maybe an email list, maybe a blog post. Watch in all the normal community places to see where people are and make sure you tag along with them or bring them along with you on your quest. A question I hear a lot about online events is, what about hallway? What about the hallway sessions? The hallway sessions are when you're just walking around and you run into somebody you worked with 3 jobs ago or someone you haven't seen in 10 years and you catch up on what they're doing, or you're able to find out, there's a great dinner, you should come join and meet all these people I'm working with now. How do we get that if we're not physically all in one place together? You guys, we've always had hallways online. It's the places in the past in between. It's those communication methods that we have found so that we can stay hooked together with a hashtag or by tagging each other. Those are our digital hallways. All of the normal social media tools, that you can use to stay in contact and collaborate and talk real time as you're consuming the information from the partner castles or from the big VMware castle. And this year, there are more hallways to explore. I'd really encourage you to get a Twitch account, get a Discord account, play around and try to find the folks who are on VMware, on these platforms already creating VMworld content. I know I've created a Discord server basically to act as a hallway. There's several that I know of on Discord that are concentrating on VMware and of course VMworld. So go check it out, learn how to use the platform, and maybe that's another space where you can go on an offshoot of your quest. So the thing that everybody is missing and worried about is interacting with people and having that social feeling of being in this large crowd, but knowing that you belong there. So another question to think about as you're planning all of the places and all the ways that you're going to build your online world is, how do you usually interact at VMworld? I know how I do. I have lots of old friends and I'm not shy, so I make new friends every year at VMworld. This is important. Find your old friends. I know for me, there's a couple of Slack channels I'm on that have been dormant for 6 to 9 months that have all of a sudden started popping up, people trying to figure out what they're going to do for VMworld. Be the first to start that conversation. Wake everybody up. Find everybody. Figure out how are you going to go together and plan your online experience. Bring your friends along with you. But don't be afraid to find those new ways to make new friends, whether by figuring out how someone's going to be casting on Twitch or YouTube or using Discord, different places. Find all of that out so that you can meet some new people this year, just like we do every year at VMworld. The biggest thing of all, don't freak out because it's 100% online and you're tired of sitting in Zoom meetings and you don't know if you can take 3 days of that with VMware and VMworld. You can do it. You have to think big. You got to think differently. Think of this as different than 3 days of pre-recorded Zoom meetings. Think of this as the content is already there. Now, how do we interact with the people we want to interact with and learn more and see what's new in the future? How do we interact with people that could never attend VMworld again? Because this is pretty cool. Most of all, how do we connect everybody so we all can be building these adventures and we can have one great big VMworld? Speaking of connecting, connect with me. I'm Gina. My email is Gina at digitalsunshinesolutions.com or gminx on Twitter. Would love to connect with you and figure out how we can interact at VMworld and share our quest. Thanks.
Hello, and welcome to the session about bootstrapping VMware, the infrastructure as code way. What we're talking about in this session is BYO infrastructure. It's an approach to automating VMware at the bare metal level and then upwards. I'm Rob Hirschfeld, your guide for this session. I'm co-founder and CEO of RackN, and I've been doing data center automation and VMware data center automation for over 20 years, believe it or not. You can find me online. I'm at Zehicle, and I've been very active with something called the 2030.cloud, where we talk about a lot of advanced futuristic concepts in DevOps. And so what we really want to talk about here in an infrastructure as code sense is to look at this traditional infrastructure stack that we've built. Because we know that if we fix things at the bottom, that physical layer, then everything we build on top of it, and this is a totally standard VMware infrastructure stack. It's something you would see in other vBrownBag presentations. As a matter of fact, it's modeled on them. So what we've seen is that while people like to squeeze the physical layer at the bottom of this down into this tiny part of the stack, it's actually a complete stack in itself. It's not just a small box. It's actually compute, storage, and networking components that you have to get right, and actually very carefully right, in order to make everything we build on top of it work. And so at RackN, we spend a lot of time thinking about exactly this problem and how do we treat these components like a cloud. And a lot of what that means is, how do we take DevOps automation pieces, infrastructure as code concepts, and automate that physical layer also? Because if we can do that and use the tools and techniques and all the great cloud-like style, we can really make a huge difference in what it's like to actually run a data center, really transform it in very positive ways. And that's what we want to talk about. It's worth mentioning RackN Digital Rebar is this product that we have that's designed to help companies self-manage VMware. So we're not a consultancy, we're not a service provider. We're literally helping companies manage their own VMware infrastructure, whether it's legacy, new, or edge infrastructure. And so that's really about automating infrastructure, securing it, and making it portable so that you get reuse out of the problem. So we see this quite a bit. We're helping multinational customers and service providers automate VMware and do it themselves. So we have a lot of experience with this. And what we've learned in this is that there are really 6 key factors in design that you need to understand before you even write a line of code, or a line of infrastructure as code in this case. And so in those factors, we have an organizational component where you really have to be able to say self-management is possible. I can do this myself. I don't have to turn it over to a VxRail or an HCI vendor or a cloud. That you can actually do it, right? And believe that you can do it. To do that well, you have to have human understandable operations. So people have to be able to see what's going on as we automate it. And then once you've done that, it has to be continuously repeatable. We don't look at infrastructure as code and think that it's a one and done thing. You have to be able to keep redoing this. One of our customers calls this repaving their data center. And they literally roll through upgrades and patches in a 30-minute window, and they repave entire 100 system VMware clusters in that time window. And that is how they create these repeatable, robust data center infrastructures, by being able to just click a button and rebuild everything in their data center. And then on the technology side, we also have to approach infrastructure as code in a systems way. So when we look at this, we're not just trying to solve one problem. Can I provision a machine or can I configure it? We're actually connecting a whole bunch of pieces together, from certificate management and inventories and manifests and DNS. All has to be done together. Otherwise, we're really just creating little islands of automation. To make all this stuff work, it has to be observable. So black box things where something happens by magic do not create reliable infrastructure as code things. Any place where you're pointing to a black box and saying Darby Dragons, you're going to have a problem with your automation and in your code. And that's a lot of what we're trying to do, is take everything that we do from an automation perspective and put it in a code repo so that it's available and you can see it and inspect it and make sure it changes and that you know it changed. There's no people running around behind the scenes and flipping bits to make sure everything works. And then we're creating connected automation. So chains of automation that all work together as a system. So a complete integrated workflow. So I want to take you through how these 6 principles really fit together into deploying VMware from the ground up. This is what we do on a normal basis. The first couple slides of this builder are just our normal discovery process. We take every piece of hardware, ARM, Intel, whatever vendor you have, cloud or physical, through this standard process. And then we'll actually be able to inventory, verify its hardware, set RAID and BIOS configuration, do out-of-band management, all these processes just to get the machine up and understand what the machine is. Perfectly normal, we do that in every case. And then for VMware, we extend that where we actually use the net boot that VMware has available. We'll pixie boot into ESXi, and then we'll install VIBs that can take additional actions in ESXi. And this is a really important point in automating this infrastructure. In order to do this effectively in an automated way, you can't create an island where ESX requires its own automation or its own manual steps. What you really need to do is come back and have a way to complete the ESXi infrastructure inside. And that's security, setting patches, installing certificates, making sure that your networking configuration, getting off VLAN 0, all those bits and pieces have to be done correctly to do it. And our VIBs are actually signed, so we can do this all with a secure boot infrastructure, which is also absolutely critical to building really robust, reliable infrastructure. And then we can hand off to downstream infrastructure. So if it's Cloud Builder or something else, that's where we now have enough information that however you want to automate on top of that, you have the information that you need, whether it's Ansible or Terraform or whatever mechanisms, or if you're back into CSV spreadsheet land, you have the data that you need to make that all work together. And that's really where we start pulling together these infrastructure as code concepts, because everything I'm showing you in this list are all components and modules that fit together. It's not a big bash script or an Ansible playbook that works, if you put in a whole bunch of value. It's actually things that you plug servers in and just the right things have to happen. And that's what makes infrastructure as code really interesting. And it's not just another HCI story where buy this exact hardware, put things together in exactly the right way. People's data centers are different. And for good reasons, they're different. And so we have to be able to accommodate those differences and let people bring in their own infrastructure and their own legacy infrastructure. And as we go migrations from 6 to 7, you have to be able to take what you have. You shouldn't have to buy completely new infrastructure. And so here's what we hear for customers talking about their needs from infrastructure as code. They need to have useful abstractions. And we're going to go through each one of these, and I'll show you an example of how that looks, and orchestration. But at the end of the day, what we're really doing is working to eliminate manual steps and silos. It really is that simple. That's the goal for infrastructure as code. So when we look at modularity, the idea here is that we're not just looking at a single script. What we're looking at doing is taking big problems, how do we automate a system start to finish, breaking it down into small pieces and making sure that each one is modular and then ultimately understandable. And that lets us build a catalog where things that aren't VMware specific or Linux specific or Windows specific can actually be downloaded and reused, right? RAID and BIOS configuration, while tricky and finicky, is not unique. No customer has unique BIOS configuration. They might have different settings, but the process and the way you do that is something that we can standardize and we can pull in and get code reuse from. And that's really important. And then really importantly to us is if you change it and you extend it or you add to it or you add your own magic sauce, which everybody has, then you have a way to code that, manage it, create your own catalog. Because infrastructure as code, the as code part, a lot of that comes from how you store it and manage it and version control it. All super important. And then from there, you have to be able to understand how these pieces work. And that means that these big modules don't just break down into big modules. They actually have to have clean and understandable inputs and outputs with good documentation and types and clear delineations. And then the big steps have to break down into smaller steps that you can understand. And that can go for us, it goes from workflows into stages into tasks. Tasks actually can decompose into templates because we want to get reuse. And that means that if we solve a problem once, we want to be able to rebuild new modules, click things together in ways that actually create reusable pieces. And that is really helpful because when you're building an infrastructure start to finish like this, we're crossing teams. There's a human element component to how all this stuff works. And so that means that we have to be able to show another team what we've done in a clear, concise way. And then we have to have a handoff so another team can do that work. And that's okay. They have clear inputs and outputs. They put their pieces together, and then we fit everything together into a simple workflow. And that's really a key component for this because it's not just about, can I provision a machine? It's, can I build a cluster? Can I build clusters and more clusters? Can I go to remote sites? And so there's a concept of building workflows that actually go through and pull all these pieces, these infrastructure of code pieces together. So if you have a Terraform template and an Ansible playbook and a Bash script and pull this ticket and this person has to go turn on a network port, that's not really an infrastructure as code workflow. It's a collection of tools, but they're not built together to deliver a consistent long-term deliverable. That's really what we're talking about, what we would call intent-driven infrastructure. I need you to build a cluster, start this process, everything else should be able to flow out of that. And then from that perspective, that sounds very cloud native, it is. And it's this way of thinking about API-driven infrastructure where you're asking for a request and things are getting done for you. In a lot of cases, we don't expect people to use our system directly or sit in the UX, right? This should be, I need to build a cluster. That should be triggered by external events or other systems or things up stack from where we are. That API-driven mentality is essential to building good infrastructure as code. Once again, it's all codified infrastructure. Those APIs become the gateway between different systems and help you connect all these pieces together. And then finally, one of the most head-shaping things that we've had to learn in this is that building infrastructure of code means that you have to cross context boundaries. So in the work that we're doing and the thing that we found to be really powerful in making it all come together is this idea that I can bounce my context back and forth. I can do work in a machine. I can pull up to a cluster level, verify that things are right, return back to the machine. And this ability to move back and forth from a context perspective really changes the game and how you can automate something because you can build a single workflow that has different security contexts, collects information, can work across the cluster, and coordinate activities in a way that is absolutely essential to accomplish this end-to-end system driving perspective. So I hope this helps you understand how we see infrastructure as code and really where the industry is going, because this isn't pie in the sky things. This is actual work that's being done by customers in the field. They're using these techniques. They're actually building data centers and clusters based on infrastructure as code practices that are repeatable, safe, and secure. Whether it's a brownfield system, it's a greenfield system where they're bringing in new ideas and new capabilities, and then being confident that the things they've done aren't going to be locked in for the next 10 years, and they'll be able to change and keep revisiting how things go. If this is exciting and interesting, please, we'd love to have an extended conversation with you at rackn.com. And everything I'm talking about, we have people doing. You can try yourself. You can just download Digital Rebar, try the VMware pieces, build your own clusters. The stuff we're doing is really designed to be that simple, because we're helping people self-manage their infrastructure, not take over control from them. So, thank you for spending a couple minutes with me learning about infrastructure as code. This is Rob Hirschfeld from rackn.
Hi there, my name is Chris Noon, and today we're going to talk about how to automate NSXT using Terraform. So my Twitter handle is alttransformer in case you want to reach out to me or follow me after this presentation. And I do blog on vmusketeers.com. So first of all, let's talk about what Terraform actually is. And it is infrastructure as a code created by HashiCorp. And what it does essentially is automate infrastructure and or network builds. And it does this in a declarative manner. So what we talk about there is we give Terraform a bunch of files and we say, this is the end result I want, rather than building out a system systematically. You can link this with a version control system. For example, I use GitHub, so you can roll back to any previous version that you have or branch out to test new features. And essentially, if you end up playing with Terraform, you'll end up having a bunch of providers, modules, and Terraform files in your file structure. So the use cases for Terraforms are vast, but the ones we want to focus on tonight are the disposable environments. So when we talk about a disposable environment, we're talking about things, maybe we want Monday to Friday, 9 to 5, and then we can tear them down when we want. Resourcing schedulers are kind of tightly coupled with that, so we can scale up and scale down using Terraform. Multi-cloud deployment is also a really useful use case. So we can use the same code to deploy in GCP, Azure, and AWS. So you can have that multi-cloud environment. Auditing is also a great feature. So what we do at the end of the live demo is we do a Terraform show command. And what that does is it just shows you the environment that we built out in semi-readable code. So we haven't got a lot of time, so I want to jump into the live demo fairly quickly. But essentially what we're going to build out today is a production and a development environment. We're going to build a web app and DB segment in each environment. What I'll do is I'll start by building out the segments. I'll then add the T0s into that. Then I'll link them together. The demo is quite simple in the fact that it's only 3 segments linking to 1 T0 each. But what I want to point out is you can make this as complex or as simple as you like. So you can add a ton of firewall rules, load balancing features, BGP, etc. So really scale it up as you feel free. So what we're going to do is we're going to drop into our NSX environment. I just want to show you that we've already defined an underlay and an overlay transport zone. And we've already prepared our edge cluster with 2 edge transport nodes. Okay, so now let's jump into Terraform. So I've got a decommissioned area and I've got a provisioned area. So the decommissioned area have all the files we're going to use today. And then the provisioning and the provisioned area is where we're going to drop into and build out this environment. So what I'm going to do first is I'm going to make sure I'm in the NSXT provisioned area. Okay. And then I'm going to bring in our service definition and our authentication Terraform files. So .tf Terraform file. So I just want to point out the authentication file defines the provider. So what we're going to do is we're going to form a Terraform init, and that's going to download the latest NSXT provider for us. And then it's also going to authenticate with our NSXT manager. So let's drop that there into the provisioned area. We're also going to define a few definitions. So one thing I mentioned before was the edge cluster, which was built up of those edge transport nodes. And then we also have our transport overlay, which I pointed out at the beginning. So let's drop that into our provisioned area. So let's perform a Terraform init. And what that does is it initializes it and downloads our NSXT provider. So we have NSXT 2.1. Okay. So now one of the commands we can use is we can use a Terraform plan to say, check my Terraform files, my .tf files, and see what needs to be provisioned or what Terraform believes it should be provisioning on this new environment. So at the moment, it's nothing. So let's switch back to our NSXT manager and we'll click on networking and our topology overview. So I just want to show you in the topology overview, we have nothing. So there's no networking elements there. Okay. So now what we want to do is we want to create our segments, as we said first. So we'll look at the dev segments. And what we want to do is we want to create our web, our app, and our DB segments. And we'll have the IP addresses defined here. So what we're going to do is we're going to drag our dev and our prod into the provisioned area. So prod is very similar to the dev. You can see the DB, the app, and the web. And now what we're going to do is we're going to clear that and we're going to do a Terraform plan again. And what it's going to do is it's going to check those Terraform files and it's going to say, out of those Terraform files, what do I need to create? So it's found 6 things it needs to create, which are the 6 segments. And if you go up here, you can see the green plus icons showing that we want to create each of these switches. So the plan is essentially just asking Terraform what it feels it should create. But now what we're going to do is we're actually going to create it. So we're going to do the Terraform apply. And what this kind of does is run through another Terraform plan just to make sure there's no difference from the last time you planned to now. Again, it's gone through those segments and it wants to add those segments. It asks you, do you want to continue? Yes or no? Obviously, we want to continue for the purpose of the demo. And we go through, and in a few seconds, we've added 6 segments. So if we switch back to our networking topology and we do a quick refresh, we can see we have 6 segments nicely deployed. Perfect. Now what we want to do is we want to build out our T0. So what I want to do is I want to build out that dev T0 and I want to build out that prod T0. So the first one is the dev T0 and we put that in an active standby state. And the second one is that prod T0 and we put that in an active state. So let's drag that into our provisioned area. It's in there, that's perfect. And then what we're going to do is we are going to do another Terraform plan. So when we do a Terraform plan, what it's going to do is you notice it refreshes the state. I'll scroll back up here now. What we're going to do is it refreshes the state for the segments. There's no changes, so it doesn't register any changes, so it doesn't want to do any changes. And then what it does see is the new files for the T0s, specifically our dev and our prod T0. So what it wants to do is it wants to create those T0s. So before we did that Terraform apply, and we want to go through and click yes, or we know the files are correct, and we click Terraform apply auto approve. So what that does is it skips that checking stage, yes or no, whether you want to deploy that. So if you notice here again, it's just gone through the refreshing state for the segments. Nothing's changed, so nothing needs to be changed. It sees new T0 Terraform files, so what it does is it creates those T0s. Now if we go back and we check our environment, we expect to see 2 T0s placed in here. Fantastic, we've got those. Now what we want to do is we want to connect all of our segments to our T0s. So what we're going to do is we're going to go into the dev file, and I've commented out some lines here that tell our segments to connect to our T0s. So we're in the dev file, for example, and it connects to the dev T0, which you can see here. Save that, we'll close it, and we'll go into prod and do the very same. You can see it's going to that prod T0 gateway. Okay, save that and close that. So what you'll find is in that provisioned area, we haven't added any more files, so there's no new elements that need to be created. But we have changed a few things within the segment section, both in dev and in prod. So now, when we clear that and we do a Terraform plan, we'll notice they'll refresh the states. And what you'll find is there's no adding or deleting. What you'll find is modifications. So that's the modification symbol. And this is what needs to be added. So it's done that for prod web and needs to connect it to that T0. It's also done it for the prod DB. So what it's doing is just connecting those to the T0s. What we'll do is we'll do another Terraform apply auto approve. And what we want to see is we want to see those segments automatically connect to those T0s. Perfect. So again here, what it's doing is it's checking the T0s for that refresh state. There's no changes on the T0s because the connection comes from the segment itself. And then what it does is it refreshes the segments and it notices there's a modification that he's doing. Then what it's doing is it's modifying the segments, not deleting and creating them again. So you don't have that down and up, just a modification. So if we drop back in here, we expect all the segments to be connected to their relevant gateways. Perfect. Now we have all of our dev segments connecting to our dev T0, and we have our prod segments connected to the prod T0. But what we wanted to do is we wanted to talk about those environments that could be spun up and spun down, specifically these disposable environments, right? So when we're looking at the environments, we want to spin this down for the weekend, say. And what we can do this by doing a Terraform destroy. Terraform destroy is obviously the opposite of Terraform apply. So I'd be very careful doing this in a production environment, say. And you can see all these red minuses. What it wants to do is essentially destroy the entire environment from the T0s to the segments. And it'll ask you, do you want to do this? So yes, we want to destroy this environment. Say it's Friday, 5 o'clock. Perfect. We don't want to be using resources over the weekend, so it's just destroying that environment. It does take a few seconds for NSX to catch up. Perfect. So now our environment is destroyed over the weekend, right? So we're not using any resources. But now what we want to do is we want to build it up again. I don't want to build it up in the same method as dragging in the segments, making sure they're done, dragging in the T0s, making sure they're done, and doing that connection. We know this works. So what we want to do is come in Monday morning, first thing, 9 a.m., and we want to do Terraform apply, also approve. Obviously, you can automate this if you like. You do that Terraform apply, auto approve. And it goes through. So we're going to build out this entire environment in 5-6 seconds. So you can see there, it's created the T0s, it's created the segments. And like I said in the previous slide, you can have load balancing features, you can have BGP, and you can have a number of firewall rules. So now if we go to our NSX and we want to check what topology has been built out, there we have it. We have our full topology using one command. Perfect. So now that's a quick overview of how Terraform works and how you can destroy and bring up environments very quickly. I just want to leave you with a few useful links. So terraform.io is where all the providers live, and you can go on there and have a dig around. It's got some great documentation around use cases. The Terraform provider for NSXT is underneath that. It's fantastic. And when I was starting using Terraform, I looked at Nico Giles's and Rutger's blogs. They're pretty useful. And then if you want to follow me, I'll be doing a little work on Terraform myself on vmusketeers.com.
Hi there. In today's session, let's discuss about Dell Technologies cloud storage solutions for VMware-based workloads. On the surface, transformation to cloud appears as if customers are transforming towards simplicity. Cloud offers enormous flexibility and scale. They also offer agility, and with all the wide next-generation applications available in cloud, innovation is what customers look at as they move to cloud. Cloud also offers pay-by-the-drip consumption model, which makes the offer even more sweet. Sophisticated cloud models have always included on-premise element associated with it. And as far as on-premise element is concerned, repatriation appears to be a real thing. As per the recent reports from IDC and ESG, majority of customers have on-premise data centers as an inclusive element as part of cloud strategy. And 80% of them do consider cloud repatriation as a serious thing, and 50% intend to do so in the next 2 years or so. With all these data points, it's clear that cloud is not a destination, it's not a one-size-that-fits-all model, but it requires an operating model that requires thoughtful consideration for effective implementation. Let's take a look at some of the use cases that enterprise customers implement as part of the cloud journey. Customers would typically want to take their on-premises environment to the cloud, which means they would have to extend their data centers to cloud and expect the same levels of operational consistency. Customers would also want to set up disaster recovery solutions for their on-premise environment and expect to have the same level of operational consistency again when they switch to the cloud. Organizations can also look at migrating certain enterprise applications to the cloud without doing any refactoring or rework associated to it. For effective implementation of cloud strategy, it requires customers to have a flexible dev test environment to ensure that data can be moved back and forth as part of development experience. Customers will also look to scale up and down effectively in minutes to ensure that they can effectively implement strategies around cloud. With all the use cases that we mentioned, let's also take a look at some of the complexities associated with it. Organizations typically would look at having multiple clouds as part of this strategy. In fact, as part of IDC's report, 83% of customers look to have multiple cloud strategies. When we talk about multiple cloud strategies, it could either be a combination of public cloud or a private cloud, or it could be a combination of multiple public clouds. In either scenarios, every cloud offers its own management tools. So what this would actually mean is customers are dealing with disparate management solutions. When you have disparate management solutions, operations becomes a serious complex issue that customers would have to deal with. It has the potential to slow down operations if customers have to deal with multiple systems. Not only that, but customers would also need to have resources tagged onto different clouds, which makes migration of resources from one cloud to another cloud a real task. Customers would have to ensure that they would have to refactor applications as they migrate resources from one cloud to another cloud. When you have multiple clouds associated with it, it requires organizations to train the right set of folks with the right tools and processes associated with cloud. Last but not least, there is a security angle to it. Cloud in general is very open. It requires customers to ensure that they have the right level of security understanding as they migrate resources from one cloud to another, or migrating resources from their on-premises environment into the cloud. To ensure all these complexities are addressed, Dell Technologies introduced cloud storage solutions. Dell Technologies Cloud Storage Solutions not only addresses all these complexities in an effective manner, but also ensures customers have this seamless experience as they migrate their on-premise environment into the cloud. There are two services that we launched as part of this solution. One is Multi-Cloud Connect, which basically provides customers the flexibility to extend their data center into the cloud. And the second is disaster recovery of virtual machines to VMware Cloud on AWS. This service provides the flexibility for customers to set up disaster recovery in VMC on AWS. As you can imagine, this service provides customers with the flexibility of subscribing to storage that they really need. It also avoids cloud lock-in, so customers have the option of presenting to any cloud of choice. And it also provides the flexibility to natively replicate using the native replication technologies that the array provides. Let's go deeper into our solution. With Dell Technologies Cloud Solution for Multi-Cloud, customers have the option to expand into any cloud of choice. They can expand their on-premises environment, they can replicate, or they can migrate their resources into multi-cloud and present it to any cloud of choice. They can present the same resource to multiple clouds at the same time, truly leveraging the flexibility that our solution provides. It is 100% data consistent and it is available all the time, so customers would not have to worry about the lack of availability zones. With our solution, you could also have automated disaster recovery. You could leverage on the tools that VMware provides. It could either be VMware Site Recovery, or you could also leverage on the native replication technologies. Last but not least, you can also integrate with multiple applications that various clouds provide, and you could operate on that with the data that we present to multiple clouds. So there is enormous freedom with the way you could operate. So with VMware Cloud on AWS, we truly provide one cloud experience with consistency and choice. You can migrate or replicate your data seamlessly from your on-premises environment to cloud, either using vSphere replication or array-based replication. You could move your data back and forth without any egress or ingress charges. And since you replicate your data with on-premise from your on-premise environment into cloud with array-based replications, you can maintain the same levels of application consistency. And there are no additional technology complexities associated with this. You can also tag compute as and when you need it, which means you can actually keep your operational costs really low. So it's a truly cost-effective solution that we present to you. Moving on, disaster recovery solutions with VMware Cloud and AWS is our other service, wherein customers can set up DR solutions for their on-premises environment into cloud. You could again replicate your data using either vSphere replication or array-based replication. And this solution is completely automated. So you could have very low levels of RTOs and RPOs. So you could set up disaster recovery solutions for high-performance compute kind of workloads. And you can maintain the same levels of operational consistency that you would have as you have in your on-premises environment. So with Dell Technologies Cloud, you can make the cloud work for you. We have solutions for multi-cloud, for disaster recovery solutions, and we are very tightly integrated with VMware Cloud on AWS. So do check us out on our webpage, that is Dell Technologies Cloud Storage for Multi-Cloud. We do have resources, we have videos, white papers, and interactive demos. And if you're interested, we could further discuss about it. Thank you.
Hello, and thank you for the time today. I'm Jim Shook, the Director of our Cybersecurity and Compliance Practice in our Global Technology Office for Data Protection. I spend most of my days with customers and internally talking about cyber recovery and cyber resilience. So I'm looking forward to having the opportunity to talk with you about those things today. In my presentation, we're going to talk about cyber recovery and how much can you afford to lose. You can't look at the news today without finding a bunch of stories about ransomware and data destruction. So we've got a couple here that are very interesting. And of course, we've blocked out the victims' names just because they've taken enough of abuse so far from the press. And really our point is to talk about what happened and how difficult it is to prevent and recover from these attacks if you're not prepared. So what you can see from these particular attacks are a few things. One, the attacks are very expensive. Losses in the tens to hundreds of millions of dollars for a ransomware destructive attack are just not uncommon anymore. Two, it's very public. There are often service outages, the term here used as meltdown, that are evident to customers, to shareholders, to partners, and other interested parties. And three, the attacks have different types of techniques and capabilities. So you really have to be very prepared in advance for these attacks to minimize the impact. And despite that, despite the fact that we've had these attacks now for a while, you can see from our survey at the top of the slide that over 2/3 of organizations really lack confidence that they'd be able to recover their business critical data after one of these attacks. And that's certainly what we see too anecdotally from being involved in this area. So what do you do? How do you prepare for and recover from these attacks? It's interesting because it is really a cybersecurity capability. If our customers use a framework to kind of benchmark their cybersecurity capabilities, it's often, and this is globally, not just in the States, the NIST cybersecurity framework. We've depicted here just a representation, the 5 highest levels, the functions that are in the NIST cybersecurity framework. We focus on recover. Many organizations traditionally, because we were worried about theft of data, which impacts the confidentiality of the data, focused on the other capabilities: identify, protect, detect, and respond. And those capabilities remain really important. We want to keep the bad actors out. We want to detect them as soon as they're in. We want to protect the information that we have. But we have to be aware that some of these attacks are going to get through, and we have to be prepared to recover from those attacks. That's our focus. So it's no longer just about the confidentiality of the data. It's also about the integrity and effects is to consider the full spectrum of cyber threat actors. So we've got various groups depicted here. Starting at the left, I think there's a little bit too much focus on basic criminal actors. So these are actors who are in it for profit. They often have the lesser ones have just cyber ransomware as a service, and they're not very sophisticated. A lot of the solutions that are out there protect really just against those types of actors. We need to be wary of more sophisticated actors, and thinking back to the headlines I showed you, those were sophisticated actors in those situations. And we'll talk more about their techniques, but they're in it for the money. We can't stop there. So insiders, nobody likes to think about their employees being bad actors, but it happens. People get angry. They might be bribed, extorted. We've seen that with attacks recently with some high profile companies where insiders were involved. So our protections have to go beyond just the basic criminals and include insiders. Then as we move over to the left, particularly with hacktivists and with cyber weapons, the purpose for those bad actors is to destroy. So they may encrypt data just like a ransomware attack, but there's nobody to pay. So if you're not prepared with the ability to recover data and you get hit by a hacktivist or a cyber weapon, you can't count on the ability to pay a ransom and get your data back. There's simply nobody on the other side. So working across all of these threat actors, very important as you think about your strategy in the cyber resilience space. Here's one of the techniques that is getting to be better known, but really important to understand when you're making your plans here. And that's the idea of using a backup in a cyber recovery strategy. So you think about normal attacks, the slide I just showed to you, the bad actors are getting into the network, and ultimately their goal is to encrypt your production data, databases, servers, sometimes file shares, just the important stuff that's in production. And so if you have a backup, you might be able to recover from that attack. Well, the bad guys know that too. And so more frequently, they've been targeting the backup infrastructure as part of their attack. They're very resourceful. They have a lot of tools. What we frequently see is deployment of things like a tool called Mimikatz to pull in passwords. We're seeing more frequently the bad actors breaking into password vaults, and then they get all the passwords for all the infrastructure. So when they roll out their attack and they encrypt the production data, they're deleting, encrypting, or otherwise destroying the backup data. So you can't count on having that data unless you take extra measures. Another thing we see for some organizations is to simply put an extra copy of data, maybe an extra backup, in the cloud. And really the public cloud, if I'm being more specific. And that's an interesting strategy to have an extra copy of data, but it's not protected. It's just an authentication away. And we've seen some of these bad actors get into the infrastructure and watch what the administrative people are doing on a daily basis. So they're uncovering those extra copies. And since it's just an authentication away, they can log in and delete or destroy that data. We've also seen them leverage cloud data for their own recovery. So they might get access to that content and then they just do a recovery to their servers and now they have all of your data. It's not a ransomware attack anymore, but it can certainly be just as painful. Similarly, a disaster recovery or DR strategy is a little different from a cyber resilience strategy. So think about DR, the idea is if we have an operational or physical disaster, we've replicated data to another site so that we can fail over to that site and continue operations without too much disruption. Very important capability. Doesn't help us much in most of these cyber attacks because the capability that we have, we use replication to deliver that data to the additional site. That replication doesn't know if it's replicating good data, bad data, or encrypted data. So if the bad actors have gotten in and encrypted the production data, our replication mechanism just replicates that bad data to the next site, and so we lose that one too. So these are different capabilities. I'm not saying that DR and backup are bad. They remain as important as they ever were. They just meet a different purpose than a recovery or a cyber resilience strategy. At the same time, we want to be able to leverage those investments that our customers have made in their DR and backup strategies as stepping stone into their cyber resilience strategy. So that's where we focus with our PowerProtect cyber recovery solution. This is an area where we've been involved for 5 years. We've really been the leaders in cyber resilience. We've helped to set the market, set the capabilities that are out there. We have the most sophisticated solution and the most sophisticated practice. We also have the most customers, and that's important because we've got a lot of hands-on and operational experience. Another thing we've done in this space, and I'll touch on a little bit later, is work with the best practice groups that are out there, like the Sheltered Harbor Initiative, and we're the only ones involved with that process, which again, important from a standpoint of maturity and capabilities and sophistication. So what do we do? What is cyber resilience? What is cyber recovery for us? I like to say we could spend a couple hours on this, and I have on this particular diagram, but I'll just give you kind of a basic overview. Of course, we're all happy to talk with people in more detail about it at any time. So on the left, what we have is our traditional data center, very simplistically depicted production environment and the backup environment. Note, we don't have DR here, but people may have a second or third site. The other thing that we've done is we've color-coded some of the data. So when we talk about cyber recovery and cyber resilience, we're really focusing on protecting the most important data. That might be 20% or 30% of the overall footprint, just depending on the organization. We can certainly protect all 100%, but normally it's a focus on that most significant part. And so we've color-coded that here between the blue and green data on the left. So organizations are already making a backup. We're not going to impact that, but we do want to leverage it. And how do we do that? So our cyber recovery vault, our data vault, is on the right side. It has a couple of important characteristics. So one, it's physically separate. We like to have it in a locked room or a locked cage, but it's not another data site. It's at your production site. It's at your DR site. It might be with a managed service provider or even a cloud provider. Location doesn't matter. It's just that physical access that helps us protect against bad actors. And it's logically separated. So you can see in the middle, we've got this air gap, and we call it an automated operational air gap because it's not always off. We enable it sometimes so that we can update the data that's in our vault. So normal status are components in our vault. They run the vault from that side. We have storage, compute, and other components there. They're not accessible if you're in the production environment. They have private IP addresses. We don't share switches, firewalls, data diodes, our Unisys stealth capability. All those things can come into play to further secure the vault. What happens, though, is we want to take that most critical data, so the green boxes, if you will, on the left, and on a regular basis, we want to update the content that's in the vault. So we will enable that vault, essentially unlock it in a very careful manner so that's limited what can happen. And we'll go through these steps. Sync, we take the data from the production side that has changed from the last time we've done this process, and we sync it over into the vault. Then we lock the vault back down. We make a copy of the data, and organizations will keep that data from a couple weeks to a couple months, depending on their vault requirements. Then we'll lock the data. So we'll apply a retention lock to it, which helps to protect further against an insider or a failure of any type. It can't be deleted before the retention period expires. And then we'll analyze that data on a full content basis. And we'll talk about that a little bit more. But essentially what we're doing is we're looking at that data to make sure that it's valid, that if there was an attack, we could use it for a recovery. Out of all of this, we can get monitoring and reporting. It's automated. You don't need somebody sitting in the vault. It runs by itself and sends out information about the vault to your SOC or NOC or other monitoring groups. And of course, the whole point of this is if there is destruction or encryption in the data center, you use the data that's in the vault to securely recover back to your production environment or another environment that you've chosen for your recovery process. So So that's really the basics of our solution here. There's a lot of detail in there, but that's our overview of everything. One of the most important things that we've done is that we've built the solution out and we've productized it. And what I'm showing you here is the graphical interface for the system that runs in the vault. So if I can skip back for just a second, you can see the vault side. This is what runs in the vault, and the vault is controlled and operated from the vault side. That's really important because we make the assumption that a bad actor who's in the data center might have access to everything. Think about when I mentioned before about the insider. That insider may have access to everything, knows all about the vault, knows when it syncs up, how everything works, and yet we're still going to be secure from that type of a threat actor. And part of that is running everything automated and operating it from the vault side. The other great things about having a product is it's tested frequently. We have a help desk. There's a roadmap. We make improvements all of the time. And so you don't want to go out in this space and get a custom one-off solution that may not be secure and may lose its security over time as changes are made. Having this productized is really important. Also, as you make changes into your vault, you might change what's brought into the vault. You might decide that certain data sets aren't critical anymore, or they've moved. And being able to use this GUI, especially on the right side here with things like policies, to update that is all very easy and straightforward. And then you can see here too the recovery tab. We've automated a lot of the recovery processes. So if there is an attack, you know what to do, and you can do it at least partially on an automated basis to speed your recovery and make it as efficient as possible. A couple things that we've learned about cyber recovery and resilience that are important to a solution that's going to be effective. And again, tying this back to the whole spectrum of threat actors and the tools and capabilities that they have. So we think about this on a couple of different levels. You can see on the slide here, good, better, best. And of course, you want to get further up as you assess the risks and the importance of your data in your environment. So good capabilities are things like making the data immutable. Some people will call that worm, write once, read many. There's a standard out there called 17A4F that people use to kind of take the place of worm. But essentially what we're doing is we're making that data harder for a bad actor to delete. So if they get into our backup environment, our infrastructure, we've locked the data. And note that I did say harder or more difficult to delete. Data that's locked really isn't immutable. There are ways to attack the data. There are clock attacks. There are insider attacks. So it's a good control that you want to add to a solution, but it's not a solution in and of itself. Then as we move into better, how do we improve our positioning there? Well, one thing is let's protect from insiders. So having those capabilities to separate the systems that an insider can't even get access if they know where everything is, putting physical controls on rooms and locks, separating duties so that different people can do different things. Those are all components of a solution that are important too. But as we get into best, this is really where we separate from everybody. And the key there is having that air gap, that operational air gap that separates the system from any bad actors that don't actually have physical access. And that's almost every case. So doing that alone is a huge step up from the good and better. I'd mentioned Sheltered Harbor before. There's not a lot of standards in this area. So when you look to how do we benchmark our capabilities or our solution, Sheltered Harbor is a financial services initiative that looks at a lot of these things and has some recommendations on it. We're the only group that's working with them in their technology solution provider program, in their alliance program. So that's a really great data point. And then the last piece is analytics. How do we know that what we put into the vault is good data? And then can we use that data when we recover? You think about some of these attacks, you don't know that an attack is, for example, a NotPetya attack, which happened a few years ago, until later. All you know is that your systems have gone down, your data's locked up. Having analytics for your vault data can tell you immediately what data is good and what data is bad. So you might be able to use some of the data that didn't get impacted. You might know that some of your data from today is bad, and think back to my sync, copy, lock, analyze process. You may have a copy of an application, for example, from the day prior that's good, and you can reuse that versus having to go back and set things back up. So all that information leverages into the process of enabling your recovery to be more efficient and more effective. This is kind of my specialty area. I know puts some people to sleep, but what's happening in the regulatory environment, what's happening in the legal environment, and we're tracking along with those things. And in fact, in many cases, we're helping to drive those. So in the US, we tend to have more industry-specific requirements, and healthcare and financial services really lead the way. They're talking about, as you can see from the FFIEC, an air-gapped data architecture. Our FBI, which is a group that we get to spend time with here, is talking about backups and ensuring they're not connected to networks that they're backing up. So you think about those backups being attacked from my earlier slide, that's really what they're referencing there. Outside of the states, the protections tend to be more broadly structured. So they're not going to be sectoral in an industry, but things like the GDPR, which protects personal data, actually has some cybersecurity requirements to it. And just fascinating to me, again, GDPR has been out for a few years, that they mention what I talked about before, confidentiality, integrity, and availability of the data, not just the confidentiality, which is the theft, but if you're going to have that data, you've got a responsibility to make sure that you can use it and that it's secure and available. So this is the path that we're working down. And when you think about how these all coalesce, it's an air-gapped copy of data that's protected in the data vault. That's the best way to meet these requirements as they become more structured, more strict, and more important in the coming years. So when you look at the competitive differentiators, and this is similar to the slide that I showed you before, I think it's important to understand what else is out there and where it may fall short. So in many cases, what we see from others in this space is just taking a backup and hardening that backup. And as I said before, things like immutability, which you can see across the top row here, it's important, it's useful, but it's not a solution. It's just an extra control that's going to make that data a little bit harder for a bad actor to reach. We're operating across all of these different capabilities, and they're all very important. So as you look at other solutions, really understand what they do, what they don't do, and where the gaps are going to be. They're going to protect typically against the, I mentioned before, garden variety bad actor, and not against insiders, not against more sophisticated threat actors, and not against things that are cyber warfare like NotPetya that we saw a few years ago. So be very careful and be very informed on all these capabilities and determining what's necessary for you to really keep a safe copy of data. I talked a little bit about the analytics and want to talk a little bit more. So how do you know that data in the vault is good? And that's what we do with our CyberSense capabilities. So think about the sync, copy, lock, analyze. We're bringing data in to the vault. We don't care if it's good or bad data. It's not going to run in the vault. So if there's malware in our backup that we're bringing into the vault, or there's dormant malware, it doesn't run. It can't impact our vault because we're keeping it in this backup format. But we want to know, is the data good? So what we do with our analytics is we take that data once it's in and locked into the vault, and we scan it. We don't have to restore it. We can read through the backup format, and we're going to make some observations, some statistics on all this data. We're going to go at an operating system metadata level. Did the size of the file change? Does it have an extension that might indicate it's been corrupted? We're going to look at the application metadata. So think about a database having an actual structure to it, that if that whole structure is gone, then that data is corrupt. But then we're also going to look at the full content. So we're going to measure things like Shannon entropy that might tell us that data has started to get encrypted. We've got chunking and similarity algorithms that will help us compare files day over day. We're going to take all that information and feed it to a machine learning algorithm that's going to help us understand whether that data has been corrupted. So no, we're not looking for malware. We're looking for evidence that the data is not useful. We repeat, we do that day over day. We have all these comparisons, and then we've got all that information available to us. So we'll send out from the vault a simple report card. Data looks good, data is suspicious. And then if you go into the vault, you can look all the way down to the file level to every single observation that can get you all the information you need to help determine root cause and help figure out how you're going to recover. Really important. I mentioned before the critical data. So as we work across industries, every industry has different focus areas. You can see a few here. I spend a good amount of time in the financial services area, so banks and credit unions looking at core banking. Some are looking at trading platforms. In the legal community, document management is really important. You know, all data is going to be important at certain levels, but what we're really looking to protect in the vault are those critical data sets that without you really do not have a business. You can't operate at all. So get those into the vault and make sure that they're protected. I've mentioned Sheltered Harbor a few times. I think it's a really good organization for people to look at for best practices. Shelteredharbor.org is the site. If you're in the U.S. banking and financial services industry, you can be an actual participant. And I think it's a good evaluation to make. It helps protect the U.S. financial system. If you're not a potential participant, the ideas that they have, and you can see here on the right, for example, how they require a data vault, the characteristics that are necessary to protect data are useful. So the unchangeability, the separation of the data, make sure that it's accessible. All those components add up, and there's more technical requirements there that are really useful. We're looking forward to winding up our last step of our endorsement process this month, which is August 2020, and continuing to work with the organization and their participants out there. So just kind of wrapping up here, you know, why Dell Technologies for cyber recovery? I mentioned before kind of some of the specifics here. The air gap is hugely significant. You know, just making data immutable or locking it is a good step, but it's not enough. All of our experience in this space, really good. 5 years. We know what we're doing. We've made changes to the product over time to reflect some of the new techniques. And then the analytics in the vault, going full content. All of those things really add up to a very robust solution. We've got a lot of other materials out there on our website, videos, case studies, white papers. Recommend that to you also. So I want to thank you very much for your time. Look forward to the opportunity to maybe speak with some of you in the future, and be safe and take care. Thank you very much.
Thank you for taking the time to look at to view my vBrownBag session that I'm going to record. It's how to use vRealize operations as you're monitoring single pane of glass. I work for Select Medical, and we're located in Mechanicsburg, Pennsylvania. I am a vExpert for 2020, and if you look at my slide deck there, I do have my Twitter handle and also the address to my blog if you would want to reach out to me after you view this. A little bit of my background. You know, I've been using the ESXi for quite a few years, vRealize operations, you know, for over 6 years. Create a lot of custom dashboards, reports, alerting. I've been using the True Visibility Suite. I also do a lot with vRealize automation, so I'm going to show some demos, you know, that whole single pane of glass, how you can integrate the two together. And just real quick with the V community, I've been involved since like 2013. Started by just going to some local V mugs, and then I thought I wanted to give back a little bit, so I've done some presentations at some HVC events. I've done a power block and also talked at some Little Hacks. And if you haven't gone to a Little Hack, those are really good. You should try to get involved locally if you can. So to use VROPS as your single pane of glass, you know, there's a lot of really good built-in stuff right out of the box. Some really good dashboards, alerting, and reports. And then once you become more familiar with it, you know, start creating your own dashboards and your alerts and start looking at super metrics. And then you can use it for troubleshooting. right sizing. If app teams ever come to you and say, I need more CPU and memory, there's some really great dashboards to get the proper size of your VMs, or to even show costs to your managers. If somebody says, hey, I want to move this to the cloud, there's some really good dashboards on showing the costs on-prem versus the cloud. So that's, I keep saying that single pane of glass. I mean, there's so many uses with VROPs. And then to start extending VROPs, instead of just using everything that's built right out of the box, they have what they call management packs. So if you go out to marketplace.vmware.com, there's some that you can get, and that'll start expanding the capabilities of VROPs. Some examples are some of the storage companies like HP or EMC have some management packs. So not only can you monitor your hosts and your VMs, but now you can start getting a lot deeper into your SAN environment. So that's, that single pane of glass. And what really made me think about the topic of my presentation is when I started looking at the text display widget. You can with that widget, you can link to internal URLs, external URLs, website widgets. You could show weather maps if you have a lot of SaaS applications. A lot of them have like a status website of how well they're doing, and you can link to that. And what you can't do with it is you can't alert off of any of that data. It's really display only. But my use case was to create VROPs to be that single pane of glass for our environment, and just to show data from many different sources. Here's some examples. I said I do a lot with VRA also, which is vRealize Automation, is I create some websites that I link to with VROPs that show our server builds, or if we're going to decom a server, or we let app teams do snapshots. So I have these dashboards that let us see what other teams are doing. So, it's that one place to go for monitoring, and you can use it for more than just the data that is collected out of vCenter. So here you can see like our server builds, I show the server name, the IP, all that information right in that dashboard. And the way I do my automation is most of it is with PowerShell. So like for doing server builds, when it's done, I create a static web page that I put out on a web server, because I store the data into a SQL database, and then I create this website. And it doesn't matter what the web server is. If you're a Windows web shop and you want to use IIS, or if you want to use any other kind of web server, it doesn't matter. And I kind of got the idea because if you go to my blog site, I've been using Hugo, which I've been pretty happy with. And what I do is I take all those pages I create with Hugo and I save it to my GitHub repository, and I use GitHub Pages to display that. And that, when I started using that, it's like, that'd be a great way to do VROPs. So that's what I do. And what management does in our environment then is they're always going to VROPs as that single pane of glass to see what we're doing with automation. So it's that nice little integration. Then with VROPs 8 and VRA 8, they did a really good job right out of the box that you can integrate the two together. So if you do a deployment, and let's say you give users access to only VRA and not VROPs, you can still integrate those. And if you look in there in my slide deck, you can see I'm showing the performance of the VM. So there again, it's always going back to that one single pane of glass that you can pull in all the information. And thinking outside the box a little bit with the text display widget, we have two different data centers. And one of the things I thought would be kind of nice to show is the weather from each. One is in Pennsylvania, one's in Texas. And then like for Pennsylvania, I even show the radar map. And that's all within VROPs, that you don't have to leave VROPs if you're in there monitoring your performance all day long. And I just thought that was a great way to show that, because if you display this on, let's say you have a NOC center and you have a whole wall of TVs and you want to be able to show the people inside your NOC, hey, this is what the weather's like outside, because most NOCs that I've been in don't have windows, and it's kind of thinking outside the box a little bit of what you can display. Ever since everybody's on my team has been working from home, we're really big users of Zoom. So we use that for video chats and chats. So Zoom has a status website. So there again, I use the text display widget to link out to Zoom, and it shows the status. Just this past Monday, Zoom was having some issues with some people weren't able to join some video conferences. So some of my team went to this dashboard that I have, and they immediately seen that, hey, there's some alerts that Zoom's saying there's issues. So, you know, it's always that single pane of glass. I keep saying it, but, you know, try to think of that's where you go to do monitoring and check performance. You know, I'm even showing an example there of AWS. There's a lot of SaaS applications that people have, and as long as they have a status page available, you could look at showing that. And there again, you could even show that in your NOC. You know, everybody's working from home. One of the things I didn't always know was when were the people actually working on my team, if they were taking a day off. So our developers internally created a web page that shows information from Kronos. So they sent everybody the link, and I'm like, man, that would be a great thing to include in the VROPS, since we're in there all day long monitoring performance, is to create this link. So you can see there, I can go out at any time and see who's working and which days. And when I talked about right sizing, you know, in addition to monitoring, you know, if an app team says, hey, I need this much CPU or this much memory, after you're monitoring your VMs for a while, it tells you what they should be, you know. So if they're asking for a lot, you can say no, or maybe it's even the opposite. Maybe they don't have enough CPU and memory, and that's why they're complaining that it's slow. So there again, to use that single pane of glass, now you're also using it to set up things correctly in your environment. One of the new features in version 8 of VROPS that I really like is the troubleshooting workbench. So, you know, you're monitoring, you're kind of seeing how things are, but then to go out here and do your troubleshooting. Here you can see all the different layers in your stack, and I really like how they do the red, yellow, green. You know, if VM is having issues, go and look at this right away and see where your issue. If you see red, you know, that's where maybe you should start looking at first. If things are showing green, you know, don't spend time in that area. So there's also many ways to show this information to your users. You can set them up as a user that they would sign into vRealize operations directly. In a NOC environment, if they sign in as a specific user, what you can do is give a list of which dashboards that you would want to display, have them auto-rotate, and what's going to display next, and set a time on there. If you have Workspace ONE in your environment, you can create catalog items that are linking to dashboards. And if you just want to send somebody a quick link by email, you could do that. And if you look at my slide deck, when you create these links for people to see outside of VROPS, you can even set a time, and you can say it's good for 1 day, a week, a month, or never expire if you're doing it on like a company portal or something. So I'm also showing that let's say there's one dashboard that you created that you have this corporate portal that's already in place, and they're like, man, I'd really like to show that data. You can take the embedded information, and that's what I'm showing, and include that into other systems. I mean, everything I'm talking about is bringing data into VROPS, but you can do the opposite too if you really have to. Here's what it looks like in Workspace ONE. You can see like where I work, we give a lot of links to all the VMware products, even some products that aren't VMware. And then this makes a nice little area that everybody comes to that you don't want to set them up as a user, but you still want them to see the dashboards. You can do that with Workspace ONE. And then what you can do is set up what they call categories. And I have a category that's called dashboards. So I take all my VROPS dashboards so to quickly see which ones are dashboards. Groups them all together nice. And this would be like if you're in a NOC environment, or even working from home sometimes, I have an extra monitor that I'll sign in and actually have like a NOC type environment in my house that you can say, display this dashboard, and then, do the auto transition, turn that on, say, keep it on the screen for 180 seconds, 3 minutes, and here's what to display next, and just have these screens. So if you're on a NOC and you have a whole wall of screens, you can kind of set up some really nice, if you don't have enough screens to show all your dashboards, just set up some rotation and set a timing on it. Works really great in a NOC. So quick overview. Just think of vRoutes as a place for that single pane of glass that you can display more than what it's collecting from vCenter. The text display widget, just think outside of the box. I really think they should rename that to the cool shit widget, because if you can display weather and websites that you create internally, it's really good widget. And then all the different ways that you can display the dashboards to users. It's whatever works best in your environment. So, I should go out and start creating your own single pane of glass. If you want to see what I'm working on next, just follow me on Twitter @DaleHassier, or go out and check out my blog site. It's vcrocs.info. So thanks for watching. I hope you learned something, and reach out to me afterwards if you have any additional questions. Thanks.
Hello, everybody. My name is Darren Schmitz, and today I'm going to be here to talk to you about VMware Cloud Foundation and deployments that involve your existing investments. So again, my name is Darren Schmitz. I'm a senior principal engineer from Dell Technologies. And so here we go. Today on the agenda, I'm going to give a brief VMware Cloud Foundation overview, talk a little bit about the benefits of using external storage with VCF, dive a little bit into VCF and vSphere with Tanzu, and last but not least, I have a live video demonstration of deploying a workload domain using the new iSCSI vVol storage in VCF 4.1. So with that, let's get going. So for VMware Cloud Foundation, if you're not familiar with the product, there are a lot of there's a couple major use cases for it. So the primary use case for deploying VCF is private and hybrid cloud. So in my opinion, one of the greatest things about VCF is it's basically the on-prem version of VMware Cloud on AWS. So you can provision your infrastructure, stand up your legacy apps, and then using the NSX networking, basically make a bridge between the on-prem and the cloud for hybrid cloud. The second primary use case for VMware Cloud Foundation is modernizing applications. So either you're developing a new application, a containerized application, or you're converting an existing legacy application into a more container-based architecture. Cloud Foundation is great for that. And last but not least, one of the other use cases for VCF is automating a Horizon VDI deployment. And by that, you can download a couple of modules, and it basically wizardizes, if that's a word, the deployment of a Horizon into VCF. When we look at VMware Cloud Foundation, there is the bill of materials is basically the listing of all of the software that kind of brings up, it's what makes up the SDDC, or the software defined data center. So at the top of the list, you're going to see SDDC Manager. And when you first have a VCF deployment, what you do is you deploy a OVA, a virtual machine called Cloud Builder, and you feed it some parameters, and it goes off and it deploys vSphere, vSAN, NSX, and vRealize Suite Lifecycle Management. So, and then last but not least, it deploys a virtual machine called the SDDC Manager machine to look over everything. So that's the main software components of VMware Cloud Foundation. In addition, there's a couple of add-on components, most of them in the vRealize suite of products. Also Workspace ONE access. Those are all things that you can additionally add in if you need. So let's start looking at the hardware, physical hardware overview, because a lot of people are curious, what does this look like if it's sitting in my data center? So when we look at Dell EMC storage and helping the portfolio, really with VCF, you start with a minimum of 4 nodes. And this can be expanded to a rack, a full rack, many racks. You add some top of rack switches, maybe even a management switch. The key is that you're adding a bunch of compute and basically servers that don't all have to be the same. You can have high-powered servers, medium-powered servers, and whatnot, and throw them in a rack and start creating what they call workload domains. But in any case, the first 4 servers that you deploy for VCF have to be the management domain, and that's a minimum of 4 servers, but depending upon how big you're going to scale, it can scale up to the vSphere configuration maximums. So like I said, if you were to grab a bunch of hosts, any number of hosts, again, this conforms to the vSphere maximums, you can create what's called a workload domain. 1, 2, 3 workload domains, racks full of workload domains if you want. Now, some of the key things that I'm talking about today is really the add-on of Dell EMC storage, or any storage in general, to a workload domain. So in my lab, obviously, since I work at Dell Technologies, I have a bunch of Dell EMC PowerStore and Unity arrays, or you can create a workload domain with PowerMax, Platinum Storage, depending upon the workload. So that's part of what I really want to drill home today is that you don't have to, the deployment with VCF is super flexible, especially with VCF 4.1. So let's look at some of the storage options. So as I said, the first 4 servers, the management domain, those have to use vSAN. The vCenters, everything that gets rolled onto that is it's mandated that the management domain is backed by vSAN. However, the workload domains that I was just talking about, they can either use vSAN or external storage. And when we talk about external storage, there are 2 terms that I want to introduce to you if you haven't heard them before: principal and secondary storage. And by no means does principal mean a class of service with the storage. It's not that the principal is like the tier 1 storage and the secondary is the tier 2 storage. No, when I say principal and secondary, all I'm referring to is the order in which it's deployed. We call the first data store that's deployed the principal storage, and any data store that's once the workload domain is up and running, any data store you add after that is secondary storage. So again, the principal and secondary does not denote the class of storage. It's simply when it's deployed. So for those principal storage options, like I said, new to VCF 4.1 is the vVols, and that's supported by iSCSI, Fiber Channel, or NFS. But for principal, you can use vSAN, obviously, NFS v3, or what they call VMFS on Fiber Channel. Now, supplemental storage options, the 2 options that you just simply can't use to deploy a workload domain is just NFS v4 and VMFS on iSCSI. The rest of everything is available for supplemental storage options as well. So from the customer point of view, one of the key, in my opinion, some of the benefits of external storage is obviously with VCF is leveraging your existing storage array investments, right? So if you have an array in the environment that's maybe underutilized, has extra performance that you don't really want to, go by the wayside, obviously you can use this for storage in a VCF environment. A storage array is an important and sometimes expensive investment, and it's best, some customers like to leverage that. And so the second benefit, I think, with VCF and external storage arrays is that you can scale storage independently of the workload domain compute. And that's important because when you're using vSAN, you often have to scale the storage with the compute. And if you have a really compute low type workload and you have that requires just a ton of capacity, it's nice that you can attach a SAN to externally and scale that independently. The third benefit for using external storage is obviously if your business is dependent on some features that are embedded in the array that are important to the business, replication, deduplication, metro cluster, stuff like that. So that is one additional reason for external storage arrays. But the final reason is just basically performance. So there are certain high demand workloads that just require external storage. So if the workload, if vSAN is not desired for a particular workload, then that's where maybe an external array can fill in and fill that gap. So let's talk about vSphere, vSphere with Tanzu on VCF. So in my opinion, one of the greatest things about Tanzu on VCF is that it is super easy to deploy. Basically, you create a workload domain, as you see on the right-hand side of the diagram. You basically create a workload domain. This deploys NSX. After that, you deploy an edge cluster. You enable workload management, and basically, it's up and running. You can run TKG on top of that. Maybe load up Harbor, whatnot. But the greatest thing about this is that it is completely lifecycled by VCF. So it takes care of updating all the components when it's time to get to the next version of stuff. This is great, obviously, because as we are moving on to the next generation of apps, this allows people, obviously, to make new containerized applications or convert existing in-house applications to container-based. So if we bring this whole thing together, I think one of the greatest benefits of VCF, especially when you pair it with external storage, is that you can have your virtual machine workloads, which are maybe even your traditional virtual machine workloads, side by side with the cloud native applications, right? So this gives the administrators a one-stop shop, a single pane of glass to administrate everything and work on everything. And because of that obviously simplifies modernization initiatives. If there's applications that are being converted in the environment, all the better. So the cool thing about external storage, especially when we're talking about vVols being brought in as principal storage into VCF, is that these containerized applications that require the persistent storage can utilize any data store. So as you're adding supplemental storage or principal storage to the workload domain, all you need to do is add a tag to that data store, which tells the Tanzu, the Kubernetes, that is eligible for containerized persistent storage. So the great thing about that is that you can have different storage types underneath. Kubernetes doesn't care about it. And obviously with that, SPBM is utilized you can use that in the environment. If there's one thing I want to convey is that VCF with external storage just simply adds flexibility. You're really getting the best of both worlds. External storage and that flexibility really adds to the on-prem environment. And from there, that can be extended into the cloud or hybrid cloud where you have certain apps out in maybe a VMware Cloud on AWS that talk back to the on-prem application. The great thing about this is that, as I said, flexibility, apps can live anywhere. So with that, I'm going to get to the live demonstration. So with VCF 4.1, we have the addition of vVols as principal storage. So in my lab, I'm going to show setting up an iSCSI workload domain that is backed by vVols. So the first thing I want to show you is in the network settings. When we create the network pool and give it a name, you're going to notice that the new thing in VCF 4.1 is a network type. They added a dedicated iSCSI networking type for iSCSI traffic with VCF. Now, previously they had NFS, but in 4.1 it adds iSCSI so that when you create that workload domain, it can basically create VM kernel interfaces for the iSCSI traffic. So you'll see we add these networks and we hit save, and that basically creates our network pool. From there, the next thing that we need to do is add our VASA provider. So to do that, there's a new section called storage settings. And as you can see, I have multiple different arrays in my lab, but I need to add my PowerStore array because that's one we're using for iSCSI today. So when we add the VASA provider, all we're doing is adding a name, the URL to the VASA provider, the username, password, matching up the container name and the protocol. And then we can hit save. So again, multiple arrays in the environment, you can add multiple VASA providers. To set this up, previously, all we did on the ESX host is basically we went into the iSCSI and enabled it, cut and paste the IQN, and then added the dynamic target to the bottom. And basically that prepares the ESX host to talk to the array when the workload domain is rolled out. So on the array itself, the only thing that I had to do, this is my PowerStore array in my lab, is all I had to do is go in and add all the hosts. And as you can see, what I did is I simply added the host and pasted the IQN in there. If you'll notice, it's not active yet. There's no active sessions to it yet. It's just simply waiting for the connection when the workload domain gets rolled out. So when we flip back to the SDDC manager, the next thing we need to do is commission the hosts. So I click on that. Here's the checklist of all the things that need to be done to the hosts. As you can see, I already completed those. Now I'm going to import a JSON file to make this a little bit faster. I upload that, and then I can basically start the validation for commissioning the hosts. And I'm going to fast forward this so that we don't have to wait several minutes. This does take a minute or so for that to complete the validation. But once we do that, I can click on next and commission. So while this is commissioning the host, we can basically go out and look at the tasks. As you can see, it's running, and the commissioning takes about 2 minutes in my lab. And once the hosts are commissioned, they are all ready to go for creating a workload domain. So we flip over to our workload domains, say workload domain, VI workload domain. And here's where we choose for our principal storage type. And in this case, we're picking vVols because we're going to use iSCSI vVols. And we say begin. And I'm going to cut and paste basically all the information into this. But the information is just basically, names, cluster, the vCenter information is what I'm putting in now, and putting in the passwords for vCenter. Here's where we put in the networking information for NSXT. Again, we're putting the managers, the FQDNs for the managers in there. It automatically does the name resolution for the IP, and put in the passwords and say next. This next screen is where we specify the vVol storage that we want to use. So I'm using iSCSI, and that's going to allow me to select my PowerStore. And then we pick the storage container that I'd previously specified, the username I want to use, and then I can just paste in a data store name for that particular data store and say next. On the host selection screen, I basically am just picking the 4 hosts that I want added to this workload domain, and I say next. I select my licenses, and say next. I review the object names for the switches and object types, and then I say finish. And this gets the workload domain deployment started. So if we drill down into the task, we've got to wait a second for the task to be populated, but in a second it will be there and we can click into it. As you can see, there's dozens of tasks that the workload domain needs to do, rolling out vCenter, rolling out NSX, deploying a bunch of stuff. I'm fast forwarding this, but in my lab, it took about 49 minutes to deploy the workload domain. But when that's done, what I want to show you is that when we click on the workload domain, as you can see, it is listed as, the storage is listed as vVol storage type. If we click into the domain and we open up vCenter, if we open up the vSphere client, this is going to bring us to our workload domain. It's a linked vCenter. So as you can see, my 4 hosts are in there. And to demonstrate vVol is working, I'm just going to basically create a brand new virtual machine just to create the vVols for this particular virtual machine. So type in a name for it. I select the cluster. I select the data store that particular virtual machine is going to be put on. I select the operating system, and I say next. Verify all of that information and click finish. And in a few seconds after that virtual machine is created, it's all done. And we can flip back over to the array to see it all in action. So if we click on storage and go into our storage container, you can see my VCF storage container that I specified earlier. If I flip over to the virtual volumes, you can see all of the demo VM virtual volumes and the cluster service vVols that the workload domain rolled out for that particular domain. So again, external storage is really beneficial when you add it in with VCF. As I said, there's tons of benefits, but the main benefit is adding flexibility to your deployment. So there are a couple of additional resources if you'd like to learn more. One of the documents that I maintain is the Validated Designs Dell EMC Storage with VMware Cloud Foundation. If you Google H17921, or click on the dell.com/storage resources and drill into the one of the PowerStore or Unity section. The document is in there. This guide is a step-by-step walkthrough on if you're a EMC customer or Dell storage customer. It really is a step-by-step guide on how to implement any of the storage arrays in the Dell EMC lineup as principal or supplemental storage in your environment. Obviously, the VMware Cloud Foundation link is out there for additional information about VMware Cloud Foundation. And with that, I want to thank you very much and have a good day.
Hi everyone, my name is Itzik Reich. I'm Vice President of Technology here at Dell EMC. And with me, I have Paul Mitchell, who is our Field CTO for Data Protection Solution. And today we're going to talk about accelerating adoption for VMware Tanzu, enterprise storage, and data protection options for Kubernetes workloads. With that, let's start with the very beginning. In the beginning, we used to have bare metal servers that used to run a single operating system on each one of these servers, and probably a single application that ran on this operating system. Then came VMware with a radical different thinking and say, you know what, why don't we consolidate all of these applications that don't generate a lot of CPU and memory consumption and run a very thin layer of an hypervisor on the top of that bare metal server, and then each VM will consume its own operating system and memory and CPU cycles, but together we can actually stage a lot of these bare metal servers that don't do a lot. And that used to resonate quite for a very long time, including today. But then in 2015 came a small startup called Docker and said that maybe there is even more efficient way of running applications on the top of the bare metal servers, but basically running a single operating system on that bare metal server. But instead of running an hypervisor on the top of it, what they did is basically fork, if you will, the kernel of that operating system, and each one of that fork ran its own application separately. So each and every one of these applications is not aware of the other one. And by doing so, you can actually save a lot of this cost on these operating system that runs on the bare metal server. And that is an absolutely valid way of running containers today. But there is also a new emerging way of running containers on the top of the bare metal servers. And that's the way that VMworld chose to do, which basically still run an hypervisor, a very thin layer of an hypervisor on the top of the bare metal server. But on that hypervisor run the Docker runtime. And by doing so, you can basically enjoy both of the worlds. You can still isolate each one of the container runtime from the other containers that are running on the bare metal server. But things like high availability, vMotion, DRS, all of these features that you used to know and love from the VMworld still exist. So you benefit from them immediately while running them on the top of the hypervisor with the Docker runtime. And if I then compare and contrast this to the storage management world, still today, people are probably managing the storage array from the user interface. So in this example, you see our PowerFlex, our software-defined storage UI. So to the left, you can see how to provision volumes, and to the right, you can see a way how to monitor the storage array. And automation, if you will, was probably script via the storage array CLI command, the way to automate and accelerate, for example, volume provisioning. That was the best way of automating the storage array using native storage tools. The thing is that everything is different today. People expect to treat your storage just as a line of code, just like everything else that evolves around writing and development and writing application that will run inside your servers. So storage is just another element, if you will, that is important, but it's as important as any other line of code for the developers that are basically developing the software on the storage and the compute and everything else. So for them, they just want to, with a single command, do everything that evolves around storage management without touching the storage user interface. And into that world of the Docker runtime came many, many orchestrators that did exactly that. And the leading orchestrator that basically has won the war big time is the Kubernetes orchestrator. And there are many reasons why Kubernetes succeeded, and it's now become the de facto orchestrator that is running on the top of the Docker runtime. Some of the reasons are full automation around everything. Starts with self-healing. So if a container fails, Kubernetes will know how to spin up a new container that will mimic the failed container workload. It's very easy to upgrade the entire stack where you go with Kubernetes. It's very easy to scale your workloads. So think about database that comes, for example, Christmas. It's very easy for you to your retail shop to just spin up another database that will automatically load balance itself within the rest of the databases in your backend and will fulfill your user request just for that time. And just like you can do spin up and scale up, you can also scale down if your workload demands are shifting, which is something, again, that is very, very new to the way of writing application these days. On the storage management, which is our focus in this session, is really everything around storage orchestration. It is very, very easy to provide storage management capabilities directly from within Kubernetes. So let's actually talk about those options. At the very high level, the thing that you are looking for in a storage array when you work with Kubernetes is a plugin called CSI plugin, which stands for Container Storage Interface. The Container Storage Interface really provides you the ability to extend your existing storage infrastructure into the Kubernetes management itself, and by doing so, provide microservices help and assistance to your running containers. Now let's go a little bit deeper into the architecture of the CSI plugin itself. How does it work? In a nutshell, if using a block storage, for example, a volume in the language of Kubernetes will be a persistent volume, which basically means that when you're a Kubernetes administrator, you log into the Kubernetes interface and you claim actually a persistent volume from within Kubernetes, which stands for PVC, persistent volume claim. And in advance, if your storage array speak, Kubernetes will answer with a persistent volume that will be provisioned for that container that you just spin up in the system. However, this is just the basic offering. Modern storage arrays such as PowerFlex or PowerStore or PowerMax in our portfolio can also give you the ability to provide unique capabilities that are coming outside of just the provisioning operations. For example, in the case of PowerMax and PowerStore, you can also designate quality of service for your running containers. So you will know that none of these containers that will be maybe spin up will manipulate the entire storage resources for that specific container workload. Now, let's see how it's actually all tied into VMware, because up until now, we only talk about Kubernetes itself. VMware in 2020 came up with vSphere with Kubernetes, which can be part of the VMware Cloud Foundation, but it can also be consumed in other fashions. VMware basically invested a lot in adopting Kubernetes and attaching it to the very core of the vCenter interface by both the management element and also the ES6i kernel itself, providing you really an holistic approach to manage Kubernetes workloads directly from within vCenter. So if you're a vCenter administrator, the familiarity of the UI will be immediately on the spot. If you're a Kubernetes administrator, you can still continue using the kubectl CLI, basically creating container pods, creating and storing them as you go. From a storage management, which is what we are discussing now, really there are two options that your storage array can interface into vSphere with Kubernetes. The more traditional way is to use VMFS data stores. Pretty much every storage array under the sun today provides VMFS capabilities, nothing new here. However, the more modern way, if you will, the first-class citizens option is really to provide volumes and storage volume to the VMware with Kubernetes via vVols, VMware Virtual Volumes. We're going to talk about the benefits in a second, but that's something to bear in mind that both of these options are available to you as a customer. And the third thing that I want you to take out of this specific slide is that in the case of running vSphere with Tanzu Kubernetes Grid, we, the storage vendor, do not provide a CSI plugin for you, just like we will in a vanilla Kubernetes distribution. Because the CSI plugin in that case is provided for you by VMware. We interface into VMware Tanzu Kubernetes Grid via vVols or VMFS, as we mentioned before, talking into the VASA element that acts as a bridge, as a communicator, if you will, between the storage world domain to the vSphere and the Kubernetes domain. Now let's talk about why should you choose VMFS or maybe another approach. So if you go with VMFS, which as we said, pretty much every storage supports today, you probably want to stick with statistic provisioning. And in a second, we're going to talk about what it is, but something to bear in mind that when a container is being brought up to the world, the data of that container itself runs on VMDK file, just like any other VM. So you can look at the VMDK file, take a snapshot of it, move it around, nothing new. Those are, again, the benefits that we discussed in advance. Why should you choose to go with, for example, VMware with the vSphere hypervisor beneath? Because it's still using the VMDKs as before. While using VMDKs, you have two options that you can provision your running containers: static provisioning and a dynamic provisioning. A static provisioning, which is really a manual provision, basically means that the vSphere administrator or the storage administrator, if you will, needs to prepare in advance the VMDK volume, present it to that running container, and then when the container is being brought up, it will use that specific VMFS with that specific VMDK. If you delete a container, for example, the VMDK file will not be deleted automatically. Or maybe should you decide that you need more capacity, you need, again, in advance to discuss this storage needs with your storage administrator, prepare these storage volumes, format them as VMFS, and then finally present them as VMDK file. So you probably already start to say to yourself that maybe that doesn't really scale, and it requires a lot of manual intervening, and you're absolutely right. However, it is an option for storage arrays that do not support vVols, just to go with VMFS. For storage arrays that do support vVols, as we said, such as PowerMax, PowerStore, and PowerFlex, there is a much, much better way to do it, which is the dynamic provisioning, which is done with vVols. Here, the way to think about it is like a menu. Imagine yourself going to your favorite fast food restaurant. You're probably going to see a couple of your items that you can order, and the same apply here. You probably want to designate a couple of different service level agreements. In the language of Kubernetes, those are known as storage class. And storage class can really mean many things, but in the context of storage, it is very likely to mean quality of service, for example. Maybe you want to designate the size of the volume with specific IOPS that are tied to that specific storage class. So when a Kubernetes admin will now go ahead and provision, for example, their database application, the only thing that needs to be pre-agreed in advance is the storage class that you want to provision, how much performance maybe is associated with that specific container. And then, I'm going to show it in a demo in a second, once the vSphere administrator logging into vCenter with the Kubernetes UI, it will automatically provision that vVols from within the underlying storage array. We're going to use PowerStore in our example, carve up that volume, attach the quality of service to this vVol or vVols if the running container contains more than one volume. And by the time that the container will be shut down, you have options such as keep those volumes to stay up and running, or maybe delete them if you will. And all of those things are done automatically for you. The only thing you need to prepare in advance is this service catalog. What's the SLA that you want to designate in your organization? Most of the customers that I'm talking to are sticking with those three. They don't want to make it overly complicated because then again, there are too many reasons to consider, and they stick with gold, silver, and bronze, which really means different quality of service that can be applied to the running containers. Now let's take a look on how it can actually be applicable to real world cases with real storage arrays under our portfolio. To the left, you can see our PowerFlex storage array, which is our software-defined product. Let's assume, just for the sake of this example, that I assign the gold service level for that storage array. Again, gold can mean many things, but for the sake of the example, let's assume that I actually want to provide it the best performance possible. To the right, you see another service class, storage class that I created, and I assign it a silver storage class. And in this case, I'm using the PowerStore storage array, which is our newly announced mid-range storage array. I specify the storage class, and now as a Kubernetes admin, I'm just logging into the Kubernetes CLI or UI, if you use the UI, or vCenter in that case. And now I'm only selecting the gold service class, which if you recall, we already pre-assigned and pre-agreed in our organization that we're going to select or make available as an option. And if I'm now choosing gold, Kubernetes and VMworld will be smart enough to interface via the VASA provider to the storage array that exposes its capabilities and the one that we agreed upon in advance that has the gold service class. And in this class, in this example, if you recall, what we are using is a PowerFlex, so it will automatically know to go to the PowerFlex storage array, provision the volume from it automatically. So nothing needs to be done here manually. So let's see how it actually looks using the PowerStore UI. So let's see a demo, how it all looks and how it's all tied together with the vVol interface with VMware Tanzu Kubernetes Grid. Let's see a demo. Right, so let's see how it all looks together with Dell EMC PowerStore and VMware Tanzu Kubernetes Grid. What we see here is a Tanzu Kubernetes Grid deployment cluster that we deployed in advance, which now can be shown here as the WCP cluster. And if we go to the vSphere client, we can now go ahead and actually prepare and tell Tanzu Kubernetes Grid that we're going to use the PowerStore storage for that particular workload. And if you recall, what we now need to do is to specify the storage policy, storage class in the language of Kubernetes that is going to be exposed via PowerStore. We're going to use dynamic provisioning, so we're going to use vBoss, which is why we are now ticking this box that basically tell PowerStore in the context of vSphere to use vBoss for the Kubernetes running workloads. PowerStore is a very advanced storage array, and one of the capabilities that it surfaces is quality of service priorities, if you recall that we discussed earlier. So we are just going to create a vVol rule known as high QS policy, which means that if the Kubernetes administrator will go ahead and select I for its storage class, it will automatically know to apply the high quality of service option from within PowerStore. And of course, you can use the low, medium workload, depends on what exactly you want to run within your Kubernetes workloads. So now that we specify the VM storage policy, the next step for us is to go ahead and actually use PowerStore for that particular workload. So we're going to go back to the vSphere UI, to the workload management, create a new namespace, which is a terminology in the Kubernetes world. Think of it like as a new cluster that is designated to run that particular Kubernetes workload. And we just create the namespace here. As you can see, it has its own a unique UI, which is part of the vSphere. And now we're going to direct that namespace to use the PowerStore vVol with the IQS policy that we just created a step before. When this is done, we now log into the Kubernetes kubectl command, which is the familiar tool for the Kubernetes administrator. They are very unlikely to use the vSphere UI. They're using the kubectl. But as we said, each and every one of the parties has its own CLI or interface that they are going to work with. And now what we're going to do is to actually run the VMworld CSI that we told and explained that is being used here. In that case, well, because we're using vSphere with Kubernetes and Kubernetes Grid, it is not using the storage CSI, but rather the vSphere CSI. And we're going to show it and tell it to use the PowerStore storage class that we designated before. The next step is really to bring up an application from that particular namespace running on PowerStore, which is what we're going to do here. We are actually going to run a Yugabyte database. If you're not familiar with Yugabyte, it's a next class database that, unlike traditional databases, can truly scale out. You can literally, within a click of a button, tell it to create new instances of that database, and it will automatically spread the load between all the available containers. That's the PowerStore UI. What's unique about it that even the UI itself has a very tight integration within vSphere vBoss that, as we mentioned, is what we are using in the case of VMworld TKG. And what you are now looking at is every time that we bring up a container, that container will use a couple of vBolls. There will be the config vBoll, the data vBoll, the sock file of that running vBoll-based VM. And it will actually run and show you the name of the running container workload that we just specified. So in that case, we call it Tomer TKG01. So you can actually see the container name is actually the prefix for all the running vBolls in the system itself. Lastly, we can also see that we are running a scale-up architecture, as we mentioned before, which is what we see here. So we wanted to scale the Yugabyte database deployment. So literally within a click of a button, it will create more containers and of course attach new vBolls to them. And which now you can see from within the storage array of PowerStore here. So if we now go to the storage container to the vBoll tab, we will see that more vBolls are now associated with that running a workload because we just decided to scale it up. And look at how easy it is to scale out the container workload, and how easy it is to also scale the vBoll implementation. We did a lot of optimization within PowerStore itself to be able to really provision many vBolls at one go, because we recognize that's a very known scenario that you want to burst you're running containers and you want to do it in a very quickly manner. And so that was the demo about how to use PowerStore vBrown with VMworld, Tanzu, Kubernetes, GUI. With that, I want to introduce Paul Mitchell, who is our field CTO for data protection solution, who is going to talk to you around the options to run data protection for Kubernetes workloads. Paul, the ball is over to you.
Thank you, Itzik. Appreciate it. That was a great insight in how, obviously, we can actually interact with storage natively with Kubernetes. I'm actually going to spend the rest of the time today's presentation talking about data protection. This is normally quite a strange conversation to have when it comes to Kubernetes. As customers move into this agile workload, there's a huge push in the industry to move things into an agility standpoint, moving platforms very, very quickly. And one of the things that we find in the conversations that we have is ultimately that people are ready to push applications where the traditional IT operations teams are not ready to do so. So if you look at this interaction that I'm sharing right now, is that obviously the developers are willing to push the application very, very, very quickly into the industry, but obviously the IT guy has operation considerations when it comes to compliance, backup, and disaster recovery when it starts to move into a different agile-based environment. I'm going to spend the rest of the time talking about PowerProtect. PowerProtect is Dell EMC's or Dell Technologies data protection strategy application that protects virtual machines natively, as you expect, enterprise applications, as well as container workloads like Itzik has just basically covered for us. We're actually working in conjunction with PowerProtect with Velero. Velero is obviously a VMware-based technology that provides integration into Kubernetes infrastructure using the kubectl API. PowerProtect allows us to protect everything at the namespace layer and provides functionality that we can protect namespaces. We can actually restore namespaces to the same cluster, to a new namespace, or an alternative cluster. And we can also include or exclude the PVCs, or the persistent volume claims that Itzik covered earlier on today. We provide the ability to take not only advantage of the CSI interface, but also to talk about some of the functionality that we bring to the table when it comes to integrating further with VMware. PowerProtect allows us to not only maintain and give you a choice of how you wish to protect the data when you're running in container-based workloads, but also the agility to be able to provide different interfaces, because that's one of the things that we're seeing in the industry is obviously people want a choice, and we'll cover that in the next couple of slides. Obviously, really around governance and compliancy, when we're talking about workloads, we want to make sure that we can recover these workloads. And what we've done with PowerProtect is predominantly taking advantage of, as I said, the Velero integration, and we'll cover that further, but also leading into Dell Technologies' deduplication data protection strategy as well. So now we can provide best integration and best of breed solutions when it comes to Kubernetes and data protection workloads from a consistent messaging and a consistent tool set. I mentioned a choice. Well, choice ultimately is if, again, do you want to use kubectl? Do you want to use a native GUI-based interface? Or do you want to leverage things like basically the REST API? We're giving you a choice of where you wish to do your level of management as you need. It gives you the ability for orchestration to be able to provide it through the interface. And we can do some nice things around there, looking at basically audit trails and compliancy and meeting business requirements, but also the ability for effectively the Kubernetes administrator to still be able to do backup and recovery, but doing that natively within the kubectl API. We can take advantage of labels, and labels obviously beginning to label their namespaces. Just think about them like you do tags or key value pairs that I can associate with the namespace so that I can do dynamic agile protection of those new namespaces and pods and containers as they come online. Simply by just labeling those using the CLI within PowerProtect, I can simply discover those very quickly and agile, put them into a policy to be able to provide an ongoing protection strategy around that. As I mentioned, with everything that we're doing in the organization, REST is very first and forefront into the technology choice. So we're giving customers a choice of where they want to play into this to provide an enterprise class solution for their data protection needs. If you look at really Kubernetes as a platform, Kubernetes is really orchestration of containers, and Itzik again did a great job of talking about where that sits. But where we feel here is that obviously, protecting just a snapshot or just effectively the PVCs that we talked about is only part of the solution. And with PowerProtect, we're actually able to obviously protect not only the traditional PVCs and obviously that using the CSI framework So again, providing the container storage interface capability to provide a snapshot mechanism, but also to be able to protect things that you wouldn't anticipate part of that. So again, as you rotate through your agile environments, things will change, like, for example, deployments and, for example, secrets, and obviously just replica sets and things will change. And with the beauty of actually integrating both Velero into PowerProtect, we can take advantage of protecting both of those. So we're actually giving you the ability to do a very flexible schema to be able to protect the data, but also to be able to restore it with its current control sets into any environment you need. We actually deploy 2 namespaces within the Kubernetes cluster. This is part of the PowerProtect Data Manager. One of them I already mentioned is the Velero, and the other piece of this is the actually PowerProtect namespace that actually provides a controller for actually orchestration and then data movers. One of the things that I mentioned earlier is obviously we're leveraging Dell Technologies' first and foremost enterprise-class data protection strategy, in the sense that we're actually providing deduplication and compression at a source layer before we move anything into protection storage. And this is all part of this orchestration that we provide with the PowerProtect engine. If I look at the integration point, we actually work with PowerProtect predominantly with any CSI implementation that has been validated. CSI as a standard is still being ratified and is very early in some distributions, but effectively PowerProtect in conjunction with Velero using the CSI framework allows us to be able to protect those orchestrated workloads, again, using that technology. I want to talk a little bit further about where we've gone to the next level with VMware, and this is the reason why you guys are attending today's session, and we really appreciate your participation today. But from an integration standpoint, was specifically around VMware Tanzu, is that we've added some feature functionality which is different to everything else. So again, Isaac mentioned already how effectively we're using the VMware CSI framework for integration with storage. We're still using that, but one of the nice things that actually came into play, and 2 things I want to talk about from this, is that we do have our ability to manage this again from the cloud native control plane inside VMware, but also we give you the ability to use a new feature that was implemented in 6.7 update 3, which is actually called first class disk. First class disk is a functionality to be able to take a snapshot of that disk without being attached to an instance or a running machine. And that was a great feature functionality that was asked for many years. And we're taking advantage of that with effectively what we're doing in conjunction with Tanzu. Secondly to that, we're actually using the same data mover technology within the same namespaces, but this time we're actually using deduplication in conjunction with change block tracking. Change block tracking is a very capability that's been alongside VMware for the longest time. And here at Dell Technologies, we've been using that for efficient data protection backup strategies of virtual machines. But now we're bringing the same capability of that into effectively protecting containers. So now that we're only sending the unique data changes post deduplication and compression to the protection storage. Just to give an example of that, by looking at a couple of screenshots here within PowerProtect, if you look at the left-hand side, you can see that part of the first policy from this particular snapshot, the first data change rate that I sent was 108 megabytes. But subsequently, the second backup as it continued was only sending 76 kilobytes worth of data change. Again, these are the things that's happening with the integration, again, between Velero and obviously PowerProtect and obviously the integration inside VMware where we can take advantage of change block tracking. You can see this is a huge efficient capability that provides that with a full orchestration engine, providing protection of your Kubernetes solution end to end. I wanted to end today just to kind of wrap up really where I talked about from a data protection standpoint. Again, one of the things that we want to leave you with from a messaging standpoint is that with Dell EMC or Dell Technologies PowerProtect solution, we're able to give you an enterprise class solution to provide you a whole private cloud infrastructure, whether that be virtual machines, enterprise applications, and of course, containers that we've discussed today. We're obviously best of breed, obviously better together, working in conjunction with VMware to provide the best solution, taking advantage of feature functionality where we possibly can. And again, as I said, we've all mentioned using it in conjunction with Velero and in conjunction now using CSI integration to be able to provide best of breed solution. Thanks for joining today. We appreciate your participation and I hope you gained something from it today. Thank you, guys.
Thank you.
Hi everyone, my name is Karol Boguniewicz. I'm an expert and engineer from VxRail technical marketing team at Dell Technologies. The topic for this session is vSphere and VxRail REST API. Get started in an easy way. And if you open that, then I assume that you're interested in RESTful APIs. And that's why I wanted to make it more practical for you. Instead of preparing slides, I thought that such a short time allocated, I will show you an extensive demo instead. And I'd like to show you three main things. First, how you can start your API journey by leveraging an interactive web-based API documentation. Second, how you can use these APIs from different frameworks such as scripting with PowerShell in Windows environments and configuration management tools such as Ansible on Linux. And finally, how you can consume these APIs virtually from any application in any programming language. Sounds interesting? Well, let's dive deeper into that. So let me start the demo. So probably the easiest way to start your API journey is to use the interactive web-based documentation for that. We're leveraging here a Swagger framework, which is an open framework for API development, very popular in the industry. And we've designed those APIs in the way that they are complementing vSphere APIs. And you can just go to this URL from the VxRail manager, and you can choose, there are 12 different groups of APIs available in the 7.0 version. I'm not going to talk about all of them, just a few of them. So if you choose the spec for LCM, that will provide you with the functionality for the automated lifecycle management, which is a huge differentiator here with value add. If you go to support, you can change the support features such as support account, or maybe remotely collect the log bundles for the system. And if you go to the system, then you can collect very useful system information, including health, etc. To start interacting with that, you just click one of those API calls, and immediately it expands and provides you with the possible response codes, like 200, 400, etc., and also the example values that these APIs would return. And you can also check the model. This will show you the data model that is used by the API, so you will know what kind of information that you can expect in return. To try it, just click Try It Out button and execute. This one doesn't have any parameters. And you immediately see here that we got code 401. That's an error message that provided vCenter credentials are not valid. And that's actually a good thing because we haven't authenticated against the system yet. So that's a good thing that it prevents you from authorized access to the API. To fix that, I'm going just to authorize using my vCenter credentials. So administrator and password. And you can check the authorization status with the lock icon, which is now closed. When you try that again, we can see there's a corresponding curl command URL. And right now the response code is 200, which is success. You can see the response in a JSON format, very useful information about the system VMs, health of that, how many hosts in the cluster, etc., etc. And a typical scenario, if you'd like to manage the infrastructure remotely, you would need to collect some inventory information. And you can do that with the hosts API available from the host category. You can check the value model. We can try this API. Again, we can see the returned the response, and this provides a lot of useful information on all the hardware components in the system. In a similar way, you can consume vSphere APIs. Also, the same approach, web-based interactive documentation. Just log into vCenter, go to the developer center, and then you can choose the API. In this case, we'll interact with vCenter, so choosing vCenter API. And for instance, to get a list of VMs on the system, I will choose the first one, get REST vCenter VM. I can provide multiple filters to filter the output based on names, folders, data centers, etc. Maybe even a power state of VM. Well, for the simplicity, I will just use the default. Let's execute. And immediately you will see also the corresponding curl command and also the response. This time it also includes the information about the data model use. And let's take a look at this CentOS 7 VM template machine. Because in a typical scenario, you're going to have a golden image from which you will create multiple VMs. It will have a pre-installed operating system with all security settings and software. I've copied the ID of this VM because I'm going to now clone this VM from this template. There is an API call with the action clone. I can populate the parameters using the data type, which is shown on the right. Now, as a source, I will provide this VM ID that I've just copied. Let's immediately turn it on. And I'm not going to modify too much in this clone, so maybe let's, instead of using default name, provide a specific name for this demo. I'm going to change the placement. It will be the same location as the template itself. Very simple, clear example here. I'm going to execute. I can see the curl command. I can see the response. In this case, it's an ID of the newly created VM from its template. I can check that from the VMs and templates view. I can see that this clone indeed was created. It has been powered on and available. So that was a very quick start with the interactive web-based documentation. What if you'd like to start your API journey using the available automation frameworks for scripting, etc.? Well, the API cookbook will be handy for you. You can go to that. It's available on the support site. And let's see some very simple example. Let's check the system status. We did that already from Swagger. We're going to do the same. And you can see that we have multiple examples here in curl, in PowerShell and Ansible. So let's start with PowerShell. PowerShell is now available on most of the modern Windows systems, a very popular scripting framework. But you can also use, of course, the REST-based calls, but it's better to install the necessary modules because it just makes things simpler. In this case, I've already installed the VxRail API, and you can see that it installed multiple namespaces corresponding to those different API groups that I shown you from the web interface. So let's copy this example. Let's copy the DNS name, in this case, of the VxRail manager. Let's provide the authentication information again. And we receive the same output that we see from the web-based interface. To make it more human readable, I can provide the convert to JSON commandlet, and now it's formatted for me. I can check the list of all of the commandlets which are available in this module with the get command and get some help about specific commandlet using get help command. This is really the same experience that you get from Power CLI if you have ever used that. So let's take a look. That you can do similar things with the Power CLI, but we will talk to the software stack that is built into the system. So I imported the Power CLI. Immediately I got some getting started information. I've listed all of the commandlets, and there are currently hundreds of them, almost 900 automation commands. When you combine that with what we provide with VxRail, you in total get more than 950. Very powerful. Now let's check the Ansible example. So I've installed the CentOS system here. I can check the Ansible version installed. I already copied this example and changed the environmental variables, and I can run this playbook. So using this different framework, this now configuration management framework, I get the same result. I can check the system information. Now let's take it further. What if you'd like to consume those vSphere and VxRail APIs virtually from any application, any programming language? Another tool, Postman, will be handy here. VMware provides several examples on how you can consume vSphere automation APIs using Postman through the collections. They are available on codevmware.com. I've already imported them on the system. You can see them here, vSphere automation REST samples. You can browse through them, and for instance, you can check VM create with details, which is an example how to create a new VM with a lot of detailed parameters from REST APIs. In the body tab, you can see the past parameters that you need to provide. So I wanted to show you a quick trick how you can use the same approach, but with VxRail API. When you go back to Swagger, when you use this hyperlink there, when you save this file, it actually saves the API specification, which you can import as a collection to Swagger. So we can use that in the same way. So I'm going to import that with default settings. So yeah, I'm importing that, and immediately I have a folder with a new collection, VxRail RESTful API configuration documentation, and that contains all the same API calls that were shown in the web-based interface. There is one more variable that you need to set up in the environment here. It's base URL. You can copy that variable from the Swagger. And again, we need to authorize against the system first to provide the vCenter server authentication details. I'm providing those here. And now when you send this call to the VxRail manager, we get the same output nicely formatted in JSON format. Now, if you'd like to do that from other programming languages, this is where the code functionality is helpful, because it can generate code snippets for you in different programming languages, including C#, Java, JavaScript, Node.js, PHP, Python, and many, many more. So let's try the Python as an example. I'm going to copy this automatically generated code, paste that into the text editor. I'm going to add one additional parameter, and this is really just to disable the check of these certificates. And immediately I can get the same output from the Python that we could see in the previous examples. This is really powerful. So let's recap. In this session, I walk you through how you can easily start your API journey and how you can use vSphere and VxRail APIs together from the same tools to get more value. We discussed how you can explore and interact with these APIs from the web browser, PowerShell, and other automation frameworks. And finally, I've shown you how you can integrate with these APIs from virtually any application in any programming language using code snippet generator in Postman. I hope you found it interesting. Please give it a like if you like that, and feel free to reach out to me with questions. Thank you for your attention, and have a great virtual VMworld.
Hey, this is Shashi. I am from PowerFlex product management team, and I focus on developing applications and workload solutions with PowerFlex. In today's session, I'm going to talk about enterprise databases on containers, specifically with PowerFlex and VMware. So let's go through some of the specific data points as why enterprise databases on containers. So a recent study by Gartner predicts that by 2022, more than 75% of looking for kind of flexibility, and then also kind of speed, and also some of the key benefits which they can get while deploying containers, respect to cost, and then also with respect to the speed of the deployment. So, and then also for a lot of customers, again, there is always a question, especially for customers who have already invested and then have standardized deploying containers on top of virtual machines. So this question, again, the answer to that is definitely yes. There are a lot of benefits of deploying containers on top of virtual machines. The specific, probably I will highlight one or two big reasons. One is the security, and then also the other specific reason is the isolation. So there are some specific benefits with respect to security and isolation, which you can get by deploying your containers on VM rather than deploying it on direct bare metal. So especially on a software-defined storage like PowerFlex, which I'm going to cover in the next couple of slides, you get the isolation and then also the consolidation benefits of running multiple container stacks within VM on the same PowerFlex infrastructure. So as I mentioned, let's go through some of the key power positions or key values of what is PowerFlex, and then also what are the key differentiations with PowerFlex. So PowerFlex, Dell EMC PowerFlex is a software-defined storage. And again, the three key tenets for this software-defined storage are harnessing the software, embrace the change, and deliver predictability. Harnessing the software is through the performance and scalability benefits, including fluidity. And then also the embracing change is with respect to the different kind of deployment architecture you supported, and then also the kind of different consumption models and then the platform support PowerFlex provides. And then also you can be sure of the workload execution predictability here. And then also it provides you end-to-end automation and orchestration capabilities. So why, again, the PowerFlex software-defined storage, again, if you want to go a little bit detail on this. So this is a software-defined storage known for its performance, scale, and resiliency. I talked about performance, how it can provide you that kind of extreme performance. It is due to the unique architecture PowerFlex provides. So PowerFlex architecture, you have like 3 or 4 nodes who are working, who are actually contributing to the I/O. Again, in the PowerFlex architecture, every node of the cluster is contributing with your I/O operations. Again, every single drive on the node is also contributing to the I/O operations. So this is one of the primary reason why you get this kind of millions of IOPS at sub-millisecond latency for any of these kind of enterprise critical applications. So the aggregated resources with respect to nodes and also the drives which contribute to every I/O operation provides you massive performance and also scalability benefits. When I say scalability, again, PowerFlex can be used with a very small footprint. You can start small and then grow big as needed. Again, you can start with like as few as 4 nodes, and then you can scale up to thousands of nodes without any impact to your performance or any latency implications. So the other key thing which is very critical for database administrators is, especially for database deployments, is the resiliency. And PowerFlex provides that 6 nines of availability. So when in a cluster, if for some reason, if there is a planned or unplanned outage, you don't have to, or an IT administrator or a DBA, you don't have to worry about the storage platform because the PowerFlex will automatically heal on its own, and then it will do the rebalancing with the existing nodes. Similarly, once a node is online, again, it knows the node is online, and then automatically the I/O operations are optimized, and then the storage rebalancing happens automatically in the background. So this is really a key benefit, especially for database administrators who are managing mission critical applications like Oracle, SQL, and then also some NoSQL databases in financial and other industries, because they don't have to worry about the backend storage for the optimized performance. They can focus on their applications, and then also they can make sure that the day-to-day operations are running smoothly. With respect to PowerFlex, again, the other key benefit or the value add is the flexibility with respect to deployment architectures. So in PowerFlex, one of the key differentiation is the disaggregated or the 2-layered architecture. Here, you can have compute and storage resources managed independently, and then also you can scale them based on your need. And also PowerFlex supports if you need a hyper-converged architecture or a hyper-converged model wherein you can have all your compute, storage, and networking resources on the same nodes. And there are also a lot of customers and then use cases where they start with a hyper-converged environment like a 4-node or 6-node configuration, and then you can, based on your need, you can add your compute resources to the same infrastructure. So you have all this kind of flexibility with PowerFlex, which is very critical for, again, databases and database administrators. And then also I want to highlight the other key differentiation with PowerFlex. Whatever is the kind of application, whether it is like a mission critical databases or a throughput intensive analytic application or like a generic mixed workload or a virtualization or a virtual use cases or a cloud native or container based applications, including AI ML use cases. And then whatever be the orchestration, whether it is VMware Hypervisor or OpenShift or even a bare metal configuration, you can deploy your applications without any performance implications. So PowerFlex supports whether it is bare metal, virtual machine through hypervisors like VMware or Hyper-V, and then also containers on top of bare metal if required. So it provides you this kind of complete flexibility wherein you can confidently deploy different kind of application based on the needs. And then also PowerFlex supports some of the key features which is very much required for databases such as native replication and inline compression, and including a lot of quality of services and also secure snapshots and others. So let us go through a little bit more detail about some of the reference architectures and validations which has been done with PowerFlex and VMware, again, especially on containers for enterprise databases. And I'm going to cover both traditional databases such as Oracle and SQL, including some of the work done with respect to NoSQL or modern databases like Cassandra and MongoDB. So as I mentioned, PowerFlex is an ideal platform for databases as well as containers because of the flexibility which I mentioned. It provides a complete flexible platform, and then also PowerFlex has an orchestration tool which is also so this is one of the reference architecture and the validation I wanted to just highlight. Again, this is a SQL 2019 big data cluster, which was, there are specific use cases, and then there are a lot of advantages of using containers with VMware Hypervisor, wherein in this solution we were able to easily kind of a container-based deployment for even like traditional databases like SQL, which is a more effective way of using all the resources. And then also it provides you all the benefits like, okay, the scale out benefits which you can provide. Again, in this kind of big data cluster deployments, there is always a challenge of data being like growing significantly on a daily basis. So this kind of environments will again help in scaling the environment, and then it's very easy to scale the environment in PowerFlex. As I mentioned, the scalability benefits, you can just add a node, and then automatically the PowerFlex will be doing all the rebalancing and whatever is required at the storage layer in the background. So it provides you the same kind of performance and the scalability benefit, and then again the SQL big data cluster. Again, this is a detailed reference architecture. I'll provide you a link for this solution. Just wanted to highlight that the entire big data cluster environment can be deployed as containers on top of VMCR. And similarly, we did a solution with Oracle, which is one more traditional large enterprise database. Oracle, again, it was done on multiple, again, operating systems and then multiple container platforms. And then also Oracle 12c and 19c, both were used as there are still a lot of customers using 12c, even though 19c has been released. Again, there is a lot of use cases, especially for Oracle, where the customers are looking for test dev and DevOps kind of environment. Again, in this solution validates that. Again, this was done with Kubernetes containers running on top of VMware. So the links are the URLs for this detailed solution. Again, whatever I shared there is very brief update on some of the key architecture concepts. But again, these are the links. This is the SQL 2019 Big Data Cluster on PowerFlex with Kubernetes and VMware, and the other one is the Oracle on Kubernetes, Cassandra or MongoDB. These are very predominant with containers. Again, PowerFlex as can provide, not only it can support any kind of deployment of containers like CSA support, and then also the benefits which you can get with applications like Cassandra on top of PowerFlex with Kubernetes. So just to conclude, whatever is the kind of applications like Elasticstack or SaaS, PowerFlex can provide you the most predictable and performance-driven outcome for any of your applications with kind of sub-millisecond latency. For an application like Oracle, you can get like 10 million IOPS with sub-millisecond latency. And then also for modern applications like Cassandra, you get up to like more than 300, 400K operations.
I will talk to you about running virtualized applications inside a modern storage platform using Dell EMC PowerStore apps on. PowerStore first is data centricity, with the ability to run any workload, whether physical or virtual, block-based, file-based, or container-based, and performance reduction. Next is intelligence, with a programmable infrastructure that enables DevOps and automation through integrations such as VRO and Ansible. PowerStore also has built-in AI and ML, which simplifies typical storage administration tasks and needs. Last is adaptability, with a flexible container-based architecture that can be deployed as a traditional external storage array or with VMware's ESX structure, regardless of location, and provides choice, predictability, and investment protection through flexible consumption models and data input. Optimized for next-generation technologies such as NVMe media, is able to provide multi-dimensional scale with the ability to scale up, scale architecture. The PowerStore OS is made up from a group of modular containers, with each container providing a container for data mobility, which handles things such as replication, one for serviceability, and even one other containers. For example, if a specific library needs to be updated due to a security vulnerability, and that library resides, take down the entire stack and failover I/O. Second is the ability to go to market faster with best-of-breed services across Dell technologies. For services that are common across our storage experience across the products, we can have a common engineering team that focuses on delivering best-of-breed shared technologies, which when delivered as a container can be easily consumed as part of this architecture, which is exactly what we're doing, for example, with our serviceability and file services. By building PowerStore from scratch, a new data path created around NVMe, we were also able to build DRR of 3.75 to 1. With PowerStore, our expected DRR is 4 to 1, made possible by having a compression offload and fine granular dedupe that is always on and in memory. And in fact, we are so confident in this that we even guarantee it. Now, PowerStore can be deployed in two primary different deployment models. The first is with a standard traditional deployment model, which is the PowerStore T model, in which PowerStore serves storage to external hosts as a traditional storage array via Fiber Channel and iSCSI. But what's so radically different about this platform is our hypervisor-based deployment, also known as apps on. Now, if you look at the PowerStore appliance and really think about it, the two nodes that run the PowerStore OS and provide the active-active AX model, the ESXi hypervisor is loaded onto each of the two nodes, and the PowerStore operating system. What this allows is local that the majority of companies' validation use cases where PowerStore provides the ability to run applications protected in an active-active HA manner with enterprise data services all in a single 2U appliance. In addition, this deployment model is multi-personality in that apart from allowing applications to run on internal compute, it also simultaneously acts and serves storage to external hosts via Fiber Channel and iSCSI like a traditional SAN, offering the ability to modernize while protecting existing infrastructure investments. Both of these models, the PowerStore T or the PowerStore X with apps on, run on the exact same PowerStore hardware, which is fully redundant dual node appliance with each node having dual socket Intel CPUs that can scale from 16 to 56 CPUs per node and 192 gigs of memory to 1.28 terabytes of memory per node. And again, it's 2 nodes per 2U appliance. In terms of drive support, as the base enclosure of the appliance is all NVMe, supported capacities are 1.92 terabytes all the way up to 15.36 terabyte NVMe drives. And for customers looking for the highest levels of performance, expansion shelves. Now let's look at some deployment scenarios where PowerStore can be used. Locations don't typically have primary data centers, so space really comes at a premium. PowerStore with apps on is ideal for these edge site requirements, allowing streaming data. As mentioned before, PowerStore models support the same core features. PowerStore is built in, and since both models are fully interoperable, the PowerStore X model with apps on can replicate to a larger PowerStore T model residing in the primary data. Also automatically inherit some core native services that come as a part of it, such as vMotion, solutions such as VxRail as a complementary extension. And remember, the apps on model of PowerStore also acts as a traditional SAN in that it also provides storage, all the innovation, all the IP that went into the apps on architecture. So PCIe domain, which pass-throughs the ESX hypervisor, enabling bare metal MVM, as well as supporting PCI fault containment. The second benefit, or the second innovation that went into this architecture is that we solved around a noisy neighbor problem. The PowerStore OS resources, which are used for serving storage, are completely separated from user space resources, which are used to create and run virtual machines, guaranteeing consistent and predictable storage performance at all times so that no resources are trespassed to the other side. And apart from allowing VMs to run on the internal nodes, it also simultaneously acts as a traditional SAN array, serving block workloads to external servers via fiber channel and ISOs. These external servers are external ESX servers. Again, you benefit from inheriting native ESXi data services, such as vMotion, allowing to move workloads around from external ESX servers to the internal ESX servers that make up the PowerStore X model as needed. And next, which we'll talk a little bit more on in the next slide, is a really tight vVol integration that we have spent a lot of time on. So let's spend some time to talk about PowerStore's efficient vVol implementation, which includes some very cool integrations that we have done to give customers the best possible experience with vVols. The first is a turnkey vVol setup. There's nothing to configure. You simply register your vCenter server and PowerStore will take care of the rest, allowing you to use vVols instantly. VASA provider registration, protocol endpoint creation, storage container creation, and even the vVol data store. Next is end-to-end VM visibility, which provides the ability to track capacity utilization, VM compute performance, storage performance, alerting, protection, and display individual vVols that make up a VM. From the PowerStore manager, a user can view all these VMs running and utilizing vVol storage from the PowerStore array. Next is integrations with VMware's SPVM. We currently expose quality of service through SPVM. Last is integration with managed snapshots. Snapshots can be taken on demand or via a protection policy assigned to a VM from the PowerStore manager, which are then displayed in vCenter. Meaning, if a snapshot is taken, a VMware administrator has access to them as needed. But it's also vice versa. A snapshot taken from But our VMware integration doesn't stop, along with PowerStore being supported as an external storage array to workload domains under VMware's VCF. Last, I want to display a use case highlighting the power of apps on in a customer scenario. So an example of PowerStore with apps on in action is in the healthcare space. Medical informatics offers a suite of applications called SickBay that unlock over 300 data points created by nurses stations where multi-patient monitoring can happen from a centralized location. This requires a solution that can provide ultra-low latency, high storage to store years' worth of patient data, and is easy to use, and provides high availability in the smallest possible footprint because these locations, again, don't have typical primary data centers. Leveraging PowerStore with apps on, the sickbay application suite can run directly on PowerStore, taking advantage of both local compute and enterprise storage in a single consolidated system. Typically, patient data disappears within 48 to 72 hours, but now leveraging sickbay and PowerStore, data can be kept for much longer so that a trend can be created for each patient to provide new insights. Streaming data can be collected at the edge from bedside devices and placed in front of a physician in real time while ensuring performance and availability in a small footprint. This is the power of Axon. Thank you very much, and I hope you enjoyed this session.
Hello, my name is Emma Kazmarek. I'm from the Data Protection Division of Dell Technologies. And today I'm going to talk to you guys about how we're providing data protection from the edge, the core, the multi-cloud. So as you look out today at organizations, what we're seeing happening is that they're looking at their data, they're looking at their software, and they realize that within their application as a whole, there's a competitive advantage that they're going to be able to take advantage of. Now, in order to harness this advantage, they're embarking upon this digital transformation, and more importantly, these application transformations are ongoing. And they can't just throw their data out into the public cloud or introduce Kubernetes into their environments and expect that they're going to be able to actually take advantage of this competitive advantage. They're having to take a step back and really do an application rationalization and determine what makes sense to really get the most out of that application transformation. And so as a result of this, what they're doing is they're looking at their applications from a top-down approach, and they're determining, does it make sense to rehost that application? You know, what we used to refer to as lifting and shifting, picking it up from its existing deployment and deploying it in a private or public cloud experience. Does it make more sense to re-platform or containerize that application? Or do we need to just completely rewrite it and refactor it? Move it from being, say, traditional Oracle deployment into, say, a MongoDB instance, where you know what, I don't even want to deal with this application anymore. I'm just going to pay somebody else to manage it. I want to move it and repurchase it and go SaaS. Great example of this, getting off of Exchange and moving on to 365 with Microsoft. Now, there are also applications out there that it just doesn't make sense to rehost, replatform, rewrite, or even repurchase. The juice just isn't worth the squeeze. At the end of the day, it's going to be cost prohibitive to even do one of those. And in those instances, we're just going to retain them and keep it business as usual there. Now, across all of this, though, if we've rehosted, replatforming, rewritten, or repurchased, what happens to those legacy applications? We have to think about how we're going to retire them. And we may have compliance that requires us to keep them around for 3 years, 4 years, 10 years. And it doesn't make sense to have them living on expensive all-flash storage once we've retired them and moved on to rehosting, replatforming, rewriting, or repurchasing. And so it becomes critical here that we take into consideration data lifecycle management and have the ability to tear it down to the most cost-appropriate storage so we can actually get the biggest TCO and cost reductions out of this. So while this is occurring now from a top-down approach, what we have to take into consideration is a bottom-up and how we support this from an infrastructure perspective. And so when we look at this from an infrastructure lens, on the left side there we have our traditional applications, our physical Windows and Linux, our non-x86 platforms, AIX, Solaris. And then we have everything that we've gone through the process of moving from physical to virtual, from being to being in that virtual environment. And on the left, really, this is a construct methodology. In order to support these applications as they're being onboarded, we're constructing the underlying infrastructure to support them. Now, as we move into the world of infrastructure as a service, containers as a service, or platform as a service, whether this is on-prem in our private cloud or up in the public cloud, more and more, this is in a multi-cloud world. And so in order to support this, this is really a consume methodology here. Now, I like to think of IaaS, PaaS, and PaaS really as terms of a metaphor for a house. in an infrastructure as a service environment, I show up, my foundation's already been poured for me, I have all my lumber, my drywall, my bricks, my shingles, and I go and build that house. In platform as a service, that house is already built, and I just move right into it. Containers as a service, I have a shell of a house, and every day I'm picking out what the floor plan is going to be, what the colors of the walls are, what the cabinets are going to be, and it's tear up, tear down. And that's how containers had been when they were just stateless. But now what we have happening is organizations are starting to containerize applications, and they're moving from being stateless to becoming stateful. So in that same instance here, I'm picking out the floor plan, colors of the walls, the cabinets, but I now also have a file cabinet in that house. And every day more and more is growing to that file cabinet. And I need to have the capability of reverting back to 3 days ago, 5 days ago, 2 weeks ago. And I just don't need the status of that file cabinet, but I also need the status of that house. I need both the application consistent and the crash consistent. And the challenge is the way that I protect those environments is different than how I go about protecting my infrastructure as a service or platform as a service. And so it makes things very interesting as organizations are going through this transformation on how they're approaching these things. And so when we look at this here, what's important to understand is, where things fall. And in conversations that I'm having with my customers, what I see is that on average today, about 30% of customers' environments fall into that traditional bucket. About 60% fall into that virtual bucket of applications that have gone through the process of being moved from physical to virtual. And then 10% is a scatter shot across the board of IaaS, CaaS, PaaS, and SaaS. Really varies from organization to organization where they are on their digital transformation journey. While this is all well and good to look at where organizations are today, we also have to take into consideration where they're going to be in the world of tomorrow. So looking out to the year 2023, what we see is an interesting shift in these workloads. What we find is the traditional applications are only going from 30% down to 20%. And at first, it kind of makes you scratch your head, but when you double click on it, it actually makes a lot of sense. And the reason for this can really be compared back to the whole mainframe conundrum from the early 2000s. Mainframe was supposed to die in the early 2000s, yet here we are 2 decades later, and the majority of Fortune 100 customers are still running mainframe in their environments. The same is true for these traditional applications. These are the cornerstone applications that have been ingrained in environments for years, non-x86 platforms, things that are very difficult to try and rehost, replatform, rewrite, or even repurchase. They've been so customized, and they continue to do very important aspects on the environment, and trying to get off them is near impossible. But where we really see this shift into the consume methodology is on the virtual workloads, going from 60% down to 10%. And really, this is being driven by 2 key things. The first is automation and the ability to take these workloads and automate them into those consumed environments. And the second is really being driven by VMware as a whole here, with their ability now to deploy Kubernetes services within their private cloud environments, is really allowing organizations to streamline their adoption and drive their digital transformation forward. Now, when we look at this from a data protection lens, it's important to understand how all these different components need to be protected. From that traditional side of the house, we know how to protect those environments, right? For your physical servers, you're going to put an agent or a client out on them. You'll have your backup server, your media server, and you're going to write it to a target. When it comes to those virtual workloads, we should be using V8EP, the VMware API for data protection. We should be doing image level backups. We don't want to be having a bunch of guest clients out there that we want to be managing across the board for hundreds and thousands of VMs. Maybe we're also going to be leveraging some proxies to accelerate that data transfer. But again, it's landing on a target. Now, as we move into the world of consume, whether I'm deploying a virtual machine, an application, or a container, I need some sort of portal for my end users to interface with to drive this model out there. And 9 times out of 10, what I end up seeing is that portal ends up being ServiceNow. But ServiceNow on its own is really just a ticketing system. I still need some automation tools underneath there to drive the deployment of these production VMs, applications, or containers. And so the market leading vendor out there from an IT automation tool set is VMware. So having native plugins into the VMware automation tool suite becomes critical. But it's also important to understand that as part of organizations' digital transformation, they may be leveraging additional automation tools. They may be using things like Ansible, Puppet, Salt, Terraform, Otter, or whatever the next one is that hits the market. So it becomes critical that not only do you have native plugins into the market-leading automation tool set, but that you also have open REST API capabilities so that you can integrate in those automation tools into your data protection solution as you go through your transformation, so that you can integrate into the Ansibles, the Puppets, the Chefs, what have you, and have that flexibility and choice. Because the last thing that you want to do is stand up your entire automation deployment for your production environment, but then still have to manually touch it from a data protection side. It's counterintuitive. As your production workflows are being deployed, the protection capabilities should flow with them as well. Now, once I get to this point and I've stood up this framework, I've got to answer 5 key questions. And based on the answers to these 5 key questions is going to determine where this data is going to live. And that comes down to cost, availability, performance, location, and compliance. Based on the answers to those 5 things, the data is either going to go one of 2 places. It's either going on-prem or it's going off-prem. It's going off-prem, it's going into AWS, it's going into Azure, it's going into GCP, or it's going into VMware Cloud on AWS. If it's going on-prem, it's being deployed as a converged or a hyper-converged instance, or as a software-defined solution on the hardware of your choice in your private cloud environment. Now, we still can't forget, though, about those applications that we've decided to outsource and repurchase. You know, we may have more compliance requirements for those resources than what those vendors are providing. Some of those vendors may not be providing any protection capabilities at all. So we have to make sure as we go down the path of repurchasing applications and moving those into SaaS models that we have the ability to protect them that meets the internal compliance requirements of our organization as a whole. Now, when we get to this point, we see a need still for 3 key things. The first is integration with object storage. Going back to the beginning here in that application transformation that's occurring, for those applications that we've retired, the ability to integrate in with object storage becomes critical, and having the ability to tier that down to the object storage of choice based upon policies of age becomes critical, so that we no longer have to maintain them living on expensive all-flash storage. But in addition to this, being able to leverage our market-leading IP and data reduction ratios to shrink that actual physical space that it's consuming upon allows us to bring forward the most efficient TCO out there and cost reduction ROI for our customers. And it's not just about integrating into one object storage platform. While we prefer it to be ECS, we understand that as part of your transformation journey, you need to have choice and flexibility. So being able to integrate into the object storage platform of your choice, whether that's S3 infrequent access, Azure cold blob storage, or even Alibaba Cloud, allowing for that flexibility of that journey. We also see a need for object store integration as we start protecting workloads in the public cloud. The last thing that we want is for the most expensive thing in the public cloud to be your protection solution. That's why our technology, when we protect workloads in the public cloud, leverages that cloud native object storage as its consumption of what it's running on and writing towards, enabling our customers to continue to drive down costs and have that cost reduction, allowing them to be investing in things that are actually important to them in the public cloud, things like microservices, things like database as a service, those really things that are driving that transformation forward so that we can keep them protected, but drive down costs as a whole. The other key area that we see a need for is the ability to provide an air-gap copy of the data for those mission-critical crown jewel applications. And where those crown jewel applications are going to shift depending on where organizations are throughout this journey. So the ability to vault down those applications, whether they are deployed as traditional, and whether they are deployed in your private cloud, or vault them down from the public cloud, becomes paramount, so that you're not in a position where you have to end up spending or paying Bitcoins to the bad guys to get your data back. And on top of this, it's about not just allowing for that, the ability to protect those critical applications, but also those critical rebuild materials. So, because if you're in a DR scenario, you're assuming that you've got access to the DR site, that you've got asynchronous replication, that you can come back up. In a cyber event, you need to be assuming that you are coming back from nothing. You're having to recover from bare metal. And so you need to make sure that you have those critical rebuild materials, things like Active Directory, things like domain controllers, things like networking templates, so that you can actually bring back those crown jewel applications holistically in your environment. And the final key piece here that we see a need for is the ability to provide one common management plane. Whether you're protecting traditional or virtual resources in your construct environment or protecting workloads up in the public cloud, having one common management plane that gives you visibility across the board so that you are able to have reporting and management through that common pane of glass. Because while we may have automated the ability to protect workloads in your consume environment, we still need to make sure that we're taking into consideration how we are protecting those 30% of workloads down the road that it will continue to be in that construct environment. And having that one common management plane that's built on HTML5 is something that we're providing for customers today. So when you look at our portfolio, this is really what we're focusing in on for our customers and what we're delivering on for them across the board. And this is really kind of specifically due to our focus and our strategy as a whole. And when you look at this, we're focusing in on the mega trends of the industry, providing value to the data that we're protecting applications as they're going through this transformation. And as data now has been distributed to the edge more than it ever has in the past due to things of work from home in the current times we're living in, it becomes critical for us to be able to provide our abilities of leveraging AI and machine learning to look in at the entropy of the files themselves, to identify if the change rate has gone from an average of 3% over the past 18 months up to 98%, to make sure that the file type still matches the extension, and to identify attack vectors that we see that are common in environments to address them. And we're doing this by continuing to provide that proven technology and leadership that we have in the industry around simplicity and automation, efficiency from a protection standpoint, and driving efficiencies in customers' environments, being able to provide protection at scale, and being able to provide that protection performance as customers continue to drive, while also focusing in on delivering modern innovation, being able to provide that native cloud protection, autonomous protection for applications as they move from the edge to the core to the cloud, and also being able to introduce new services and recovery options for our customers as they move forward. That's what we're doing here at Dell Technologies, and that's how we're providing protection for our customers from the edge to the core to the cloud. Thank you, and have a great day.
Hello, everybody. My name is David Klebanov. I am with a company called Alkira. And today we're going to talk about a pretty exciting topic. We're going to talk about networking. Like, when was the last time that networking was exciting, right? So, but today we're going to make it exciting. And what we're going to do, we're going to talk about networking, not just networking in general, but we're going to focus on networking in the context of a cloud. Like, what does happen to networking when the cloud era hits? And specifically, our agenda is going to be around three individual topics. We're going to recap the different options that exist today for cloud networking. We're going to talk about what are the challenges around cloud networking today, how are these challenges being mitigated. So spend some time talking about that, but then really talk about the Alkira solution and see what we bring to the market with what we call an Alkira Cloud Services Exchange, which is really focused on solving this networking and other issues for the cloud era. And at the end, I'm going to give you a bit of a glimpse on a couple of deployment use cases or main deployment use cases that that this technology can be applied to. So let's play out an interesting scenario in here. So think about this three personas that you see on the bottom of the screen. And in fact, these are the two categories of personas. The first category of the persona is the networking and security person, right? This is the traditional infrastructure, IT personnel dealing with all the networking and security aspects of the infrastructure. And then next to it, you have the cloud architects, the cloud administrators, and the application developers. So these are the folks who are dealing with directly with the cloud aspects of it, from the compute standpoint, from the storage standpoint, from the application standpoint. And now look at the collection of these clouds. Right now, some of these clouds are familiar to us as an infrastructure as a service clouds, which are the three main ones for AWS, Microsoft Azure, and Google Cloud Platform, the GCP. Right, but we also have the SaaS offerings, and there's quite a few applications that really kind of a part of that software as a service offering. But some of the most prominent ones are Office 365, Salesforce, Box, Dropbox, all kind of software as a service applications. And then, of course, we have the internet applications, which are more of a generic in nature. So when we see, from the persona standpoint, when we see the cloud folks, how do they perceive these clouds? They're really enjoying the day, right? These clouds were built for compute, storage, application, microservices in mind, and really cater to the needs of the cloud folks. And if you think about some of the key attributes that are really playing very well in that space, are the time to service, the agility around time to service, the ability to do on-demand capability delivery, right? The as-a-service consumption, which is extremely important element that we're going to come back and circle to a couple of times, and then the ability to do scale up and scale down for the infrastructure. Now, these are all great. At the same time, when you look at what happens to the network and security aspects when it pertains to the cloud, you can see the plethora of challenges that network and security architects and engineers are facing around scalability and the expertise that are required, and security and visibility and over provisioning. So quite a few challenges that these folks are facing. So how is the industry coping with this? What are the several sort of solutions that exist on the market today that allow the networking folks and the security folks to try and address the networking needs for the cloud? So the first one that we're seeing quite a lot is the use of the co-locations, right? It's a very proven, very solid model. However, it comes with certain drawbacks. Many times co-location deployments carry a high provisioning cost, right? A complexity of provisioning, because many times they are anchored on a physically deployed gear, physically deployed equipment, right? Routing between different regions of the same cloud or across multiple clouds becomes very cumbersome because the traffic needs to be extracted from the cloud to swing through the co-locations, especially if network services such as firewalls are deployed in those locations. So the suboptimality of routing is something that strikes the tone with the co-locations. The second approach that we're seeing is a cloud-native approach, where organizations are leveraging the cloud-native capabilities of the three major clouds, the AWS, Azure, and GCP, in order to deliver these networking capabilities. So some of the drawbacks we're seeing is that it's really dependent on the cloud provider. Every cloud provider addresses this differently. So every solution that is built on top of these clouds in a cloud-native fashion is very specifically tailored for that cloud. Lack of expertise from the networking and security folks becomes very, very challenging because, again, the clouds have been built with compute, storage, application in mind, not quite with networking and enterprise-grade networking in mind. And when you figure this all out and you somehow deploy this, you are hitting quite a lot of restrictive cloud limits, especially for networking and security, because these clouds were really not, like I said, were not envisioned to be built with networking, security, visibility, and other elements inside. Now, the third one that we're seeing is the do-it-yourself approach to cloud networking. This is where the organizations are leveraging either automation, orchestration, or provisioning tools in order to automate some of those tasks that would otherwise be done in sort of mundane manual fashion. Doing this, using this automation, orchestration, provisioning tools, still in a do-it-yourself fashion, but a little bit more sort of elegant. Now, those are obviously provide an evolution over the previous methods, but yet they also carry a certain degree of suboptimality regarding learning curve around those tools, the disruptive nature of deploying those solutions because of the need to download software into your existing cloud environments, and to some degree, a large failure domains that are created by the fact that these do-it-yourself networks really span multiple clouds without any means to constrain problems, routing related problems that could arise from human errors, misconfigurations, or things like that. So when we think why these problems exist, the thing that really strikes the tone is that the cloud and the network really operate based on different characteristics. When you look at the clouds, you really see the clouds operating on the level of principles, on the intent-based approach, while the network is operating on the level of primitives, which is really understanding these nitty-gritty details and all of these nut and bolts that need to be sort of operated in order to build the network solution for the cloud. Now, where we really want to transition is we really want to bring the network philosophy and the way of thinking closer to the way the clouds operate. And by doing that, we really empower the network to behave like the cloud and have those cloud-like attributes. And that is going to create this cohesiveness between the cloud and the network, and is going to allow the network to really deliver on the cloud promise. Now, let's look really quick on the Alkira offering in this space and how we are mitigating some of the shortcomings that we talked about prior to that. So the service that we are offering is called an Alkira Cloud Services Exchange. It's a solution. It's anchored on what we call an Alkira Unified Network Platform, which is a foundation for an entire solution. It comprises of a collection of what we call an Alkira Cloud Exchange points, which are, think about those as a virtualized cloud, multi-cloud points of presence. These are not hardware-based. These are not VNFs. This is a completely autonomous software stack that is deployed on top of the hyperscale infrastructure and really allows the organizations to bring the resources, be those single cloud resources, multi-cloud resources, on-premise resources, users, SD-WAN fabrics, whatever lives on-prem, into this unified network platform through the connectivity through this Alkira Cloud Exchange points. Now, if we think about some of the key attributes that come with that type of approach, is an ability to completely design your network using a digital design canvas. Basically, draw your network on the design canvas to express your intent, and then click a button to implement or provision that intent onto the actual virtual infrastructure. The ability to insert network services such as firewalls, load balancers, DNS, DHCP, IP address management systems, and others into this network, leveraging this digital design canvas, and then using the intent-based policies in order to steer the traffic. Now, the elements around segmentation, encryption, which are the security aspects, the day two operations around visibility and governance for this network. And again, at the end is the chargeback billing elements of the solution in order to really kind of have a deep understanding of what are the resources that are being consumed and pay only for the resources that are being consumed as part of the solution. Now, the three really key things that I wanted to kind of leave you with in this slide is a delivery of this entire solution as a service, which is a very sort of significant contrast to the do-it-yourself approach that we talked about previously. The ability to provision everything in a single click using the digital design canvas and the integrated network services marketplace, and the ability for this entire intent to be provisioned on top of the infrastructure and really be ready for use in minutes. So these are the three things I really wanted you to live with this, from the understanding of the solution. Now, let's quickly look at three popular use cases that we're seeing being deployed out there. The first one is pure networking use case, right? And you can think about this as an end-to-end cloud or multi-cloud networking use case where you have multitude of cloud workloads from various clouds that are being connected into this cohesive network infrastructure, right? So we're talking about multi-region or multi-cloud in some cases, multi-account in cases where you have different departments that are leveraging different sort of credentials to access their workloads. So all of that is being cohesively brought into the Cloud Services Exchange solution. The ability to provide an end-to-end segmentation across these multiple workloads and micro-segmentation to sub-segment certain workloads within a segment, right? the ability to do a global route propagation within this segment, so keeping the segmentation end-to-end, yet providing the global route distribution and route propagation across the regions, across the clouds, be that within a single cloud exchange point, or be that across multiple cloud exchange point, really on a global scale. Now, the sizing of those cloud resources and the ability of the network to really accommodate the sizing of these workloads as required. So when sort of a compute administrator deploys a workload that requires large or extra large capacity, the network can play along with it and provide the connectivity that accommodates those needs from the compute standpoint. And as I mentioned earlier, the ability to really just pay for the services that are being consumed in form of billing, or perform a chargeback to the organizational units that are consuming those resources, so IT does not really become a single bearer of the financial responsibility for the deployed solution. The second use case that we're seeing a lot is the use case around stateful security. So as these applications move into the clouds, we're really seeing the need for the security to be extended into the clouds and really maintain the same security posture that existed for these applications where they were on-prem, and maintain this posture when now these applications reside in the cloud. Now, I'm giving here an example of the Palo Alto Networks firewall, right, and how firewalls being deployed within the Alkira Cloud Services Exchange with auto scalability to accommodate an increased and shrinking demand for capacity, and the ability to do firewall zoning in order to segregate different resources, be those in on-prem resources, sites, users, SD-WAN fabrics or whatnot, cloud resources, AWS, Azure, GCP, but also in external resources such as extranet connectivity through mergers and acquisitions, partners, or just a plain internet-based resources. And all of these are just mapping into this zone-based approach inside these firewalls that are deployed within the Cloud Services Exchange. So really the ability to bring that stateful security from not just an on-prem data center applications, but all the way into the cloud applications. And lastly is the use case around operational visibility for network and security. Now, obviously, when you deploy networks, you have to make sure that operational elements, visibility elements are accommodated. And here, there's a really multitude of different visibility, troubleshooting, health, visibility elements around networking, security, and the entire operations of the environment. Now, I know this was quick, just to give you guys a bit of a sample of what we do and how we solve these cloud networking challenges. If you want to learn more, we invite you to go to www.alkira.com, watch videos, read briefs, schedule demos, and take the next step in that networking journey for the cloud. With that, I wanted to thank you and wish everybody a pleasant day.
Hello and welcome to VMware SD-WAN by VeloCloud session. 5 ways VMware SD-WAN enables network transformation. I am Rohan Nagi, Senior Technical Product Manager at VMware. I also run SD-WAN 360 podcast. You can do a Google search for SD-WAN 360. It's one of its kind podcasts. I also co-authored a couple of books on SD-WAN. You can check on Amazon for those SD-WAN books. So let's go through our agenda for this session. 5 essential capabilities that SD-WAN delivers in here, which can transform your network using the VMware SD-WAN. So we'll look at how SD-WAN simplifies the deployment. But before that, we will kind of go over the problem statement, what the problem statement is with the legacy architecture. Then we'll kind of touch base on the SD-WAN 101, where you understand the components, how the VMware SD-WAN solution really works, how the architecture is. And that's where we'll go over those 5 essential capabilities like deployments, simplification, application performance, security, what are the flexibility in the security. So with that, let's get started. I call this as IT 1.0, and that's where the legacy architecture comes to play. The traffic pattern, if you see, is very predictable. User from the branch side will try to access a resource which is sitting in the data center. So request, response, and typically it happens over the private circuits, which is an expensive circuit which takes time to get it installed and configured. And then moving on, we started getting more and more public internet connection, but those were used kind of as a backup. So there is an active backup scenario. Not all the circuits were leveraged at the same time. So there was some inefficiency. At the same time, configuring them, pushing out the policy, different network functions at the branch site, all those created that complexity, and that's where I'll consolidate in the next screen for that problem statement. So like I mentioned, all the user traffic, getting backhaul to the data center where the resources are, but over the years, or even during this pandemic situation where users are working from home, we see that user locations are changing. At the same time, apps or your applications have started moving to the cloud. So your applications are now everywhere. There are on-premise applications, there are cloud-based applications. So enterprise networks are really not ready to work from anywhere. Like I mentioned, apps are moving, even the data centers are moving to the private cloud, the public cloud. WAN is really getting complex out there. You can see actually 50 to 80% of the traffic is backhauled to the data center. And at the same time, complexity has started increasing on the branch sites where, you have hybrid connections, you have public internet, you have private internet. So these are some of the problems. But what are the real user concerns for user? Poor voice quality when they are using a business collaboration application like Zoom. At the same time, inconsistent experience when the user changes their location, let's say from branch office to working from home. What are the IT concerns? IT concern is to provide security when the users are moving, when they are using, let's say, different laptop. At home, I'm using my home laptop. How do I access these company applications securely, or applications which are in the cloud? And these leads to other problems, which I have kind of listed out here, scaling problem. At the same time, if you see the biggest kind of a drawback with the legacy architecture is the hub and spoke model. Every traffic from these spokes, from these branch sites, has to go to the data center where the hub is installed, which increases the latency. So with the current environment, if we have to move away from this legacy architecture, what we want is the networking and even the security actually must come together to serve the user either at the branch or at working from home or from any location. And that's where SD-WAN comes to play. And I'll come to this VMware SD-WAN architecture, but let's do that SD-WAN 101. What are the basic capabilities for any SD-WAN solution? So the key 4 things are transport independence. What it means is, if you remember the problem statement, even when you have multiple circuits, we are using them in a primary backup mode, primary standby mode. But with SD-WAN, you'll be able to leverage all the circuits at the same time. And with VMware SD-WAN, all the circuits by default are in active fashion. So you are leveraging all the circuits, and that brings transport independence. Any kind of circuits you can bring in to VMware SD-WAN. The second key piece here is, now that I can use the public internet, what about the security? How do I access workloads in data center or in public cloud? So I need some kind of a secure overlay, and that's where VMware SD-WAN will build up secure overlay tunnel between branch to hub, branch to data center, where the hub is branch to branch, dynamic branch to branch, or even when the traffic is going to the cloud. And you might be wondering, traffic going to cloud in a secure fashion. And that's where VMware SD-WAN comes to play and it shines, because one of the VMware SD-WAN component, the gateway, it's in the cloud, hosted and managed by VMware. As a customer, you don't have to take care of that gateway. It has a global footprint. And we'll talk about that in the next slide when I kind of share the components of the VMware SD-WAN. And that secure overlay over public internet or private internet brings in the cloud VPN, where the VMware SD-WAN supports multiple topologies, like I mentioned about the hub and spoke, branch to branch. And at the same time, application firewall, there is an integrated firewall built into these edges, which you deploy at the branch site or at the office, your home location. Now that we can leverage any circuit, security is in there. Who will take care of the link steering if there is any blackout or brownout condition? And that's where the third components come to play is the path selection or the application performance. That's the key. And that's the number one driving force for adopting SD-WAN solution, dynamic path selection. And with VMware SD-WAN, we take a further step away with our secret sauce, which is DMPO, dynamic multipath optimization. It will leverage all the circuits. It will break your single session, traffic session into per packets, into small packets, and it will send across multiple links. So your user traffic will go on all the available circuit, and on the other end, where the VMware SD-WAN gateway or the hub or any VMware SD-WAN data plane device is, we are going to reorder the packet. That's the key here. So per packet, sub-second, that's where this dynamic path selection comes to play. We continuously monitor all the circuits, and if there is any link impairments like latency, jitter, packet loss, we will adapt to it in sub-second fashion. First of all, I think the very key important thing here is you need to make sure that you detect it sooner, and that's where that sub-second comes to play. And we'll talk about this later in the slide. And the fourth key pillar is simple interface, simplicity, which is built into the VMware SD-WAN product. And this is where three key component comes to play: the management plane, the orchestrator. From a single place, you can manage and monitor your circuit. Edges, the CPU device, which could be hardware, virtual, which goes onto your branch, which goes onto your data center as a hub device. And then the third key piece, very important, is the cloud delivered, the cloud-ready gateways, which has a global footprint. So if I have to access any SaaS application, your traffic from the branch will redirect it to these gateways, and then we are milliseconds away to the SaaS cloud or to the internet using these gateways. So we have 1,000+ gateways across the globe. That's where, and why choose VMware SD-WAN? I think we talked about it. Cloud adoption, that's where the gateway comes to play. Assured application performance, DMPO, we talked about it. Simplification, simple, like zero-touch provisioning to kind of instantiate when I drop ship the edge device to your location. With simple clicks, you can zero-touch provisioning, you can kind of activate your edge device and you are ready to go. And then flexibility in the security solution. And that's where VMware SD-WAN comes to play. And now talking about those transformation, I think deployment simplification, that's the key we will talk about first. And this is where I want to show that zero-touch provisioning when the edge device is drop shipped to your home or branch office. And this is where I'm going to kind of share a video and talk through it, what it is about. So as an enterprise admin, you will create a site from the orchestrator. And once the site is created, let's say the device is drop shipped to a remote location where a non-IT person will kind of unpack the device, power on the device, connect the internet cable to any of the WAN ports. You don't have to worry, or you don't have to call the IT support to which port should I be connecting to. So just connect the power cable, connect the internet cables, and then you will receive an activation link from the enterprise admin in your email. So just use your laptop, mobile device, or an iPad and connect to that email, access that email from that device, and click on the activation link. Once you click on the activation link, then the magic happens. The edge device will talk to the orchestrator, exchange security tokens, and that's it. It will get activated. Once it is activated, you don't need that non-IT person, or you don't have to call a remote admin sitting at that branch location to do any modifications or any configuration. You can do everything from that centralized orchestrator management plane, which is also sitting in the cloud, managed and hosted by VMware. It's again a multi-tenant in nature, the gateways and the orchestrator. So you can see the activation process here. Once it's activated, enterprise admin from the orchestrator can view that edge device, and they can kind of use that device to do the further configurations and monitoring piece of it. So let's move away from that video, and now let's talk about that DMPO piece of it. DMPO piece of it. This is where DMPO comes to play. Continuous 24/7 link monitoring we do, so we know at any given time how the links are performing. So we can do link steering in sub-second fashion. Even when we have a single link, we can do on-demand remediation and aggregation. First, we detect the application, because all of our edge devices runs a deep application recognition engine, what we call it as DPI. So today we can recognize 3,000 plus different application. We already built up a secure overlay from the edge device to the hub device or to cloud where the gateways are, or from branch to branch. So all your application traffic which is going inside this SD-WAN overlay tunnel is continuously monitored, and we know at any given point how the links are working. Just to give you kind of a quality score, like a before and after. Before is where, let's say, your traffic has started flowing through this one of the ISP link out here. When you see these red and yellow marks, this is where the WAN impairments are happening. We will try to either remediate these situations, or we'll try to do the link steering if the other link has a better SLA for it. End-to-end, what you need to remember with the application performance is this key thing: continuously monitor, dynamic per packet steering, and on-demand remediation when you have a single link. With on-demand remediation, we do the jitter correction, error correction, automatic steering when there is a blackout and brownout condition. On a single link, we do the on-demand remediation for a brownout condition. And this is just a use case for a business collaboration application. Let's talk about the architecture for the cloud. Like I mentioned, one of the key components, the gateway, is in the cloud. Globally across the cloud. Today we have 1,000 plus gateway around the globe, which has a footprint globally, and these are kind of sitting in the same co-facility where the SaaS providers are. That's the key to it. So we are kind of milliseconds away to the SaaS cloud. And you can see here now from the branch, I can directly, the traditional approach was to backhaul to the data center and then go to the SaaS cloud. But now with this gateways, you can just redirect the traffic to the gateway and then it goes to the SaaS cloud. That's where VMware SD-WAN gateway comes to play. Flexible architecture, you can place there is no rip and replace kind of a thing for VMware SD-WAN CPE devices. They come in different form factors. VNF, you can have pre-installed on hypervisors. We also can instantiate these edge devices over the cloud. So any kind of topology is supported. There is no rip and replace kind of here. You can augment with your current topology. Even if you have a third-party kind of a router, you can place your edge device here and you can run a VRRP, or you could run it in a fashion where you have internet connections and the MPLS is going through the CE router for the service provider, and it has a pairing with the PE router for the service provider. At the same time, you can get rid of the CE router and you can use our edge device where it is terminating all the public and the private connections. And you can also connect to a non-SD-WAN site using this overall topology. At the data center, you can stack up multiple edge devices to form a cluster. And that's where that flexibility comes to play. When we talk about security, that's very important. We give multiple options. Like I mentioned, we have a built-in firewall, which takes care of your traffic inspection. At the same time, you can still use that backhaul to the data center where you are running a next generation firewall, let's say. So you can still use that legacy approach. There are still some enterprises which leverage that because of some compliance reason. You could also instantiate a third-party firewall on selected SD-WAN edge devices, and even those are supported. The fourth is the secure web gateway, where what you are doing is you are kind of, like I mentioned in the problem statement with the legacy architecture, the branch is running multiple network functions. So it's heavy. It's a thicker branch. So what we are doing is we are taking the complexity away from the branch and putting that in the cloud. So in this case, we are putting the security functionality like CASB providers like, Cloud Access Security Broker or other functionalities of SASE, which I'm going to talk about there in a second. But what it means is we're taking the security functionality away from the branch and you are putting it in the cloud. So the SD-WAN task here is to provide you with the transport and the WAN improvements. And that's where that SASE approach comes to play, where you are taking the security functionality in the VMware SD-WAN gateway. So all those SASE components like DLP, CASB, Secure Web Gateway, Web Access Firewall, all those things are there in the cloud, and SD-WAN will make sure that you have the WAN acceleration and connectivity to the cloud. And there is plus more, the visibility and the monitoring to Nyansa on the branch LAN side, and then the monitoring on the WAN side with the vRealize network, what we call it as warning. I think this is what I have for the session out here. You understood the problem statement, where the VMware SD-WAN comes to play, and what are those 5 things we talked about which can transform your network from your legacy architecture to an VMware SD-WAN. This is what I have. Thank you.
Hello, everyone. Thank you for joining. My name is Jason Bakke. I'm a storage development principal engineer with Dell EMC. I've been with the company about 9.5 years. In this session, I'm actually going to talk about and actually demonstrate the migration of VMware's vCloud Director from a traditional Linux cell with an external Microsoft SQL Server database to the embedded Postgres SQL database within a vCloud Director 9.7 appliance. A little background information on this environment that I'm using for the demonstration. This is an environment I built for our technical marketing group about 9 years ago. I deployed it. I've been maintaining it over the years, upgrading it. And like many VMware products, early on, we used a Microsoft SQL Server database backend. And so I've been using this, it's actually on SQL Server 2016 today. But what's important to note is as of VMware vCloud Director 9.7, support for the SQL Server backend database externally, that goes away. So we need to shift this environment to PostgreSQL with the embedded vCloud Director 9.7 compliance. So I'm actually going to perform both of those steps in one shot here. The migration to the appliance off the, I think it's a CentOS cell that I'm using today, as well as some embedded PostgreSQL. It's actually not as complicated as it might sound. I've actually been through these types of migrations 3 different times, and this is the 4th migration that I'm performing. You simply follow VMware's documentation. The documentation is very well laid out, and it boils down to 4 major steps. And you can see those on the screen on the presentation display here. Step 1 or stage 1 is upgrade the existing environment to vCloud Director 9.7. That's important because VMware wants us to be on the same exact version for the existing cell when we make that jump to the new appliance. So the second stage is to deploy the new vCloud Director 9.7 appliance. The third stage is to migrate the SQL backend database to PostgreSQL. And then the last step or last stage is to copy any shared transfer service data, which we will do. And optionally, if you use certificates beyond just the self-signed certificates, we need to migrate those as well. I do not demonstrate the certificate migration in this video, although that is a fairly easy and well-documented step. So we're going to go into the lab demonstration now, and we're actually going to watch this migration and deployment take place. So again, the first stage is to upgrade our existing environment to vCloud Director 9.7. Now, in the interest of time, I have a 15-minute presentation slot here. I've already actually gone ahead and upgraded my existing cell. I've been through these upgrades many times over the years. You've probably been through the upgrades. Here, I'm just going to go and verify that we're on version 9.7, which is going to be the version of the appliance that we're going to migrate to. I'm also going to just kind of float around, spend about 30 seconds here just checking the health, make sure that my vApps are up and running. There's no error messages. We get a couple different looks here at the vApps that are deployed. And those are the types things that I want to see when we're done with the migration. Here I'm going to use an application called Dell EMC Replay Manager. I want to make sure that I have a good snapshot or backup before we go through the migration. So I use Replay Manager. As you can see, we're quiescing the virtual machines that I'm using as a backup. So I have a point-in-time backup of not only the vCloud Director 9.7 cell, I also have a backup and a application and data consistent snapshot of the SQL database. And here you can see using the Dell EMC plugin, I can verify that I've actually just taken a snapshot of both in their application and data consistent. Stage 2, we're going to deploy the new vCloud Director appliance. Now, before I do that, you'll see in the documentation steps that VMware has, and I'll post the link at the end of the video here. We need to create a new NFS share for the vCloud Director shared transfer service data. For this particular environment, I'm actually using a Windows NFS share. So I'm creating a new share here, allowing no root squash for that share, which is important. Click apply. Okay, and we'll actually go back and revisit this screen a little later after the deployment and verify that the vCloud Director, the new vCloud Director cell, has actually written the information into there. It's very important that that shared transfer space is working properly for the health and well-being of the vCloud Director environment. Now I'm going to open up a web browser and we're going to go ahead and deploy the vCloud Director 9.7 appliance. Okay, so I used some time compression here. I think I used 8x. This is simply the deployment of an OVF appliance, and this step actually takes about, I want to say, 10 minutes or so, not only to fill out all the information, but for the completion of the deployment. As well as we're going to actually power on the vCloud Director cell, watch that boot up, and then we'll pick up where that leaves off. But I'll show it all here. You can see I'm not skipping anything important. So our vCloud Director cell has now deployed. First thing we need to do now is to power it on, and I'm going to open up a web console and just kind of watch the boot up sequence. You will see a couple of error messages there. That's quite normal. But it's going to, upon first boot, it's going to run some post-deployment scripts or installation scripts based on the information that we provided in the deployment of the OVF. And again, I use time compression here because it's not a good use of time to sit and watch that. I wouldn't be able to finish this video within 15 minutes. So you can see our cell has deployed. We're at that blue screen at the end. That signifies that we're done. And we can now actually open a web browser and go to the vCloud Director provider page. And I'm doing that now. So we're going to log in for the first time as administrator. There's no other accounts linked to this provider instance. We've provided really no configuration, and we've not imported any configuration from our previous vCloud Director cell. So this deployment is happening in parallel, and then in the third and fourth steps, we'll migrate over the database and bring over the configuration data. So you can see just by looking at the screen here, this is an empty, unpopulated cell waiting for configuration. I'm going to actually SSH as root into the new cell. And the first thing we're going to do, again, I'm following VMware's documentation, very good documentation on these steps. We're going to stop the vCloud Director service. First, we'll check the status, but we will end up stopping those. I'm getting ahead of myself. We're checking the status of vPostgreSQL. And now I'm going to tail the cell.log. Really what I'm looking for here is just to look at performing some health checks of the new cell that I deployed, making sure there's no abnormalities or errors. Because if there are, of course we want to stop and correct those errors before we continue. Now we can see, now I'm actually looking at the NFS server, and we can see that the new cell has populated information into that shared transfer service. That verifies that my NFS mount is working correctly. We have no permissions issues. Okay, I'm going to log into now as root into port 5480 and check PostgreSQL health, and that looked good. Stage 3 is going to be migrating the SQL database. So now we've got two cells, the old, what I'll call the old cell or the existing cell, running side by side with the new vCloud Director appliance. So I'm going to log into or SSH into the both cells. The old cell or the existing cell will be in the upper left corner. The new cell is going to be in the lower right, and we'll do a little bit of work in each of those cells to perform the database migration. So this is the portion where we're going to stop the vCloud Director service or daemon on both cells. Use the same command on both. And now we're going to continue our work in the new cell. Now, according to the instructions, we need to perform or actually create an allow rule on the Postgres database to allow external traffic in the form of the database migration that we're going to perform. We do that by creating this text file, okay? And we provide the IP address and the account and group that we want to have access to the Postgres database on the new cell. I've done that using VI. I've verified with a cat command that that new file and information was populated. What that does in turn is actually populates yet another file under var VMware with that allow rule information. So now that allows us to go back to our old cell, and we're going to perform the database migration. It's you can see the command in there. We're telling the cell to migrate the database using the cell management tool to the new vPostgreSQL database listening on IP address 188.144.114, or sorry, 14. And there's a password in there that I've pixelated out. And this process actually doesn't take very long. It could vary based on the size of the environment, but when it's done, what we're looking for is data migration succeeded, a success, 0 failures, 0 skips. Again, if you see anything other than that, probably stop, reattempt the migration. So the last stage, or last step, is to migrate the shared data information. So we're going to copy over some files from the old environment to the new environment. And aside from the SQL database that we just migrated, these, I think it's 5 files. These 5 files hold the configuration of the vCloud Director environment. We're actually going to use these files once we copy them over to perform an unattended or scripted installation of vCloud Director in that new environment. So You can see we've copied over global.properties, response.properties, certificates, proxy certificates, and trust store over to the new cell. Okay. And once we're done with that, these files will be used for that unattended installation. Now, because of the nature and the security implications around using the SCP command, I have to provide the root password for each of the 5 files that I'm copying over. Okay, so this is where we're actually running the unattended installation using those files. This is the opt VMware vCloud Director bin configure command with a whole bunch of switches. And again, the documentation provides those switches, but this imports the remaining configuration data into the new vCloud Director cell appliance. So now we're going to start the vCloud Director service on the new cell. And I'm actually going to tail the cell.log file and watch for any errors or abnormalities here. And once this is 100% completed and we don't see this file continuing to write, that's a good indicator that the cell daemons are now started and we can actually log in with a web browser and perform a quick health check and verify that all of our vApps have been migrated and the health of the database is intact. And we're just about there. And cell startup is complete. Took 59 seconds. It actually takes longer to start up the cell than it does to migrate the data. So now we're going to log in to the provider console of the new cell. I'm going to use the administrator account here, but at this point, my other domain connected accounts should exist because they were copied over as part of the configuration. Now we can see, and there they are. There's the 3 users that I have imported. And we can see I've got it pixelated out, but our license file has been migrated over as well as part of the configuration. And there's our tenant, TechSol, and there are all of our vApps are now populated in the new cell by way of the database migration. And we can look at just another view here in the MyCloud view, see our various vApps and the VMs within those vApps. We've got a couple steps left here. I'm going to take a look at the vCenters here, and we can see that our NSX manager on the right-hand side has been carried over. That's also important for the deployment of VMs. One of the last steps we want to perform is we need to delete the old cloud cell. And that's quite simple. Right-click, choose delete. So now the only cell we have left in there is the single cell of our new deployment. Now we're going to power off the old cell, and we're going to delete it. Remember, we took a snapshot or a backup of this, so if at any point in time something went sideways here, we have a good rollback point and we can fix and reattempt. I've pixelated out some of our VM names here in this environment, but you can see we're looking at VCD cell 2, and we are complete at that point. So I showed all of the steps. I didn't skip anything. I did use time compression on some of them in the interest of time, but following the detailed documentation, it's not a complex procedure. Just make sure you have some form of backup. Use array-based snapshots if you can. I would also recommend using quiescence if you're going to snapshot your SQL database and your cloud cells while they're online. If you do not have the ability to quiesce the data to get app and data consistent snapshots, one method you could do is request an outage from your tenant and shut down both the SQL server and the old cell, and then take a snapshot that way. Then you're sure that we've lost no data in flight, then power them back on. That's the end of the presentation. I'm going to leave you with links to 2 documentation resources. They both point to the steps required that I followed to perform this migration. One is simply the online documentation on the top. If you prefer reading PDFs or printing out PDFs, there's the vCloud Director 9.7 installation guide. On the bottom, skip right to page 115, and it's really, I think it's about 3 or 4 pages, not even 4, to follow these steps. But you follow these steps and you'll be successful, and you'll have your migration completed, and at this point in time going forward, you will be off SQL Server and you'll be in your new embedded vPostgres SQL environment. Thank you all for joining, and I wish you all a wonderful VMworld.
Welcome to the session today. We're going to talk about VM performance innovations around protecting your mission-critical applications. My name is Brian Reynolds, and I'm a product manager in the Data Protection Division at Dell Technologies. We're going to talk a little bit about the challenges we have today when protecting our mission-critical applications and the innovations that we're working on in Dell and going to be previewing around the enhancements to our scale and performance when it comes to VM image backups. And finally, we'll talk a little bit about how this new enhanced data image backup is going to allow you to do more with your data than just protect it. So let's talk a little bit about the challenges. Today's VMs are faster and bigger. VMware continues to enhance the performance and capacity of the VM disks, which means that our VMs are running faster and they can handle more transactions. We're also seeing that they need to be able to accommodate that global environment, so they have fewer downtimes when we can be able to take those VM image backups. And when we talk about traditional backups, one of the challenges we have is when determining those deltas that we need to for being able to archive the data, we find that we have to halt the VM while we're looking and capturing that image. And that's going to result in the application becoming stunned. And the other problem we have is that we have a dependency on our external proxy, our agents. These agents we use to move and transfer the data to our storage. And these external proxies exist in our production environment, which means we have to be able to deploy and manage those resources, and they're taking away from our ability to support our production VMs. So let's look a little bit more into a VM image backup. There's really three stages that make up a backup. We have our snapshot creation. And this is where our point-in-time representation is collected for the VM and we use this to be able to determine the deltas. We see that this operation requires for us to be able to quiet that VM so that we can be able to get those changes. The next part of the process is to process those snapshots. And this is where we have to work with our external agents to move the data over and determine what those changes and deltas are, and then send those over to storage. And finally, we have to clean up, which means that we need to consolidate that point-in-time representation with the current VM and ensure that we have all those changes captured. We tend to see a lot of IOPS degradation in both the creation and the deletion steps. We also see a lot of impact on our performance when it comes to processing and moving that data, since I'm using production resources. So that introduces the problem. How are customers getting around it? Well, today, they're using workarounds to solve or to deal with those issues. One of the things that they're doing is they're taking a limited set of data and trying to protect only that, which requires our users and customers to be able to determine what is the valuable data and continually making sure that they're protecting the right information. This still has a challenge because I still require my agents on the host now to be able to capture those file and application level data. The other option that we've seen customers try to do is limit the backups, not take as many, and be less frequent, and hoping to capture those backups during those downtimes. But in our global environment, we're finding that time is unpredictable, and I may need to have my systems up when a backup is scheduled. The other problem I have is that it increases the gap between my backups, which gives me fewer copies to be able to use for restore. And I have less ability to be flexible when it comes to restoring my system. So here at Dell, we've been working to enhance the way that we do VM image backups. And the way that we've been looking to solve this is to ensure that we eliminate the need to pause that VM during a backup. This solution that we're looking at is storage agnostic. So we're going to be able to leverage this across all our various storage platforms. And we're eliminating as well the need for us to be able to have that dependency on our external agents during that processing of the data and moving it to our storage. This would be ideal to solve those problems with your large data sets where you can't afford to have that IOP reduction. So let's talk a little bit about this new enhanced VM image protection. So first off, we've enabled our VMs to monitor the changes. And as PowerProtect Data Manager makes a request for a backup, it's able to get a transparent snapshot of those changes without any IOPS interference. And these snapshot then is able to be pushed directly from the ESX to our PowerProtect DD without having to do any additional hops. And then my final step is just cleaning up. And that cleanup operation is very simple. It's just a simple removal of that transparent snapshot with no requirement for me to sync up those changes with the current running VMDK. So this really allows us to be able to see improvements when it comes to performance. We've eliminated the need to create that point in time snapshot, which means that I no longer have that pause of my IOPS. And as we look at large VMs, I can be able to take that snapshot without any disruption to the business. And therefore, it is truly transparent. We've also been able to reduce the need for that cleanup. So therefore, the cleaning up and removal of that snapshot is a simple operation with no impact to that running VM. And in our labs, we see that those IOPS can stay consistent across the entire snapshot operation, which is ideal for those VMs which are large that need to be able to have their IOPS maintained in order to handle the high transactions that they're trying to process. From a scale perspective, we've removed the need to copy those changes to an external agent. And this has allowed us to be able to remove those hops. And so I no longer need to be concerned about where my external agents are deployed and how they're deployed and where they sit in relationship to my ESX. I've also been able to, with the embedded data mover, reduce the impact on our production environment. So we're no longer using production resources when we copy our data over from the ESX to the PowerProtect DD. And this has eliminated the need for a management of all of those external agents. Since I no longer have to deploy them, I no longer have to manage them and make sure that they're upgraded and that they're all running and keeping healthy. I no longer have that ownership, and I'm not leveraging my production resources to be able to have to allocate space for them. So therefore, I'm able to truly use my entire ESX for my production without having to account for space and resources required for data protection. I've also been able to ensure that as part of when we deploy that embedded data mover, we have the ability for it to be propagated and scaled automatically. So as you add hosts to your cluster, that data mover will get automatically moved and installed and deployed and configured. So there's no work for you as a customer to ensure that that data mover is up and running. And as we expand our environments, those data movers will expand with it. So this is really changing the way that we can protect those VMs. So the VMs that used to be unprotectable, we will now be able to protect, which allows you to be able to take more backups and no longer have to wait for downtime, which gives you a lot more flexibility when it comes to providing solid recovery. Since your copies will be more frequent, you're not going to have data being lost. And I'll have the ability to recover those in the same manner that I do with a backup. I'll be able to go directly from the PowerProtect DD to the ESX with no additional hop or involvement of those external agents. And this ultimately allows us to focus back on the VM as a valuable asset. I no longer have to be concerned about what's on my VMs. I can protect the whole VM and be assured that I'm not losing any critical data. Nor do I have to be working with trying to manage all of those agents that may be looking for the file data or application data. I can just protect the whole VM, no agents needed. So that really reduces the amount of infrastructure that I need to deploy and manage It makes things easier for you as a customer to be able to ensure that you've got data protection up and running without requiring you to configure and manage in your production environment any of those external agents or those host agents. So in summary, this is going to be an opportunity. We're excited to present to you this new innovative way of doing enhanced VM image backups. We realize that this is going to provide you with a solution for those mission critical applications that today you cannot protect. And it'll give you complete coverage of your entire VM without having you to have to figure out what data needs to be protected or what's critical on that particular disk. And this is ideal when I need to be able to protect those VMs that have a need to be able to run in this global environment. And we're excited to offer this new enhanced VM image backup with a snapshot and the data movers that have been developed here at Dell Technologies. And this is going to open the door for you to be able to move over some of your systems that may be currently still physical to a virtualized environment and still be protected and have the same level of data protection that you would expect without the need of having to deploy all of those agents. And we're really excited to be able to provide this for you because we know this is a problem that's been around and we believe it's about time for it to be solved. So if you'd like to learn more about PowerProtect Data Manager and what we're doing to be able to enhance our data protection from a VM image perspective, please check out our website or join us on Twitter. And thank you very much for joining me in this session.
Good afternoon, good morning, good evening, wherever you are. My name is Mark Stockham. I'm a field CTO with Dell Technologies Data Protection Solutions, specifically working with VMware technologies. And today we're going to be talking about data protection for multi-cloud in VMware environments. So what do we mean initially by multi-cloud? Multi-cloud for us in this context is those on-premises, those hybrid, those multiple public clouds, any or all of the above, being able to operate in all of those clouds and give data protection solutions regardless of where the workloads run. Which hyperscalers are we going to be talking about? Primarily AWS, Azure, and GCP and Google. There are others that we'll touch on, but primarily those three. The most appropriate use cases will be covered for data protection relating to all of these clouds. We'll discuss optimal architecture. We'll be looking at some of the critical workloads, and we'll also touch on automation elements for reasons that will become apparent a bit later on. So to start off with, what are the most appropriate use cases? Today we're going to be talking about long-term retention to start off with. We'll then be moving on to cloud disaster recovery, backing up into the cloud from on-premises environments, and also backing up from within the cloud itself. In all of these scenarios, we're going to be looking at it from a data protection storage perspective, so the data domain, be that a physical appliance, a converged appliance, or a virtual appliance, and looking at things also from a data mover perspective, so the data protection software itself. In all of these scenarios, performance efficiency and the ability to operate in the multiple clouds, Amazon, Google, Azure, as well as VMC, etc., are going to be addressed in the use cases. So first scenario, long-term retention to the cloud. In this case, we're going to be using the cloud to give us the ability to hopefully reduce our reliance on tape, on those less accessible mediums, those things that take us longer to get data recovered from. So we've got the on-premises environment, we've got an active tier carrying out operational day-to-day protection and recovery. We're taking some of that data that has aged out and we're moving it to the cloud tier. We have a long-term retention tier, if you like, using S3 compatible storage. So in this case, looking on premises at something like Dell EMC ECS, Elastic Cloud Storage. But the topic for today is, of course, the cloud. So equally, we can take that deduplicated, that compressed, that encrypted data, and we can move it into the public cloud. Use a public cloud provider purely for their storage. So we have the ability to use AWS, Azure Blob Storage, AWS S3, Google Cloud, various other clouds, purely to give us that storage capability. So we're taking the highly efficient deduplication that the data domain gives us in the first place. We're able to take that policy engine, use that policy engine to decide what we're going to move to the long-term retention, the cloud tier. We can scale highly based upon the physical appliances that we can deploy. We can also use a data protection appliance like a PowerProtect DD series 3300, 4400, giving us an entry point, much lower entry point. And we can take, even if we want to, a virtual appliance, a DDVE, and start at something like a 1 terabyte incremental increase of storage, and deploy that and use that as the on-premises storage. We can support third-party data movers, but obviously better deduplication is achieved with Dell Technology Solutions, and this helps us to move away from the likes of tape. So this is an entry point, if you like. This is using the cloud environment purely for its cheap storage. Moving on to the next level, cloud disaster recovery. So taking your virtual estate, your VMware estate that runs day to day, taking that environment, protecting the data onto a data domain on premises, be that physical, appliance, etc., and then taking some of that data and pushing it again into cloud storage. In this case, Amazon S3, Azure Blob, and making sure that we have copies that are available in the cloud. Should we want to spin that workload up in the case of a disaster recovery, we can convert that image, we can pre-convert it, or we can convert it on the fly and run it as an EC2 instance. The same thing can occur for Azure, so we can convert it to an Azure VM image and run it there. Pre-conversion also available should we need to or want to. But if we do want to run it just as another VM, if you like, we can also leverage VMware Cloud on AWS and just run that, or just take that image, bring it up, restore it into as a VMware VM, and we can then run that in the cloud, carry on running, and then should we need to move that workload back on-prem after the disaster has passed, we can vMotion that virtual machine back on premises. So we've got two options. We can take the option to run it as an EC2 or an Azure image, or we can run it in EC2. What this means is we've got this orchestrated failover capability into the various clouds. Recovery can be minutes. If we pre-convert some of these images, pre-conversion can be run on a regular basis. Once that image is uploaded into the cloud, we're able to recover in minutes. We can have recovery point objectives as short as 15 minutes, seamlessly integrated with what's going on premises, and application consistent recovery is available in Amazon itself. So this can replace a secondary or a tertiary data center. I've seen this in a lot of cases throughout EMEA, which is the region that I cover. So can obviate the need for making high physical hardware purchases, and also the cost of facilities managing entire premises. So what about if we want to actually back up from on-prem into the cloud? What does that look like? Of course, we've got the usual efficiency of DD Boost. We deduplicate to the client side, we compress, we encrypt. That information is protected on premises. We could then take that data and move it into a data domain virtual edition, a PowerProtect DD virtual edition, running either in Google Cloud, in Amazon, or in Azure. And this gives us the ability to leverage the lower cost of running natively in those cloud environments. Being able to run in EC2, for example, is much, much cheaper than running in VMC. What we can get here is the ability to write directly to that storage appliance. We don't need to have storage on-prem. We could. There's another scenario coming up shortly in which we cover that use case. So we don't need to use on-site storage. Boost takes a lot of the pain of ingress, of moving data from on-prem into the cloud, and it gives us a multitude of deployment options. Use case here could be a remote site with a very small footprint, not enough footprint to deploy even a data domain virtual edition or a small appliance. If you have limited WAN capabilities, the ability to carry out this client-side dedupe allows us to minimize the amount of data that gets transitioned. And the facilities on site may not be suitable to host data protection storage. It might just not be suitable. So this is the scenario that we see in a lot of cases, customers wanting to take the data, move it out, and store it initially in the cloud. So just jumping very briefly into an architecture slide, the architecture we're taking into consideration here is the use of virtual proxies, client-side deduplication, giving us the ability to do change block tracking from a VMware perspective and take as little data as possible to move it across the network to then let it reside on the highly efficient protection storage, giving us minimal footprint. We'll cover why that's important very soon. But the highlight here is, whenever you move to the cloud, between clouds, between zones, availability zones, regions, et cetera, or when you egress, obviously one of those hidden costs is the cost of moving data. The less data you move, the better things tend to be. And also, if we're doing this from a software-defined perspective, automation is something that we can leverage, and we'll come on to automation in a few slides' time. What we can also leverage here is a lot of the in-stack and vRealize automation capabilities of the stack, and that data efficiency really does pay dividends when we're not just on-prem, but also in the cloud. So what about if we have existing platforms that we're running on-prem and we want to replicate that data elsewhere? Well, again, the efficiency that we have as part of the platform, the deduplication, the compression, the encryption, allows us to take that data and then just carry out a replica between the on-prem environment and the PowerProtect DD Virtual Edition running in either GCP, AWS, or Azure. And what this means is we're able to take that data and get it into the cloud in as quick and as efficient a manner as possible. Some customers just want to be able to move their data and get it into the cloud so that they can leverage it and replicate it elsewhere. We've got the ability to support third-party software should we require it here. Very easy to deploy through the various different marketplaces. Latest and greatest versions have been released in the past week or two on some of these platforms, and this means that reduces that ingress-egress cost, means that that bill shock is reduced or minimized. So what about where we have VMC, VMware Cloud, for example? In this scenario, we've got the on-premises environment. It's running as you would expect, all your virtual machines, vSAN, ESX, NSX, et cetera, We're also able to configure and run the environment in hybrid link mode, so we have that VMC instance that looks, smells, feels exactly like what's being run on-prem. So that's great from the perspective of being able to run workloads either on-prem or in the cloud in a hybrid and a seamless fashion. But from the data protection perspective, what we really want to be doing is making the most of the adjacency that we have between the VMC instance and the native Amazon facilities that reside next to it. In this case, we're able to run PowerProtect DD Virtual Edition as an EC2 instance using S3 storage. And because it's sat literally next door to the VMC instance, we've got high bandwidth, we've got a variety of methods of connecting to it, which gives us the ability to drive down cost for protecting those workloads that reside in VMC. We could equally run it in VMC, but it's a more cost-efficient option to deploy in native Amazon. What do we get here? Enterprise-class data protection for VMware Cloud and AWS. We get that image-based protection capability, instant recovery of those workloads either within the VMC instance, or we can vMotion them or just run them on premises. We've got the ability to store in S3, which gives us that cost benefit, and it's a consistent and seamless operation experience for the VMware operator. We'll come on to that a little bit later on from an automation perspective. What about when we're protecting workloads from an in-cloud perspective. So in the scenario here, we have a multitude of applications that reside on-prem or in the cloud. In this case, cloud applications. We have a specific set of application tools that allow us to take that data and move it from the client directly to PowerProtect DD Virtual Edition residing in Azure, Amazon, Google GCP. The ability to take that, leveraging all of the existing benefits, the deduplication, et cetera, the minimization of network traffic, and fundamentally giving higher performance, lower backup window times, being able to manage this stuff on-prem and let it reside in the cloud. And a lot of the deployment capabilities are available through those marketplaces. So it makes a lot of sense to be able to leverage the benefits of being able to run PowerProtect DD Virtual Edition in the cloud on whichever cloud provider you want, and be able to protect those various workloads that you are interested in. Not forgetting the likes of Kubernetes that are covered in other sessions and other topics of much discussion elsewhere, but are also protected by our PowerProtect suite of products. Mentioned earlier on about the low cost footprint. Just a very brief slide here. The way in which we deploy in AWS, for example, natively on EC2 is a much more efficient from a deduplication perspective. So we're able to store much less data to protect the same workloads. We're able to use less compute instances, so the cost of EC2 compute will be lower. The cost of storage will be lower from a block perspective, and the cost of object storage will also be low based upon the lower footprint. And you can see some comparative costs in here, but just to make the point that it's not just about the minimization of the network traffic that we mentioned earlier on, but also if we're running natively in the cloud, we're able to drive down costs there too, which is obviously a key driver for most customers moving to the cloud for cost reasons. Now, all of this would be slightly irrelevant if we didn't have a way of managing the entire environment. So we're able to use Data Protection Central to get a single view of what's going on throughout the environment. A number of ways in which we can deploy and utilize this. This is not the only way in which we can do this. We also have the ability to tie into the likes of Tanzu Mission Control, but that's a topic for the cloud native side of things. Just want to make the point that all of this needs to be visualized and managed in an effective fashion. And while we're speaking about management, it'd be remiss of me not to mention vRealize automation. So taking the scenario we just mentioned where we had on-prem, we had VMC, and we've got the native EC2 data domain running in EC2 natively, we also have the ability to tie into vRealize automation. So vRealize automation being that element that gives us full lifecycle management of those VMs, regardless of whether they're running on-prem or in VMC when we're in that hybrid link mode. Now we have a comprehensive set of vRealize integration capabilities right now, regardless of which data mover that is being used. But the product management have asked me to give you a sneaky peek into what's coming soon, what's coming next. So as you're no doubt aware, vRealize 8.0 released earlier on in the year. vRealize 8.2 integration for our data protection extension will be published shortly. What this will allow us to do is give customers, yourselves, the ability to create policies which can then be exposed through vRealize automation and can be attached to virtual machines, giving us those day two operations for protecting, backing up, restoring to new and various other tasks that you'll be familiar with from vRealize Automation 7 that we will be the first to promote, to produce for vRealize 8.2. That's something that will be coming out later this year, but watch this space. This should be the first you've heard of it. So in summary, what we're talking about from a data protection perspective are solutions that map across all of the VMware cloud delivery options, regardless of whether you're on-prem private cloud, whether you're using some sort of subscription model, VMC on Dell EMC, AWS public cloud, GCP, Azure, etc. All of these delivery options are covered. We can protect workloads in those clouds, from those clouds, replicate to, restore from. In addition to the obvious Kubernetes, Tanzu, vRealize integrations that we've mentioned also. And this technology that we use, the architecture that we use, gives us a significant benefit right now. And watch this space throughout the whole of VMworld. Look for Dell Technologies data protection solutions and see what's coming next, what we'll be announcing, and what's coming next to further enhance the way in which you can protect your workloads when they're running on any of these VMware platforms. With that, I'd like to thank you for your time and your attention. And if you do want to get in touch, my name is Mark Stockham, mark.stockham@dell.com. Please feel free to reach out, and I'll be happy to answer any questions. Thank you very much for your time and attention.
Hello and welcome to this talk. I'm David Espejo. I'm based out in Colombia, South America, and I've been part of the vBrownBag community for quite some years. So I really appreciate the chance to share these topics at VMworld 2020 Tech Talks. So let's get started. In this session, we will talk about a little bit on distributed systems theory and why it is important for us in IT, right? So first of all, theory, right? That sounds really academic, and it's really academic. So first of all, why? Why to bring this topic from textbooks, from academia to IT? Why it is important? Well, first reason, it's because distributed systems are all around us in the everyday systems, products, protocols that we use and consume every day. They are all around us. And in my experience, this academic topic is not open for the interpretation of a specific vendor. It's a concise, exact, precise topic that when it's clear for us, and that is the main goal of this session, to try to bring light on how these topics can be found or can be traced to most of the systems, protocols, and products we use on the day-to-day operations of an IT environment. So examples of distributed systems will be, for example, DNS, the distributed naming service, network file systems, some network protocols like BGP or VXLAN, and even Netflix. It's a planetary scale distributed system that happens to provide the streaming services to end users, right? So they are all among us. So now, if that is pretty much clear on the why of the importance of this topic, what is a distributed system? For most of these definitions, I will reference the textbook by Professor Tannenbaum, who is very famous. He wrote several textbooks that are used throughout computer science schools throughout the world. And he provided some definitions for this topic. So first of all, a distributed system, it's a collection of autonomous computing elements that appears to its user as a single system, right? So there's a lot there to unfold. I will try to unfold a little bit this definition. Examples of distributed systems that operate like the textbook definition are, for example, a vSphere cluster. You have several nodes. Let's say a node in this context can be a hardware device or a software process. There will be several nodes that appears to its user as a single system. You log into vCenter, you see a cluster. A cluster itself, it's a form of or an implementation of a distributed system. For example, NSX has most of these services are distributed by nature. So it's a collection. There are several components, And one of the principles is that each component could act or could operate independently from each other. But in the practice, they will need to communicate, right? You have several components, but they will need to communicate to achieve a common goal. So the next feature, the next base feature is the single coherent system. Its users are not aware of the distribution of processes, services throughout many nodes and many systems. No, they will see or they will operate this as a single system. This is not the same as having a single view, right? If you are thinking about the infamous single pane of glass, I will dive a little deep on this in the next slide. It's not the same. It's just the coherency here comes by providing the user an experience in the system that behaves exactly the way the users expect it to behave, no matter where it's deployed, no matter how it's consumed. It will respond to user requests exactly how they expect it to answer or to respond, right? And for me, this has a lot to do in the trade-off between complexity and abstractions. You know, most of the promises that technology do today is providing simplicity, right? Eliminating complexity, and complexity cannot be eliminated. So the formal definition for complexity is shown there in the presentation. There was another professor called Herbert Simon. He provided a formal definition for a complex system that happens to be one made up of a large number of parts that interact in a non-simple way. So it's very similar to a distributed system. We can say that a distributed system, it's always complex, right? But simplicity, it's not just removing parts, because the system needs all of its parts. It's just, hiding the diverse components, hiding them from the users, and make the system appear as a single coherent system, right? So that is the abstraction, the most realistic goal with a complex system. Well, so let's dive a little deep on the base features. First of all, a collection of autonomous elements. If you have several elements, they will need a way to communicate between each other, to exchange messages between them. And also, if you have different independent components, nodes, or processes, more likely each process will have its own notion of time. There is nothing like a global clock for a distributed system, so you will need a way to provide time coordination. And also, if you have several members or several nodes to form the system, you will need a way to manage membership. You can have an open group when whatever node can be part of the group and can send messages to all the members of the group, or you can have a closed group. And if you have a closed group, you will need a way to authenticate, a protocol to authenticate nodes, to accept nodes into a cluster, and once accepted, to provide authorization on or trust on which part of the groups it can communicate to. So the technical or academic definition for this problem is admission control. So it sounds very familiar to a vSphere HA cluster, which happens to have an admission control mechanism. So examples of these requirements or these features for distributed systems implemented in the day-to-day components we use in IT, it's, for example, AMQP or RabbitMQ, a protocol, a messaging protocol used by some VMware products, or NTP, the Network Time Protocol, and a way to provide time coordination for a distributed system. Active Directory, for example, an example of authentication protocol to accept or deny requests to join a group. single socket layer, TLS, etc. Different ways to provide trust for this collection of independent elements. And the single coherent system, as I was referring previously, it's not the same as a single system view. It's not the single pane of glass. That is a fair goal, but it is harder to achieve than just to say it. So it's the trade-off between appearance versus expected behavior. And the coherency here has more to do with expected behavior than with appearance, right? So the overall goal is to hide the complexity, but the most important goal is that the system behave exactly like its users have designed it to behave. Right? When you have different components, you will need a way to provide services for these different components. That is being called middleware. And middleware provides at least 3 functions to a distributed system. First of all, communication. It will provide mechanisms to communicate components of the distributed systems. It will provide transactions, a way to manage transactions, because most of the times an application relies on different services that are distributed along many nodes or components of the system. So the scalable way to manage that is by using transactions. And finally, reliability, a way to handle partial failures. If you have a system made up of different nodes, you will have to face the reality. A part of the system will eventually fail. So how to hide the partial failures of the system from the users? You will need a way to handle rapidly or have a way to tolerate failures. So you will see this in operation in an HA or high availability event in a vSphere cluster. It's just a way to restart automatically VMs in another node. That is a way to hide or to manage partial failures of the systems for the user. So examples of middleware services are, for example, RPC, which is a highly used protocol or communication protocol used in Windows environments, for example. The microservices design pattern of today's applications relies on communication between components provided by an API, which happens to be kind of a middleware. And also serverless. Serverless work only with transactions, probably atomic transactions, but those are transactions provided by this, let's say, middleware layer that are necessary for a distributed system. So in summary, that's it. In my opinion, when you gain more knowledge or at least study a little bit this distributed systems topic, you will get a better idea on how to design an IT environment, and also it will set your expectations at the right level on how it operates. So I appreciate the chance, and I hope you like this talk. Thank you for watching.
Hello, welcome to VMworld 2020, the remote edition. This is Richard Kenyon, and I am giving a presentation called Catastrophic Failure, Tales from the Trenches. I've been a vExpert for the last 3 years. I'm also been for the last 3 years the Buffalo VMUG co-leader. You can reach me at Twitter and LinkedIn via the hashtag you see there. And I've been in the IT industry for about 20 years at this point in varying capacities. I used to be a web developer. I used to do some coding. I used to do some databases. I even used to do some help desk as well, which is what everybody should do at least once in their career. And I have moved up the tower to be a virtualization and storage engineer at Synacor in Buffalo, New York. And I would like to give this talk and let you know one of the issues we discovered when we went to do a NetApp maintenance. So if you've ever been at a bar with your friends, you're out drinking, you start telling war stories about, what's happened to you in your career and things like that. This is my story. So first of all, here's your beer, and I'm going to give you the story of what happened, and then we're going to walk through how it actually happened and all the troubleshooting that went along with it. So to give you the point of reference, my company has a DR facility located in Dallas, Texas. The facility is completely virtualized. That runs on a storage infrastructure of NetApp. We have about 250 ESX hosts. We have a DR vCenter, and we have a development vCenter that's hosted in the data facility. One of the DIM modules in our NetApp ended up having some errors on it. So we failed over from one node to the other node, which is standard operating procedure. And in the process of doing that, the technician, which we were in communication with on site, ended up pulling out the node to replace the DIM, as one does. And as soon as he did that, the rest of our environment completely dropped and went read-only. Our first assumption was he bumped a power cord, he bumped some fiber cables, he bumped a switch cable that's in the chassis, he knocked over a circuit in the rack. He must have done something. We come to find out within about 20 minutes that he actually didn't do anything. There was a bug in the specific version of ONTAP, which is NetApp's operating system that we were running, that had a specific version of motherboard firmware, which had a specific version of network card firmware that had a bug in it that just had a loose counter. When the counter went over 1,000, it caused a kernel panic in the NetApp node that was running and dropped that one and rebooted it. And that happened all within the span of about 90 seconds. So that then caused all of our DR environment and about a quarter of our development environment to go read-only. And then when the node came back up online, it was like basically pulling the hard drives out of all of our running VMs. We had then no customer impact, which is great because it's the DR facility and development facility. And then we had to spend the next 4 hours, kind of piecing our environment back together and learning a few different things in the process. So that is the story of how that actually happened. And this is actually what happened from the point in time we realized there's a problem until the solution came to be, which was some assistance through NetApp as well as a lot of our other teams on site. I'm telling you this because everybody's been in this situation before. And sometimes having a person tell you the story of how they solved it might help you in your environment. So the first thing that we start with is, something just broke. What just went wrong? We have to figure out how it broke, what happened. So our first set of questions, once we realize there's a problem, is what can I, as a virtualization and storage administrator, hit right now? What's up and running? What's functional? What pieces are a problem? And that obviously is your vCenter, your storage controllers, as well as your general administration boxes. Okay, now that we can figure out what we can and can't hit, let's figure out what scope this is. What data center are we in? We're in our DR facility. What cluster? It's our administration cluster, our production/DR cluster, and our development cluster. Next question would be, if you are a service provider like my company is, the next immediate question is, which clients are down? Do you have any revenue generating events? Do you have any people that are going to be calling you asking questions? Do you have any customers who are using your client's application stack for their own purposes? And the answer to that in this case was no, nothing like that in our production facility because it's DR. The next thing that we ask is our network operations center, always has a bunch of dashboards up. They're looking at traffic for our clients. They're looking at our data center facilities. They're looking at all of the different things that they are responsible for. So we ask them in chat, hey, we're doing a storage change right now. what do you see? What is going on your end? And unfortunately, in this case, the next screen I'm going to show you is quite literally exactly what they saw. Everything broke. Literally, their entire monitoring solution got overwhelmed with as many problems as they've seen. Because if you think about it, when you have 1001 VMs automatically go read-only, each VM could have up to 60 checks, if not more, and it just overloads the monitoring facility. So our network operations center currently is a newer set of employees that doesn't have a lot of experience. And as Fry is showing you, basically they thought it was the end of the world because they had never seen their monitoring solution break like this. So that's a little bit of an added stressor into what they started to panic and have all these issues come up. And they're like, oh my God, what do I do? And I and my team had to kind of walk them through, relax. We're all here together. Let's fix what's wrong. And then we kind of told them, here's what happened. Here's what we know of at the moment, and kind of brought them back from the brink. But it was quite funny to see in chat that a bunch of people just went, everything just broke. So first we had to tell them where the stack broke. And this picture is where myself and my teammates have control of. Our storage administration team and virtualization team control the following stack. We control the data center square footage, the power. We help the networking team arrange their equipment to be delivered, installed, and then managed at the data center co-location itself. And the network in our instance consists of fiber as well as Ethernet. We then move down the stack to storage. And in our case, we have object storage systems, and we also have block and we have file storage systems. Then that ties into our server infrastructure, which are physical machines, as well as physical VMware hosts. And my team's responsibility is the VMware side of that equation. Once you move down the stack a little bit further, you hit the guest operating systems. And the guest operating systems in this case are mostly Linux CentOS and a little bit of corporate infrastructure for the Windows. When we break it into the storage side of things, this picture is exactly the hardware that broke in the data center that I am referring to. So it's sometimes rare when you can see physically what actually broke, and it helps in presentations like this, as well as having good pictures of your data center. So our NetApp system was the one that went down. The block and file side of the equation went down. Object store was a different setup, so that was fine. And the picture right there is an AFF 8080EX, and the back of the picture shows the relatively well done wiring that the technician was working with. So we can immediately see that he could have hit a power cable for the switches, which are up top. He could have accidentally knocked one of the fiber cables offline to the node he was not replacing and working on. He could have hit one of the SAS cables, or he could have hit one of the power cables to the secondary node as well. So any one of those things at the time when we first noticed an issue was our first, here's what's going on. So now we've moved to the storage. Which pieces have failed? Which volumes are down? Which network interfaces are okay? And which HBAs are okay? Everything from the NetApp point of view at the time when we checked seemed to be perfectly fine. All the volumes were online, all of the cards were up, all the NICs were up, all of the volumes and pieces, everything seemed to be fine until we checked the uptime of the cluster and realized the secondary node we had failed over to had rebooted, which shouldn't have happened. So the next thing we do is, okay, now we need to check DNS, make sure that's working, because that's usually one of the first things that we check. And DNS wasn't working. And then we move down to, okay, that's a virtual machine. Let's make sure our vCenters and our PSCs are functioning. We were at 6.5U1, and the vCenter and the PSCs were read-only. So we had to go and find those, make sure that they were doing their FSCKs and come back up, rebooted perfectly fine, and we had network connection, and now we can start fixing our environment. In the time of about 20 minutes where we have gotten to this point, we now have our network operations center a little more calmed down. We are letting them know what's going on bit by bit, and we're feeding them information. They then ask us, as is our chain of command, do you need an incident manager? And an incident manager is responsible for communication between all of the following teams: the network operations guys, the data database guys, systems administrators, email administrators, web operations portals, an internal program called VAM that we have, the storage team, myself, and then the network team as well, because all of the pieces of this data center broke. So all of these teams are going to need to have a person in charge of fixing their individual pieces. And an incident manager, while they may not necessarily be technical, always comes in with this face. They know nothing. They don't know what's going on, and their role isn't technical troubleshooting. It's being a frontline communication for all of these teams to ask a question to, so that these teams can do troubleshooting themselves. They also then report up in case this was a client impacting event. They would be responsible for communicating to the clients as well as our internal executives, who usually would start asking questions if it was a client impacting event. They are a very important piece to let the technical teams troubleshoot without getting bugged every 5 minutes. What's the status? What's going on? Why did this break? They are the front line in letting the teams that are doing the work do the work, as well as feeding the executives information they need to know, as well as the clients of the company of Synacor what they need to know. They're very good at what they do, but it's sometimes funny when they come in at 3 o'clock in the morning looking like that. So what actually broke? Here's a list of the VMs that we have. The left side is the DR facility. The right side that's expanded is the NetApp cluster that went down. So as you can see, organization is a very key part of your network and making it sure you can quickly see what broke where and how to fix it. So if we didn't have the data stores and the VMs organized like this, it would be very difficult for us to bring 1001 VMs back online after a reboot, because they went read-only, without knowing exactly where they broke and exactly which pieces went down. The right-hand side is actually especially interesting to note, is because that's actually our data stores. A lot of people don't quite realize that you can make folders for your data stores. And in this instance, if you have multiple different types of hardware, you can very quickly find out which data stores broke, because you know which hardware they're on, because you know which cluster they belong to. So this was an invaluable piece that I really hope a lot of virtual administrators utilize, and it makes for a very well laid out plan for day-to-day maintenance, as well as you can kind of see what things lie in different places. As I said, we had about 1001 VMs go read-only, which means we now need to bring them back online with a set of reboots. And because vCenter is as it is, sometimes it's hard to make a large change like that. So we ended up doing a PowerShell script at the time I didn't know existed. You can actually do open VMRC, and it ends up giving you a quite wonderful screen of things that look like this. So you can bring up on your 50-inch monitors all of the VMs that you've rebooted and watch them reboot to make sure that they are FSCKing properly, and bring them back up to functioning states. And every so often, you might have one that just gets stuck, and you can easily pinpoint it by having a screen that looks like this. You can also open a web console with PowerCLI, but I found doing the open VMRC a little bit easier, because it sets, in Windows at least, a taskbar group for things that you can cascade, you can stack side by side, or in our case, you can just tile and watch them all come up at once. We broke it apart by doing our email infrastructure for the DR side into groups. So we did like SMTP servers, we did POP servers, we did migration servers, and we did our LDAP controllers all in separate groups so we can watch the bits and pieces come up. We also obviously brought up our DNS, our corporate LDAP, our corporate Active Directory, our corporate domain controllers up in the same way. It just helps if you group them all together, which, as I said in the previous screen, you can see on the left where those pieces reside so you can script against them. So now that we have our environment back up and running after a few hours, we can figure out what actually happened. And in this instance, NetApp jumped on immediately because we opened up a P1 case with them, as well as we had a early case open to saying, hey, we're doing some maintenance. So they immediately called us and went, This is something you should never see, is an emergency root volume not working properly when the nodes came back up. So they actually, to their credit, it's one of the reasons I enjoy working with the NetApp hardware, they called us immediately and said, hey, what's going on? How can we help you? What broke? We filled them in. We gave them a VDI to make sure that they had WebEx into the environment. And they started working and looking at how they can help us while we were bringing up our environment on the other side of that screen. They waited for about 4 hours. They did their research. They did their logs. And they found out that, as I had mentioned earlier, we had a strange issue of firmware versions on top of your OS versions being kind of funky. They said that this can be fixed with a workaround, which we then did. I'll show you that in a minute. And then they said that they also wanted to check our other prod facility and make sure that wasn't impacted. And it was to be fixed at a later date. So we now know that we had to fix that. So they were very, very helpful in working with us and being there when we needed them. And so we had, So we had the DIM, we had the panic, we had the root vol issue when it came back up, and NetApp did a quick give back once they did the thing. And here is the actual item that is the problem. The counter on the membership report sent, in our case, was above 1,000. And then our production facility, one node was affected and one node was not for further RCA. So that is the horror story that we have of an entire DR facility going down and being brought back up within 4 hours. If you have any questions, comments, or concerns, I hope you enjoyed your beer over my story, and I can be reached at the following information. So thank you very much, and enjoy the rest of VMworld.
Hello, everyone. My name is David Santos. I'm an NSX engineer, and today we're going to talk about some troubleshooting tips and tricks to NSXT. So to start, what we have in the box for in the NSXT box that help us to troubleshooting when we have some problem or we're facing some issues with with the solution. We have syslog that we can send logs to either login site or other log solution. We can have multiple syslog servers configured to NSX, so it works really well. Also have TraceFlow, that's a powerful tool where you can select the source and the destination workloads, and check the path between those two workloads. Also, topology map, that's something new in 3.0, where you can see all the segments and T1s and T0s that we have configured in our network. Container inventory, so in 3.0 we can also check the clusters that are connected, the Kubernetes cluster that are connected to NSX. Also, what are the namespaces, configure them, and the containers, the labels, and everything. Also, the ingress rules. Mirror, either logical span or ER span. They are really useful for troubleshooting. IPFix and VRNI, that's got better in the last version, and latency. So the latest part is really nice. It's really useful when you need to check if the communication between two any transport nodes are working fine or not. So for each one of those topics, I have a video here. The first one is the integration with login site. So this integration is native. So when you integrated login site with NSX, it has a content pack that brings all those nice charts to login site, and also it has all the rejects done. So here, this blue blue These blue words here are called extracted fields, and they are the log parsing. So it helps logging site to index all the unstructured data that received in a syslog format, and index that to easily search for an information, an event, an error, or everything that happened in NSX or any other platform. The next one is trace flow. Here we have trace flow. So we're going to select a source workload that can be either a VM or a pod, and the destination workload that can be either a VM, a pod, or an IP address. In the case of an external IP address, you check the NSX communication up to the edge node. So you check if everything from the workload up to the edge node is working fine. In our case, we're gonna select a container as our source workload. Here it's a Deltaforce app, and we're gonna test the communication to A. After the test is done, we can check here all the components that participate in that communication. Here I have the pod, the segment, T0, T1s, and also we have the hypervisor that are hosting that pod or that workload. Something that's nice is that we can see here the IP address of that workload, of the hypervisor, the management IP address, and also the hypervisor version where is NSX installed. The other feature that was added to NSX 3.0 was the topology mapping. So the topology map is something that's really helpful to understand the NSX topology and what's connected to what. So here you can see that we have our T0. We can download the routing table, the forwarding table, check what's the BGP neighbors, also the T1 configuration. When you have multiple segments connect to the same T1, we're going to group them, and also can ungroup them to see what's connected there. Here we have a segment Deltaforce that's being used for 4 pods. We can also check the labels that those pods are using, and we can export that to PDF, and also have a mini map here that is really useful to look to search something really quick. Topology map, it was something that people was asking a long time ago, and now it's happening in NSX. So I'm a really fan of that. Containers inventory, it helps a lot to figure out what we have in the Kubernetes cluster that are being used. That it helps a lot to cross-reference what you have in Kubernetes and also with what you have in NSX, and it helps to create firewall rules and check what are the rules, the ingress rules created in NSX. So here you can check the containers and the clusters. In this case, we have 1 cluster working and 2 clusters that are not connected. And we can check that there's 3 nodes in each one in that cluster. We can look for a specific namespace like Deltaforce, and we can check like the ingress rule. We can check what has been configured for load balance. In this case, we have a URI rule that's balancing /app and /web to our pods. And also we have here the SSL offload that has been configured. We can also check here the pods that are connected to that namespace, and also the service. In this case, we have two services, web and app, and also all the segments T1, T0 that communicate, that are being used for that Kubernetes cluster. Other thing that's available in NSX also is the port mirroring. We have two types of port mirroring in the simplified UI. We have the L3 span and also the logical span. The cool thing about L3 span is that we can mirror the whole segment. In this case, we're gonna mirror a segment that's being used for a container, and we're gonna send that traffic to an external IP address using GRE. In this case, I'm sending that traffic to my desktop computer that has external IP. Here I'm gonna start Wireshark and do a little filtering here to get only the pod network. I'm gonna generate here some traffic, 172.26, and after generate some traffic here, I can check all the communication in that network that's really useful for troubleshooting and to check if everything is fine or not, if why some application is not it's not communicating with another. So it's something really useful and really helps when you face a problem with connectivity. VRNI, in the last version of VRNI 5.2, we have a new dashboard, an NSXT dashboard. It's providing a lot of useful info for NSXT. So here in the right side, we have the topology, the NSXT topology, with all the controllers, managers, and also the nodes, the transport nodes. And when you click in a transport node, we can check the traffic that's going, that's ingress traffic, egress traffic, the latency between that transport node and other transport nodes. Also the traffic that's being received, the traffic that's being dropped, and also the usage, the disk usage, CPU usage, and memory usage. And so it improved a lot. Something that is really cool about this dashboard also is we can check here how many VMs are hosted in that host. What's the transport zone that is being used, the IP address, the management IP address, and also if everything's fine, like what's the connectivity status to the management plane, to the control plane, and there is a lot of other nice metrics here that help us to check if everything's fine with NSX or not. Also, NSX, the new version, I think it started in 5.1, and also in 5.2 we'll have the dark mode. Dark mode sometimes is helpful for people that likes dark screen, that don't like clear screen. So it helps too much, especially when you are in the front of the computer the whole day. So in the Kubernetes integration, these dark modes got really cool because there's a diagram here of service that looks really nice. So here you can check like the namespace, the service of like that of the container integrated the Kubernetes integrated VRNI solution. And here's the diagram of the service. So here you can check like all the pods that are configured to that service. And also we can check here the NSX that's integrated to that Kubernetes cluster. Also, if you have here like a connection to a physical device, and also like the firewall rules, and here the master nodes. So this diagram here really help us to check in a graphical way what's happening in the Kubernetes cluster. That's all I have. Thank you very much for watching, and see you next time.
Hello, everyone, and welcome to my webinar on taking the guesswork out of VDI troubleshooting for your work from home workforce. First of all, I would like to thank the vBrownBag team for putting this together so quickly, especially us having a stage set up last year to having a webinar this year so quickly and easily. In this particular webinar, I'll be talking about the VDI troubleshooting process, and over the past 6 months or so, especially since our pandemic started, we have been going through a lot of organizations have been moving more towards VDI to basically make their employees work from home. So in this particular webinar, this is the agenda. We'll be going over some of the main VDI complaints that we see on a day-to-day basis. What are some of the VDI components and their stress points? We'll be looking at a troubleshooting flowchart that we have put together in order to quickly understand where the issues could lie, and to have a systematic approach into troubleshooting a VDI performance scenario, a performance issue. And finally, I'll be going over a couple of examples to show you how you can troubleshoot an infrastructure or networking issue with regards to the VDIs itself. So let's talk about some of the major VDI complaints. So firstly, a lot of people, when it comes to VDI, they have issues with either login or if it takes too long to log in. So this could be quite a few, this problem could have quite a few fold. It could be something related to their LDAP authentication, Kerberos authentication. It could either be that there is some kind of congestion on those Kerberos or LDAP servers. Also, it could be something on the connection server regards. It could be something on latency. So there are a few different things that we can talk about in this perspective. But this is one of the complaints. The second is not being able to access the application, and the application crashes quite randomly. What that means is once the user is logged on to the VDI desktop, the mission critical application, such as the ERP system, the databases that they utilize to do and perform their job, it either becomes inaccessible or it crashes randomly. So this could be an issue either on the VDI side, or it could be something on the application side itself where there is very high responses. Thirdly, it could be sluggish user experience for the application. A sluggish user experience could be due to quite a few different scenarios. It could be the internet connection. It could be their home network. They could have multiple people using their home network, streaming Netflix or any other applications, especially in the work from home scenario. When you have multiple people in the same house working, it becomes even more harder to maintain a specific level of user experience. Next is the performance challenges during certain times of the days. during certain times of the days, there could be certain batch processes that you may not necessarily be able to find out in just one go, where one VM or one VDI desktop or multiple VDI desktops may end up having this particular issue. And lastly, you could just have random session drops. Typically, random session drops do not happen mainly because of some kind of a network-related issue where there's a complete network outage within the data center. That could be like a one-off scenario, or it could just be scenarios where a particular VDI desktop does not maintain connection. Some of the view agents inside the desktops probably crash or something of that sort. So there could be a few different scenarios with regards to these, with regards to some of the most common complaints that we have seen with regards to VDI desktops. So in this particular section, I'll be covering what are the most important VDI components and its response. But before I do that, I would like to quickly show you how people used to access C traffic before VDI and how VDI has actually made it a lot simpler. If you look at the bottom of my chart, you can quickly see that there are a lot of RDS traffic. So before VDI desktops became more popular, people used to RDP into their work computers and then access the application traffic from there. Similarly, when you're at home, you could RDP into your work desktop, going through a firewall, through a VPN, accessing the application from there. Similarly, if you wanted to access the application directly, you would use home VPN through the firewall and directly access your ERP servers, databases, and any other applications that you needed to. But with all this, there are definitely some security risks associated with that. And that's why VDI has gained a major popularity over the past few months, especially when security has been put in the forefront of many organizations, along with the ability for them to work from home. When it comes to VDI, there are a few different components that you need to be aware of. First of all, again, just like a regular VMware environment, you need to be aware that they all run on top of an ESXi host. You have multiple virtual machines or VDI desktops that are running inside. Apart from the VDI desktops, which are the most critical components, you have your connection servers, your security servers, and other components that are associated with VDI itself. You also have your on-premise applications that all these VDI desktops need to be able to access. Again, just like your databases, ERP servers, if it's a medical organization, any medical softwares and things of that sort. So you can quickly see all that. And similarly, when it comes to a remote workforce, they need to be able to access the VDI desktops from their homes, either using a public IP address that is set up on the VDI desktop pool or the connection server, or through a VPN that has to go, that will basically divert traffic through the firewall into the data center to look into the connection servers itself. So looking at such a complex setup, you can quickly see that there could be multiple areas where there could be potential stress. So let's take a look at some of these areas. Firstly, on the VDI desktops itself. On the VDI desktops itself, you can quickly see, you should be able to quickly see if there are any potential problems with regards to the compute, CPU, the memory related information. Are they spiking up? Is your GPU performing optimally? This basically helps in the user experience of that particular end user. Secondly, you want to see the ESXi hosts those VDI desktops are sitting on. Do those VDI desktops, do those ESXi hosts essentially have enough compute, enough storage, and processing capability to have the number of VDI desktops inside them? Thirdly, you want to see the connection between these VDI desktops to the application servers. are there any network latencies between your VDI desktops to the application servers? Is there any application delays or application response times between the two? You would want to take a look at this to ensure that your application performance between the VDI desktop and the enterprise application is seamless. Next, you would want to see the traffic, you would want to see the VDI on-premise user experience when it comes to your thin clients that are inside the environment. So there could be any issues such as networking issues between the VDI thin clients to the VDI desktops itself. Another thing could be the firewall. The firewall could be blocking certain packets, could be causing packet drops that could impact the end user experience as well. And finally, you want to take a look at, for a remote worker, the most important aspect is the connection. There could be an issue with regards to the internet being slow or the home network being slow. So you would want to take a look at the connection, the network connection between the VDI remote user to the VDI desktop tool itself. So a simple troubleshooting flowchart would begin as you see over here. You would always want to keep your end user experience in mind when you start your troubleshooting process. You would want to see whether the issue is due to a network response time or an application response time. See, if it's due to an application response time, you would want to see the VDI performance. The VDI performance can be split up into a couple of different things which you would want to troubleshoot, which is either the VDI session setup or provide you with the desktop activities and resource provisioning. So desktop activities include all the different processes that are running in that particular VDI desktop. And once we understand all that, we could provision the resources accordingly. Second, when it comes to application response time, you would want to look into both the application dependency maps to basically see the flow of your enterprise applications. As you know, most of your enterprise applications are multi-tiered. So you would want to see if there's an issue in the database, the web servers, and so on to quickly troubleshoot any problems. Next, you would want to see any transaction analysis. Are there any particular errors that are taking place between the different queries when it comes to the application response times itself? When it comes to the network response time, there are a couple of things to look at. One is to look into the north-south traffic within the environment to quickly see if there are any bandwidth limitations, any band link issues between your north-south traffic, and also see if there's any network switch or router related issue with regards to traffic diverting to the internet. Secondly, with regards to the LAN east-west traffic, you would want to make sure that that you have adequate east-west traffic visibility so that you can see all the connections between your VDI desktops to your application servers, or even between the different VDI desktops in between different hosts and things of that sort. And finally, you would also want to see the network edge performance to see if there are any particular issues with those remote sites within your environment as well. So this would be a very, very simplistic troubleshooting flowchart to quickly see what's going on within your environment. So in this, I'll discuss a couple of scenarios where there are infrastructure challenges. First, in order to see if there's any infrastructure challenge, monitor based on the different VDI desktops and quickly see if there are any issues in your compute, in your storage related information. And in this particular case, you can quickly see that there is some memory health related issues for a particular VDI user. Second, once you identify those memory related issues, you can drill down to see the level of spikes in each of those VDI desktops and the resource constraints and challenges that they have. Finally, once you have all the resource constraints, you can drill in and try to find out what are the different processes that are taking place within the environment. This could be done using either a specific tool, monitoring tool, or you could also use, you could also drill into the OS from the task manager as well to get this level of data. Next, a scenario to look into some of the networking challenges. First of all, when you want to view your networking challenges, you would want to visualize the end-to-end dependencies for applications, right from the thin clients all the way to the databases of the applications itself. Once you get that information, you would want to see what are some of the issues. And in this particular case, you can see network response time is higher than usual. So using this, you can isolate the issues to the virtual network. And finally, once you get this information, in order to understand what is causing the network response time, you would want to isolate the issue further to see what's causing the issue. And in some cases, issues such as virtual packet drops can be the root cause of your high network latency within the environment itself. So once again, everybody, thank you for listening to my presentation. And I would like to thank the vBrownBag team for giving me the opportunity to do so as well. And if you have any questions, feel free to reach out to me on Twitter or LinkedIn. And my website is also listed down below. Once again, thank you very much.
Welcome to this vBrownBag session deploying SQL Server 2019 big data clusters on Kubernetes with Ansible. Today, we're going to explore one of the many different ways to deploy a Kubernetes cluster with the end goal of deploying a Kubernetes application, in this case, Microsoft SQL Server 2019 big data clusters. My name is Doug Bernhardt. I'm a senior principal engineer with Dell Technologies. I've been at Dell now for a little over 8 years, and I've been working with SQL Server for over 25 years. Storage is obviously a very critical component of a big data or database environment. So now my primary focus is SQL Server and storage integration. While I've managed to hack out what I needed in VMware to get the job done and learned a fair amount about Kubernetes, Ansible, and Linux along the way, my primary background is SQL Server. My journey to Kubernetes and Linux and tools such as Ansible was one of necessity. Since my background is primarily SQL Server, my main goal was to deploy this new application, knowing that I needed a Kubernetes environment, and it was prior to the release of vSphere 7 or even the beta. Therefore, as part of my research and trying to get a Kubernetes environment up and running, I found the method that we're going to cover to be very well suited to my needs. Over the coming days, you'll surely hear a lot about forward-looking concepts and what's new in vSphere 7. This session is not about that. We're going to walk through a basic deployment of Kubernetes that's on a very simple environment of good old ESXi and vCenter. Also, keep in mind that there are literally over 100 different distributions to Kubernetes, as well as various different deployment models. This is a deployment of open source Kubernetes, or what is often referred to as vanilla Kubernetes. To perform the deployment, we're going to use basic VM templates and Ansible open source playbooks. Finally, we will deploy a big data application, Microsoft SQL Server 2019 big data clusters. There are various use cases for this deployment method. Maybe you're not ready to go to 7.0 just yet, or perhaps you want a similar deployment process and tools for bare metal, cloud, and VMs. This deployment method is similar to what you might use to deploy on bare metal with a few virtualization twists. We've got a lot of ground to cover, and this session is a whirlwind tour. If you don't get everything, no worries. I have a link to a paper at the end of the session that covers everything in detail. SQL Server Big Data Clusters is a big data and AI platform that deploys a data lake in a box, as I like to call it.